You there, Jeremy? Bueller?
Want a soda?
I was just thinking we should get like 30 people to all go into that official Flat Earth Discord and just start having like raging debates. They'd be like, what is going on?
Dude, I can't post links in I was like, you guys ever talk about flat earth topics? And they were like, no. And they were like, try a legitimate chat. So I went in there and it looked like they were talking about flat earth shit. And this guy, I just jumped in right in the middle of a little debate they had going on there. People aren't really talking that much. So I tagged Jerry because I'm like, yo, I can't post a video of my evidence. What kind of debate thing you got going on here? He's like, you can't have a sunset on a flat earth or whatever. He's like, L for flat earthers. Don't know nothing. I'm like, okay.
Looks like Jerry was in there like looks like this morning at 9 a.m. So I mean he's going in there and
Oh yeah, he's high ranked in there. He's ultimate.
he's the ultimate. Jerry says one of his comments, since the solar system is flat, why don't we fall off? Seems like Crit would have a field day with these guys.
Yeah, Crit probably is Crit going crazy in there or what?
No, I don't see any posts by him, but let's see. Well, it said he posted here the last post. I just searched for his name yesterday at 10:37 p.m. So he's in there.
Yeah, Moyak was complaining about Crit earlier. I'm like, dude, I don't know. The best we can do is give Gio a timestamp. Kurt was doing his little thing. You do you.
Yeah, Crit's like at war with a lot of these guys. I mean, the times I'll step in is just when it's like clogging up the chat when it gets out of control. But I think Crit kind of knows to keep it somewhat chill, not just go because he'll start doing all the screenshots and all that stuff. He's the fastest screenshotter I've ever seen. Like he'll take someone comment that happened 15 seconds ago. He's already got a screenshot. He's drawn stuff on it. It's already like locked and loaded.
Yeah, I'll have your comment highlighted, cut out everything. Yeah. But you hear him arguing with me about C and light speed and shit earlier. Just the ridiculousness around that whole thing. They got C from the constant speed of a photon through a vacuum. That's what C is. All photons are massless particles that move at C. Except C is not constant. Because they give C in meters per second. It's like 200 something million or 20 million or something. It's a ridiculously big number, whatever. The point is they got that number to change. That's not constant anymore. They can't handle it in their mind. They have cognitive dissonance. Earlier I was killing them on on star trails. Kojo was on my side for a lot of it.
What was that? Yeah, I don't think I was here for that.
You know, I see star trails at the equator that appear to converge and diverge.
Yeah.
You ever see star trails at the equator? They appear to converge and diverge.
Right.
These guys were saying they don't measure an angular difference in relation to two stars. I'm like, dude, you can see it right here. There's definitely an angular difference in here between the two stars over the course of a night. Look at the bottom, look at the middle, look at the top. Definitely a difference. Oh my God, I brought up reverse star trails because Kojo was saying, all right, it's perspective that's causing that to happen, the apparent convergence and divergence. I'm like, cool. So we need to take perspective into account when we look at stars. He's like, no, just star trails. I'm like, well, that doesn't really make sense, but I'll roll with it. I'm like, all right, we're going to do a reverse star trail. We're gonna look at Polaris, and since that's stationary for the most part over the course of a night, it's basically stationary. We're just gonna go towards it, and thereby create a reverse star trail of Polaris. And we're gonna need to take perspective into account for its movement. I don't like that though, because if we're taking perspective into account, you know, that's a whole nother. They've been saying for years you don't take perspective. Stars are so far away, you don't take perspective into account. I don't know how many times I've heard him say that.
Yeah, I guess on their model, if it's that far away, the way that they try to describe it. That they wouldn't take perspective. I don't know. It seems like he still would have perspective, but
Well, they do when they need it, and they don't when they don't want it to be. It's pick and choose fallacy. I don't know if that's a real thing. I might have just made that up. Maybe it's called cherry picking. I don't know. They do that with a lot of stuff. You need your system to be open, it's open. You need to be closed, it's closed. Whatever we need. Do you need vertical refraction? Do you need horizontal refraction when if there's vertical refraction, will that affect it? Yeah. But if we don't need it to, then no. It's constant shit like that. Is the thermosphere hot or is it cold? Both. It's funny because they say it's so hot up there that it actually make that the energy transfer from the solar winds or the sunlight or whatever gets the gas so hot that it excels to orbital speeds. Whatever what's this thing called when you needed to leave Earth? Oh, I can't remember the name of that.
escape velocity.
Yeah, they say the energy transfers into the gas molecules and gets them so hot that they reach escape velocity, and that's how they escape Earth. That's their reasoning for us losing whatever they say. It's like 100 metric tons a day or something of gas, but the energy doesn't absorb into the rubber tires on a Tesla and get so hot. Like, that doesn't even make sense. You can't pick and choose on what things you want to get hot and what things you don't want to get hot. it's ridiculous. Pick and choose. That's got to be a real thing because that's what they do.
Selective.
They got selective perspective. Yes, selective thinking. I don't know what you call it. It's bullshit, dude. I really like the idea of that, of just having a few people go back through the data, all these hours and hours and endless hours of video we have, go back and just capture them saying like key phrases. Like the thing Crypto was talking about earlier with Rumpus, how he would never say the Earth's and entropy doesn't apply to the Earth, and then have him saying it does or whatever. You know what I mean? Just two contradictory things back to back because they just do that shit all the time. Sometimes within sentences of each other, and it doesn't take. You don't have to go back years. Sometimes it happens instantly. Just to show people like what they're getting into and what they're about to be dealing with.
Is there ever a thought that we give these guys way too much attention?
Yeah, hell yeah, bro. Dude, make a flat Earth only room, and we'll see which one fills up.
I mean, it kind of goes deep into like the question of just like truth versus deception. I mean, it's one thing to just like have an open platform where everyone can come. That's understandable. But there's also like, from the perspective that the globe is completely false, it's like they want us paying attention to them. You know, they would want us kind of wallowing in the lies and the deception and going deep on black holes and debating their thing and trying to debunk their model. You know, they love that. That's like giving them food. You know, they lap it up and they want all the attention, and you know, they want us talking about the globe basically all day, so that we're not actually talking about other things or discovering other things or waking up other people.
Yeah, definitely. No, a lot of it is tactics. Absolutely, probably one of their tactics.
But I mean, there is a larger discussion, and anybody new who's listening, they may want to hear both sides. So,
Yeah. That's why we should record them guys saying contradictory statements and let them see what side's saying what. Well, you know what I'm saying? Let them see the other side. Yeah, what they're saying, or entropy does apply to Earth, and entropy doesn't apply to Earth. They're saying you can get vertical refraction from a horizontal refraction, and then you can't. Like, it's space is hot, space is cold. Like, just all kinds of contradictory statements. Let them see what these guys are really saying. You feel me? Because somebody might come in and just catch like maybe the Globers getting on the flat Earth or just not even. You know, I don't know.
yeah, I think there's a place for all of it. Like you said, I mean, having separate rooms would just allow for a little bit more focus on what people want to be listening to and what's going on with it all. But yeah, but when we have one room, it's like they have the ability to just come in and kind of just derail it into whatever globe stuff.
Even in the other room, if you wanted to, you could do what Bev does and just let one Glober in at a time. That way, it doesn't turn into a shit show. We have our, you know, if everyone can control themselves and just let one flat earther. That's another problem when it gets heated and shit. And I don't know. I feel like we got to let two people go back and forth with it more because it's very frustrating for one guy to be going against two or even three or four other guys. You know, he's trying to make his comments I hate when they do that shit. Like if I'm trying to get in some heated shit and trying to go back and forth with them, like, dude, I need to respond to what he just said, not have you go for another 30 seconds with your fucking shit.
Right.
Would that be exactly the same if I went to a room with flat earthers and it's one of me versus 10 flat earthers?
Absolutely.
Let's steamroll me.
I just said that. Yeah, we need to control ourselves too and just let one flat earther go at them.
A lot of that comes down to like just moderation, and I mean, yeah, and even temporarily muting people when it when it happens, and just letting people know, like, okay, just let those two guys talk for whatever, finish what they're going through, But then it can be hard because let's say there's two people, let's say it's whatever, Jeremy and Kosho, for example, and they're really going deep on something. And even if we let the room know and like, okay, guys, don't interrupt them. Let's just let them finish, hash out whatever they're doing. But then somebody new might join. They listen to 2 seconds of it and then they blast in, So it's like, it just takes a lot of moderation.
Yeah.
Yeah, and I think there should be like a 1v1 room or something where people, if they want to do a 1v1, because then someone joins in on like a general VC, and then you can never join in the conversation because it's always two guys going at it. Could turn into that.
Don't we have like a staging room or something that we could do that in?
Yeah, the stage rooms. I mean, these rooms can be made so that, like, for example, this VC room right now, I could make it to where like everybody who joins is automatically muted except for the two people or whatever, maybe the mods and then the two people debating. So that's an option. But yeah, the stage room is kind of like that as well, where there's only the people that are on the stage are able to speak. So yeah, we could use that as well.
What's up, all that?
I mean, I like listening to two people. Like, I don't always have to jump in. I like sometimes where it's just two people and you can actually hear them going back and forth, and you can hear the full ideas actually being hashed out without, someone else jumping in or someone else derailing to some other topic.
Dude, I really try hard not to. I've been trying hard, working on not jumping in and shit on people. It's hard though.
Yeah, sometimes it's hard when, like, if you have someone on the globe side who's fuck up and can't answer any questions or anything, you're like, fuck me, stop being an idiot.
I mean, I just like to pitch, throw my 2 cents in, especially if I think I got like a good point or something. Even if the other person's doing good, like I still like to jump in, just because I think I got a good point. But yeah, we've been doing this for so long. We really got to it's not going to hurt if we give two guys 10 minutes to go at it.
Yeah.
We've been doing this for years. Really, we can't bite our tongues for 10 minutes.
I feel like it's kind of mental. I mean, I think I've been on Discord for like 3 years or something talking about flat Earth. And why? Just why?
That's what I'm saying. You've been doing it for 3 years. What's 10 minutes? Let's give these two guys 10 minutes because they want to go at it. We somehow can't even manage that though. We're just fuck up.
But I think I give people the 10 minutes when I'm not here. So when I'm here, it's
when
fine.
I'm here, you had all the 10 minutes is when I was sleeping. I just slept for 8 hours.
Yeah, when I was asleep.
Yeah, do your uninterrupted 10 minutes after I leave. Well, man, you were saying you're a robot in a little.
Yeah, go on, Jim.
A minute ago, were you saying you've been here for 3 years, and were you saying why? Like, you were asking yourself why? Is that what you were saying?
Yeah. Like why do I keep coming into these places and talk about the Earth being flat? Because sure, it's sort of a hobby, but it doesn't change anything. I mean, it's just a thing to talk about, I guess.
I'm not going to sleep watching.
How you're sleeping?
Hmm?
Well, is there a part of you that I'm not trying to get into the whole like, you know, are you questioning the globe conversation per se? But I mean, is there a part of you that like, even though you might think it's 0.00 whatever percent that it's actually not a globe, is there a part of you that thinks it may not be, and therefore you want to be around to see how it all goes down?
I think it would be very tough not to be a globe. I mean, I think sort of everything is possible, but yeah, I think it's a globe, but I don't know why I like originally came here. Maybe I thought that it was easy because I was in religious debates and shit, and it's like you can't show it either way. It's just purely impossible. But then I thought this was a thing that you can easily show, but turns out some people you can't show things, so it's not that easy.
Yeah, but if there was a scientific test or experiment that everybody could do independent of everyone else, you know, falsifiable, repeatable, et cetera, then this wouldn't be an issue. But what we have is
Well, I think there is.
we have a whole bunch of things that are asserted as science that depend on, you know, like Bob, the science dude, was going yesterday all about sending radar to Venus and how absolutely dead set this is, radar to Venus. So I you know, and I've looked at this up in the past, but we also did it kind of live last night. And the only ones that claim they did this is NASA, Jet Propulsion Laboratories. It's like, oh, okay, with their special equipment that no one else has. So it's just kind of like, all right, you know?
I thought you meant about the Earth, because I think that you can actually do it for the Earth quite easily. Well, quite easily is a loose term, but you can do it. Yeah, you can just sail around the Earth and check the travel time.
Okay, well, I mean that's a possibility. You'd have to have a
And
really good
also
way.
fly. Like you can fly from Los Angeles to Australia and then sail that same path and just see if they correlate.
I have to say, Mailman, when we did the role reversal and you were playing a flat earther, I was like astonished at how well you did. Like, you know, the argument so well. It almost seemed like you might give them fair consideration.
Yeah, because I think there are, well, some sort of gotcha things for the flat earth side that they can throw at us. And there is like no proper answer to the questions. So I can just ask those questions. I mean, I'm an atheist, so I can ask what happened before Big Bang, and I don't have an answer. I mean, I don't know. But I think that's still a valid answer to that question.
Don't you think there would be answers to some of these questions that on your side seem lacking at all, in your opinion?
It depends on a question, I'd say. Because so there are questions that are, yeah, but there are questions that are like non-questions, sort of. Like, how do you have gas pressure without a container? It's like, well, we don't claim that there's a place without gas pressure, so, well, I mean, it's a weird question.
I guess what I'm getting at is there seems like to be like such a divide in the discussion, where on our side it's like it seems so obvious, like beyond obvious, like how could you accept that answer? And then on your side it seems like, or first of all, you're saying that how could you not accept the answer? But it does seem like there's some answers that are just a little bit lacking in fortitude. Like yesterday with Geo asking for that evidence, and then NASA is the only one. But then still the claim on Bob's side is, well, of course, you know, like it's obvious. Here's the one thing, but he's not critical at all about that being the only thing he can come up with.
I think I wasn't here yesterday, so I'm not sure about what the thing was, but
well, just in general, yeah.
Yeah, sure. But I think on the flat Earth side, there's much more unanswered questions than on the globe side. Like all the.
But that would be due to, you could imagine that's due to the fact that if it's a conspiracy to hide those things, then that would be part of the effort being made, right?
Sure, but then you'd have to say that the things that are actually happening in reality aren't happening in reality. Like people just traveling, shipping, international shipping, intercontinental shipping flights, and all that shit should not be happening.
Just as far as the times that you're supposed to be there and it takes to get from one place to another and that kind of thing.
Sure, yeah, that. Plus the use of GPS and all the other things that are based on sort of the globe. I mean, those would have to be different than they actually. Well, I would say they actually are.
Just to make a comment on there being more unanswered questions of the Earth not being a globe. I mean, I guess I was trying to relate. Like, let's say that you were born. I'm not trying to say the globe is a cult right now. But I'm going to use a cult analogy. Let's say that ever since you were a child, you were brought up in a small family or whatever, and it was a cult. You know, whatever. Let's say five families that lived on 10 acres, and it's an
island, maybe.
On an island, yeah, and it just they brainwash the kids. They have all these weird things they do. You know, all that stuff. So you just grew up with it your whole life. You know, the elders of that, you know, or the parents or the grandparents, whatever, you know, they're all sort of in on it, you know, the whole 9 yards. And if you then got off that island, you know, let's say at age 15 or whatever, you just got out of there, and then you came up on the shores of New York City or whatever, it would be like, wow, I have a lot of unanswered questions. You know, I thought that my whole world, what I thought was reality and who I was and where I came from, was on that island with that cult, and now apparently there's a whole lot more to reality. So I'm just making that link. Like, we've all been born into the globe thing, and it's been pushed in all these different ways. And if indeed it isn't a globe, then yeah, of course there's a lot of unanswered questions. I mean, there's a lot of it's like a huge thing. I mean, it's not. Yeah. So.
Sure, but if I'm born in the island, then the people in the island actually know that what they're talking about is horseshit.
Right. So in that scenario, the people that are making the CGI for NASA know that it's horseshit, but they're convincing most people.
Sure, but then again, I'll go back to the distances and travel times on the surface, because that's my best evidence for the being a globe, because I've watched a lot of the people who have actually done circumnavigation.
Right. Well, then, I mean, for that one, doesn't it get down to it being verified? I mean, you don't know at what levels the deception may be going on in terms of the GPS systems, in terms of flight tracker, sure. In terms of the actual speeds of some of these things. But I understand. I see RC. I know RC is into this topic. I know he talks about measuring certain short flights that he's taking, distances or different things. But we could get into all that. But I mean, if you're talking about these massive distances across the Earth, the ones that require it to be a globe, I would say you're putting a lot of faith in the data that you may be getting.
Well, then, sure. But then that's what I said, that there must be a lot of people in on the sort of the conspiracy.
Well, there would be enough. Definitely enough. I mean,
sure. But then I could say, I mean, which one is easier to lie about and create, the flat Earth narrative or the globe Earth narrative?
Easier?
Yeah, like how many people would have to lie if the Earth was flat and said to be a globe, or if the Earth is globe and there are flat Earthers who say that it's flat? Which one is the easier explanation?
Are you indicating that if this whole phenomenon of flat Earth would then be perpetrated by people lying about it being flat and coming up with a way of convincing people that it is? Yeah, is that what you think is going on? Like, is that if you had to analyze why this phenomenon happened? Is it because people
No,
are like
originally,
trying?
yeah, sure. People thought, I mean, people might have thought that the Earth was flat before they could travel, and then that's an idea. But then later on, some people like Robotham, I think Robotham was just a con man and a liar, because I think there's evidence for it.
All right, so
Well,
this
you think
idea,
his intentions? Why was he doing that? What was his intention then, lying about it?
Robotham's? I don't know. Maybe he got some money for it. I'm not sure. I'm not 100% sure. But I think there was some things that he conned people with before or after Flat Earth, if I remember correctly.
all right, so this kind of idea would be okay. So all ancient peoples thought the Earth was a stationary plane. They built their entire spiritual, metaphysical systems upon it, et cetera, et cetera. Copernicus and the Greeks blew all of our noggins, and they were just such geniuses that they figured out the Earth actually was a globe after all these eons of time, and they just fried our minds. And then now we're in the Copernican revolution, and the wonderful men at NASA have just absolutely solidified it, and we have wonderful, probes and space images and satellites and stuff. But then someone came along and made a lie about the Earth is flat, and then convinced people. Is that kind of what you're saying?
No, I'm saying that the ancient people had sort of a reason to think that the Earth is flat, because they just looked at the horizon and said that the sun goes below the Earth to the underworld. Now we know that it's not the case, so we have to change. So I think that there was reason for those people to actually think that the Earth was flat, but not anymore, because we know what happens to the sun or to the moon when day and night cycle happens. And I think there are some people. Sorry, go on.
No, go ahead. There are some people.
No, I was sort of finished. I think there's some people. Like, let's say that there are people who benefit, like if the Earth is a globe, or if the globe is a lie, then obviously there are people who get their income based on that lie. And there are some people, if the Earth is sort of flat, they get income from that. But I mean,
that's kind of what we're getting at. Like, do you think that like the flat Earth, like regardless of Robotham's motivations, but like the modern current flat Earth debate is surrounded by, or was initiated by, people that were planning on deceiving people into thinking it might be flat so they can make money on it? Is that what you're saying?
No. Some people just believe it. But of course, there's some people who actually make money of it. But I know that there are some people. There has to be some people who actually know that it's a globe, but they just pretend it to be flat to get some income, like Nathan Oakley, QE. But like there are some people, many people who actually, I think, just believe that it's flat.
So you think that, if you had to assess the reason that you've been involved in these conversations, like, I guess what I think Gio was trying to get at is, like, there must be some curiosity on your part that we might be right to be in this conversation this long, because if we were obviously as wrong as some ballers make it out to be, then what would be the point in even arguing with us?
Well, I guess I'm just trying to find like the logic in the thinking, and just like to debate. I mean, I think I've been in religious debates, and it's like, I don't think that there's a deity, and I don't think that someone can sort of show to me that there is one. So I sort of can't be shown otherwise, but I'm still in the debate. I don't know why.
But this is more interesting because these are things that we could possibly prove to ourselves, or show in decisively
it's
one way
physical.
or another, right? Yeah,
it's physical,
right?
But
So
then again,
go ahead.
It's actually impossible to show this to some people. Like, they won't accept it.
Well, that's the thing. Is like, I guess it seems like there's possibly an end to this that we all kind of feel is possible. Like, there's There's a way of
I
showing
don't
that
think
it's
that.
impossible for it to be a globe for given reasons or whatever, or it's impossible to be flat for given reasons that no one could deny at some point. Like
I
there
don't
could
think
be
so.
some kind of objective proof given. No,
No, I don't think so. No.
that's interesting because a lot of ballers would say there is already definitive proof, but you're at least saying that there's no definitive proof either way.
Well, yeah, because it's still subjective. Like I asked Nathan Oakley, what would he say if he was sent to space? He'd say that it's fake, that it's CGI and motion, like motion simulation and shit, because you can't have gas pressure without a container. So there is no way of showing Nathan Oakley that the Earth is a globe. It's purely impossible. So the debate will never end. That's a fact.
Yeah, and well, unless there is some kind of definitive proof that beyond is the gas pressure without a container. You know, I guess what I'm getting at is that I wonder why it is you think that people like you and I or whoever else might completely think that the globe side's ludicrous, like completely obvious that they're hiding things, and the tactics used by ballers is making it more obvious because they're just trying to win the argument rather than actually make good points sometimes. You know, you understand what I'm saying? Why is it that we exist? Are we just fooled into these people like Nathan Oakley, like pretending to be flat earthers, and we're just like caught up in their rhetoric? Because we're not like unintelligent people, so there must be something more to it, right?
Sure. I mean, I don't know. I can't be in your shoes because I don't think like you think. So I don't know.
Well, you did such a good job. That's why I'm asking you, because you did such a good job playing a flat earther. It seemed like you kind of like understood the logic behind it, you know?
Yeah, I know the talking points, and I mean, you can have logic that is just sound but not valid. So
I guess that's what makes this conversation interesting. If you have talking points that are sound but not logical, it seems like a contradiction. But I understand what you're saying.
No, but yeah, you can say that if gas pressure requires a container, then the Earth has to be contained. But I mean, gas pressure doesn't require, or the atmospheric pressure doesn't require a container. But I can take your assumptions about gas pressure and then argue as a flat earther. Like I can say that creation needs a creator, and then just ask about the creator because it's creation. But I don't think it's a creation, but I can assume the same thing and just ask and play a theist and ask an atheist, like, where's the creator for this creation?
I would say though that your side kind of begets more if you had to file one on, into the category of belief, that your side has a harder time arguing out of that, because if you believe that gravity acts like a container, then it's obviously a belief because you have no way of showing that, and we're kind of like more on your side that you would be arguing with the people believing in God in a way. We're kind of more on that side. So it's kind of a role reversal for you, isn't it?
I mean, I'm not sure what you meant with that.
Well, I would think that it's easier to call the globe side a religious ideal, to compare it to religious beliefs, because you have a lot of magic on your side that just has to work that way, even though you can't prove it,
Well, we don't. I would say no. I mean,
Well, like gravity acting like a container, and keeping the atmosphere completely contained while it hurtles through space in several different directions. I mean, that's a fantastical claim that you have to believe gravity just answers, right?
Well, you can just say relative density disequilibrium and it works still. So.
Right, but we can show relative density in like practical ways.
Sure. Well, I mean, air is more dense than nothing, so it'll just fall towards the ground. But I gotta go. I just came to work. I have to change my work clothes, but I will listen.
All right, cool. Thanks for answering. Yeah, I was just trying to get that. It does seem like, that relative density is provable and demonstratable, so it makes our side a little bit stronger in that particular issue. If you're saying gravity does it, then it's just pseudo force, and it also contains everything and keeps everything orbiting and balanced and everything. That seems like almost a God claim in my mind. That's all. I don't know if they made the word. You guys were talking about words the other day, Gio, with the way that they're made up. And one of the ones I was going to bring up in that conversation I never got to was the idea that gravity could have been, or could be seen as the combination of grave deity, like either dead god or serious god. Gravity, grave deity. Not that that's the way it came from. I know that's not the origin, but it's interesting to put that together.
Gravity just came from gravitas, weightiness of words.
Yeah. Mm-hmm. But if you think about it as grave deity, it's interesting.
And just weight, right? Gravity means weight.
Right.
From what I understand, if you go back to the earliest time when actually gravity, that the term everybody thinks of gravity, when it first came about, it was early 1900s.
Gravitas.
Yeah, but it was derived from gravitas, which is just originally just the weightiness of your words.
Or the heaviness of things in general.
Actually, I don't think it had to. When you say gravitas, that original term, if you go back to like Greek or whatever, it had nothing to do with like weighing something or anything like that. It was just like weightiness of words, like the heaviness, like
right, like seriousness almost,
right,
like grave,
yeah.
like the grave god would be a serious god, right?
I don't know. I mean. As far as the etymology. Oh, when you guys were talking earlier about with Mailman, he said he came from like religious debates and stuff. I felt like you guys were kind of talking past each other because you said, like objective truth or objective. How did you say it?
Examples or
objective examples. See, he doesn't.
Yeah,
that was what I was going to ask him was if the best thing you can do in a conversation like that is say, do you think there are objective truths? Most of the time when people's on the other side, they're like, say, I don't want to say he's atheist, but that kind of side of the argument, there will be no what's that? Sorry.
Just that I am an atheist. I just got from.
Well, let me ask you this real quick. I know you got stuff to do, but would you say there are objective truths?
I mean, it depends on the definition of the objective truth. Like, what do you mean with it? I mean, objective truth. I exist. That's sort of an objective truth, I think.
So there would be objective things that are objective in reality and nature.
I would say, yeah. I mean, I can't prove it to anyone else, but I would say, yeah. I think so.
But you would say more times than not, everything would be subjective.
Not sure what you mean. That.
Well, typically,
things that happen in reality, I would say, are sort of objective.
Well,
they happen to everyone.
When you said you had listened to religious debates and stuff, I came from that kind of background too, and it's kind of funny because typically the argument goes like whether it's between say an apologist like a Christian or an atheist, the Christian would come from like there are objective truths as far as morality goes, and then the atheist would say everything's subjective.
I think it's just theists add one level to it more. Like, okay, you're saying that the morals are objective, but they're subjective to God, so they're not objective because God can change the morals, so it's subjective still.
So basically, you'd say so. That's what I'm saying. You would say everything is subjective.
Well, the morals are subjective. I mean, I think that's sort of obvious that they are subjective, but
so in that one category. But I mean, then the topic goes on like we're in this arena that goes, one way or the other, whether it's a globe or not a globe.
Yeah.
So
I mean, I think that is objective because that's physical.
What's that?
It's concrete. Well, the earth is physical. Morals are not.
Okay, but you would say that you could objectively prove that the Earth is a globe.
Sure, yeah, I would say that, yeah.
Okay, that's strange. I mean,
Well, then the
fair enough.
conversation wouldn't.
But,
You
I
said
mean-
the conversation will never end. There'll never be a way to prove it one way or another. But then
Yeah,
you're saying that there is a way.
Sure, because there is, yeah. What is objective? Yeah, because something that is objective can be subjective to someone else. Like if there's hard solipsist, he would say that the Earth doesn't exist.
Hey, that's kind of objective would be.
Well, would you say that morals are objective?
Me personally?
Yeah.
Yeah. I would say so, yeah.
Yeah, I say they are subjective. So now there's
Right.
something that you say is objective that actually in someone's head isn't. And that would I would say the same thing about the evidence for the Earth shit.
It's the same thing. It's when you get into splitting hairs, like I think there's some things that are objective. Then you can get into the finer things as far as like the splitting hairs of it. But it happens in morals too. In morals, like, would you say killing somebody is good or evil?
I mean, that's I think that's so much.
I'm saying that's
question.
one. Okay, that's one side of the pendulum. Like that swung all the way to one side, and most people. I mean, me personally, I would say objectively killing somebody like another human being. That's evil.
Well, what is evil? I mean, evil. I think already assumes there's objective morals or a god, and I don't accept that there is such a thing. So, evil would have a different definition or meaning for me than to do so.
Yeah, but if you think everything is subjective, then you would say for somebody else, if it's all subjective, then somebody else that walks along that says, I think it's okay to kill people, then you would be okay. You would have to be okay with that.
Okay with what? With
Someone else saying
that
they think it's okay to kill people.
Well, no, because
you said morals are subjective.
Yeah, because they are.
Well, if morals are subjective, then one person that thinks that it's okay to kill people, you'd have to be okay with that.
Well, I won't have to be okay with the killing of people. I have to be okay with someone saying that it's okay to kill people.
Well, I mean, okay, that's my point. I mean, yeah,
sure, but there are people who think that there's objective morals and they say that killing is wrong, and then there are people who have those same morals but say that death penalty is okay.
Well, I didn't.
So it's subjective, even though you have God as backing of your objective morals. It's still subjective.
I only brought it up because I just kind of had the same background of listening and paying attention to those debates. It's funny how those same type of intricacies in those topics have bled over into this. So you've got globe, not globe, flat, planar, whatever on one side, and then the globe, and then there's like this most of the planar Earth, flat Earth would say that there are objective truths, but then when you start delving into those objective truths, what?
Like most flat earthers would be in the theist corner, and then it's mixed on the globe Earth corner. I haven't seen a lot of atheists.
Okay, let me point out one thing, just one thing in general, like let's say the whole level, horizontal, all that stuff. Most people would say like that's an objective thing. It's like tools that are used as far as objectively. Well, now when you argue with somebody that was on the globe side, they would say that's subject. They would. Somebody on the globe side would say it's all subjective to where you're standing. It's only at a point, blah blah blah. So there's like one side that would say there's an objective.
I would say it's still objective, but like if I have a ruler and I measure something, it's objective. And when I move,
if you have a like geometrically like a horizontal, like I would say that's an objective, like a water level or whatever. It's a tool. It's an objective tool that would establish that. But
Sure.
now, like you would, like I've heard people argue. I don't argue a whole lot, but I've heard people
Yeah.
argue against that and say it's only at that midpoint, just for your perspective, that midpoint.
Right, it's
And if
just
every
between
time you
those 3
move,
points.
and every time you move, it changes. So basically, every horizontal, no matter where you're standing, it's actually subjective to where you're standing.
I mean, I would say, I mean, sure. I mean, because yeah,
Yeah.
I think it's still objective. Like if I have the water level tool, obviously the horizontal line isn't real. It's just imaginary line. It's not a physical line. It's just a reference line between those 2 points. It's not a physical line. So yeah, you can say that there is a line between those 2 points, the shortest path, and that would be horizontal on a globe and on a. I don't
But
know
it's
how that.
well, it's just only from that point though. That is subjective because every time you move, it's not the same. Would you say it's
No,
not the
it's
same every time you
objective.
move?
No, it's objective that from that point the horizontal is there.
But what? But if you move, it's not going to be the same.
Well, I don't know what you mean with that.
Well, if you set up a water level and then you move
Yeah.
it 10 feet, is it the same horizontal? Is it parallel?
It's still perpendicular to vertical.
Yeah, but are those two horizontals parallel?
No, because verticals are parallel.
Right. So that's just subjective. So everywhere you're moving, it would be just subjective to where you're standing.
No, it's objective to the point where I'm standing.
Yeah, but it's
Vertical,
subjective. It's subjective to the last place you were.
I mean, sort of sure. Like if you have horizontal line and another horizontal line, those can be perpendicular. So then horizontal is also subjective because horizontals can be perpendicular or parallel.
Well,
I kind of don't see your point.
All I'm saying is that if you have something like, I would say it's an objective tool that no matter where you go, whether you move 10 feet, 100 feet, whatever, it's still going to be that same horizontal that would be parallel to the last one. But you wouldn't say that, right?
Yeah, because I think we live on a globe where things have weight, and the weight is what gives you the possibility to use the water level tool, and that is vertical.
So you would say the water level would be subjective to something else.
It's subjective. I mean, it uses gravity or whatever word you want to use for that. That the weight of the water gives you the horizontal, and that is obtained from the vertical.
Right, but it would, like, if you move, like you said earlier, none of the verticals are parallel to each other, and none of the horizontals are parallel to each other. Yeah, so I mean, there's really no objective, what's the word I'm looking for?
But there is.
Objectivity to
Things
it.
have weight. Things have weight, and you use that fact to obtain vertical. I mean, that's subjective.
But yeah, but that's what I'm saying though. Just from like where you're standing, that to me that's kind of crazy. Like I would want my tools to be objective no matter where I go, not moving. Like if I was able to establish something, if I move, I want it to be parallel to the last position, but you wouldn't say they're parallel. So how do you work that out?
Well, like work it out. Do you mean how do I figure it out, or how do I square with it? Or
Well, I mean, if you have a tool that is it's supposed to be objective, creating a horizontal, and then if you move, it should be, I would say, parallel to the last position so that you can make accurate measurements. But you say it wouldn't. So if I have one horizontal and then I move 100 feet, if it's not parallel, so that I can make measurements between them, how do you work out the difference?
Well, let's say I say that because the Earth is a globe and we have gravity and things have weight, that's why you can use the water level, and that's how it establishes the horizontal. What would you say is the case? Like, why does the water level do that?
Just creates it's a zero pressure state.
Zero pressure state?
Yeah, if
You
you have like
mean hydrostatic equilibrium?
one long tube, it's just at the top of the water, it's just a zero pressure state that equalizes.
Sure.
Yeah.
But what form does it take on the horizontal? Like the pressure layers on Earth would be horizontal.
Yeah, all the way along. It would be that zero pressure state would just be a straight line. You agreed with that earlier. You said it would be horizontal. It'd be a straight line.
What would be horizontal?
Sorry, it broke up. I didn't hear you.
Yeah, what did I agree to?
Oh, just a while earlier when we first started on that part of it, that aspect of the conversation, you said that you did agree that there was a straight line between those 2 points.
Sure, but it's not a physical line, so I can take 2 points anywhere and just imagine a line between those 2 points. It's not a physical line. It's just imagine.
Yeah, but I mean, you could still use those 2 ends that creates that zero pressure state and make marks. Then if you moved it, I would say me personally, I would say that tool is objective, so that if I made 2 marks, moved it, I would expect that next horizontal to be parallel with the last one. Whether it's higher or lower, it would still be parallel.
But to me, like I said, there's cause for the curving and the not being parallel that I've said. You seem to just say that the pressure layers are flat or horizontal, and how do you know that? And do you have any reason why they would be that way?
Just physics.
Like, what gives you the idea? What physics?
Hydrostatic equilibrium.
That forms a sphere and it has gravity.
No, it's just a zero pressure state that creates a horizontal at all points along that zero pressure state.
But that's not hydrostatic equilibrium, because hydrostatic equilibrium is pressure and gravity.
You should. I don't think you're right about that.
I mean, that's what it says with physics. Like if you Google it, I can just Google it now.
Hydro is, liquid. Static would be at rest.
A fluid.
And then at each end of it would be a zero pressure state, and it would, between the 2 points, you'd have a horizontal at all points along that zero pressure state.
Yeah, it says that in fluid mechanics, hydrostatic equilibrium is the condition of a fluid or plastic solid at rest, which occurs when external forces, such as gravity, are balanced by a pressure gradient force.
Well, I mean, just down. I mean, what?
I mean, if you're talking about hydrostatic equilibrium, it has formula, which has G and M and R in it.
Every time I've seen somebody do the formula, and I'm not versed in that, so I don't know. Every time I've seen somebody do it, the G always cancels out.
Don't think it cancels out. I'm going to post a picture of it. But yeah, I mean, I still think that the hydrostatic equilibrium is just.
So you're saying that it wouldn't be now? Like if you had that zero pressure state, you're saying it wouldn't be horizontal all along that zero pressure state?
Well, not according to, if you're using hydrostatic equilibrium, then no, then that would be a sphere.
Then why did you say earlier that you would say that the water level would create a horizontal line?
Because the horizontal line is not physical, and you can imagine a line between any 2 points. And if you have weight, then with the water level, yeah, the both of the ends are at equal elevation. So sure, it's a horizontal line between those 2 points. So
well, this was like at the beginning of the conversation. This is what I was getting at, was that you would say everything is subjective to whatever the case may be, subjective to gravity, subjective to all these different forces, whatever. I would say it's subjective. That's all I was getting at. I didn't mean to get into that whole thing. I know everybody gets bored with it. That was all I was trying to point out, was that you would say like all these things are subjective. It's subjective to this thing. I would just say it's
Oh,
subjective.
no, I would just say, no, like my weight is subjective then, because I mean, I weigh differently on different points of the earth.
Sure,
I mean,
exactly. That's fine. That's all I was trying to point out, was that when it comes to these
sure, but
topics and you try to
you
get
have to
into,
accept
like,
it too.
delve into like a certain thing, when one side would say something's objective and then somebody else would go through all these different things to point out the subjectivity of everything.
Right, I still don't. I mean, water level or
I'm
stuff.
I'm just saying we were just talking about
We
talking
agree.
about little banter about like the water level, just in general, talking about it. I would say it's objective. You gave all these different reasons why it would be subjective to different things, and
No,
then
but what is subjective? What do you mean with subjective there?
different, like, when something is objective, it is just, it's true. It's a self-evident, like, truth. Like, subjective would be things can change, this can change that. Like, I don't have the exact definitions in front of me, but
what did I
know
say?
the ideas.
Sure, but what are you saying that is subjective about like the horizontal for me? Why is it subjective instead of objective?
Because it would always change no matter where you are. Like, if you took it from one point,
Yeah,
and you say that is okay, that's horizontal from this one place. If you moved, it's not the same horizontal. It's a different, which goes against, like,
sure. But what if
geometry.
you? It doesn't though. But what if
Okay,
you take?
all right. Let me put it this way, just real quick.
Okay.
If I have a horizontal from one point, and I actually physicalize that horizontal from where I'm at, my reference point, and I have the vertical at that one point. Well, all geometrically, all along that horizontal from my point, every perpendicular to that would be vertical, and they'd all be parallel. Would you agree with that?
If you were on a plane, then yes, without gravity, yes.
See,
then it would be.
There's the if.
Yeah, I mean,
Do you
agree.
personally?
No, but if the Earth was flat, then sure, that would be the case.
Guys, I've just had to stop my Spotify. How is everyone?
Think we're good.
Fantastic. Pretty good's always better than usually good.
Yeah, I mean, I'm at work, so. But it's still, yeah.
I've just basically just brute forced my way in here. How's everyone doing? Old friend of Geo's. How's Geo? Geo here?
Yeah, I'm here. Yeah, what's up, Rotten? Good to see you, man.
How you doing, man? You all right?
Doing good. Yeah. It's been a while. Good to.
Oh man, long time. No fucking here. Yeah. Are we live streaming?
Yep. Yeah, we're live now.
Oh God, I've got to behave. That's not good. Okay. Okay, I'm gonna behave. So how you doing, man?
Pretty good. Pretty good. How about yourself?
Yeah, still spreading the truth, taking the toll. About yourself? I'll tell you what, I'm really impressed with this server. As soon as I've come in, it's like you can tell just with the channels that you've made, you've got like a seriously fucking awesome server, dude. Like I've just rocked up, right? Like if anyone, I don't know what the whole rigmarole is. I've probably just disrupted everyone's fucking breakfast right now compared to where you are in America or whatever. I'm English, by the way, if you haven't guessed. Yeah. Seriously, dude, you've got a great server here. How long you had this for?
Yeah, well, we've been up for I think about 6 months now, maybe 6 or 7 actually. I think we started in like September. But yeah, it took me a long time to get this all built. Really, actually, kind of a couple of years on and off. I mean, I wasn't working on it nonstop, but yeah, I mean, I kind of first started working on it a long while back, and then slowly but surely kind of got it all finished, and then I launched it, around last year.
Hey, I'm impressed. I really am. Yeah. It's very nice. I do apologise for not joining it sooner, to be honest, because I was a little bit dubious. I was like, yeah, it's just Geo being Geo. You know what I mean? But hey, mate, fucking hell, this is awesome. Everyone's how cool is everyone though? Like, you know.
It's good. Yeah. I mean, we've been doing live streams and some live shows, and it's been great. We've had a lot of in-depth conversations. It's a lot of people that have been in the community for a long time, so it's a lot of
old schoolers, yeah.
Yeah.
Cool.
Then it kind of varies throughout the day in terms of conversations, and the activity levels kind of varies, and it's fun. It's every day is a new day. It's always
the best days. The best days, mate. Yeah. No, seriously, mate. I'm fucking impressed. I mean, check you out. Yeah. I hope this does well. Because what's the general ethos then? Would you say, if I've just rocked up, and what would you say is your ethos for the whole server?
Well, that's a good question. I'd like to hear, if some other people have some thoughts as well on that. But also, I think in the welcome section, there's like some kind of explanation there as well, kind of the mission statement, the kind of vision and all that. I would say, to have an open platform that everybody can speak their mind and
not get censored.
Yeah. And also,
is that true or false?
Well, I think, if there's the only thing is that, like, one thing that I was always frustrated with in a lot of these communities is just all the insults and, people beating each other. And I know that, sometimes that can be fun or entertaining. I mean, I sometimes it's humorous.
No, it's just fucking annihilatingly boring after a while. Yeah.
Yeah. And I think in a way it kind of detracts from getting to the root of the information, because once there's a good convo going, and then once that happens, it just sort of devolves into the name calling, and then it sort of loses the actual information of what was being.
Well, it just distracts from the real core of why the hell we're here in the first place, right?
Yeah, so I think if anything, we try to moderate, as much as possible with that. I mean, obviously we're not sort of excessively strict, but trying to not have it go into dumpster fire territory. So if anything, that's a factor, and try not to, the over talking and, that kind of stuff. But there's no censorship at all in terms of people's viewpoints, and,
that is fucking awesome. That is great to hear. Thank you very much. That's awesome. So I can speak my mind, and you know what I mean? You won't censor me, yeah?
Yeah. I mean, the only thing is, the whole, pandemic stuff or whatever, just since we're on YouTube and whatnot, that's the only topic, the jabs and all that. And apparently Discord has been kind of cracking down on that more too. So
what's this about a pandemic? I've never heard about it before. What's going on? I don't watch TV. I don't watch TV. So what are you on about?
Well, then you wouldn't know anything about it.
No, I don't.
On Discord.
I haven't watched TV since 2007, so I'm sorry, I ain't got no virus.
On Discord, I think you can talk about it, but if you post something on text chat about some medical advice, you might get your server taken down. So.
Yeah, I totally take that nod. I totally take it. I understand it.
I mean, that's the only topic that, we're just trying to be somewhat cautious on, but yeah, I mean, I think part of I think what's cool, like if there's at least some level of a standard of mutual respect, meaning there's not just the constant insults and berating each other and belittling each other. The cool thing is that if it can get into like you were asking about kind of the ethos or the kind of vision in a sense, like where if there's at least enough mutual respect where people can share their minds, instead of feeling like they're gonna, people are just gonna be insulted and attacked for their viewpoints, I kind of see it almost. It's more like a garden, and everyone's kind of throwing their seeds into the garden, and then if you like something someone else is saying, you can resonate with it, or vice versa. So I think like when there's a level of respect, then there's kind of more community and more exchange that can happen.
That is the beauty of community. You know what I mean? That's why we're all here. I think personally. You know what I mean? Yeah, definitely. Yeah, cool. I'm glad to be here. Thank you very much for accepting me, guys, and thanks for bringing me in so quick. I suppose because I suppose if I was a random, I'd probably have to go through a few more hoops, right?
Yeah, no, it's awesome. Yeah, I mean, I haven't chatted with you in a long time, so yeah, I'm glad you found us and came in.
Hey, Gio, is Rotten one of the guys that you were saying you missed talking to that I was trying to figure out the other day? Maybe it's one of them. At least I couldn't remember who it is you were referencing. There was somebody that you hadn't talked to that you were mentioning, and I had never heard of him. No, maybe not. Either way.
Yeah.
Maybe it doesn't matter. But at the end of
there was an interesting conversation you came in on.
I know Geo from like the old Ice Wall servers, and but when was it the what's that server called? Fucking 24/7 Flat Earth, where sheeple like overtook it and shit. You know what I mean? He like just fucking hacked it, didn't he?
Yeah, the old I guess I don't know if people refer to it as the 1.0 since now they do 2.0, but yeah, that original.
I seriously think that I'm a little bit I wouldn't say left or right. I'm a little bit sort of anarchist, you know what I mean? I don't like any rulers whatsoever. I'm basically my own person. I'm just saying this as a little bit of a sort of disclaimer, would you say? But I definitely I don't know. Maybe it's just me, but like 24/7 Flat Earth Discord, so it's like the new fucking. Oh, could you really say that? You know, can you really say it? Like the new Flat Earth Society? Oh, no, I didn't say that, did I? Did I say that? I did. Yeah. So it gets me into trouble a little bit, you know what I mean? Maybe.
I don't think anyone here is gonna criticize you for being critical of any kind of
that's what I do. I just ask questions. Yeah. I'm just it's just my opinion at the end of the day.
It's hard to I imagine make that kind of sweeping statement when there could be lots of people involved in that server that don't have any clue of what you're saying. But maybe there are. I don't know.
I don't know. I'm just you just weigh up people's incentives, don't you? And then you put them against, why do people spend themselves so much time online in certain servers? Is there a monetary objective to it, or is there something more? You know what I mean? And the people that have true incentives, like Geo here, because I know Geo has a genuine incentive. You just it's a no fucking brainer. You know.
Feeling as well, which is why I'm here.
Yeah. Well, I'm not joking when I say that I left this whole community about a year and a half ago through the COVID bollocks, for my mental health, but now I'm back for my mental health. Strangely enough, figure that one out.
That seems to happen. That seems to happen a lot, actually. People go away because they need a break mentally, but then they can't stay away
like,
because they need the mental fortitude. Yeah.
But like I'm surrounded by fucking morons. You know what I mean? I'm surrounded by fucking NPCs, and like I need people that I can actually seriously talk to. You know. And you guys are the only ones I can fucking talk to. So thank you. Everyone that's here, Geo especially, because you man, like 2 years ago, was the only guy that I could possibly talk to. So fucking yeah, you're all fucking legends, all right? Anyone that's here, I hope, is here for the truth. If you're not here for the truth, then you can fuck off. As far as I'm concerned. But I don't want to.
Well, that's what makes this discussion interesting, because we're trying to figure out psychologically where people are at on the other side.
Exactly. It's like I love learning, right? I love failing at learning because it makes me understand and learn from fucking failing. I love it.
Right.
It's like why can't people just understand that fucking being a fuck up can actually turn you into a fucking genius? In a sense. You know what I mean? It's like you have to fail to really realise what's going on in the fucking world.
Right. That's a beautiful thing, actually, because then it becomes like a win-win no matter what. If you fail, you win because you've learned.
Yeah. And like, I'm a little bit pissed now, so I'm going to give the mic over to someone else.
Well, there was an interesting discussion that you came in on that could pick back up. I don't know if Mailman's working and too busy to continue with what was being said before.
We can talk. We can continue.
Buster, I've never heard you before, but that was a great little back and forth you guys had going. I don't know if you want to try to pick it up, but what I was going to add to that, at least beforehand, maybe even, is that this whole discussion's kind of what's interesting about it. Like we were comparing you said something, Mailman, about like you think most flat earthers tend to be theists. And I was making the comparison myself to the ballers versus flat, as the ballers having more beliefs. If you really wanted to get down to the nitty gritty, it might be that the ballers have more beliefs because they have to believe in gravity and some of these magical answers that flat earthers aren't satisfied with in a practical sense. And this whole thing about it being like pointing the finger at the other side and saying, you're the one that believes, and no, you're the one that believes. And this guy brought up earlier today, actually, there was something someone was bringing up about LIGO, and well, LIGO says this, and then the flat earth side was saying, well, we don't believe LIGO. And then they're saying, well, you're not believing it as a belief. And whether that's actually categorized as a belief, if you don't believe something, is that a belief in itself? You know, and I think that's where this argument could just go in circles, where just because we don't believe what NASA's saying, it's not that that doesn't make it a belief in its own right. And then in a larger sense for the discussion, because we don't believe the Earth is a spinning ball, doesn't necessarily categorize us into claiming that the whole thing is flat, which is how it gets pinned sometimes, and frustrating for me, at least.
I think
you're not the only one that gets frustrated, mate. Don't worry about that.
But I think it is kind of weird, like flat earthers, like most of them, well, yeah, I would say most of them are probably theists. And some just accept the Bible with little evidence. But then when it comes to like the physical shape of the earth and things, they just say, no, I need more evidence. So it's kind of strange that they believe something with little evidence, but then something concrete they don't believe. They just need more and more and more evidence all the time. I think it's interesting.
Right. That's what I'm kind of pointing out. Like, first of all, I would say that I don't think that most flat earthers are flat earthers because of a biblical belief. Even though I think that most flat earthers would have to say there's a creator, quote unquote, or whatever, because that seems to be in some people's minds the necessary antecedent, right, to creation. But regardless of that, yeah, that's what makes this interesting, because we're on the one side saying, no, that we need proof, but then at the same time, you know, there may be more of a jump towards that theist belief.
Oh, listen,
as far as
flat
that
earthers
goes,
don't
but-
need proof, right? Seriously, it's the heliocentrics that need to prove to us.
I
it's
agree.
fucking
That's what I mean.
heliocentric,
That's what
right?
I mean. Yeah, we need proof that it's a ball, like real proof, not just gravity. You know, painting with a wide brush. This answers all the questions. Gravity, or whatever it is that you have to believe.
And I would say the same
To
thing.
believe in a
but I would
mystical
need some
theory that's
evidence.
never been proven. Okay, fine, all right. Just get me another fucking beer and I'll fucking believe whatever you fucking want, dude.
I would just need evidence for the flat Earth. I think we're on the same point.
But this kind of, I was kind of
Okay.
trying to lead this back to what Buster and you were going back and forth about.
Evidence number
objective
one.
truth.
Just stand still, right? Look around you, and do you feel like the world is spinning? And now you've not got to take any drugs. You've got to be completely drug free, and you've got to just stand still on your own. Stand still. Can you do that? Can you do that? All right.
That's
Do you
so
feel like the
subjective.
world is spinning?
No, that's just like I can.
Evidence
Welcome to
number
Flat
one
Earth.
for flat earthers. Evidence number
I
one.
just,
Yeah, but that's still
Yeah,
subjective because objective
No,
is,
it's fucking not. That is fucking
Well, it is,
physical,
because-
goddamn, repeatable evidence. That
But
is
it's also
scientific,
repeatable that I can-
goddamn evidence.
But it's also repeatable that I can stand on a train and not feel it moving while it moves. It
Do you
doesn't
feel
make the
like you're
train not moving.
spinning? No. Of course you don't. Because
Sure.
you're not
And when
fucking
I'm standing
spinning
in an
around.
airplane,
Should
I
you?
don't feel like
Should
I'm
you feel like you're
spinning.
spinning if it was spinning?
Yeah.
Should you feel like you're spinning?
You ever
If
been
it
on a
was spinning?
fairground ride?
Sorry,
You ever been
If
on a
the fucking
fairground
thing's
ride?
spinning, you feel it spinning.
I can only
haven't
hear
been on a
one
fairground.
person at a time.
all I
Have
was
you
saying
never been on a
earlier was
Been
fairground.
on a fairground ride?
the difference
I don't know what
between
that is.
subjective. Hang on, the
I
difference
haven't
between
been-
subjective and objective is the subjective is all based on personal like feelings, beliefs, opinions. The
Yeah.
objective like does away with that.
Yeah, because I mean, I've never been on a fairground ride that rotates at 15 degrees per hour and it has a radius of 39, 59. Never been into those.
So the argument seems to be that
I've actually, sorry, just quick. I've been in a restaurant that is rotating much faster than 50 degrees per hour, and I didn't feel any motion.
which restaurant?
In Finland, in Tampere, there is a large, like a tall tower that has a restaurant on top, and it's rotating.
Oh, really? How fast does it rotate?
I just gonna check it out. Just a sec. Don't remember.
All right. But it takes less than a day to complete a full turn.
Well, much less than a day.
Right. Oh, that's interesting.
Well,
I never
boss-
heard about that. That's a good point. It's a good point.
But Buster,
But
do you think is it objective if nobody can can experience any type of movement of the Earth? Is it, even though it is subjective from the individual person, but does it then become objective because everybody agrees that the Earth is not moving?
I just
Sorry, quickly.
No, I mean
quickly,
being a consensus doesn't make it objective. I mean, everyone agreeing with something doesn't make it objective.
The tower that I've been to rotates once per 45 minutes. So yeah, I didn't feel it. So
All right.
it's much faster than 15 degrees per hour. It's over 360 degrees per hour. It's actually,
But we're talking about axial rotation
Like-
compared to surface speed. Then can't we just like cut through the difference between that and say that, yeah, 15 degrees an hour axial rotation is totally different than being on the surface spinning at 1,000 miles per hour. You can compare that to the whole and say that it's relatively not as fast as you might think, but it's still 1,000 miles per hour.
But that's
in
that's
relation to what?
miles per hour is just speed. You don't feel speed. If you're talking about rotation, then you don't use miles per hour to refer to rotation, right?
Well, I wouldn't say you don't feel speed to begin with.
Well, you don't.
So how do you feel speed if you're in a Concorde that's traveling to Mach 2?
Okay, well, then we have to get into the idea that it's if it's a oblate spheroid, it's not a perfect circle. It's constant acceleration compared to linear velocity. All of those details. I think if we really worked it out, there might be some. And then we're talking about elliptical orbits, and there's all these kind of things that seem to be accepted on your side that just kind of like, oh, we'll just accept that we don't feel speed because if you were on a one linear plane direction, you may not feel it, even though you can kind of feel it, in my opinion.
Kind of feel it. How do you kind of feel it?
Yeah, on a plane, you know that you're in motion. I know friction and all that is an argument.
Yeah,
without friction,
there are a bunch
it has
of
to be like it has to be such a perfect system with all these different rotations and the vector graphics being used mathematically to convince us that you wouldn't feel a thing when on our side we might reason that there would be a point where there might be a little bit of a change in acceleration or momentum or just a balance of any sort with elliptical orbits and oblate spheroids, and it has to be so perfect in your mind, continuously perfect.
No, it doesn't have
that
to be perfect.
there would be no hiccup whatsoever that would ever make us think that there's a motion to this whole thing going on.
That's no one's
That
argument.
seems unbelievable from our
That's
side.
no one's argument. It's just a straw man.
Yeah, no one said.
What do you mean? That is the argument. It feels perfectly
that's no
serene
one's
and still,
argument. That is
right?
All
All these motions are going on, and we feel nothing.
Perspective.
Here comes the change up.
Yeah, it's not about it's so perfect. It's just about magnitude. If it's a small magnitude and it's way lower than it has to be for you to feel it, it has nothing to do with being so perfect. So it matches so well that you don't feel it. It has nothing to do with things matching or being perfect or synchronized. It has nothing to do with any of that. It's just that it's a very small magnitude of a value for you to feel. And if you think you should be able to feel something in an airplane, just picture how you feel when you're moving or when you start moving. We know that it comes from our vestibular system, and we know how that works. You have like crystals on a liquid. I'm not know exactly the specifics, but if you do something similar inside of an airplane, like you pick a liquid, you put some crystals inside. And when the plane reaches a constant speed, if those crystals aren't moving inside of the plane, then they're not moving inside of your vestibular system. So if the crystals are not moving in the liquid, you're not going to feel anything. So for you to feel, the crystals would have to move in the liquid when the plane is at constant speed. So
when I say perfect, then what I mean is that it has to be so perfect to keep it within that range of the small magnitude that's acceptable.
No, but it's way lower. Just like the example Mailman gave is something that spins 32 times faster than the Earth, and he still couldn't feel it. So it's not perfectly within the range. It actually could spin a lot faster than that.
But if you actually measured the miles per hour of the outer circle of that spinning restaurant, what do you think the miles per hour would be?
Yeah, but motion isn't feelable, right? Your rotation is
because it is.
How is it?
But hold on, if I take the restaurant and I enlarge it so that the radius would be so that the outer sort of the rim of the restaurant would rotate 1,000 miles per hour. if I walk from the center to the outside, would I feel different when I arrive to the outside, even though everything's connected?
Yes, you should.
Yes, you would.
You would.
Why?
Yeah, the centrifugal force would increase as you go to
Why?
the edges.
Because it's faster.
It's not faster. It's 50. It's one revolution for 45
No, but
minutes.
the centrifugal.
That's
Yeah,
my
but
point.
that's the rotate. That's you feeling rotation, which is different than you feeling centrifugal force.
Sure, but
Uh,
just if the rotational speed is the same and I go further out,
yeah,
I
if you're
think I would still be the same or
if
less.
you're stationary, in either point, you wouldn't feel the rotation, but you would feel a different amount of force. So if it would feel heavier, and your vertical would be tilted because of the centrifugal force, but you wouldn't feel the rotation more, but just because you're rotating.
But if I have something rotating and it's rotating at similar, like let's say 15 degrees per hour, and I go further away from the center of rotation, how would the G forces change?
If you're rotating at the same time in a larger distance, that requires a bigger centripetal force to keep you in that rotation, right? So you would feel it. I mean,
So,
that would not that you would feel it, but it would be a bigger force, right? So you'd feel your vertical tilting.
which way? Which way?
Hmm?
Would it tilt inwards or outwards?
Like the top of a plumb line would tilt toward the center. The bottom would tilt towards the outer, towards outside. That would be the change in.
Like if I have the same speed or the same like 15 degrees per hour. Oh.
I'm not sure if I'm getting your question.
Yeah, I'm just like if there's well, let's say there's a merry-go-round and you're 1 meter from the center of rotation and it's rotating at x amount, like 1 rotation per hour. The further you go towards the outer, or like away from the center, you're saying that you'd feel more G forces or
Yes.
centrifugal force.
Yes.
Oh, interesting.
Because
It's not like intuitive. It's not intuitive for me because I would say that it's less because you're getting further away and you're churning less and less and less all the time.
Yeah, but you require more acceleration just to keep in that same distance from the center. If you're going faster and you're still rotating at the same like rotation rate, it requires your speed to change more towards the center, right? So it increases the centripetal force.
But the radius of my turn is all the time getting lower and lower. But I'm still moving faster. Yeah. Interesting. I didn't want to hijack the discussion with this.
No, that's fine. It took a nice.
Yeah, I felt like Bacon was almost arguing my point for a minute there.
No, that there are certain ways that, for example,
we can measure or calculate how much the G forces would be on the supposed Earth.
Yeah, and this the same way, like centrifugal force would increase as you go away from the center. It should increase as you go from the poles to the equator, and you should be able to measure that. That's not an insignificant value. That's something you should be able to measure with a pocket scale.
Was it 0.3% at the equator? Was it 0.3% less at the equator because of the centrifugal?
Compared to the poles?
Yeah.
I don't know. Let me check it.
If I remember correctly, it was 0.3%. I'm not sure.
Yeah, we don't have to get into the details of that any further, other than maybe just to, if I have anything more to say about that, is as far as me saying it was perfect for, for us to feel like it's completely serene and still without any movement. Like everyone agrees, we don't feel any movement, not like even a little bit ever. So it would have to be perfect to whatever degree for it to work that way with all of these rotations accepted. Like if you were just told all of these things and you didn't have the mathematical understanding or the the explanations that go along with it, anyone would also agree that that seems ridiculous on the surface. Pun intended.
I don't think it feels like ridiculous. Like, why would we feel it? I still don't know.
Yeah, I think it sort of makes sense, like in a very intuitive way, because usually whenever you're rotating your field and whenever you're not, you don't. So if someone says, well, you're above something that is spinning, maybe the most intuitive thing would say that you should feel it. But that's just like the first thing that should come to your mind. The second one would be to try to make a more realistic assessment of the whole situation, or to put more thought on it. Don't just stick with your first intuitions. Just think a little bit more. So if you just apply, just put the numbers, right? The size of the Earth, how fast it rotates. Now you can make a better assessment on whether or not you should feel it. And you shouldn't. Even if you rotate faster, you shouldn't.
And it's not like the Earth suddenly stops sometimes and then accelerates to one direction. Stops. And our down and up is just in relation to the Earth.
Anyway, so yeah, but there's a lot of people in here I bet that might want to say some things about this or have a comment to make about whether the actual speed of the Earth spinning and the actual rotation, the axial rotation compared to ground speed, how many flat earthers are able to accept that we wouldn't feel the motion, and how many flat earthers feel like that's even with all the math and all the justifications, it still doesn't really add up that we wouldn't ever feel anything.
You don't feel it, but you can measure it when you go forward.
I mean, yeah, there are better things that they're more sensitive things than your vestibular system.
I think a lot of flat earthers would also accept the continents are like moving. We don't feel that either.
Really?
Still motion. Nah, they're not sure.
You think a lot of flat earthers think the continents are moving, but the Earth isn't? Is that what you said?
No, that they accept that the continents are moving towards each other and away from each other, but you don't feel the motion either.
That's an interesting question.
Isn't like Australia like moves 70 centimeters every year, something like that?
Could well be. Yeah.
Well, often what I think about when I think about sort of the spinning Earth and gravity and all that is that when you look around and you see all the trees and, they're all, dropping a leaf comes down from the tree or whatever it may be, and it's like gravity would have like this Earth, if a globe was spinning and then you had gravity, it's like those two things have to be synced up to such perfection that it all seems like it's actually just stationary and still as it is, other than the little wind blowing or whatever it may be. But this theory that the heliocentric concept that, is being kind of sold to people, you have to somehow believe that the gravity force is not just sticking things to a ball, but it's perfectly acting on every single piece of matter to make it seem and appear as though it is actually just a stationary surface.
I think
that was my point.
I don't think that makes any sense.
The gravity could be 11 meters per second squared or 8 meters per second squared. It would still fall down. I mean, it isn't perfect. It doesn't have to be perfect.
Yeah. What exactly is being perfectly synchronized because as far as I understand, I mean, gravity just cares about how much mass you have, and that's it. There's no extra anything to synchronize anything.
Yeah, if
Yeah,
everything
all
weighs double, then it would still be the same thing. Things would still fall down. Or if things weigh half, they'll fall down.
all motion is relative, unless it's a pendulum or a Cavendish thing or a gyroscope, where you get to think that that's a fixed
Still,
point. But
No, they're
other
still
than that,
relative.
everything's relative.
They're
they're
still
still
relative, but they're not inertial. Being relative doesn't mean inertial and non-inertial doesn't exist.
Yeah, for them.
Well, the next question about relative motion, gentlemen, is relative to what? Unless we can find all the things that motion is relative to, even that statement is problematic unless we can find everything that all motions are relative to.
Yeah, obviously, motion is relative because I can be in motion and see someone in motion while appearing to be stationary.
I would agree with you up to a point, Malaman, but because of the implication of needing to find everything that all motion is relative to and the impossibility of being able to find everything, even that statement is problematic unless you're saying that you can find everything that all motion is relative to. It would have to bottom out at something that everything is relative to at the very least.
But hypothesis, we don't need to find an ultimate reference frame in order for us to know that motion is relative. You just see that it's relative in two reference frames, and then you know that it's relative. You don't have to know if there's an ultimate reference frame.
Well, I guess the only problem with that is you're saying we don't need to know that motion is relative by discovering any and all things that motion is relative to. That's a bit problematic because at that point you're saying we know motion is relative, despite the fact that we don't necessarily know all of the things that motion is relative to. That's a bit problematic, is all.
So I don't see how it's problematic to say that motion is relative, but I don't know if there is a ultimate reference.
Yeah, I mean, when you do things under inertial frame, and then you move to another, also inertial frame, everything works the same.
Everything is in an inertial
everything
frame
that
in your system.
everything that you predict under inertial frame is also predicted by another inertial frame, regardless on how they are moving regards to each other. So even if there is an objective inertial frame, all inertial frames seem to be compatible with each other. So we completely unnecessary to have the objective one because it will be as useful as any other inertial frame.
Well, the only non-inertial reference frame we normally reference in these talks is something spinning. But the only way that we know something is spinning definitionally is if it is spinning relative to something else that is not spinning. That thing that is not spinning, the background, space, or the ether, if you ask me, would be the absolute referent to give us spin in the first place.
No, if you're just referring to a spinning frame or a rotating frame of reference, that is fundamentally different than an inertial one.
But you
So
can't
there are
have spin.
physics doesn't. The physics of an inertial one doesn't work the same as a rotating one.
I'm just dealing with the definition. We're saying this is a spinning frame, fine. Definitionally, you only have something spinning relative to something in the background that is not spinning. And
Inertial
so
one.
that would be the absolute or the most absolute reference frame, the background that it's spinning in.
No, the
Well,
absolute thing that. All right.
It's just that you said that you have to have something. If something is spinning, you have to know that there's something that it's spinning against it, and that is motion being relative, and still you don't have to have an ultimate.
But the most absolute standard would not be the spinning frame itself. It would be the thing that it's spinning against.
Against an inertial one.
Of motion.
Yeah, I can have something, but I can have something spinning against a spinning.
No, the rotating frames of reference are spinning compared to inertial ones, and that's you can flip that. You can say that the inertial one is actually rotating and the rotating one is inertial. That doesn't work. So it's not as relative as you might be suggesting. Inertial ones are fundamentally different than rotating ones. Inertial ones don't have pseudo forces. Rotating ones do.
So what are you trying to say? The world is flat.
He's saying you could model anything however you want because all motion is relative. And if you assume any fixed point, you could model anything around it.
Yeah,
It's
said
all up in
anything.
the air.
Well, this
Wow.
goes
So
to
you're
the
trying to tell
Something
me?
that no one ever said.
Can we rewind? Yeah, yeah. Are you trying to tell me that everything that I was taught at school is bullshit?
some of it, not all of it, maybe just some of it. The part about the Earth spinning. It looks like we're trying to determine whether it's spinning or not, and we can't even decide whether we can tell if the Earth is spinning, inertial, non-inertial, or not.
Well, where's the proof of that then?
A bunch of philosophy, a bunch of conjecture, a bunch of assumption.
Let
I
me
don't
guess.
know.
You're gonna tell me that there's proof of some kind of like water level or something. You know what I mean? You're
We
not
need
gonna
some
tell me.
way to prove it.
You're not gonna tell me water levels.
Well, when we're talking about proof,
An actual evidence of proof, are you?
we need
Are
some
you?
sort of tiebreaker to break the tie between it being a moving, spinning ball or something else. So we need some
Surely,
sort of tiebreaker to tell one versus the other.
surely, right? I know because I was like, I was taught as a kid, right, that water can stick to a ball. That's what I was taught as a kid when I was about 5 years old. I was taught as a kid when I was about 10 years old that water can stick to a ball.
Do
Oh,
Yeah,
you
I
still believe
haven't
that,
you ever
or
said like
have you changed your
wet
belief,
balls?
or what?
it's amazing. Oh no, it's fantastic. Honestly, if you've never tried this kind of make believe, it's fucking fantastic. Honestly, like go for it. You just have to just let go of everything and like forget everything that you've ever thought about before, and just think about water on a ball. You know what I mean? That's all we have to think about. It's fantastic, really. It's like you
The
just
first thing
fuck
you
every
need is a water. The first thing
yeah.
you need is a ball that's so big that it looks flat, and then you could think
Yeah,
water sticking to it.
yeah, you know what I'm saying. Yeah, there you go. So I mean, it's like who cares? It's like, alright, I like Santa Claus, yeah? Alright, Santa Claus, move over. I've got fucking globe here, you know.
It's the Santa Claus for adults.
You know it, mate, yeah. I mean, why even stop there? I mean, I could go on, but like, I don't feel like I should. I feel like I could take the piss so much. But I don't want to because, like, I used to be you. I fucking used to think we lived on a fucking ball. And you know what the globes used to fucking... No, I'll retract that. Sorry. Do you know what they commonly misconstrue is the fact that we used to fucking live on a ball. They conveniently forget that we used to think like they did. Yeah, fucking weird, isn't it? Oh, it's so weird that the people that we're arguing or trying to persuade, we actually thought the fucking same. But yet we're the villains, right? Yeah, we're the fucking idiots. We're the fucking idiots. Because who would ever fucking think about a flat Earth, right? Yeah. Such a dumbass move, right? Yeah. Such a fucking dumbass move, right?
Well, I guess
Maybe.
I mean I can't speak for all of globe earthers that are kind of here trying to assert the globe, but perhaps they are trying to get us back into the thing that they still believe. I suppose, like they know that we used to believe it, but I guess they think we've gone, off the rails, and they need to get us back or something.
I think the fact that you changed your mind is somehow an evidence for your position. It's just not a very good argument. That's just no argument at all.
Sorry.
It's just saying, well, if I change my mind, there's probably there. Oh,
can you repeat
my thought here?
Sorry, can you repeat that statement again? Sorry, I didn't hear that.
Yeah, the fact that you changed your position on something isn't actually an evidence that you have the correct position now, just because you changed it.
But
the reasons why you changed it are...
Did I change my position? Are you? So you're saying from like Glober to Flat Earther, yeah?
What I was listening right now is I was like you. I believed in the things you believe right now. That's the sort of things I was hearing like a couple seconds ago, as if that was something relevant. And I'm just pointing out it isn't.
Oh no, it's completely irrelevant. It doesn't matter whether the fucking Earth is flat or fucking round, mate. It doesn't matter at all. It doesn't matter whether people fucking lie to the masses or anything. It doesn't matter.
That's
it's
the
very
point,
inconspicuous.
when I said doesn't matter, it doesn't matter in a way that points it makes any evidence for your side or the other.
So what's your point? What's your point?
The point is that if I change from A to B, that's not evidence that B is the correct position, is it?
I don't get your point though. Seriously, fucking please tell me your point.
It's pretty easy. It's just the thing you just said. I used to believe, let's say, Santa Claus, right? Now I don't believe anymore. Is that evidence that Santa Claus doesn't exist just because I used to believe and now I don't? Because if that's the case, then a lot of people used to believe in God and then don't believe anymore. Is that evidence that there is no God?
Well, you got to literally fucking slap me around the face with a wet kipper and tell me that is God. You know what I mean?
No,
Can you do that? Can you do it?
I don't know what you mean.
Oh, right. So you can't give me fucking true evidence then?
I honestly don't understand what you're saying.
With a keeper is evidence.
Yeah. I mean, what more evidence do you need but a wet kipper?
I don't even know what that is.
A wet keeper would show that water sticks to a shape. Now that would be evidence of water sticking to outside of not a sphere, but a keeper.
Please, just reiterate your point again, and I'll very enthusiastically retort to your question.
I don't even know who you're talking to.
No, nor do I know, actually. He seems to have disappeared. Oh my God, this always happens. That's why I'm single. Hmm.
Well, I think originally Bacon, the fact that we used to, that we originally, I mean, I wouldn't say for myself that I really truly believed the globe Earth, but I will say that I accepted it. I mean, I did accept it as being the case, at least to some degree. Although I questioned it even when I was a child. So I mean, I kind of have, my whole life had questioned it. The idea of water sticking to this ball and flying through space at millions of miles an hour.
Damn right.
But I think Bacon, what he responded thinking that was said as a way of evidence of what is the case. But my understanding when you said that, it wasn't necessarily that is evidence for something. It's just more the process of sort of being in community and discussing it, and perhaps in some cases maybe the globe earther is not really understanding maybe fully, or maybe having as much of an experience or awareness that we at once did accept that and have already sort of broken free from the concept. And so it's sort of like trying to reconvince somebody who knows that his girlfriend cheated on him, and it's like trying to convince that person that the girlfriend didn't cheat on him. It's like, it's not gonna happen.
So what is the ethos of this server then? Gio, are you there, dude?
Yeah, I'm here.
What's the ethos on the server? You know, I mean, what's the goal? You know what I mean? What's the fucking gist?
I think trying to think of how to summarize it. Let's see. How about
sorry to put you on the spot, but like, you know, it's my first time here, and I think whenever you get into any experience, it's always good to just fucking lay out your fucking truths in the first fucking moment. You know what I mean? So, yeah, what's the whole ethos of the fucking server, dude?
Well, I mean, I feel like I kind of responded to that a little bit earlier. I could do it a second time, or but I mean, I would say, yeah, the capacity to be able to come together in community, discuss different topics, be able to explore truth and discover truth, learn from each other, be able to just have, put information out into the world.
I'm right, yeah. I'll tell you what, there's nothing better than laying down truth. Do you know what? More people get scars from truths. But like, at the end of the day, they still come back with a fucking memory.
I mean, since you brought it up, like, I'll just kind of, like, on the welcome page, the Earth Awakenings platform supports community discussions, multiple live stream broadcasts, research project development, and social networking for exploring the nature of human life in the Earth, the nature of reality, Earth cosmology, spirituality, human health and nutrition, and the study and observations of the celestial objects in the skies are a few of the topics that we focus on discussing and exploring. This platform is intended for members to be supported to freely share their viewpoints, perspectives, experiments, tests, knowledge, and wisdom. And then the final one is the goal of this platform is to share and exchange ideas, not to convert or convince anyone into a particular perspective. Each person is respected and honored for what their own personal viewpoints and perspectives are.
There you go. It wasn't hard, was it?
Well, it's like, yeah. I mean, trying to summarize all that in like 2 sentences is more difficult than.
No, sorry, mate. I didn't mean to put you on the spot, but like, if you're making your own server, you kind of putting yourself on the spot anyway, aren't you?
Well, I think, yeah, I mean, I think that there's a component, like there's certain, servers or environments that are pushing, like let's say have a particular idea and are very much pushing that idea. And then if you accept that idea, you're accepted into the community. And if you're not, you're, ousted, kind of a thing. So that happens in some environments. I think with this server and with this platform, it's instead of that, there's more of a, like, I mean, in terms of like having at least a basic level of mutual respect for each other so that people can share their viewpoints and be heard, and, other people can reflect and bounce ideas off each other, in that sense.
Fantastic. All right, what's the subject of the day then?
Then I think, well, just one other thing I'll say too. I mean, sometimes it's more debate style. Like, if there's people that, so oftentimes it can be more debate style. Other times it's more, kind of like podcast, or, that idea of building, where you're kind of building off of each other.
What's the debate of the day then? What's everyone talking about today?
I think it's kind of open topic right now. It's not like we also, I mean, if like the show's being hosted, then there's like, a host where, they're kind of guiding the conversation in that sense. But right now it's more of just an open panel.
You're very religious, aren't you? You are though, aren't you? Oh
No.
yeah, it's nothing. I'm not saying it's anything against you, but you are, aren't you?
No, I'm not. I'm not religious at all.
Yeah. Oh right, okay.
No, I'd say I'm spiritual.
You're
but...
a fucking atheist then. You're a fucking wanker.
Hey man, my dad was a wanker, dude. Be a little sensitive about that.
Who said that?
Rotten, do you remember Kosho? Do you remember, you know who Kosho is?
I remember him, yeah.
Back in the days?
Yeah, I do.
Howdy.
How you doing, man? You alright?
I'm always good.
Are you though? Or are you just the hick that you always thought you were?
No, it's just something I say. I say it when people ask me how am I doing.
Occasionally I come out and I just fucking you load of bullshit, you know what I mean?
Truth is, have an introspective introspection. Yeah, sort of introspection.
Mate, it's great to have a different perspective on life. Yeah, I totally agree with you. Yeah. And with Gio here as well, I totally agree.
Yeah, Gio's. I like Gio's outlook. He's very. Actually, there's some people who are experts in different things. Gio really actually is kind of he knows a lot about astrology. Like, and I say astrology with a capital A, not like soft astrology.
Oh, really, Gio? Seriously, you know about astrology? I know about astrology.
Yeah. I think we've actually chatted about it.
It must have been a long time ago, though.
Yeah, actually, just the other night we did like a long session on it. I'm always a little.
Just the other night.
No, we didn't. No, you're lying there. No. Seriously, dude. I could have a long conversation with you about astrology, dude. Seriously.
Why was Coach just saying the other night? Why? Because it was just last.
No, it's just funny. It's funny because
I'm not joking because I know that astrology is fucking real.
Oh, but I mean, that's why we were kind of messing around with that the other night, like kind of talking about how
you don't mess around with fucking astrology, dude. It's fucking serious. It's like fucking real. It's like you literally start off in Aries, right?
Oh, you mean like the spring equinox?
Yeah, that's where we are now, right?
Well, I think it used to start off in Aries. I don't know if it still does. I think it
Yeah, but that's where you
it's still.
start. And then, like, the beauty about the whole astrological cycle is fantastic. The more you learn about it, the more you realize you know nothing. It's fucking mental. I'm not joking. It's just fucking nuts. So yeah, brilliant, great server. Let's learn about loads of stuff, and then let's learn about astrology. Yeah, who wants to learn about astrology? Because I can tell you what, I can teach you a little bit about the stars.
Well, I'm an Aries.
Are you really?
For real.
I'm actually a Leo. Would you believe?
I don't believe anything about astrology.
Oh, I see. Oh, right. You're a non-believer. Okay. But why? Oh God, I'm not in the right frame of mind right now. I need to reconnect and.
Drink water.
No, definitely not water.
Well, maybe tomorrow.
No, more beer. Definitely more beer. More music. Who's turned the music off? Someone's turned the music off. I'll never forget their name.
So, Kosho, do you think that the geometric relationships between the what you guys refer to as the planets, I might call them the luminaries, Venus, Mars, etc., that the geometric relationships between those have significantly meaningful correlations and connections to human life?
Significant. See, things like that. There's things that I know that are true about them. So it's like there'll be a snapshot. Any given moment, it will be a snapshot of these the relationship between these bodies in the sky and stuff like that. And then so it's unique in that way. And you can kind of like we do with the star charts. You put the connections together, like the stars that are. The wandering planets that are connected. I think that there may be something you can glean from it, and I don't hold it to the same regard you do as far as it influencing events and people and this kind of thing. It seems like because you said there is a pattern, like there is a pattern that comes up like on the big scale, like on the world events and stuff like that for certain conjunctions. I think that's interesting, but I just don't hold I don't hold it in high regard as I'd have to see something substantial to be convinced of that, basically. But I did suggest something the other night though. I was bringing up ghosts. I was bringing up because somebody said something about like when something traumatic happens, it gets like ingrained in the granite for some reason. And I was like, yeah, I think I was thinking like, what if that's like what a ghost is? It's like a very traumatic thing that just kind of shocked the environment in such a way that's like something lives there. Anyways, I don't know why that got me thinking about the planets and shit. But if you think about the different relationship between the planets and the stars, each being like a snapshot and like a unique position of everything, there might be something to say that about the fact that like that's going to identify exactly. It's like a unique identifier, you know what I mean? But the only thing is, I don't know if that's going to influence your personality or something like that. It's just kind of like a unique place in the universe. So that was a long-winded non-answer, Gio. I apologize.
Yeah, no, it's all good. I mean, have you ever thought of like trying to see if you could empirically see if there is any correlation yourself? Like outside, I'm not saying like reading a book or saying looking at what other people say. I'm saying, have you ever thought about like scientifically observing it yourself? Like, because it is like nature essentially. It's almost like observing nature and seeing if there is any correlation or connection between the sky and human life.
Yeah, I mean, like I said, I don't have the motivation to do that because I don't, like I said, I don't have. I don't know if I'd have to see something that looks like it's somewhat valid, and then be like, "Whoa, this looks interesting. Let me see if that's true or not." Right now, I guess the only thing I could do is like I could look at like where the star conjunctions were and all that kind of stuff, and I mean the wandering star conjunctions, and kind of see what was happening at those times. I wouldn't know what to test for, like how to test for it. Like I don't have like a burning question, or curiosity about it, because I used to do tarot reading. I told you, and I was pretty familiar with cold reading and how that works.
You work with a tarot deck, right?
Yeah, and I would do it in a therapeutic way with other people, but ultimately I would tell them that there's no magic involved here. I didn't say I forgot what I said. I said I'm not going to interpret the cards, or I'm not a psychic. I'm like, we're going to interpret the cards together, and it's like a therapeutic thing. So I didn't even. I don't know. It's hard to say because you can be superstitious about something, but ultimately the reasoning inside of you knows that you don't have evidence to suggest that it's that there's something true about it. You know what I mean? So I'm not saying that it's not true. I'm just saying I haven't seen any evidence to make me want to look and really see if there's anything there.
Yeah, I got you.
Yeah, I mean, I'd have to see some like proper examples of like, really these correlative connections. You know what I mean? It's hard because there's not just 12 zodiacs. There's 12 zodiacs and their relationship with the stars that they were born in, and I mean the constellations they might have been in, and so it's like it's too much to study, really.
Yeah, no, it is a lot to, and I mean, being able to like decipher and kind of tease out or elucidate. I like that word, elucidate. To be able to like reflect upon or elucidate the layers of energies that are coming through any one chart is a massive task. There's so many components to it. I think of it almost like a diamond that is reflecting in a myriad of different ways, and there's potential to glean from all of it, but being able to do it accurately and skillfully is certainly a very unique capacity to be able to do. And that's why people would, perhaps consult with someone that is skilled in it, not necessarily to predict the future, but more to glean insight and understanding of how sort of this like compass of the sky seems to be correlated with one's life in a meaningful way that has like a care and a compassion for our outcome, and how that's sort of correlated that with our lives.
Hey, can I ask you something? In the interest of maybe learning something or discovering something, and certainly not in the interest of trying to challenge your astrology. I was just wondering, because I know that you do know a lot about the different conjunctions, and I was just curious about like if you give some examples for evidence for these conjunctions and kind of what like the moods that they influence and that kind of thing. If you have anything on top of your head.
Yeah, you mean like in an individual life, or
no, I mean like maybe something, maybe like on a wide scale. I know you said something about the 60s and 70s. You said something about 67, the Summer of Love, or no, 65 maybe. I forget what year it was. But just like stuff like that. Stuff though that because I know I've heard people respond to you and say that you're looking at the times where it fit. You're not looking at the times where it didn't fit. But I don't know. Maybe you have like pretty extreme examples.
Yeah, he's basically like trying to tell you that, you know, give us some fucking hardcore evidence that you got fucked up back then, you know?
I really what I'm saying, but yeah, you get what I'm saying. You get what I'm wondering. Just because I've heard you talk about it a few times, but and if you don't want to, it's cool. Just I don't know if you have them on the top of your head. A couple examples of where there was like an obvious correlation between conjunctions and sort of what was going on.
Yeah. Well, it's a huge question in and of itself. Because I mean, the thing as well, like if you're talking about, there's just different scales. Like for example, if all the luminaries, the planets, they're all moving right now, in their cycles, so they're always moving. So they're always making interrelationships with each other. They're always making alignments with each other. Some of those cycles are longer because of their orbits, if you want to call them orbits, and some of them are slower. So Pluto, for example, is very, very long, like 240 years, rather than something like Saturn, which is like 29 years. Mars is only 2 years. So they all are moving at their different paces, and of course that's why they had to put Pluto all the way out, that far away. Because of its cycle, I believe it's 243 years. And so they sort of had to put that one there. And then, Uranus, for example, is 84 years. So they had to put Uranus,
Yeah, but your point is...
That's good. Keep me on point here.
I will. I'm sorry. Yeah.
Okay. So when making correlations, to look at one of those larger cycles that lasts for 10 years, we'd have to look at the whole decade rather than just, one time. Like you'd have to look, because it's such a long time period. Whereas if someone is having something personal in their lives, a transit, something that happens to their own chart that only lasts for a week, then you can really pinpoint that down on a much smaller scale. I guess that was the main. Because you're just asking about like some correlation that is really solid, right?
Well, no, just with this, that's not so that you could convince me or something like that, but just, or not convince the whole room, but I mean just so it convinces you, or it looks compelling, because ultimately it's that kind of thing that would drive me to investigate more. You know what I mean? If I saw there was actually something funky like that, right?
Right. Well, I would say the thing is I guess like any big topic, like even with the shape of the Earth as well, it's a preponderance of evidence. I think a lot of people would say that, meaning that if someone were first just starting to look into a lot of this, which a lot of people have done, like they either start looking at their own charts or different components of this, it's usually not just like one thing, as it were, but there might be something that is intriguing or that really kind of sparks their attention with it, but it then ends up being hundreds or even thousands of correlations as you really because it's like observing nature essentially, so it's like a mirror. But okay, that still might not have really been responding to what you're saying directly.
No. It's like I said, I wasn't.
That's
I wasn't.
Responded to a good question.
Yeah, but I wasn't. Dead set on you needing to answer that anyways, because I know it is kind of putting you on a spot. I don't want to open it up to, some kind of
wits
or whatever. Yeah, I'm just trying to see if there's some examples like for my own personal.
Trust me, there's plenty of us around. It's all good. It's all right. So it's fine.
Yeah, I mean, what I would suggest, Kosho, like even if you have at least a cursory interest, I would suggest, if you want to get like a basic understanding of how it works, and then see it for yourself, as it were. Meaning see the correlations yourself. That's, I would say, the ideal, because then you're having like...
You really want to see that though? I mean, it's like... You know what I mean? You really want to see that?
Well, yeah, I mean, I think it can glean a lot of insight. It can glean a lot of insight into various different components.
Of course you can. That's exactly what life's all about. Fucking damn right. My hat is off to you, dude. My hat is off to you. But would you really want to do that in real life?
Well, like when I first started, like when I looked at my own birth chart. So like your birth chart is, that moment you were born.
Yeah, you've actually looked at your
whole
own birth
position.
chart.
Yeah.
Wow.
And
This guy is solid. And what made you look at your own birth chart?
well, I would say a lot of reasons, but I mean,
It's not like something that everyone does, is it? You know what I mean? It's not like everyone goes down the pub and then suddenly someone says to you, "Oh yeah, let's go and check out our birth charts." What made you check out your birth chart?
yeah, no, it's true. I mean, it'd be interesting to know what percentage of people even know their own chart. But well, I guess I kind of first got, like, when I was around in college time, I got interested in astrology and began just researching it. Some just stuff I could find on it, and then eventually started really trying to look for the good stuff. The stuff that was actually solid and in a lot of ways. And then sort of through my journey, yeah, I ended up. I mean, I've worked with a lot of different astrologers as well. So learning from others that are experts in their field at that time was a huge help for me, and figuring out how to get my chart and then how to understand it, what it is and the different components.
Yeah. So, where are you now with your astrology then?
I still work with it in various ways. Yeah. I'm always aware.
You're very apprehensive. I'll tell you where I am with my astrology, mate. I fucking love it. It's the fucking bee's knees. I won't fucking lie to you, mate. I know for a fact that it's the bollocks. Right? Now, I don't care whether you tell me that you've done it, or whether you think you fucking haven't done it. You know what I mean? At the end of the day, I don't fucking care. Right? I know because I know. You know now because you know. Am I wrong or am I right?
Well, yeah, no, I mean, so what was like, what, have you looked into, like, have you, you looking at like the signs or more of the alignments and transits and
No, you're getting off a little bit there on the old aspects, but I'm basically like, I've been there, mate, on the signs. You know what I mean? And
yeah, it's awesome to, yeah, for me, like, I just remember when I first started understanding each sign, it's really beautiful to really see them. It's just profound.
It's beautiful to hear someone like yourself think about it as well, and like you seem very knowledgeable about it all as well. I'm very eager to learn from you, dude.
Yeah, well, I feel the same right back at you. Yeah, I would love to hear your viewpoints and reflections on it as well. And
See, that's the key about knowledge, isn't it? It's like why can't people just learn from each other? You know what I mean? It's like, fucking hell, get your fucking asses together. You know what I mean? It's like, fucking Jesus Christ. It's like, do you think you're here for fucking ever? You're not going to be here for fucking ever. You know what I mean? It's like, fucking get your asses into gear and fucking start fucking learning. You know what I mean? Seriously. Fucking,
yeah,
do you think that fucking life is here on a plate for you? No, it's fucking not. You're here because you're fucking here. So make sure you fucking learn about everything that's fucking around you. Wouldn't you agree with that? Would you not agree with fucking learning about what's around you?
Definitely. That resonates deeply with me. I've had that spark within my being my whole life, and yeah, just like a very endless burning fire desire to learn more, understand more. And
I wouldn't go that far, but yeah, but definitely. You know what I mean? It's like it's a fucking burning desire, right? You know what I mean? I fucking love the fucking truth. I love it. Honestly, I'm not fucking joking with you. I fucking feel it. I fucking do. I really do. So I feel it when people lie. You know what I mean? Does anyone else feel that? It's just me. Okay.
No, I feel that way too. Like what sold me on astrology is I watched a lot of Santos Bonacci,
Yeah,
and
Santos Bonacci. Yeah.
like he points out a lot of stuff that we see every day.
Yeah,
That-
yeah. He's really cool. Yeah.
Like a lot of these logos are rooted in astrology, like the different planets and all the
Yeah, the
different,
symbolism and
patterns.
stuff. Yeah.
Right. And another thing that was big for me was Leonardo da Vinci's Last Supper. Each
Oh wow,
character,
the whole picture. Yeah.
right, each character is a different sign of the
Oh my god, I forgot about that.
zodiac,
Yeah.
with Jesus as the sun in the middle. And once you look into that, you'll see that there's a bunch of quote unquote Last Suppers that have been painted. Like there was one done by like a some like Chinese person, some like Indian person did it. It's all over the world, these symbols, and it's all like everything is rooted in what's going on up above. Everything, man. It's insane. Just the amount of connections.
It's what really fucking throws me though, you know. It's like all these connections, like I totally agree with you, and I know I know where Santos Bonacci is coming from, but it's like seriously, it's like can't you just fucking chill out and just fucking have a spliff, you know what I mean? He's fucking cool, and I love Santos, and like you know, I know exactly where it's coming from. It's like if you don't fucking have sex for fucking ages, you're great. You're gonna ultimately you're gonna be God if you don't have sex for fucking 6 months or whatever. You know what I mean? It's a bit daft though, really. When you look at it like that, you know what I mean?
I think that's
But that's what he's
that's
selling.
a short. That's
what he's selling.
Yeah, no, I'm sure you did say. And
No, that is what he's selling.
I know. I agree with you. I'm not challenging that.
And I don't think there's anything wrong with that because
I don't think that it's a really complete idea though, because I think ultimately, if you look at like the people like Jesus and Buddha and the other people who like didn't eat, and like they do this like meditation where they're not even eating, and they don't allow their bodies, like they're basically trying to get the influence away from their bodies and their urges and stuff like that. That kind of makes sense along in the same regard as this dude who's not having sex, because sex would just be one component of it. Ultimately, you'd want to control your bodily urges completely. Right?
It's like I've read stupid books. It's like honestly, I don't know what's better. Is it better that the guy that's read one book or rather the guy that's never read a book at all? I don't know.
The guy who's read
one or the other.
I think the guy who's never read a book ever. I don't know how that would be better. How he'd be better off.
I'll tell you something. I've read more than one book, and like I fucking start to get a little bit pissed off because like it's far too much fucking information out there. Far too much.
You know,
well, there is an interesting dynamic. There's actually a bass player who plays bass in a band that I like, and he was talking about the difference between, like growing up, and as you grow up as a human, through your teenage and, adult life, if you're going to learn an instrument, studying everything you can, all the professionals and experts and musicians and everything you can to learn everything that they're teaching, and then go out there and play. But another perspective would be to not have any of that, not have any teaching, nothing, and just have that pure
retrospective. Yeah.
Just that pure like expression of
ignorance.
Yeah, Charlie Parker said pretty much the same thing. Is like you learn your instrument, you spend hours and years learning, and then you forget all that shit and just play.
Yeah, especially if you're doing improv. Yeah, it's people that do really deep improv work, like playing, where they often refer to like getting in the zone, where they're just completely, just essentially becoming telepathic with the other musicians is the ultimate that can occur in that improvisation. And when they're in that, they're just like in a zone, or they're in a groove where they kind of almost try to not think and just have their mind be as free and open as it can to just channel through whatever's coming through.
They say that the mind is really Satan. That is what the mind is. It's just like, to be honest, like,
somebody said that to you.
As old as I've gotten now, I'm actually starting to agree with them. You know what I mean? The mind, my mind, is my worst fucking enemy. I am thinking about things that you would never believe. But yeah, like, it's...
Are you Satan?
Yeah, maybe.
Oh, what's up,
dude? But maybe it's just my mind, right? But what I'm saying is that you just need to fucking stop thinking. Yeah, maybe. I don't know. Have you ever read the book by, what's his name?
Oh. Aleister Crowley?
No. Fuck him. Fuck Aleister Crowley, the fucking satanic wanker. No.
You said you're Satan. And
no, I did not say that. Please, can I not? Do you know what? One of the most wishes of my whole entire life is not to be misconstrued or
I got you. I'm messing around with you.
By anyone.
Okay,
I do not want to be misinterpreted.
I understand where you're coming from, man. I'm just messing with you.
No, you obviously fucking don't, because you've.
I do.
Obviously...
I apologize, man. I'm telling you that I'm making a joke about it, okay? But I totally see. I totally see what you're expressing. I don't think that you think you're saying.
So you just think I'm mildly mad.
Well, we're kind of jumping to a couple different topics, but this is an interesting one. Like, do we all have the light and the dark within us?
Yes, that is the point. That's the point of the Bible, is to show you that even God is bad sometimes.
What? I don't think
that's the point.
I think it's showing you that God's bad sometimes. I don't know if the Bible aside,
you want me to show you? I can fucking show
you. Any description of sin and whatever, because everybody knows I talk about this sometimes about how I think that what people are describing sin and all these different religions ultimately comes down to is your egotistical urges of the human body and the human condition.
Yes,
the things that that exist in you for some, because there's a purpose for it, but sometimes you overindulge in it, or it overtakes you, and then there's a dialogue between an argument between that urges and then some other urges, which you can fill in the blank whatever you'd like. You know what I mean. Some spiritual urges. I ultimately don't think there's evil. There's like evil demons. If there's a spirit out there, I think that it's not evil. I think it's just a universal spirit. I think the evil that people see in the world doesn't come from other spirits. I think it comes from, like I said, you're succumbing to your body's urges.
I agree 100%.
Well, okay, so if the creator is everything and it created everything, then didn't it create all of the bad and the good? And therefore it's all on some level part of the same. And that the creator, God, whatever word you'd want to use, does purposefully create things that are, whether it's painful or, demonic or whatever it may be, as part of the overall sort of dance of consciousness?
I don't think
It's a
so.
very interesting question. Although I wouldn't necessarily agree with you.
I don't think so. I don't think that like for instance, those, like, let's say, first of all, I don't think, I believe in the Big Bang, for instance. So I think that this entity
I
was
don't
clever.
believe in the Big Bang
I know,
either, mate.
I know. That's why I'm
It's
prefacing saying
a
that.
complete load of bollocks, mate.
But
That's
yeah,
all
but
it is.
I think that this entity is clever enough that he put very simple basic instructions, and those base instructions and laws and this type of thing, on its own, had the probability of bringing about things like chemistry and then biology. And at any rate, it's these biological imperatives that actually we require in order to exist, like hunger and lust and this sort of thing. And it's those same urges that, if managed correctly, aren't an issue. They are necessary because it drives you towards those things, which definitely helps sustain life as a whole. But it's it's when you it's when you're not being influenced by virtue or whatever, but you're being influenced by these urges, and you let them, you overindulge in them selfishly. I wouldn't say that's anybody else's influence other than uh, you know your own. It happened because you have those urges.
Hey, listen, it's your own fault. You're a good guy.
Not a good guy, but yeah, I don't know if that made sense, Gio, or not, but yeah,
Well, yeah, no, I hear what you're saying, but then where did those impulses come from if not the creator?
No, that's what I'm saying is, in an indirect way, by making quantum mechanics, the laws of the universe, which created chemistry and the laws of nature and all that stuff, and then eventually chemistry can bring about biology, and then eventually life. Like through these things, which may not have been purposely constructed, but sort of um, like cleverly came about, right? So it's almost like if if in biology it's just kind of a happy accident
We
that
don't care
these
if you're
necessities
gay. Okay, it's
come
okay.
about, these urges, because these urges are obviously necessary for the sustaining of life, like the persistence of life. If it wasn't for those urges, then people wouldn't have a desire to continue to consume stuff and then live, a few days, or to sleep with a woman and make more people. You know what I mean? Like, these urges wouldn't exist, or the people wouldn't exist if those urges didn't exist. So they're definitely necessary, but it's they can take control of you, and it's usually people who let those selfishly take control of them that end up doing these sins.
Hey, there's no sins, mate, when it comes to fucking just being yourself, alright?
I mean, my sense of it is that the creator purposefully creates out of itself, which I think it is all love and light, truly, but it can create darkness out of itself, which is secondary to its nature, but is still, real in a sense in terms of what it can create, the type of experiences. So it creates that darkness from the void to
Fuck that bollocks.
play a role, and it has a purpose.
Do I have to
It definitely, it's doing it. I mean, whatever we call the Illuminati, all this stuff. I mean, it clearly has a depth of desire to experience every possible thing it can experience, which includes the dark and the light.
Okay, so I have to do this then.
We can't see you, so we don't know what you're doing. It doesn't make sense what you said. You
No,
have to
but
do this now.
I basically have to.
Yeah,
I don't want to be against this, but apparently I am.
Well, that's clear. That's I understand what you're saying absolutely. But Gio, also I just say this just because, like I said, you obviously mean you have different philosophies about the universe in general, anyway. So, in my philosophy of the universe, um, everything that there is can that's what we're trying to seek out is how everything came about, and then we were finding that everything that exists, like my shirt, the Indian food that's about to arrive, all this stuff, it can come about from uh, you know these simple rules. I mean, like the quantum mechanics, the Big Bang, these constants and all that kind of these laws of nature. And I think that actually is clever. That let's say this God, this entity, described those laws before the Big Bang happened, and then he sat back and didn't do anything else like miraculous. I mean, just like those laws that were created, let it create everything. I think that's actually that to me is more clever and also even more more beautiful in a way. That's my opinion. Because it seems like a very difficult feat.
Well, I'm wondering if I'm fully catching what you're saying. I mean,
I'm saying that
if you created, it's just like creating a movie or anything. Like there's the dark and the light, and then if you then created like a structure for that, in the Vedas in terms of karma, sort of the law of karmas. But if you kind of start to, I mean, that's just one outlook and one terminology. But if you then built a system of essentially what's right and what's wrong, and then you have the light and the dark, then in my mind, you can create many, many different beings and entities that are on various spectrums of that. And there's like a teleological, which that word means like a goal-oriented, a teleological conclusion. So there's a goal of perhaps integration and transcendence and reconnection to the spirit.
I'm simply just saying that, like, instead, like, if you think about it as a movie, like, there's a director who he'll literally like write the script, he'll tell every actor exactly what to do, show them the stunt moves, everything. Like, he'll literally lay everything out and get his vision shown. Now, what I'm describing is a movie that gets produced by someone who does even buy a camera or tell anybody his plans. He does like a simple he writes a simple instruction that nobody even reads. It's like he does something completely unrelated to making a movie, and then it just so happens that a series of events takes place that is he's no longer in control of, but because of the actions he took or whatever, series of events take place where this story that he envisioned or whatever, it comes about and is produced and is filmed and then distributed, all just because of like a simple behind the scenes instruction. I think that is kind of it's kind of incredible if you think about it like that.
I gotcha. Maybe. I mean, I'm kind of hearing what you're saying, but I don't know if I fully understand.
Well, you understand even atheists?
I mean, you're talking about kind of like a creator that sort of stood back, did the Big Bang, put a little bit of instruction in there, and then just let the thing unfold. And then at that point, it's not really connected to. So in that sense, like it isn't all of these people in the earth and the consciousness, but in fact, it's something separate that just created it, and then it's just letting it go.
Well, no. It would exist in my idea. So atheists obviously believe the same thing I believe, except for without the God part. Just like those rules just came about, and everything came about from those rules. But I'm describing the same thing, except for it was maybe there was a will involved, and that spirit is not separate from everything. It actually exists in everything, and that dialogue that I was describing before, the argument that you have, like the sin of listening to your body, the dialogue is taking place between the spirit and your egotistical urges. So the spirit exists in everything, and it just doesn't have it doesn't have an innate ability to just influence it directly, because that'd be magic. Like the God that I understand is not like a magical creature, right? It's bound by all the laws of the universe, apparently. Anyhow, I digress, man. I was gonna go for a walk before my Indian food got here, so I think I should do that. So I'll be back.
All right, man. Well, yeah, no, I appreciate you sharing that. Yeah, it's definitely interesting, and yeah, I'd like to hear more on that at some point, because yeah, I think I'm partly getting it, but yeah, it's interesting. I like hearing it.
Yeah. Oh, I have to tell you that what I was describing about the instructions, it's almost entire, like an atheist would have no problem with not somebody writing the instructions, but the instruction being there and everything coming about from those instruction. Actually, most people believe basically in a basic sort of way. I've just kind of, maybe due to bias or I don't know what, but I just have reason to believe there's a spirit there. So
I got you. Well, if you're gonna head out for a minute, that's cool. Yeah, I just wanted to ask, like, if you have 2 more seconds, how would you then link that back? Because we were talking about astrology earlier, and you were talking about that. So, in your kind of viewpoint of the creation, the creator, whatever that all is, or or no creator, however that works in your mind, is there any mechanism or way in which this system, even if it is heliocentric or something, because I know that's your perspective. So, if even if it's planets out there, do you see any way in which that could be all correlated and synchronistically?
I mean, I can't say that I've ruled it out, but I can. I mean, I would be compelled to say that I don't have reason to suggest that that's the case. I could see it. Like I said,
so you won't rule it out. So it could.
Yeah, I'm not rule it out. I don't have any compelling reason to adhere to it. So that's like that's why I was asking you earlier about evidences and stuff, because if I saw some evidences, it would lead me, or at least give me some curiosity to investigate it further and stuff. But
right. Well, I hear you on that. Well, because I mean, some of the most rigid, kind of hardcore heliocentric, Newtonian Cartesian worldview kind of people, they often say, when Big Bang and all that stuff, materialism, they'll say that the concept of astrology is just completely impossible in their mind point, it's from that like very, very sort of rigid heliocentric atheism perspective, because they would say that, the Big Bang, although the forces of gravity or whatever, but in no way is there any intelligence that would somehow be able to make these correlations with such significant accuracy and potency. So they just say that it's completely impossible, which is why a lot of the mainstream tries to call it a pseudoscience.
Yeah, I would just say
it's like they took the spirit out of the universe and put it into a material thing that was devoid of the actual spirit and symbology and consciousness that's actually contained within it.
They're spiritual scientists as well. I think the only thing is, because I would think someone who said that was impossible would just be kind of maybe biased or something like that to say that. Whereas I think a more appropriate reaction or response to something like that would be, there's like what I said, like there's no compelling evidence, or maybe they haven't been given any compelling evidence to suggest that. So it's not that it's impossible. There's no reason to take this kind of out. It's like a very extreme claim. So it would seem that there should be some evidence to compel it. That's all. There probably is. I'm lacking this one.
Okay, I see what you mean. Well, yeah, I mean, there might be some variations. There might be some people, of course, that would accept it as possibly being possible if they were shown evidence. And then there's others that will claim that it's just completely impossible because, like, the Big Bang was more or less sort of random with just gravity. And then we all just evolved, out of the swamps of the earth and all that stuff into what we are now, like the whole evolution kind of narrative. So from that perspective, like if it's hardcore materialism, then just because these orbits happen to be the way they are, there's no way in their minds, in some of their minds, like I said, the most rigid ones, that would consider that there actually is a meaningful correlation that essentially has to have some sort of creation behind it, as far as I'm aware. Can you think of any way that if there was correlations that there would not be a creator, Kosho, or would that make you think, yeah, there's a creator if you saw the correlations?
Well, to be honest with you, just because, like I said, this is just my personal belief. But even the Big Bang itself and the universe and the rules that, like I was saying before, these rigid rules that lead to everything else, that even in itself kind of implies to me a creator. So at least some sort of creator. Because, like I said, it does seem like there's a simple set, not a simple set, but a small set of rules that everything comes out of. Yeah, so
like a code, like a code of some sort.
Well, yeah, I mean, exactly. I mean, there's the code of the universe, the code of life. I mean, all the laws of nature that we always talk about, that bring about chemistry and everything else, and it's all due to like a very small set of rules. So it is kind of, I mean, either it just randomly happened like that, or yeah, there's some kind of, willed that brought that about. I don't know. That's most of the reason why I kind of have that belief in a God or whatever. But ultimately, you would just call that God of the gaps then. But I don't think there's anything wrong with that. As long if there's no answer currently and you're still seeking answers, I don't think that there's a I don't think that there's a flaw in believing in God. In that case.
I gotcha. Yeah. So from your viewpoint, yeah, that would integrate in pretty well. In terms of that part of that code does involve the sky clock being correlated in like very specific, like a symphonic correlation, as it were.
I posted a video for you the other night. I don't know if you saw it, but it was called Orbital Resonance or something like that. And it was actually really interesting when I saw it. And I wish Chronic was indefinite. He might be able to speak on this, but it was basically describing, and it's going to be too complicated for me to try to express it, but it's just due to the orbits and stuff like that, that it is actually likely to see that certain like if there is orbits and there's stars and there's moons and this kind of thing, then on average it's more likely to see them double in distance as they, so like the first moon or planet would be one distance, and then the next one would be twice that distance, the next one would be twice that distance, and so if this is likely, then it would say that it's also likely then that you'd have a resonance because of this. And there is like especially in those what do you call those, like like the Kiss of Venus and stuff like that, like those patterns and stuff.
Is that Steve Mold's video?
Yes, you said Steve Mold. Yeah, it was Steve Mold. Yeah, that's right.
Right.
Exactly. Yeah, each of the luminaries, the way that it moves is in a frequency, and they're all harmonies, and they're all within different like octaves and frequency of. It's like a symphonic tone of harmonies, which meaning the frequencies themselves have harmonic octave layers to them, and they all create different sacred geometrical structures.
It's kind of crazy because he just made like he put like different noises in it, like he made like a little orbit and he put different noises in it. Oh, excuse me. And anyway, it ended up making like a beat. It was crazy. Let me pull it up. You saw that though, Bacon? What do you think about it?
Uh, yeah, it explains a lot. It was weird that some of those like orbits were matching perfectly, like twice the period and distance. But that makes it make sense. Just like tidal forces.
Yeah, exactly.
Explain why the face of the moon is always the same, for example.
Tidally locked orbit is actually a common, and the most common, like most of the moons in our solar system are supposedly tidally locked. Yeah, I've heard that once. I haven't verified that myself, dude. But I've heard
Which ones? Wait, say that again. I didn't catch that.
I've heard that most of the moons in our solar system are tidally locked.
To what does that mean? To their own little planet?
Yeah, to whatever planet they're orbiting. Yeah, like they're just like our moon is. Our moon's tidally locked, where like it's only one side facing us the whole time. It's actually.
I thought there was like a very very huge coincidence.
No, it's a coincidence. The size. The coincidence you're thinking of is the size of the angular.
Yeah, but that isn't as perfect as like the moon facing the Earth all the time. Because if the moon is facing the Earth, if the rotation of the Earth, the rotation of the moon and the orbit of the moon around the Earth are just like a tiny fraction of difference, that would accumulate with time. So at some point, you'd start seeing a different side of the moon.
But that's. You said it a second ago, man. That with the orbital resonance, it's a very similar reason why they always end up being, or not always, but they're very common for them to be.
Yeah.
It works exactly the same way. Like
yeah, I know. That's why I'm saying it. I thought it was like a huge coincidence.
Oh, you thought it was? I see. Okay.
Yeah, I was being suspicious. Like it cannot be just a coincidence. Like it has to be something. There has to be a reason why it's like that. It cannot just be out of chance. And actually, there is a reason. It's not just out of chance.
Yeah, exactly. Like, because we were talking about how the frequencies of the planets or the wandering stars as well. And I just Kosho, I just posted 2 images. This is this little piece of software called Archetypal Explorer. It's actually a guy that was involved in the same graduate school that I went to. He actually made this. But anyways, I'm only posting it. I'm kind of posting it to show how like the idea of a transit, like a conjunction or opposition or a square, which is 90 degree, they're like a wave pattern, meaning just like when the moon, like when an eclipse happens, the moon and the sun get closer and closer, into alignment, and then it happens. And then, so you could imagine that as like a wave, like if you just put kind of like that gravity microlensing wave thing that Chronic has,
Okay.
Because essentially that's what they claim it is that they claim that the gravitational lensing happens because 2 things are conjunction. But anyways, that's kind of their thing on it. But anyways, my point is that it can be put on a wave chart, on like a 2D wave chart, even though the actual thing is aligning in the sky. It gets closer. So like if you have Uranus and Pluto that are going to do a conjunction, since Pluto moves slower and Uranus moves faster, Uranus is going to pick up pace more and more, and it's going to catch up to it. So once it gets like within, usually for these what's called world transits, about 15 degrees is when they seem to be really active in the collective psyche. Anything within 15 degrees. So once it gets to 15, and then it goes to 14, 13, 12, et cetera, all the way down to 0, which is exact. And then it goes, the other way, from it.
You have to explain that to me. So okay, so each thing is always a pair. There's always going to be a pair, right? Okay. And so
it gets more complex though, because you get triple alignments.
Okay.
Like in 1969, for example, Jupiter came in to align with the Uranus Pluto. So 1968-69 is Jupiter Uranus Pluto. So you get there are, but in general, yes, you can think of it a general transit as just two of them, but it gets very complex because sometimes there's 3, 4, 5, or even more involved.
Is this program available online, or you have to pay for it or something?
Here, I'll post the.
This is pretty cool, dude.
Website. I think it's like $10 a month or something, I think. Or what is he at? $13 a month, it looks like.
Wow.
So yeah, it is. But there's a free trial, I think, that you can have. I think it's for like a whole month. So you can actually, I think, just get the free trial and, check it out.
I almost want to waste my time and just put one together myself.
But I mean, the reason I was showing it is because like it shows how if you look at like those graphs like that, like what's cool about what he did here is like it's basically just mapping the alignment, but instead of two objects in the sky, it's putting it onto a graph like that
Right.
shows through time basically. So like on the bottom you've got the months, November, December, etc. And I think you can change that scale. And then on the left, how high the graph goes, that is how tight the orb is. So the orb is the name for how tight the degree is. So if it's right at 0 degrees, for example, and it's peaking 5 degrees, a little less peaking, 10 degrees even, So on the left there, it shows how tight the orb is. So it just sort of shows the actual transit, from a side view where you can actually see it moving through time and when it peaks and when it comes down. And you can look at all the dates and like what happened in your life, like in the past, on all of those points of it.
That's fascinating, man.
So yeah, I thought I'd just mention that because it
No, this is cool, dude.
shows it shows it within the frequency waves, like each of the quote unquote orbits, if you want to call them that, or cycles, of these different wandering stars. And each of them is in their own cycle, but then the way they align is its own cycle. So like the actual, like Jupiter and Neptune have their own frequency and their own cycle of timing, and because they also both have their retrogrades. So Jupiter, Neptune has all of its. Uranus and Pluto has all of its. Saturn, Pluto has all, what I mean? Each different combination has their own frequency wave, and cyclical nature. And then, of course, they're all kind of dancing together when they're all moving.
Can you kind of go back in time with this? Like, can you take this and go anywhere in history and research what sort of connections? Like, could you go through time with this?
Exactly. Yep. Exactly.
You can. That's cool, man.
Well, I mean, a lot of the work that I've done throughout my whole life and a lot of the people I've studied with, that's exactly, a lot, like virtually everybody looks back at their own life for sure. Like when they look at their own chart and their own transits, because you have your chart, but then you also have transits, which means that the things are the luminaries, the planets, they're still moving after you're born. So you're born is like a freeze frame of the sky, and that's your chart that you're born with. But then everything keeps moving. So you get what's called transits to your natal chart, meaning that let's say you're born with your sun in 5 degrees of Libra. Okay, so 5 degrees Libra, that's where your sun was when you were born. Well, after you're born, if Pluto comes along and starts to conjoin with your sun, the position where your sun was, you're going to get a personal Sun-Pluto transit. And that's going to affect you for the entire time that you're in that transit. So you can not only look at your own current transits of what you have, well, you can look at your own birth chart and you can look at your own current transits. You can look at the transits you're getting in the future, and then you can most definitely go back and look at all the past times in your life, especially if like significant events happened, like, that like this happened when you were 18 or 15, whatever it is. But yeah, like, and I did that at the beginning. You can basically go through the entire history of your life and then look at all of the transits you had during those times and see the correlations and how that was playing out.
This is cool shit, man. I want to, Bacon, I got to talk to you when I get back because I want to see if you want to try to make something like this with me, dude. But I got to get beer. Otherwise, I'm not going to be able to get beer. So I'll be right back.
All right, bro.
You'll be right back.
Beer run. But I think they have like times that I don't know what it is where he's at, but
yeah, in Texas, at midnight they stop serving.
Yeah, so you can't even buy any alcohol past midnight, even at a grocery store?
Yeah, at the bar you can.
Right. Well, get your DoorDash going.
Yeah, I gotta go. I don't want to be stupid, dude. I was telling people in Gems every fucking night. Fucking hell, I gotta. Night, I'm there at 11:59, dude.
Oh, you're funny.
Yeah, it's my biggest flaw. It's my greatest curse. But I gotta go. I gotta talk to you about my curse. I'll be back.
You just wait till the last minute?
No, I'm chronically late. I'll be back.
All right, dude. Talk to you later. Chronically late. It's all right, man. Everyone has their timing, and they're all beautiful and perfect.
Thank you.
So Bacon, what could we do? Like we could like you're a coder. You want you could code something pretty cool when it comes to some of this stuff. I'm trying to think of what that could be.
Well, thank you. Yeah, I'm coding right now. Actually,
Nice.
always coding. That's my hobby and my work as well. I mean, the good thing about computers is that they do exactly what you tell them to do. But the bad thing is that they do exactly what you tell them to do, you know. Does that make sense?
Yeah. Yeah, I see what you're saying. Well, can you make apps?
Like mobile apps?
Yeah. Or
I
software?
never tried. The desktop apps I've done before, but I'm more into web. whatever I do for web, so I can access wherever I am.
And then do you do
Just my
graphics?
browser.
Yeah, I got you. Do you do graphics as well?
Yeah, sometimes I built a renderer once.
Do you think you could build okay, a 3D model of a planar stationary Earth with a similar layout to the Gleasons, and could you have all of the wandering stars? Like if I told you the cycles that they move in and how they move between the tropics, could you design something that has those all moving in their tracks at their frequencies? And I can tell you all of that. And then you could create to where it could be created to where you could, move it forward in time or back in time. And then you could also see the current time.
Sure.
And yeah, and that it could also
That'll
show.
take a while.
What do you think?
Yeah, that's definitely doable. It would just take a while.
And then that would be able to be like graphically synced with an actual chart. Like essentially, I'm just gonna grab. I'll just post. I don't know what some of these other ones are. I have a couple of them saved, but just something like that. So if you had the 3D system, the 3D one that I'm referring to that showed all of the actual positions, right? So it's like, you have sort of the AE type map. You have the Tropic of Cancer, Equator, Tropic of Capricorn, and the Sun, Moon, Mercury, Venus, Mars, etc., going all the way to Pluto. And actually, there's one that's called Eris as well. There's also something called Chiron, which they say it's an asteroid in the heliocentric model, but it's actually very significant astrologically. Like we do know what it represents and what it is. Whereas some of these things, there's actually many more wandering stars that we don't even know what they do yet. Some of them. But anyways, that's a whole other topic. But there's actually a lot more than just these. But these do seem to be like the major ones. Anyway, so if those are all moving in their cycles, and then that would just be badass to have in and of itself. And then you could even create like a way to view it from the ground of the Earth on it and shit. Like that'd be amazing. But anyways, and then if you could then kind of flip it into another mode, and then it would basically go as an overhead view. So it would show you the overhead of the whole Earth, Polaris in the middle, all of that going out, then that would then be your actual chart. And those lines in the middle that show it's called the aspects, which are the degrees of separation that they have from each other. Then over this huge, amazing, AE map, like planar Earth system, you could then have all of those wandering stars in their positions. And then you could zoom up to the top, see it from above, and essentially you would get a chart like this, where you would be able to see, but it'd be way more badass than this, because you'd have all the you could have the fixed stars in there, then you could have the actual signs, you could have it all in there, and then to draw the lines in the middle to show the geometric relationship, because that would be closest model in terms of that.
Yeah. What would be the geometry of the sky? Would it be like a dome or something? Like I have half a sphere or a disc? What you picturing?
Yeah,
About the geometry of the sky.
yeah, that's a good question. I mean, for this, it could be like a mild dome. When I say mild, I mean that because the thing about a dome thing is that it kind of denotes where the edge is, does it? Like, it, in an interesting way, because any dome over a planar surface has an arc, and that arc completes somewhere on the physical land. Because as we know, if you have an arc and a straight, a planar straight line, they're going to intersect as long as the arc is arcing towards it, and if it expands outwards, which a dome would. So that's what's interesting about the dome idea, is it then denotes, does that dome come down, 20,000 miles past Antarctica, 50,000? What would that then be? So it kind of starts to denote a size of the whole thing.
Yeah, that would be necessary to create like a 3D model of it, right?
Yep. Yeah, exactly. But do you think you could make the dome adjustable? Could we make it, Yeah.
I mean, most things you just use like variables, so you can play with them and see how that changes things. You
I think
probably saw that
Walter
simulation.
Bislin's does that. It can change the dome like that, the size or whatever, like the arc.
Mm-hmm.
But the thing about like the part about the sun and the moon and Mercury and Venus and all that, those wouldn't be too much affected by a different size dome, wouldn't you think? I mean, I guess they would if the dome was right at Antarctica, then it would. But otherwise, it's if you have that dome out quite a bit, by the time you're just getting from the center to the equator and all that, like it doesn't seem to me like there'd be, an excessive amount of difference, perhaps. But I guess it still depends on the size.
You
of
mean
it.
like if the dome was a lot bigger than Antarctica? Is that what you're saying?
Well, I guess partly what I was just saying is that, okay, from Polaris to the equator, let's say, like just within that range, if you change the size of the dome, how much does it change of that center part? Less than it does of the outside. How does it, move, basically? It makes it different.
Yeah, I'm not sure what you're asking.
Okay, I probably didn't say that well. Okay, if you have this huge, this thing I'm talking about, huge planar Earth, stars above, and then all the sun and the moon and all that going between the tropics. You were asking, would it have a dome? And then I was saying, could it be adjustable? What I was then saying is that if you adjusted that dome from large to small, it's really small, like right, meaning the dome comes down right in Antarctica, right past the ice or whatever, versus a dome that went out thousands, even hundreds of thousands of miles, then the arc of the dome over the planar Earth, the part that we're in, the continents and stuff that we're in, the arc would be much, much less than it would be if the dome was right in Antarctica. Are you with me on that part?
The arc would be less. You mean like a amount of degrees? Is that what you're saying?
Yeah.
Yeah, sure.
And then all of that, how much would that change the position of Mercury, Venus, the sun, etc., if you made it 500,000 miles past Antarctica or right at Antarctica? And I suppose in the software, we would be able to see that, like, exactly modeled.
Well, if you model like stars over a dome, over a flat surface, at any point on that flat surface, you'll be able to see all the stars at the same time. So if you're at the bottom of the south, like if you're at Antarctica, you would still see Polaris. So you'll be able to see Polaris everywhere if we just model like a dome with stars above a flat surface. Stars.
You're gonna have to model the magical light paths that must exist in order. Yeah, so if you can somehow
that I had no idea how to do.
Yeah.
I mean, actually, no, one way. But it's basically modeling a heliocentric solar system, then projecting from XYZ coordinates to let long and then back to polar coordinates, that'll give you that magical path.
Well, I just posted 2 images in the chat. I just want to say I don't agree, or I don't see it the same way you do with that. Like that one on the bottom just shows like general stars laid out over an AE map. Now, I don't think that has the southern thing correct because it just shows them in red there. But anyways, it does at least show the general sense of it. So in my understanding of it, let's say that you're in South America. Let's say like Ecuador. So you're in kind of right at the equator. In South America, you would be only seeing the small region of the sky of your local area because you can't see forever. There's atmospheric occlusion and the Earth is absolutely massive. So you're only going to see like the blue stars, some of the green stars, et cetera. You're just going to see in that local region. And then the thing above is a planisphere, which essentially is a star chart. It's based on the celestial sphere, but it is based on like a geocentric type system because it's basically the stars mapped out on a flat sheet. And then you spin it, and you spin the little disc underneath. But the little opening there of stars, like the blue part, that actually shows what section of the sky you can see. And if you imagine that that's a huge AE map, I'm not saying that that's the exact right proportion. You could make that, like in this software I'm talking about, you could actually make the size of the sky you see actually correlated on a huge AE map. But a planisphere just shows a particular little wheel in there of the stars you're going to see, but it does cover those stars. So in my understanding, yeah, the planisphere shows how we only see in a local area. And yeah, that's my understanding of it.
Yeah, I understand your understanding of it. But what I'm saying is if you code that into a 3D software, that wouldn't happen. Like in a 3D software, you'd be able to see all the stars from every point on the surface. I'm not saying that's how it works in real life, but that's how it would work on a 3D software. And the scale doesn't really matter because like
no, you'd have to
3D
make the software you have to make it you'd have to make it fit the real size of Earth. Like how in like what is that, Grand Theft Auto games like that?
Yeah.
Whether you play them or not, you've probably seen them. But those games are like pretty somewhat kind of triply realistic to real life. Like it's kind of a trip how much, the sky and the horizon can look like the horizon. So you'd have to make it like that. Now, if you zoom out of it, like I was talking about, where you can see all the Mercury and all that stuff moving around, the sun and moon, I mean, yeah, that would be badass. But if we're talking about like what we can see from it, if you're going to zoom into that level, you'd have to make it correlate with that. So the world would have to be absolutely massive.
Yeah, but just making it bigger wouldn't change that, like, because the way softwares render things, so they bring everything down to a 1 by 1 by 1 cube, and the original scale basically doesn't matter. It all becomes this 1 by 1 by 1 cube that gets rendered, and the perspective that is used in 3D softwares, simply that wouldn't happen. And you would have to do something else. You have to like maybe curve the surface or then build your own ray
right,
tracing.
What are you saying? What doesn't happen now? You lost me on that part. What doesn't happen?
Like see just a portion of the sky if
the
surface is
yeah, it works like that, dude. Have you ever played like Grand Theft Auto? You look up and you see like the sun up in the sky or whatever, and you run to a whole nother part of the city.
But that's not modeled as a dome of stars above the Earth.
Well, I don't know exactly what like geometry they use in that. I'm just saying that you can definitely create that. I'm not saying this is all easy, but there's a couple different things we're discussing. First of all, if you build a computerized type simulation that was real to life in terms of being able to walk around on the ground in that world and have it actually match the sky that we see, I don't see there's any reason
that exists.
That's not
that's Stellarium.
You could call it that, although not really, because it doesn't really have the full map. I mean, you can go around to different coordinates, but it's not really like the actual. Like, dude, I was thinking this. How cool would this be if we did?
What's wrong with Stellarium?
Well, it's just not real life. It's just
specifically what issue do you have with Stellarium? So can you be excruciatingly specific, or can you not?
Yeah, I could try to. I would say there's a couple of things with it, but one is that it goes off a coordinate system that's given to it, not the actual Earth.
Why is that an issue?
Because that coordinate system is the...
What would you prefer it go off of?
That's the foundational matrix by which they're claiming the sky correlates with the ground.
What would you prefer it not go off any system and then just never be able to model or show anything? It needs to go off of a system. We both agree.
How badass would it be if we set up like cameras all around the world and actually took images of the sky and then put those into a whole system?
Well, we already know
It
that
would be
matches.
what happens all the time.
Called telescopes.
Yeah,
Hey,
that,
Gio?
you're
you guys ever-
describing reality.
Have you ever
Hey,
seen?
Gio.
Have you guys ever seen? What is it? Google Sky? Is that what it's called? Where it's basically like Google Earth, but for the sky. That thing's pretty cool.
Yeah.
Hey, Gio.
Have you seen that, Chronic?
Yeah. It exists in reality.
Well, possibly not everyone has. That's why I brought it up, because like it's something that not everyone may know about. But no, what I'm talking about there. Okay, what I was trying to say, Stellarium is a set of coordinates and a map and model that is given to, that's kind of asserted, as it were. And then the coordinates are claimed to match with particular positions on the actual physical Earth, and then that matches the sky. What I'm saying is that that's different than if we actually had. I understand telescopes look at the sky. That's not what I'm saying. I was talking about like a worldwide effort to have 3D camera telescopes, whatever they would be, at all around the Earth. And, you don't have to take it all at the same time. You could do it at different times. And just get a snapshot of the sky in that moment and then link those all together. It would be like Stellarium, but it would be linked to the actual physical Earth. You could say, oh yeah, there's that tree over there, and that is the Earth, and it would be a map of the sky.
What's ironic though, Gio, is that is what Stellarium is. That is how Stellarium was built.
Hey, Chronic, I'm live streaming the telescope right now, actually a camera, and those are 6 satellites in real time.
Very cool. Very cool.
Gio,
you see the irony. You see the irony in that statement, though. That's you're describing exactly what has already happened in history,
and we're doing it now.
Why are what I was referring to is a software that actually links them all together, though. Not just. I understand there's all kinds of stuff looking at the sky. Obviously, I'm not new to life. I understand that. I'm talking about a way of actually systematically positioning yourself on the Earth, measuring distances yourself, not depending on anyone like government given coordinate systems, but your own system, and actually mapping the Earth and the sky together.
Okay, we're not going to be able to get through to you. You're describing what has been done over centuries.
You claim it's been done, but you're only going off of what I'm describing, which is the coordinate systems given to you without you having verified those actual positions and distances on the actual Earth.
Not at all. Not at all.
And that can be the difference between a globe and the Earth actually being planar.
Okay. I won't be able to get through to you. It's fine though.
By the way, I was just gonna wanna ask Bob, why aren't those satellites moving?
I don't know what you mean about getting through. I mean, if you're stating that this has been done, then what is your claim? That
I'm not making any claim.
Your claim is that you have certified pictures of the sky on all positions of the Earth to verify Earth is a globe and that those things are light years away.
That's ludicrous. I'm not claiming anything, Gio. It's fine. It's fine.
Yeah, Bacon, those are geostationary satellites. The streaks are the stars and the dots are the satellites. There's 6 of them there. The bright one's name is Onus 5.
I see they sort of form a line. Is that line aligned with the equator?
No.
These,
I mean they're in geosynchronous orbit. They're right over the Amazon basin right now. These streaks are the stars. The satellites are right there.
I hate to address the elephant in the room, but I don't know if that's the sky, dude. That looks blue.
That's because the camera has 2 blue sensors, a red sensor, and a green. Well, it's got 2 green sensors, a blue sensor, and a red sensor. That's just the artifact. But you want it dark? I can make it dark. Not a problem.
Is the scope on an alt as mount or
equatorial?
Equatorial. So do you track the position angle for the images you take so you can know sort of what north and what east is?
Yes.
Okay. I thought you could only have
there you go.
Geostationary satellites if they were exactly above the equator.
No, they don't. Well, I don't think they have to be right above the equator. I'll show you where these are if you want.
But if they're orbiting,
there it is, right there.
Geostationary could be anywhere, but you can have equatorial geostationary in that model.
Yeah. What I mean is they are orbiting the Earth, right?
They have to do a great circle.
Well, that's what they say.
So, so if they're not doing that around the equator, their latitude on the ground is gonna keep changing up and down, right?
Right. It was going to negate the geostationary effect.
Yeah.
Oh,
So
in any event, that's where that one is.
So Bob,
right.
Bob,
that's close to
so-
that's close to my girlfriend.
Nice one.
Hey, whoa.
She lives in the middle of the Amazon forest.
Okay.
Let's not.
No, that's true. That's true.
Cool.
She lives in the middle of the Amazon
Where my
forest.
fucking girlfriend lives, dude. What's your girlfriend's name?
Anna Paula.
I'm just kidding. I'm messing with you. The geostationary effect. Go ahead, Joe.
Well, I guess yeah. I mean, what I originally brought up, I feel wasn't really addressed, and I didn't say it to be confrontational. Was just saying my viewpoint. Like, does Bob or Chronic or Kosher or any of you guys like? How in your mind have you validated or verified that things like Stellarium, let's say, and or the software that Bob's using correlates to the physical ground the way that they claim it does?
You know, I'm literally doing it right now.
It matches reality.
Yeah, I'm literally doing it right
to
now.
multiple continents, and it matches.
The simplest answer is it matches reality. Or in Bob's case right now, it is literally reality. Unless you think that we're in a matrix or there's a Truman Show effect inside of our eyeballs. Well, it equals reality. What Bob is doing. Whether or not he has Stellarium or some other software pulled up on a different computer, it is reality. No.
Well, I was going to say
but
that,
I guess the original question was, what has convinced you that this correlates with the physical ground in the way you believe it does? That's really
the example I was going to give you was remember, like all those times where we're using my fucking what's it called, celestial navigation thing, or using Bacon's much more sophisticated one, which does the same thing. We were asking you guys to pick any place in the world and use Stellarium to tell us the elevation of the stars from that position, and we were going to correctly locate that position based on that information alone. So that tells you that there's a lot of truth there, more truth than the truth you even just asked for, because there's a lot that implicates, but certainly the one thing it implicates is that model of Stellarium is absolutely correct, right?
And to give my experience of that, I took some star sites in my backyard, and just to try a trilateration with like data that I collected myself. And that was not just pretty close, but when I went to Stellarium, I got like almost the exact same value of the elevation angles. So I can confirm that one, at least here in my backyard.
Now, do you notice that Stellarium matches what we're seeing in reality?
That's pretty cool.
Yep. So this is what's actually happening
in reality. Yeah, and then
here's
compare it to
Stellarium. And if you look at it right there, that satellite is Amazonas 5. See, you've got the 2. Then you've got these trailers here.
Yeah, exactly.
I've got 4 of them listed.
Yeah.
There's actually 6.
So you can pretty easily right there just figure out your position angle in your scope right now.
Oh, yeah.
See, they're aligned vertically.
It gives it to you. It gives it to you right there. See? There's my alt-az.
Yeah.
And there's the hour angle and declination.
Oh, that is there?
It's right here.
Dude, oh my God.
Oh, it says apparent, so not actual, right?
Okay, good. Yeah, I was going to originally use Stellarium, but I had to fucking use Almanac instead. Figure out where it was.
What's up, Bandy? How's it going, man? You wanted to say something?
Yeah. Just quickly. I don't want to derail. When we are at the equator, looking at star trails, right? Do they appear? Not that they do or don't, but do they appear to converge and diverge? Jerry, be quiet.
Well,
yeah.
Can you finish the question?
Do the star trails appear to converge and diverge at the equator?
Across the entire sky? Yeah, that's a kind of a weird question.
Well,
I would say they do, and it actually fits both models.
Yeah,
Of course, it
I'm
fits both models.
I'm not saying the stars do that.
No, I don't think. I don't
Hold on,
think they
Bacon.
would converge.
Hold on, Bacon. Hold on. I want
Just to
Bacon
show you this is real, I'm going to turn the tracking off.
to Chronic.
Sure, go ahead.
But do they appear to converge and diverge at the equator, the star trails themselves?
Do they appear
think
to
so.
converge and diverge at the equator?
Yeah.
That's a nonsensical question.
Yeah, what in the world do you
Well,
mean by that
Oh,
question?
can I try? I think I understand the question.
That's exactly correct. They converge and diverge. Do you not?
How? No, explain to me
Can I-
how they do. I don't think either. There's no answer to that.
I think
There
if
is
you picture
They
if
do
you
on a
picture the
globe.
lines.
They do on a globe. If you know your.
Let me ask.
Sure, go
Let
ahead.
me try
Bacon.
to explain. Okay, so
Yeah,
I think
what
what
is
he
the
was
post
asking.
this one. I'll post this
It-
one. It shows just real quick. I'm posting in the chat. You guys have all seen it. It's
Yeah,
that
it shows
kind of
them
picture.
rising. Yeah, it shows them rising.
It's the
In
globe with local
Sorry.
stars, but it'd be the same. Yeah, it shows. Just look what happens at the equator. They converge and
let me-
diverge. Yeah, sorry. Go ahead.
All right,
go ahead, Bacon.
So what I think he's asking is like if you trace the lines of the stars on the sky, if those lines would appear to be converging, or would they appear parallel in the sky? I think
They appear to be rotating about the celestial
Something
poles.
can't
Yeah,
both converge and diverge.
diverge.
That
You
doesn't
can't
make
do
any
both.
sense.
No.
They rotate about the celestial poles.
Like, doesn't
what-
matter if the Earth is a globe or not. That
Yes.
statement doesn't make
No.
any
It does.
sense.
It does. It does. I think because
Absolutely.
if you
Dude,
they
it's
can
as
be.
simple as something can't converge and diverge at the same time.
But
Like,
it's not
you
at the
know
same
what
time.
that
It's not at the
means?
same time. It's not at the same time. So I
So
think
then
what he's
Bandy
asking-
didn't ask the correct question then.
Okay, yeah, I think I understood the question. I'm trying to clarify for you guys.
Okay, go ahead.
If
Go
you
ahead.
allow me. All right. So if you picture those lines, like they can be diverging as the stars go away, go above.
Oh, okay. Oh, I
from
see.
the
I see,
horizon,
Bacon. Yeah,
and
I
they
got it,
converge again as they pass this zenith. Let's say, and
Yeah,
that
yeah.
can be visually what's going on, depending on how you're taking a picture of those star trails, because cameras. No, I mean cameras usually don't have that wide of an angle, and when they do, the position of the position of the stars in the sky have to be like projected into to the surface, right?
Sure.
And that might make the stars that are the highest to be further away from each other than the ones that are closer to the equator, to the horizon, let's say. So that can create on an image or on
I
a video.
understand. Yeah, I understand
Right.
now. The question is still they cannot do both at the same time.
Yeah, we understood what I meant,
it,
right? I think that's
depending
what
on
he
what
meant.
depending on what you're comparing and where you might be looking. The answer is either they appear to diverge or they appear to converge. They can't be doing both across the entire sky at the same time from the equator.
This is just
the ones
If you
the ones that are rising.
basically
the
you
ones
need to basically, Bandy, your question you needed to be a little more specific on in order for someone to actually give an answer.
You see that picture I've just dropped, Chronic?
I don't.
In the chat. Yeah.
Yeah,
Yep.
in the chat. Well,
Yep,
they
yep.
appear to converge and diverge.
Okay, can I ask a
So
question before we even talk about it?
What sort of
direction?
lens?
What? No, nothing about the lens.
Okay, cool.
Simply what direction? That's all.
What do you mean? What
Are they going up? Are they going up
No.
or they're going down?
What direction was the camera facing? What cardinal direction was the camera facing when that image was taken?
Well, it's probably east or west.
Oh, but you don't know the answer though. You don't know which one though. Okay.
It looks the same at both.
And
So
the funny thing is that the funny thing is it doesn't actually even matter. But yeah, I get the point now, Bandy. I get the point.
Only on the picture. It's
But
on. But Bendo, it's
thankfully,
only on the
thankfully, when you move more north or south, you get a better idea of the shape that we're on.
Well,
So it's good thing people aren't only concrete, cemented to the equator. That's a good thing, right?
Chronic, this ain't about the shape of the Earth.
Oh, it
This
never is.
question.
Never is.
So what? Oh, Chronic, I don't know why you're so defensive, right?
Sorry,
you
go
guys,
ahead.
you
are
guys
I'm trying to give
are
you, I'm trying to give you context,
are
man.
so bloody defensive.
No,
It's
go
like,
ahead.
oh my god, I've got to think about it. They're trying to trap me into a corner. Oh my god, how can I answer this so I
No.
don't get trapped
I'm more
into a corner?
interested in. I know I'm interested in the background of the question, so I do want you to
I
elaborate.
promise you, you're right.
Well, we were talking about it for about 7.5 hours
Don't
last
spoil
night.
it, Kosho. Sorry, go ahead.
Weren't we, Kosho? Right?
I wasn't here for 7.5 hours. When I got here, I was very upset.
You were very upset and you were very cranky, right?
Yeah, because my friend tried to pit me against another one of my friends, dude.
Right, because your little equations that you did for the ground position
don't make me
proved
punch in the leg.
exactly our point, right? That they do.
But Banso, this is the thing. I'm not interested in trying to disprove or prove. I was trying to find something out for myself, dude.
I know.
It's fun and stuff, but it's like some people are actually making it like a battle, dude. It's like that. I'm just trying to figure out what the hell is going on. And that's
Exactly. That's what we're trying to do. That's what we're trying to do.
So after the 7 hours, what was the resolution after the 7 hours? I predict there wasn't one.
People were exactly. People were staunch that they do not appear to either converge or diverge.
Yeah, well, what happened was
that's true. That's just because of the picture, Bento. So if you that picture is aiming more or less towards the horizon, right? If you would aim it up, the lines would be closer, right at the center of the image, and they would appear to diverge as you go to the sides.
Right.
Just like it is right now, but right now you're aiming at the horizon, so it appears
Well, it was
that
a
they
bad
diverge.
question. A better way of phrasing the question is: do the stars appear to rotate about the celestial poles? The answer to that's rather easy. Yes.
Yeah, but this is the problem. This is the problem with the conversation is
don't bring the poles on the equator.
It absolutely has everything to do with the poles. That's
Obviously it does, Bob. Obviously it does, but a flat earther would never ask it in that regard.
Yeah, but
I know because they want to try and find gotchas with ambiguous questions. By the way, Bandy, I'm showing satellites live right now.
I don't care about your satellites. I'm talking.
Of course
about
you don't.
question.
Anyway,
just the problem was that.
Well,
so
I feel like we didn't really hold on. We didn't. Well, go ahead, Kosho. Sorry.
So I was just saying, so many people. This was. I started to get a bit perturbed because I was answering somebody's specific question. Jeremy's question. It wasn't about the Earth or proving the Earth. It was just about the star trails or something like that. It's because the argument he was having with somebody else, and then it turned into people interpreting the question as it should have been asked as something different, and I shouldn't have answered that question. I should have answered the question they didn't ask, and it's like we were answering a specific question for a personal argument he was having.
Can I make one more quick note? Just one more quick note. So another answer I could have given you, Bandy. Here's how non-specific your question was. I could give an answer that they appear perfectly parallel. Two stars appear perfectly parallel to one another all across the star trail, across the night at the equator. Now, just with that answer, could you try to guess two stars that I would be referring to?
I've got no idea.
They'd be two very, very close stars to each other that rise right above your zenith if you're at the equator, and they stay approximately parallel to each other all the way across those star trails. Right? That's an equivalent. That's an equivalent answer, though. That's an equivalent type of answer. You get that, right?
But are they parallel or just
so they don't diverge or they don't appear? Well, your question has the word appear. What does that mean? So they don't appear to converge or diverge if they're appearing parallel the entire time.
In our frame of reference.
Well, I know what he means by appear.
That picture, the star trails appear to diverge.
No, not two stars that are right above your zenith next to each other. No, they appear parallel the whole time.
Oh, but Bento. If you get a sextant and you measure the angle between the start of one trail. What is this noise? Go. Never mind. So if you measure the angle between two stars of different how do you call it, trails, that angle will remain constant. The whole path. They wouldn't get further or closer to each other. The angle between them.
Say that one more time. Just what you said. Say exactly what you said one more time. Because I think just say what you said one more time. You said use a sextant to measure what?
The angle, between two stars
Yeah,
across
they're
the
in
night.
different. They are in different lines. You know those lines that they form in the pictures that Ben saw in GR sending.
Oh yeah,
You found
the star trails, right?
Yeah, the trails. If you get 2 stars of different trails, right? So they're in different declinations, and you measure the angle between them with a sextant. It doesn't matter when you measure it; you're always going to get the same angle between them. So they're not getting
What do you
further
mean by
away
the
from
angle
each other.
between them? How are you making that measurement? I'm trying to.
Oh, you point one side to one and the other side to the other, and then you read the angle from the sextant. Just the angular in your field of view.
Yeah. Okay.
Yeah, how far they are in your field of view. So how far they are in your field of view is not going to change. Anytime you measure, that angle is going to be the same. So they cannot be getting further away from each other or closer away from each other in your field of view. It only does so in pictures because of how perspective works. So if you have curved lines like that and you're below them, they're going to appear to diverge, but that's just due to perspective. If I can put you inside of a big cylinder, right, and the cylinder has parallel circles forming the cylinder, and you take a picture of the cylinder, a circle at the side of the other circle are going to appear to diverge in your picture, but they're actually parallel. Does that make sense?
Yeah. And I think what Kosho did yesterday, depending on your ground position, right, the stars' ground position also appear to converge and diverge, but funnily enough, the opposite way to what you think they might. Is that right, Kosho?
No, it's not. It's not. That's what I'm saying. But the data that what I measured or what I calculated is honestly irrelevant to this. It's more relevant to an actual celestial navigation observation or whatever, but it's irrelevant to this idea. And then that's what I didn't. What I didn't calculate was what Chronic had just, or not Chronic, but what Bacon had just described about the angular distance between the two, not the difference in the angles from as they appear from you as they move. You know what I mean? So I was doing a more practical question that end up not relevant.
Did your calculations not show that the ground position of the stars, right, converged and diverged because they were different? They got wider and they got smaller. Yes, they did.
Yeah, but you're saying
saw it
this. I have to make clear what it showed. What it showed was when measuring, let's say, 2 stars, one of them being on your latitude, one of them being some other latitude, as they move in the sky, the difference between the elevation angle of each of them is going to change as the night progresses. Like it's going to increase and decrease. I think it decreases as it moves away from you and increases as it's over your head. But that's a different question. It's not really relevant to this.
You were talking about ground position yesterday.
No, it's the same thing. The elevation angle is going to be related to the ground distance from you. So that's why I put both of them on there, because
you never said elevation angle yesterday. You only were talking about ground position.
No, I went back in and I put in the angle also, but it really they're interchangeable in that regard because it's the one gives you the other.
Well, you never brought that up yesterday,
I
FYI.
did.
You were only talking about ground position.
I know.
Because you actually said it's a little bit perplexing for both sides.
Yeah, because I was relating it to what the discussion, and it wasn't until afterwards that I realized that it's actually not. I was doing a more practical thing, but what I should have done is try to measure the angle as they changed, the angle from each other in reference to one another as the night goes on, which is not what I did. So it ended up being irrelevant.
Anyway,
I'll post the thing I did.
Sorry, I derailed the conversation.
You didn't derail it, Mr. Banstock, because actually I derailed it by making that picture, man. By doing that math.
Ben, so I sent some parallel circles, seeing from the inside. If you want to take a look at it.
Yeah, this is what I was describing last night. Yeah.
Yeah, I am not arguing at all that the stars do or don't in reality. That's not what I'm.
Sure.
What I'm saying.
Yeah, I understand. I completely understood that now.
Okay, cool.
Because people were
Just
yelling at me last
explaining.
night because I was stating that because we're strictly talking about the perspective. We're strictly talking about what would be what's observed.
Yeah, exactly. How they appear. They may not do that, but what they look like, that they may, or what they do look like, what they may look like.
Because they're
So-
definitely making parallel circles. That's a fact. They're going to be parallel circles no matter what two stars you pick.
Maybe we haven't confirmed that yet.
I have actually, dude. I'm not kidding, man. Don't laugh at me, dude. You guys are always laughing at me, dude. You know, I have to go to a therapist because you fucking.
You're a funny kind of guy. Like you
Yeah,
should be
man.
happy because you bring joy to people's lives, Kosho.
Yeah, I love bringing a nice chuckle to a. Oh my god. Anyways, I'm gonna post a stream, Mr. Banson. Obviously, Banson's a good guy. Just make that clear. I'm posting right now a picture of a graph of a proof of the shape of the Earth, and you know, I don't know if you care about what it means that the Earth is a globe or not. Who cares? What it ultimately is showing is that these are the stars, these are the latitude and longitude, and these are the longitude 10 minutes later. The longitude 10 minutes later. The latitude doesn't change, not in the whole day. And the fact that the latitude doesn't change tells you that if you were to take the path of these GPs on the ground, they would just be, you know, two parallel circles, maybe of different sizes, of course, but parallel in nature. There you go, Benson.
Thank you. Oh, just quickly, Chronic, have you looked into any jelly experiments yet?
Dude,
No.
that was my thing, Benson. Why are you asking him?
Kosho has promised to deliver on that, so.
He's going to deliver.
You guys fucking suck, dude.
Well, I thought you had access to the
To ballistics, Joe?
No,
Dude,
to the
you can get
high
that.
level, right, of insider experimentation.
Mm-hmm.
Dude, you can get that from the grocery store, dude.
This is M13, the Great Star Cluster in Hercules, by the way.
Hey Bob, have you
That looks nice.
yeah, that does look pretty good. Have you ever done any photometry with that telescope of individual stars?
No.
So, are you able to sort of I don't know what software, I'm not familiar with that software, but like if you took a single star, you know, a bright one maybe that's not obviously blended with any other stars. Would you be able, one of those, would you be able to fit just a simple aperture around that and just measure all of the counts that are inside an aperture, you know? Like all of the you know, all of
Well,
the
yeah, it can be done, not with this equipment though.
yeah.
This is a camera. This is just stuff that you guys have access to. This is stuff you could be doing.
That's what I was going to ask you, Bob. Is what exactly is this from a telescope that you have yourself?
This is live.
So this is live. This is live, but your telescope is not like something that we could.
Can you?
No, it's actually a camera. It's just a 300 millimeter camera.
There's your camera.
Can you point to Orion Nebula?
I'm just asking if this is your camera or if this is a public camera.
No, this is mine.
Yeah, 300 millimeter.
I will say on Stellarium, there is a tremendous amount of cartoons in that software.
Yeah, sure.
Okay.
They're like actual cartoons, like pasted in, because they kind of try to make it like more dramatic, you know, like, oh, here's this galaxy, and it'll have one of those CG.
No, those are actually photographs.
Do they come
Not...
from the? Do they come from the straight from the Disney studio?
Yeah, straight from Disney to your Starfield. Yep,
that'd be kind of cool.
Well, one thing you can do right now is screenshot what Bob is streaming and figure out exactly where he is.
Of course, but
can we see if Pluto has
well, considering my latitude and longitude are right there, you don't really need to do too much.
Yeah.
I didn't say how.
The other one that's extraordinarily cartoony is Google Sky. If you look at Google Sky, you just zoom in. There's literally like pixelated cut-ins of full-blown cartoons.
Well, you know, not everyone, you know, not every citizen and civilian of the globe world Earth is an astronomer scientist that needs to see raw data, or else, you know, their lives are are
Well,
destroyed.
The Orion Nebula is below my horizon, by the way. Can't see it.
Yeah.
I agree with you, Chronic. I don't think that Google Sky was designed to be some kind of real. I don't know. I guess it's not real to life. I guess it's sort of more of a hodgepodge of different things. But yeah, I hear what you're saying, though. It's not claimed to be a raw data thing. Well,
no, but that's
I don't know. I mean, I guess you have to see what they claim. I guess. But
you're describing.
They can't. There's no way they could claim that shit's real. A lot of stuff in there. If you just get it and start zooming around, it's literally cartoons. Like I'm not saying. I'm not trying to like call NASA stuff cartoons. I'm saying it actually is digital graphics put in there.
I know, but what you're describing,
you can point to that and actually see exactly what's showing there. A lot of people do it.
Go ahead, Kosho. Go ahead, Kosho.
Sorry.
Yeah, he's describing the composite nature of the images and the fact that when you zoom out, it's a flat rectangle, and so it has to look like that. What you said, like about it being like cut up or whatever. Like missing spots and pixelated and that kind of thing, and some of those spots.
You can see this one with your eyes, by the way. If you have a dark night.
Which one is that one?
It's a really shitty night.
That's the cluster still.
Yeah, that's the Hercules cluster. I just zoomed
Just
out.
a wider field. Yeah.
It's just gonna look like a star, right?
No, that's thousands of stars right there.
Oh no, I mean to the naked eye.
To the naked eye.
No, you'll see it. It's kind of fuzzy.
Yeah, it looks like a dust ball.
Yeah, you can see it pretty clearly with a good set of binoculars.
Oh, yeah, I saw the cluster. I saw the Milky Way when I was going back from the Amazon forest.
Oh yeah.
Yeah, I was flying during the night, and I thought there was like a cloud or something. And an hour later, I realized the cloud was still there, and that was actually like the Milky Way arm.
Do you live in a city or something?
No, that was in the airplane.
I know what I'm saying, but because you usually like in Texas, there's plenty of places like out in the country and so, and in the ocean also. You see it. Yeah, you see it clearly. It's hard to see it in the city area or even a small town.
Yeah, it depends on what Borley number your skies are. I'm 3 to 4 right now, so plus we've got a full moon tonight, which really is just washing everything out.
Mm. Yeah,
I mean, I can't see shit tonight.
What's right, man? I was trying to ask Bob about this software and if it works with any camera. That's all.
Real quick, if anyone wants to join my stream, I just pulled up Google Sky.
All right.
Tell me what this is. I mean, it's literally pasted in. Like you can actually, it's a square that's posted into this. Can you see that part? And then are you telling me that that's in the sky with all the colors? I mean, because they even admit, like in the Hubble stuff, they color it. They use these artists, they add color and they add all kinds of stuff to it. This is what is in Google Sky. So I'm telling you, like they literally are pasting, something else into whatever the rest of this background is.
Because that's a high resolution picture of it.
No.
Okay, so they're pasting in a cartoon.
No, what is that? Is that the Cigar Galaxy?
It looks like a supernova.
It was one of the first things that I just
back it up a bit. Let's see where you are.
That looks like a supernova.
Yeah, that's look at this thing.
Galaxy right there.
You're telling me that's what's in the sky? That
yes,
thing?
You can see that.
Yes,
I mean, we have people here.
Look at these over here. You're telling me that thing? This thing is cut in. Look at that.
What do you mean?
Oh, Lordy Lord.
No, that's exactly what it looks like.
These are composites.
Okay, Bob, hold on. You're telling me right here, that's not cut in? Come on, Bob.
That's what they're saying.
No, that's what it looks like right here. You're looking at the galaxy. That's an image of the galaxy that they put in there so you could see detail. That's what the galaxy looks like. That's the Cigar Galaxy.
That's the border to keep all the illegal aliens out.
Yeah.
Right?
And Bodes is right below it, and the Garland Galaxy's off to the left.
Look at this thing up here. Look at this cut in like red light. Look at that straight line there. That thing's jacked and cut in there.
Yeah, those are images of the galaxy they put in there, so you got a really clear view of it.
Okay, so so what you're claiming?
But Gio, let me say one. Bacon. One last thing, Gio. Okay, you see the Cigar Galaxy you zoomed in on. Okay, maybe it needs to be. We need to more explicitly explain it to you. So, if that if that image was not placed in there by the software, that high resolution image of the galaxy, what you would still see is that galaxy at a much lower, crappier resolution, right?
And you can see out the edges.
Yes, you can see the outer bar, the outer edges on the lower resolution version. That's simply all it's doing. So, anyways, go ahead.
They're
Bacon.
pasting cartoons into here. So this is
They're pasting real images on top of the. Go ahead, Bacon. Go ahead.
I was just gonna say that
ones that you
for-
think
sort
that
of-
they have extra super duper equipment to get a super duper thing.
Of course,
we have people here that do it. We have people here
Yeah,
that do
I've
it.
done it myself.
Hey, Chronic, do you have an image of what a crappy image looks like of that? So we can
Okay, so
compare
the same thing, the same edges.
How
and
about
things like
this?
that.
This is real. This half cut in. What is this thing? What is this?
Well, I want Bacon to get a. This is comedy.
this-
Sorry,
Chronic,
Bacon.
get me on this one. Come on, at least give me something to hold on to.
I really want to hear what Bacon says. Go ahead.
Bacon, what do you got for this? This is a half cut. What is this deal?
Yeah, I was just gonna mention that this sort of things, like croppy and edges, you also see on Google Maps and Google Earth, right? That doesn't mean Earth is fake. I mean, Earth exists. We know that's how it looks like. So you can also see the exact same thing there because we know they're combining lots of pictures. It's not a
Look at
surprise
these.
that they do the same for the sky.
That last one was a bipolar star.
Yeah, that one. Yeah, what's up with this one?
That's
Look,
bipolar.
if you don't know what you're looking at, you can't figure out what you're talking about. Obviously, that is two images. That's probably a seam in the image that they've got. That's no problem with that.
Yeah, just all you do is anytime you see that, just realize that that's exactly what Chronic said. It was some great insight because that they're placing images over the images, and the images they're just deciding to be placed in are ones of these famous structures.
It's just a
that they
better
have
image
pictures
over
of.
a crappier image. It doesn't take that much of a sophisticated explanation.
Hey man, I was backing you up. I take back what I said, dude.
That's fine. Take it back. It's all good. And yeah, Bandy, to answer your question.
Yeah, I'm not like, I understand that Google Maps might say, like, for example, like, look at this thing, like this little dually, like that, right? Like they're obviously like pasting that in. But that's kind of the whole thing that's in question.
One of the most famous galaxies in the sky, Andromeda.
And
Okay,
what,
let me
exactly. So
I'm
you're
gonna
saying that
one of the most well-studied galaxies in the entire sky. Anyway, sorry. Go ahead, Gio. Go ahead. That is literally Andromeda, the closest major galaxy to us.
We're gonna crash into that bitch one day, dude.
Okay, so how can I, without NASA's digital Hubble anything, how can I see that?
You can buy a set of high-powered binoculars. Even you don't even need your own telescope. Just get some pretty good quality binoculars, and look in the night sky where this software predicts or says that Andromeda should be in the night sky.
Yeah, I'll show you where to look.
Guess what? You'll see something that matches what the software told you should see.
I'll see a light there. I'll see a light there, but am I going to see a bunch of little balls orbiting a big ball?
Yeah.
I understand it's a luminary. It's
I will show you where to look.
I'm not
right
doubting
now.
there's lights in the sky. There's all kinds of
You see this constellation Cassiopeia?
I'm saying you're
Looks
not
like
going
a
to see what this shows you.
Yes,
You see this constellation Cassiopeia that looks like a W? It's in the north sky right now. If you look at this side of the W, see that forms like a little wedge? All right.
Yeah, I'm aware of Cassiopeia.
Great. If you follow that wedge down, you come to Andromeda, which is right there.
Oh, and look at that.
You can see it with your naked eye.
Yes.
I'm not doubting there's a luminary there. What I'm doubting is that there is a big...
It's not a luminary, it's a galaxy.
Big swirls of balls orbiting...
Geo. It's a galaxy.
Yeah.
Can you look Livestream one text? Can you just look at the picture I sent on Livestream one text?
Yeah, it's right there.
I see it, Bacon. What about it?
Right. So that picture was taken by someone on the server.
Me.
Okay. So Geo, the what you're saying. Okay. So if you took a set of high-powered binoculars or your naked eye and you went out and you looked at that exact location where it's telling you to look, Of course, nobody here is saying that you will be able to resolve that great of detail of compared to what the software you're using is showing. However, if you actually went to a way bigger, way more powerful, bigger light collecting area, better instrumentation telescope, then yes, you will start to be able to resolve structure and spiral arms and features in reality. You will see that.
You know what? Instead of doing this like a battle or whatever, I got a really good suggestion for you, Gio, because you're a buddy, and I don't want to. If we battle this, he's not gonna want to do this. But I think that it might actually be cool, like because Bob just described how to see it. I told you can see it with your naked eye. So over the course of however long you want to do it, just like go out there and check it out with your naked eye a few times.
That's not the contention. I mean, I've looked and studied.
No, hold on.
Life, so I'm aware that there's all kinds of activity.
That's not the whole thing. That's not the whole thing. I was gonna say, look at it with your naked eye, and then just like look and make sure that's consistent, and then look at it through binoculars, make sure that's consistent, and then after you've done that a few times, look at it through it as the highest powerful telescope you can possibly look at it through, and see it in detail, this thing that you've been seeing the whole time, and it might possibly answer some questions on it.
Well, it's like the devil's in the details, because the devil's in the details, because the difference of there being electromagnetic plasma pulsations of different colors and sacred geometrical forms and different lattice structures, all of that is understandable in my viewpoint. However, if you take it to this next step of that claiming that these things are balls and that they're actually galaxies, you then have to zoom into a level at which there seems to be something else entirely going on to support that model that I don't see empirically validated.
Well, that was a bunch of nonsense. Thank you for that.
Sorry, I'm actually looking up, Bob. There are two.
Well, thanks for just writing me off and being really rude about it. Do you have any response to it? Because what I said is empirically validating the super zoomed in Hubble type images that are showing us the type of quote unquote galaxy that you guys are saying is the case. You have no empirical validation of that other than from government organizations like NASA that claim that they have super duper telescopes. But what we actually see is the actual lights and the way that they actually are observable to us. So there's a huge leap.
Yeah, I'm confused what you're
leap there. And what I'm saying is that, in my understanding, I have not seen you or anyone empirically validate that actually is what they are, what NASA's providing.
All right. Give me 1 sec. I'll show you images I've taken with a non-governmental telescope of that shows structures of a galaxy, structures like spiral arms. So I'm actually using effort to do this for you, and I have zero optimism about what their result will be.
Well, I don't doubt that luminaries have orbital and spiral structures. The entire universe is a spiral.
So then what's your argument?
That they're not balls orbiting a big ball.
Oh, come on, Gio.
They got no balls, man.
Well, if you want to see balls orbiting balls, you can look at Jupiter.
Hey, come on.
There's a couple other things I can think of, but yeah, man.
I mean, the moons of Jupiter are clearly orbiting it.
It's an extremely easy way to see balls orbiting bigger balls.
And atmosphere without a container.
That one you can see with your naked
eye. In a spherical planet.
Orion Nebula.
Chronic, I'm reluctant to ask you this question, dude. Because you're not very helpful when I ask you for help. You always just pick on me.
The nice
you're easy to pick on, Gosho. I don't.
Okay, that makes me feel better. Thanks, man. I thought it was just okay. That's cool, man. It makes me feel a lot better. All right, I'm looking at this fucking thing in Hubble. I do this a lot. I like going to Hubble catalog. I always like looking at their pictures. But to tell you the truth, man, I don't know what I'm doing, dude. I'm just like clicking on shit. I don't know what it means. And
yeah, one sec. Here's an old image of the galaxy M100 taken with a private telescope, non-government owned, that is 0.8 meters in diameter. Pretty decent sized mirror.
That's a Manly telescope.
Yeah, of a spiral galaxy with tons of structure. In the chat. You got some feedback, Bob. Sorry, go ahead though, Kosho. Something about the Hubble archive.
I'm gonna Google it.
Chronic. Do you know why? Some of those stars have like a blue dot in the middle?
Like which ones?
They're Indian.
There's the
I
cigar
know.
galaxy
Geo
right
been to
there,
a
Chronic.
couple.
Yeah, another one with the same telescope, the same 0.8 meter. It's a Schmidt-Cassegrain.
Yeah, I mean, offhand, looking at these two, I don't have any conflicts with them. They look good.
Yeah, and the second one that this directly answers Bandy's question earlier that was unanswered. So if you compare the second real image taken by me with a telescope to your software of the cigar galaxy that you looked at in that software, Bandy's question was, Chronic, can you show me a real telescope image that is crappier, that shows the same thing, that is just lower quality and not as good? This directly answers that question, Bandy. Comparing the second image I sent with the one that Geo was looking at in the software.
Now that looks heaps better. Doesn't it?
Yeah, it was super low resolution, spatial. The pixel scale is much crappier and larger for this image taken with a much smaller telescope. But
Where's
it's
the one in
amazing. It's amazing what
Sky?
you get when you. It's amazing what you get when you go to a larger telescope, or you go above the atmosphere. Go ahead, Bacon.
No, I was asking where is that one in the sky on Google
Which
Sky?
one? The first one is the Galaxy M100.
No,
I mean, you want me to give you the
the
coordinates?
spiral one. The spiral one.
Sure. Just I'll look up the coordinates for. I don't remember this off the top of my head.
Right.
It is.
How don't you?
Somebody watching a sitcom?
No, I think that's Bob's software. Every time a exposure is finished or something.
This Google Sky is crappy.
No, I
Doesn't
had it
show
on
coordinates.
mute. That shouldn't have come through.
Well, it did.
The
one.
Something
bad.
fishy's happening in here, and I don't like it.
This Google Sky is pretty crappy.
Hey, Chronic.
Well, Bacon admits it. It's pretty bad, right?
No. I mean there are not a lot of options. It doesn't show the coordinates.
Well, if you start zooming into some of these objects, like some of them are like four hacked up cut things that are just all. It's just a mess.
Okay, I mean the web page.
Yeah, the whole thing is just old and outdated. Maybe this is not really an updated project. I don't know. Maybe it was just sort of a cartoony thing that they threw together and
probably
Google Sky. I don't know.
Hey, Chronic. Just like you said, yeah, I know. I'm looking at Hubble's stuff right now, dude. Okay.
Mm-hmm.
Like, what is your explanation for this? Sorry, I didn't mean to interrupt. But
no, it's cool, man. I'll work.
Kosho's been trying to say it for some minutes now, so
it's fine. It's fine, man.
No, go ahead, dude.
Hold on,
Each one of these things I zoom into on Google Sky, it's like a different. This one is not even cut in. It just has like a graphic. It's just very strange. But I'll stop. Go ahead.
Wait, Kosho. I switched over to your live stream, Kosho. A lot of live streams going on right now. But I already know exactly what I know exactly what you're looking at. But I'll let you ask it just for posterity.
No, dude. I'm as curious as a cat right now, dude.
What are you wondering about the gap?
Yeah.
The gap there, right?
Yeah. Well, that's one of the main questions. Every time that happens, there's a gap. It's like the crosshairs is on a fucking gap, and I want to see the cigar galaxy, dude. Why is it doing that?
Yeah.
And also,
sorry, go ahead. And also what?
Also, where's the cigar galaxy? How do I find it? Because this picture is supposed to be a picture of the cigar galaxy, and then there's just
Yeah. So the first thing I noticed at the top, the title there, HST, which stands for Hubble Space Telescope.
That's right.
ACS stands for the hold on.
That's right.
Yeah, Advanced Camera for Surveys, and then WFC is Wide Field Camera.
Yeah.
So you're looking at a wide field camera image from the instrument called ACS, Advanced Camera for Surveys. Anyway, so that camera, if you look at the design of it, that camera is made up of two individual chips. And the two chips they're abutted up against each other, but the way that they're basically fabricated into the camera, into their mount, the mount that holds the chip and stuff, allows for a gap between the two different chips of like 20 pixels or something. So that's that exact gap that you're seeing.
Okay.
So what happened in a lot of, I guess this is like a freaking teaching time right now. But anyways, what happens in a lot of these imaging campaigns and programs that use cameras with gaps in them is what's called dithering. So your strategy for taking a bunch of images, say you take 24 different images, after every 3 images, for example, you'll shift the pointing very slightly, which is called a dither in technical term, dither. And so what that dithering does, it allows you to cover where the gaps are. Yeah.
I understand. I really appreciate that big time. Should I look for a different observation?
Yeah, you need to. Yeah, if you want to go, I can tell you exactly how to do it. Yeah.
Yeah. So I'm looking at these list of. Oh man.
You closed your stream.
Hold up, sir. I appreciate that big time, and I was going to ask you actually if you just wanted some other time because I don't want to take up. But I mean, this is interesting information because this catalog is available to everybody, and this is like a fucking huge archive of all the pictures.
Yeah, but you could easily hand wave it away to say it's just government Illuminati planting the data there.
That's true, man. But I'm trying my hardest not to.
Okay. Anyway, you can continue. Unless
no, I'm just looking at this. I'm looking at this list now. So what's a good strategy then for picking the?
Oh, my bad. Are you streaming again?
I'm still streaming. Yes.
No, you're not. You're not.
Oh, I mean, that's because Geo sabotaged me. Hold on.
Okay.
Right. So now I'm streaming this. What the hell? Can you see this? Anything?
Yep. Yeah.
Where is it? All right. Anyways, I can't see my stream. So either way,
I can see it.
Cool. There's a list. What's a good strategy to picking these bullshits?
The order is I would recommend is camera first. So you want to filter by instrument or detector.
Okay, and what kind of camera do what
detector? If you click detector,
what should I be looking for when I do filter the camera?
WFC3, WFC3.
That's what I want. Okay.
It's the most recent and sort of highest quality detector on Hubble.
Well, I'm just gonna pick one of these then. Cool.
Can you click detector and it should filter by detector? No.
All right.
You don't. If you click it, right? Is it not filtering?
It just takes a long time because I'm trying to do it so it's not boring.
Okay, whatever.
No, but yeah, no, it's filtered now. But my computer's real slow, man.
You want to go reverse alphabetical. You want to click it one more time. Oh,
I did that, dude. I'm
okay, that's good. That's fine. Go down. You definitely don't want to do whiff pick 2.
I thought that's what you said.
No, whiff C3. 3.
So
there you go. See, whiff C3 UViz right there.
I would have totally thought that's so confusing.
All right, try to get either like a visible or infrared. So you can go.
Where does it say that? Right here.
Yep, next to it. I see F555 and F814.
Are those nano?
Yeah, they're the wave passband. Yeah. So down a little bit more, you'll see 555 and 814 next to each other. Keep going, you'll see them. It's down there. 555, 814. You'll see it. Yeah, right there. Yeah. So just display one of those two and see what you see.
The moment of truth. We're gonna see if Chronic was full of shit and everything he said, or
your computer is slow as hell.
No, it's not. This is not even my computer, dude. Okay. Okay. Now what?
I see the old page. The new one didn't load on the stream.
Okay, and it gives me a whole wide range. So how do I know where to look for Cigar Galaxy?
Dude, I mean, if I could see it, I could help you a little more. But do you not see an image preview yet?
I see the whole thing.
Okay.
It was cool. I just don't know.
So it should be a mosaic of The cigar galaxy.
It's a big portion of the sky.
Okay.
I don't know, man.
Yeah, I mean, I can't see your preview anymore, but what are you asking now? Are you still confused, or?
Yeah, it just shows me a big portion of the sky. I don't know. Where's the cigar galaxy?
What do you mean?
I'll take a screenshot and I'll fucking post it, dude, but then we'll do it some other time.
Sure. I mean,
All we
you
see
gotta-
is
you
just
found-
a list. That's all I've
Look
seen.
up M82, Messier 82.
Yeah, that's right. That's what I was.
Yeah, he's at the correct spot. He's just he's not able to show the display.
You see the picture I posted?
Oh, you posted a picture?
That's what I'm looking at.
All
Dude.
I see is the listing, Kosho. That's what you're showing.
You know, it's probably. Oh, it's because you know what? I know why. Because the way the streaming works, they changed windows. Hold on.
Yeah, you got to stream a different window.
There we go. I got it, boys. That's why we need Terry here all the time, dude.
now we're seeing something.
Okay. Yeah, so from this page, I get this thing. I know I can this, it'll center again. I know I can zoom in. I know all that stuff. I know these things do something. But how do I find the cigar?
Yeah, you went to zoom out more. Zoom out.
Yeah, look up M82.
Yeah. He did. I'm seeing what might appear to be M82.
In one of these, it's just one of these guys?
No, you're slow or something, but I'm appearing to see. I'm starting to see the galaxy.
All right, well, dude, that's a stupid way
There
of
you go.
doing it, then, dude. They fucking zoom in way into it, so you can't even tell that you're zoomed into.
Do you understand? Okay, all right. Come on, think about it, Kosho.
Yeah, I get it now.
Think about the field of view of the detector and how much of the sky that galaxy takes up.
Yeah, that's a good point, man.
Okay. There's no way in hell you're ever going to get that entire galaxy in one single Hubble pointing.
Okay.
That's the point of what's called mosaicing.
Yeah, right, and that's why the James Webb you get a much bigger portion of the sky. Right.
You don't, but
yeah, I can. But just never mind, dude.
Okay. Not to be that.
Appreciate your help, man. Thanks for the encouraging remarks.
I'm impressed you got that far, so that's good.
Yeah, I got all the way there. That's cool.
Yeah. Beautiful looking galaxy in Hubble.
Hey, real quick, what does the stuff at the top mean? Like when you can click on these different like buttons and there's like the first, the galaxy. What are these for?
Different surveys.
Oh, so it'll just take me to different pictures.
So some of them are different. Yeah, some of them are different surveys, and some of the ones on the left, like DAO font and source extractor or sextractor for short, those are catalogs of stars that have. So all the stars in that image have been cataloged and measured by some method, which is colloquially called photometry.
Yeah, I heard you say earlier.
And there's catalogs of them that are generated. So if you're ever interested in a single individual star in any of those images and like its magnitude or its color as measured by Hubble, you can look deep into those catalogs.
Okay, I appreciate it, man. I appreciate being patient. I appreciate everybody else in here withholding the same rude remarks he was making. Thanks again, Connor.
You're welcome, man.
I would never figure that out, man. I thought, I was like, what? It just shows me this white line. I was like, is it in the line?
You were almost there. You just needed to zoom out.
Yeah.
That's all.
Appreciate that big time. So wait, so that image that still image, well, I guess it's just it's not from the Hubble, obviously.
There you go.
Yeah. Somebody's camera.
So, yeah.
True.
You guys are deep in the weeds there with whatever.
No, so what I'd like to know is why do people think that this is unbelievable going by a machine that's out there that's doing this?
Do you believe it? Do you believe there's a machine out there doing it, taking these images?
Well, I got no other reason to believe it's not.
Of course they are.
Look at this picture I just got.
Is that what you go off though? Whether you have a reason or do you just get to the bottom of it either way?
What do you mean get to the bottom of it?
Well, I'm saying the question of whether that is what it is claimed to be. Do you need to question what reason they would do in order to question the phenomenon itself?
That statement doesn't really make much sense.
Well, Terry said he has no reason to question it, I think is what he said, right?
Yeah.
Yeah.
So that's what I'm saying. Do you need a reason to question something, or would you just question it anyways? Because do you question everything, or only things you can think
No,
of?
I don't have that. I don't have that as my first thought to question something straight away.
Okay, so your first step would be to kind of accept it, and then
Yeah, if it doesn't smell right or seem right, yeah, I might be skeptical of it. But where it's coming from, why would I have a reason to doubt that this Hubble telescope that's been up there and documented and verified that it's doing these images?
We have enough verification that it's actually there and doing these things that we don't need further documentation of that. All right, we have warrant to believe these images.
well, what would you say your best one or two reasons for believing the Hubble is real would be?
Oh, come on.
Because it's real. That's why. It's like saying, why
Because
is that
people
airplane
launched
real?
it.
Or why is that satellite's real? Why is, I mean, the questions are silly in itself.
Yeah,
Nope.
I mean, come on, Gio, you're better than that.
You know what's he's a lot better than a lot of us. But that aside, did you know that flat earther called Shines? You guys know her? And a bandsaw, we talked to her the other day.
Yeah.
Anyways, her father-in-law actually was one of the lead scientists on the Hubble. She's a flat earther too, and she actually talked to him about it. But anyways, I think that's interesting. So she'll even tell you about the that it's up there, or that it's something. I always find that weird that flat earther believes that the telescope's up there.
Okay,
Yeah,
so
she just started her own server. Did you get an invite to that?
No.
Of course not.
Oh, I guess I'll have to send them around.
Thank you, Jerry. Thank you.
She told me not to invite you guys.
Okay.
Yeah.
What's her reasoning for thinking the planet Earth is flat, though?
I guess you'd have to ask her ultimately, but so far in terms of the Hubble being real, it sounds like Hannah said just because it is, and then is there anything else, or is that the only reasons you guys think it's real, just because it is?
I mean, by virtue of it, what the pictures it takes, it's taking these awesome images. I guess you could kind of take them from Earth, but not really. I don't know if
We
you
have
ever seen that
warrant
deep
to
field.
believe that it's there, Gio. I mean, it's beyond question right now that it's there. There's too much. We have too many verifying facts to show that the Hubble is indeed there.
Well, that's what I was hoping to get. Like you guys kind of just said just because, but I was,
I said just because. They didn't.
Fair enough.
I said
We
the
have
deep
warrant
field
to believe it
pictures.
because we have many valid reasons to believe that it's there.
Well, that's what I'm saying. Like, what's the top 1, 2, or 3?
We launched it.
Countless human beings on Earth with their own hands built this thing.
I could count.
Some of those same human beings put that thing into a truck and shipped it to a launch pad. Some of those same human beings took that thing out of a truck and strapped it into a space shuttle, and some of those same humans witnessed that thing get launched into orbit. I mean,
And then some other dudes
into the sky.
yeah,
some other dudes had to go back up there.
it got launched directly like a missile, boom, straight into the Bermuda Triangle.
Yeah, right.
And then
And you could
subsequent shuttle missions went up and repaired it.
Yeah.
Right into the Bermuda Triangle. It's at the bottom of the ocean today.
Yep.
Splash.
Yep.
Yeah, they sent Specsavers up to sort out Hubble.
And then
Hey, I got a
from
question.
there forward, they just pump the CGI, just a steady
For
flow.
sure. I mean, we gotta have a little bit of fun sometimes. It can't always be so serious in here. Of
I got a
course.
quick question though about that because we always talk about like these expeditions flat earthers could do, like to Antarctica, and I know you guys have excuses for it and stuff, but there would be other there's a ship called the SS Mercedes out of Florida, and it's like it's a gold, like it searches the bottom of the ocean for sunken treasure, and it's found like billions of dollars worth of gold. They had to give it back, unfortunately. But regardless, I would think that maybe there were some adventurous flat earthers who would take it upon themselves to maybe go explore the ocean floors and see for themselves that if it's full of like Saturn V's and space shuttles and whatever else would be down there.
Well, they don't necessarily have to sink to the bottom. I mean, that is a trippy idea to think, in terms of at the Bermuda Triangle, like what actually is down there, or other places. Is there just a graveyard of all kinds of equipment? But in reality, any device that they would launch up that would come back to Earth, they would easily be able to retrieve it and bring it back, tow it back, whatever it may be, to not leave it out there. Like, why would they leave their evidence floating around the open ocean?
But you just said though that they could easily go retrieve it. Yeah, the retrieving might be easy, but discreetly. I don't know if these are large objects, right? Like, are they going to really? Is it a guarantee that they're going to be able to discreetly, bring these things back and hide them somewhere?
Yeah, I mean, essentially, I would see it as it's like military transport. So it's just military transport where they have multiple different drones and equipment that are keeping radar and track of their path and everything that's around them. So yeah, they're just doing a retrieval.
Yeah, but don't you think somebody would see it?
It wouldn't be that hard to do it discreetly if they're in the middle of nowhere.
Yeah, but they have to eventually. They're not just going to take it to the ocean and then just guys, let's keep it in the ocean, guys. Just put it in the fucking trash pile in the middle.
Most of the
Right.
ocean,
You have
the
to ask
ports
yourself
are
when
in.
you deny all these things, like deny the telescope's real or deny any of these observatories don't see what they see. You have to ask yourself why. Why would they?
Who's denying that telescopes are real, Anna?
The Hubble. I'm
You
just reading it
guys
right now.
apparently you just denied all the Chronix things for like the past hour.
Never denied. Never denied. Chronic looks at pictures. Never denied that.
Oh, he
Bob,
just
you're
looks
showing-
at pictures, right? That's all
Bob,
he's doing.
you're
He's just
showing
looking at pictures. So silly.
Bob, you're showing an image of the moon that's the right way up.
Most ports in America are in massive cities, so how are they going to hide these huge pieces of equipment, these satellites and rocket ships that are sending them? How are they going to hide that?
It's not like they can just put a
on the
blanket
East
over it.
Coast. There's no ports that aren't in occupied areas in America. It just doesn't exist. So how are you going to hide that?
Scientists spend all this time and money and effort just to lie to everybody.
If you want world domination and to control people, then that would be top on your list. Yeah.
Yeah, but that's what I'm saying.
Chronic, he's just all out for world domination.
No, not Chronic himself.
I'm low
you're
level.
referring to
That's what most scientists are like. They're just like Chronic. They're just like Jay.
But you were talking about the people that retrieve the things. What I was going to say is that, have you ever seen those huge Freightliner that huge military vessels that essentially they open up in the back and you can drive things into them? All they would need is a large one of those, whatever the floating rocket or whatever it is that's out there. They just go, pull it into there, close the garage doors, drive where they go, boom, they go to their military bases and they retrieve.
Hey, Gio.
Well, Kosha was
Gio,
in
I'm
the
just curious
Navy.
about
I
something.
was in the military for 5 years. I don't think either of our experiences would match that.
So all of the missions that are going on every level of
Hey,
the
Gio?
military on all fronts?
Gio, by the way, my father is a mechanical engineer and worked on the moonshots. Are you saying my father is a liar?
Oh my God! Seriously?
Yeah.
Seriously?
You have to
are you saying my father's
a lot
lying?
of people that do this work, liars.
You're calling his daddy a liar.
You do have to call these people
I'll make
liars.
I'll make sure to only say the words that I say.
It's implied. Doesn't matter. It's implied.
Oh God!
It is.
For
And there's
what
no
you're
real
saying to
reason.
be
I mean,
true,
it's silly.
there are
You guys
implications,
take it to
whether
such
you want to
extremes.
be a
I mean,
man and admit that or not.
if
For what you're
rocketry is
saying
being
to be
faked,
true, there's
yeah,
implications.
if rockets are being faked and they're not going to space and they're actually falling in the oceans and the military is retrieving them, somebody who worked on one of those things unknowingly, of course, would not be. Perhaps, I mean, they could be a liar, but in general, it doesn't mean they have to be. They could just be doing what they're doing.
Now all
They're
rockets are fake.
compartmentalized. They're just making the equipment. The liars in that case would be the actual levels above them that are actually doing the media stunts and the actual, that
Oh,
part of
for
it.
God's sakes.
So of course, just
I
engineers
know,
that
like,
worked
just
on the
admit
Saturn
it,
V
man.
or
Just
whatever are
be a
not liars,
man
but
about
the
it.
astronauts and the people who actually ran the fake moon landing, they are lying.
Oh yeah,
Just be a
fake.
man about
Everything's
it.
fake.
And who knows
Yeah,
That's
what
so funny.
Chronic's
we're all
motivation is? I don't know.
we're all fake. We're not real.
Chronic may very well want world domination.
Even Bandy's not real.
Carrie's not real. Andy can't be
Hey,
real.
you're not real.
Back to another, not to kill that very interesting conversation.
Dude.
But I actually looked up Bob. I don't know. Obviously, I don't know your exact location, nor do I care to know. But
It's in northern Michigan.
if you're interested in doing any sort of real astronomical observations in science, there's quite a few transits that are beginning in the next 30 minutes or so that you might be able to point your telescope to and measure some exoplanet transits.
Chronic wants to have a trans party.
Okay, Kosha.
If you're interested in doing real science,
Well, you
come on, man.
You know what I mean. You know what I mean.
What a big thing to say, dude.
I think
Hey,
it was
hold on,
implied.
Chronic.
You know what people know what I meant,
know,
Bandy.
Chronic,
Chronic,
and you know what I meant too, Chronic. So.
Yeah, you guys are doing the whole thing. Hey, Chronic, can you help me out for a second, dude? When you say the transits, a couple of them in the next couple of minutes, you're talking about you have access to just a catalog of all different satellites and them transiting?
Link it to you right now. Yep.
That's pretty cool, dude.
There you go. It's called Transit Finder. It's maintained by Swarthmore.
I thought that was a dating app.
No, it's
dating app.
Yeah, it's a really cool tool. It's called Transit Finder. You just put in your sort of coordinates and what parameters you want, and it will generate a list of all of the upcoming transits that are viewable from your location.
Are a lot of them
Are you after a new dating app, Kosha?
Yeah, well, 2022, man. But hey, are these all naked eye I guess observations? But a lot of the satellites are going to be real small and stuff.
Are you saying satellites? Are you saying the word satellites?
Listen,
You
dude,
did say that at one point, but
I thought that's what you were saying, man.
You said satellites, but maybe you didn't.
Yeah, maybe you misspoke or something. I was confused. I'm saying so. This generates a list. If you use that link, it'll generate a list of upcoming within the next day or two, however many, whatever parameter you can give it. You want to give it all of the upcoming transits of different planets in front of their star that they're orbiting.
Oh, so this will give us the opportunity to do the luminosity. What do you call that kind of
light curve transit?
Yeah, that's right. Oh yeah. Dude, quiet, man. But yeah, okay, that's pretty cool, dude.
But then the naked eye ones, I think one of the first parameters you can select on that list is what target list do you want to search through. And there's a bubble there called the TESS objects of interest, and so you were asking about naked eye objects. A lot of them aren't.
Yeah, of course.
But the best chances, the best likelihood of getting one, of generating one of these targets in a list that may be bright enough is the TESS archive.
Okay.
TESS, yeah.
Okay, and this is a question for you or Bob or anybody else who knows the answer. But do you know any tool for an amateur like myself? If they wanted to use this sort of catalog and they also wanted to just observe and measure the magnitudes Like
Yeah.
something very similar. Like, what's a good tool to measure the magnitude?
Yeah, so I've talked to Slacker about this also actually in Gems. He's usually in Gems. He has another instrument setup. I think kind of similar to Bob's actually. I don't know the exact specs of his scope, but anyway, we discussed a little bit, and I think he was interested in doing just some hundreds and hundreds of amateurs do this. Amateur astronomers do this
That's pretty cool.
every night. But anyway, what was your question? Oh,
No,
software.
what would be a good tool
There's
then?
tons.
Yeah.
There's tons of tools and software. There is Python. If you're familiar with Python, there's something called
Oh yeah, I've heard of it.
yeah. There's something called Exoplanet. Like that's the name of the software. There's another really easy GUI interface that's easy for it's very straightforward, a graphical interface called Astro Image J.
Okay.
All right, so
pretty
Chronic,
popular.
when these transits are occurring, what is your understanding of what's happening when they happen? And I guess number one, what do we? I can't even talk. Okay, what do you observe, or what is observed? I know it's a dimming, and the light dims essentially, and goes on a wave. I can't even talk right now. A curve wave. I understand all of that, and so what is your understanding of what's happening, and then what are you observing? Just to review that.
Yeah. So, let me start with in the beginning there was a survey ran by telescopes, and these surveys looked at all parts of the sky and just stared at stars for countless nights, and some of these stars had very periodic dimming, like very periodic, that were much smaller types of dimming than the traditional variability of stars that we've known about for hundreds of years. How stars can vary and there can be flares, they get brighter and dimmer and stuff. So anyways, from this initial,
and this is different than the twinkling.
Of course, yeah, of course, yeah. So from this is a very these are very obvious signatures of something going on. Something. They're not claiming anything. No one's claiming anything yet. That's why we call them objects of interest to begin with. So these objects of interest that are logged and flagged as being an interesting thing are then followed up by dozens and dozens of other telescopes all around the world, government-owned, private-owned, amateur, no affiliation to Illuminati, anything like that. And tons of observations are made of this periodic dimming, and so some conclusions are made with more data. Some conclusions are arrived at that this particular star actually seems to just be going through a higher period of stellar activity, nothing more, nothing less, based on deductions that are made from the empirical data that's taken, empirical observations, things like that. In other cases, there are models that people have derived and built in software or out of software, whatever, it doesn't matter, that will attempt to model this star as if it has a planet that is orbiting it that's nearly perfectly aligned with our line of sight, so it will transit. I'm sure I'm not saying anything new. So
associating
right?
associating a concept of a planetary body orbiting the thing in an orbital cycle that correlates with the timing.
Yes, to an extremely high precision confidence, right?
Right. I got you.
So we can predict.
And then these are fixed stars, right? These are not any wandering stars.
Well, all the stars all have proper motion.
Right, but I'm saying that they're fixed. So there's like the stars that are in, the constellations, like they're fixed in position to each other, and then there's what we might call a wandering, like a planet type thing in the.
I don't agree to the first thing.
Venus. Well, okay, you would agree that Venus moves differently than what I'm calling the fixed stars.
Differently.
it traces in its position against the sky, which is why it moves through, like, Aries, Gemini, etc. It moves through because it's moving
Okay.
at a different.
It has a larger proper motion on the sky than farther away stars. Sure, I'll accept that.
Well, yeah, like even on a heliocentric model, like Venus would move differently than all the stars that are light years away.
Differently, sure, with a larger proper motion than the other stars, which are not fixed in reality. But continue for the sake of it.
Yeah, so these the dimming that you're referring to in these phenomena, what I'm asking is that they are on fixed stars, correct? Because the thing about the quote unquote wandering stars like Venus, Mercury, there's like thousands more that wander. So I'm just saying, are you doing these on wandering or fixed stars?
No star in the sky is fixed. So we got to get past that stepping stone, I guess, before we can advance to
They're
N-wave.
fixed in relation to each other. That's what
They are not. I disagree.
Well, that's what the term fixed means. It's not that.
That's why I disagree.
Technically, on both of these models, as it were, like the stars are moving. Like on a planar Earth model, the stars above, of course, they're moving. On the heliocentric model, you guys kind of maybe claim that for all intents and purposes, they're not because they're so far away. But in reality, you also say they're moving.
No, I disagree as well.
The whole Milky Way galaxy is not moving?
You need to. You're using the word fixed, and we disagree with fixed.
Yeah, it's not fixed. I've never heard any scientist say that it's fixed.
Okay, so the sign of, let's say, Aries, the stars that people associate with Aries, are you telling me that those are not referred to as fixed stars in your understanding?
There are no
Correct.
fixed and wandering stars in modern astronomy. I'm sorry. Those terms simply aren't used. Use the correct terms, please. Planets and stars.
Okay, so when I go to Wikipedia and the definition for a fixed stars is compose the background of astronomical objects that appear not to move relative to one another in the night sky.
Oh, you said an A word there. You said an A word. It starts with A. It starts with A. You said it in sentence. What was that A word?
Astronomical.
No. After that one. A P.
Apprehension?
Not quite.
I don't know why you interrupted. Let me just finish.
Sorry,
Unlike the foreground of solar system objects, which appear to move, which is what I was just saying. So, the Venus ones appear to move. Generally, the fixed stars are taken to include all stars other than the sun. Nebulae and other deep sky objects may also be counted among the fixed stars.
Yeah.
So, why did Bob just say that that's not part of astronomy?
Okay, now listen.
Completely false.
So the words that you just uttered in several instances, not just one, in several instances during those few sentences that you just said, I heard the word appear. I heard the word general, in general. I heard so these are non-specific these are, I would consider them layman terms for a general audience to get an idea, but do not represent the actual reality. You disagree with that? I'm telling you that the word, literally, you said words that mean what I just said they mean. So in reality,
I'm not denoting one or the other.
Mean anything.
I'm not denoting one or the other. I mean, from this Wikipedia article, it also says here, astronomers and natural philosophers before divided the lights into the sky into two groups. One group contains the fixed stars, which appear to rise and set but keep the same relative position over time. The other group contained, they say that they're talking about the planets now, which were referred to as the wandering stars. So what is in conflict in your mind? Are you saying that the fixed stars, in your viewpoint,
no, that's a cherry definition you're using to try and support your silly position.
Let me try to take a different. I agree with you, Bob. But let me
try
to take a different.
Doing condescending insults. So if you're going to do that, it's not going to work. Please.
Let me try to take a different approach. Okay, and see.
Yeah, go ahead.
Sort of. Okay. So I have empirically. So I have myself, literally me, this human being talking to you. I have confirmed empirically with data taken from observations, measurements made, that the stars that you are referring to as fixed, which may have been historically labeled as, are indeed in motion. They have their own proper motions relative to each other. Period. So either you can take what I just said of my own observations, data, measurements, experiments, all empirical, that show this, and accept that, and we can move forward with the conversation, or reject it, and I guess we go nowhere.
Well, it's a really big deal because let's just take Orion's belt. We all know Orion's belt. You know, you're telling me that Orion's belt are not fixed, but that they wiggle and wobble all over around is what you're telling
They
me.
have their own. Each one has an absolute proper motion and a relative and also a motion relative to each other.
Okay, then
Yes,
how much are
I'm saying
then the
yes.
next question is how much are you claiming that they move or wiggle or whatever the word would be? How much are you claiming they move?
Oh, we can measure that. We can clearly measure that. You take an image with telescopes or with whatever, however high precision you want. The better you want your accuracy of this motion to be measured, you need to scale your precision of your instrument that you're using to that, to however whatever level of accuracy you want. Take an image in 1962, take an image in 1982, take an image in 2002, and take your fifth image in 2022. Compare, perform a method that's called astrometry, METRY at the end of that, astrometry, and you have directly measured the proper motion of whatever stars that you're observing, i.e. they are not fixed.
Okay.
Did that come across clear?
Yeah, and thank
Okay.
you for sharing that.
You're welcome. Yeah.
And I appreciate you sharing it and everything. So I guess, but the original question I was actually asking, because you would agree that whatever motion those have, like Orion's belt or something like that, is extraordinarily minimal compared to, let's say, Mercury. The way that Mercury is clearly moving at a significant.
Now,
You can look up
now you're making a little more sense. To me.
Orion's
There you go.
belt, yeah, like Orion's belt. Our whole lives we look at it. There's Orion's belt. Now, if you're saying there's absolute some motion deep in there, that's fine. But I'm going to refer to those as fixed stars, unless you'd prefer to use a different name, compared to something like Venus or Mercury or something that is really cooking compared to the other.
Yeah, unfortunately, a human lifetime is only 100 something years at most, and not 30,000 years to actually see this visually. For one human.
So you're claiming Orion's belt will not always be Orion's belt.
Of course not. Of course not. Yeah, and you know this. You've seen this stuff before. I know you haven't. So
But the original
try to
question,
move forward, though.
The original thing was actually, it wasn't even that deep of a question. I was just trying to get clarification that when you're doing this micro lensing, the light dimming, and because that's originally what we were talking about. Is
no, we were talking about transits.
Yeah, the transits. So when those occur, it was kind of just a simple question, but we went on a deep thing. And I do appreciate your sharing. But I was just more asking, like, you're doing that on what I would consider fixed stars? Is the answer?
Okay. Well, does that change anything? Do you have a narrative here, or if it doesn't?
No, that's what I'm saying. I was
then...
just asking for clarification. Like, you're not doing it on things like, in this case, it's not done on Venus or Pluto or whatever. It's done. You're doing it on the fixed stars, as it were. Those are the things that are.
My scientist brain will not let me accept that. So you gotta acknowledge. You gotta at least understand how my brain just won't let me accept you saying that. I can't. I cannot help it. I just can't. I'm trying to come to your level, but I can't.
Gio, you should really just use the correct terms rather than made up ones. All right. We call them stars,
or old world astronomy understanding, which was flawed and not correct.
We understand when we say the term star, we understand that they do move very slowly. We understand various characteristics of them. When we talk about planets, we understand various characteristics of what a planet or a moon is. We don't have to make up terms like fixed stars and wandering stars and crap like that.
Okay, so hang on, but just to be fair, because now you're claiming that I've made something up, which is a weird kind of attempt at attacking.
Yeah, it's a cherry pick.
You're claiming that this person talking to you on this Discord made up that term. Is that what you're telling me?
Yes.
And it wasn't you. And the Wikipedia page here doesn't talk about. And the Wikipedia page doesn't talk right here about the Pythagoreans, Plato, Aristarchus of Samos, Exodus.
I don't care what they said.
Ptolemy, Copernicus, Tycho Brahe.
Nobody cares what they said.
All use the term fixed stars.
Use the right term.
All these guys use the term fixed stars, and you're claiming that I just made it up.
Yes.
Well, he didn't make it up. Come on.
You're just cherry picking. You're cherry picking a definition because you don't want to use the correct term. Just use stars and planets. That's the name of the bodies now.
I'd
That's
like
the
to get
current
back.
term.
Sounds
I'd
like
like to
Hannah
get back to
Hannah
the
was
science,
willing to
though.
be honest and say, of course I
Yeah.
didn't make that up.
Is the science not
If you
more
want to say
important
you don't
than
think the term is correct, the one you want to use,
than the
that's fine. But
words?
obviously, I didn't make up the term.
Okay.
Sorry. So go ahead, Chronic.
I just it's extremely interesting to me. So that keeping on the science is actually what I would like to do. I'm trying to do. I can actually tell you how we determine with some level of confidence that the star, so that the planet that is orbiting the star we're observing and measuring is spherical. Is anyone interested?
God damn it, I am, dude. I am. Hey, real quick though, I wasn't listening. I just want to make sure you did make it adamant that the main thing that gives you guys the confidence is the cyclical nature or the periodic nature. You see that, right?
This is also, just real quick from the Wikipedia page, describing fixed stars in terms of relational mechanics agrees with Newtonian mechanics.
You say Neptunian?
Newtonian.
I was like, what the fuck's Neptunian mechanics?
That's how physics works.
It's
on
all
Neptune.
relative, though.
So if you imagine this, I'm sure there's actually like animations or figures. I'm kind of lazy, but if you imagine the shape of this object that is eclipsing a star that you're observing, that if the shape of this object, the outline or the shadow, the shape, whatever, however you want to think of it, shape of this object governs the shape of the light curve that you observe. If you think about that, right? So think about a circle coming in front, a smaller circle eclipsing in front of a bigger circle that's behind it, and how if you could measure very precisely the shape of that eclipse, so the brightness changing for that, you're measuring the brightness changing for that transit. If the shape of this object was a square, a perfect square, which obviously is crazy in reality, for something to naturally form in a square shape in space. But anyway, if it were a square or if it were a triangle or if it were something, there would be a very obvious signature of that shape in the light curve that you observe. So I can claim with a pretty significant degree of confidence that the shape, the shape of this object eclipsing the star, transiting the star, is a circle at most. That's the most that I can deduce. It can be a pizza. It could be a pizza. It could be a whatever. Let me get to the punchline.
It could be like a lens. It could be like a lens. Like if you take your eyeball, if you put like a contact lens in your eyeball, but if you put like one little, like a small black dot on the contact lens, or a medium size, or a large one, of course it's going to block different amounts of your eye. And so I get that.
So here's the punchline with how amazing our technology and our instruments have gotten, how sensitive they've gotten. After that eclipse happens of whatever that object was, that transit, whatever mysterious object that was, we continue measuring that star, can continue the measurements every 30 seconds, every 5 seconds, whatever. And we can actually see now, only in the 21st century, we weren't able to do, our instruments weren't sensitive enough in the past, however many decades, only until recently, 10, 20 years ago, we can actually measure what's called a phase curve for that planet. So that as that planet is orbiting and moving, side to side around the star, different phases of the surface of that planet are being illuminated by the star it's orbiting. Like think of phases of Venus or phases of the moon or whatever. And we can actually measure that. We can measure that. And so that gives us even more confidence, even more. It just builds on the mountain of confidence we already have that the real shape of that object is a sphere, is a ball shape. Does that make sense? How you see the phases of it changing, which is called a phase curve, and then it'll eventually go into a secondary eclipse, which means the planet is now behind the star.
Mm-hmm.
Yeah, and the star is now in front of the planet, so you don't see any signal from the planet anymore. Like all of this is all of this is done a lot.
I was going to say
Who cares? That's just light in the sky, man.
Yeah. So how have I heard? I think I followed everything there, but how would you say that what you're claiming to get with the phase shift thing is different from, let's just say, a geometry of the distance doesn't really matter right now, whether it's light years or 3,000 miles. At the moment, doesn't matter. Just let's say a big ball and a smaller ball, spheres, one sphere going in front of another sphere, etc. And like you're describing, or let's say a circle of light, an orb, a circle, whatever you want to call that. Like it doesn't have to be a disc. I'm just saying a circle and another circle.
Hey, Chronic, can I ask you a question?
I'm just wondering, is there a way to?
I know, but actually, what I was going to say, what I was going to correct you before, it was based on what he was asking you. Actually,
Like I could imagine there could be, right? Like I'm imagining, a sphere does have the curvature to it. Therefore, if you put one sphere in front of another, and it's blocking that light, yes, like the amount that it's actually curving around the ball would be different than if it was, let's say, like a lens, like a almost like a 2D lens type concept where there's one circle going in front of another circle.
I was going to tell you before, Chronic, because you said it could be these.
Well, maybe you can't delineate between them, and that was my question: is if you feel if you can.
I don't know. Did you say that before, though, Chronic, or did you say it could be these other shapes? Because I was going to say that spheres are the only shapes that appear to be circles always.
There's two scenarios. There's two. No, a pizza appears to be a circle also.
No, it doesn't.
Okay.
Not from every observation, like from every angle, like it's on.
No, I'm talking about one given specific scenario. Yeah. So if you're talking about, of course, the phase curve for a pizza would be way different, obviously. But
you're seeing it multiple times, obviously.
Yes. I don't follow exactly Geo's your lens analogy. If it can explain our empirical observations better than our what our current understanding is, then I'm happy to consider it and try it out. But I need to fully understand what you even mean to take the first step, right?
Yeah, and I got you. I think it's just like, okay, let's just say you're standing in a huge Costco warehouse and, it's dark or whatever. And then, somebody shines a big sphere, a couple 100 feet away from you, whatever it is, a huge sphere. And then there's a smaller sphere and, the smaller sphere passed in front of the large one and you can measure the exact way the light, et cetera. What I'm saying is that compared to just, if the spotlight thing was a good example, maybe if the spotlight was just like a.
Does it have to be a spotlight? Why can't it just imagine that the bigger sphere that's 200 feet away is just it has a light inside of it. It's a hollow sphere that has a light inside. That's just so it itself is the thing that's generating the light. It's illuminating. No, just think of it that way. Why does there have to be the spotlight thing? That would be a better analogy. Is that the larger sphere is just the source of light itself. That, in my opinion, that's a way better analogy than a spotlight. So can you pick up the analogy in that scenario, or does it break down?
Right. No, I see what you mean. That's actually interesting as well, and kind of brings a little bit of another component into it. Well, imagine, okay, you know how like if you took a sheet of paper and you just cut out a circle and you put it flat on your table?
Sure.
Okay, what if you then turn that up to the sky? So now you have a circle on you're looking at a circle, like a flat circle.
Through a piece of paper?
No, just the sheet of paper is the flat circle.
But it doesn't always appear to be a circle.
Like, okay, I'm not even saying that the things are flat circles. I'm just talking about these two different geometries. I'll try to say it this way. Again, the Costco thing. Okay, you have a huge sphere that's lighting up, and then you have a small sphere, and then you get the phase shift and all that stuff. If you now just take an alternative concept of a circular light, it's just a flat circle that's emitting light, and then you have another circle, like a black circle thing, that comes into it. So what I'm asking is there any way to decipher between those like two flat circles versus two spheres?
Yeah. So, okay, I think I'm following a little more. Yep. So, in the two flat circle scenario, so remember the two scenarios that I presented that are empirically measured and observationally confirmed by. Okay. Those two separate scenarios are, number one, the actual transit itself, when the transit happens, right? And the second scenario is the phase curve, which is in between. It's after the main transit, but it's before the secondary eclipse. It's before the planet goes it's before the smaller flat circle goes behind the bigger flat circle. Those are two independent, separate scenarios. So now moving into your warehouse two flat circles analogy, the transit itself, I will give you the transit itself can be two flat circles. Let's just say, it can be observed with a two flat circle scenario. Let's just go with that. However, the second scenario, you have the smaller flat circle after the transit has happened. And so now you're seeing the full bigger circle that's illuminating, the bigger flat circle that's being illuminated, and there's no longer a transit happening. As that smaller flat circle continues its orbit to wrap around the backside of the flat circle, you would see a very constant brightness, a constant magnitude. In other words, you would not measure a phase curve, because none of the light that the bigger flat circle is illuminating is falling on the smaller flat circle anymore, because it's off to the side, so to speak. Right.
Right. And I do totally got you on that. The only thing is that how would you know it's going behind it if you're not witnessing anything?
You are, though. What do you mean?
I'm saying I get the idea that it passes in front. You can there it does, it does the dimming thing, but then you're saying it's now circling around, orbiting, coming around the back end. But if you don't observe anything when it goes around the back end, which makes sense, it's like it's just a small thing going behind a big thing. How do you know it is going behind there?
That's the best. No, that's sorry to cut you off early. The amazing thing about how sensitive our current generation technology is in instrumentation, you do see something in reality. You measure what's called a secondary eclipse. So you measure very, very slight, an additional slight dimming of the light that you're measuring, the brightness. And it's much, much smaller. That's why it's only taken recent, new generation instruments and telescopes to be able to measure that. It's a much, much smaller dimming, much smaller. The secondary eclipse. Kosho, you probably have. I've sent images of this, and
I was gonna ask you.
It goes around the back end. It does dim a little, but just not a lot.
And does that make sense? Why it would dim a little bit?
Because there's no added
exactly
light from the
exactly.
side.
Yeah.
Wait.
You're what you're measuring is the combined light from the main star or the main object, and the reflected light from the planet. You're measuring both. You're measuring the combination, the sum of both of those. But once the planet goes behind the star, you're losing that added brightness from that's reflecting off the planet. So you get what's called a secondary eclipse. Yeah.
I like the idea. It's a pretty wild idea. The only thing is, like, you're claiming that like the light is like the amount of light that bounces off like the Earth here, you're saying that you're actually picking that up, the light bouncing off the planet, you think?
Technology and instruments are amazing in the 21st century.
I don't think,
yes, sir.
I don't think, I don't think that you understood his question. At least maybe I didn't. I think.
No, I'm getting it. He's saying,
I thought you were just asking if we said the light from Earth.
No, I was just using the analogy to say that in this heliocentric idea, in our solar system, at any one time, our Earth would be reflecting some light off of it because obviously the sun is hitting it. So I'm just saying, like, you're telling me that in a similar type system, far, far away, you have a sun and then you have a planet maybe similar to Earth. I mean, whatever, let's say it's the same size, whatever. And you're saying that far away, that the amount of light that planet would be reflecting because of its star shining on it is measurable, whether that planet is to the left or the right of that thing versus behind it. And because it's behind it, now that little bit of shine that would be coming off that planet is now not there.
Yes, sir. I am indeed.
But
I put a great diagram explaining this.
Is it fair?
Of course, the diagram that I just posted in the chat, before you say it, of course you can call it a cartoon. It
I
is
wouldn't
a
call it a cartoon.
diagram that's supposed to be a description of what I'm describing.
That's certainly
So-
a diagram. But hey, Chronic, is it fair though to because I don't know if it got better, and I think it has gotten better, but I mean, because they use like the most common ones are these super Jupiters, right? So is it fair to really say like Earth? Because I think
it's way easier. Yeah, it's way easier to detect this very, very subtle signature and this change with a much larger, Jupiter-sized planet.
Super
However, our instruments and our sensitivities are continuing to get better and better. That this pushes down the size of the planet naturally that you can detect this signal from.
Yeah, but that's what I wanted to make sure that you said about the cyclical and the periodicity and that kind of stuff, and then not just of how many times it goes around, but exactly what you were just saying about the signature, like the values of the light. It's actually telling you something. So I remember when I first heard about the transit data, and even the scientists, like, it looked like what they were doing was pretty boring. Like, they're just looking at data over and over again. But
if we had SE in here, he'd be laughing his
yeah, exactly. Yeah. I mean, honestly, they look like they just sit in like a fucking boring office and they just look at this data, and
he'd be posting that one. He signs that one meme of just like 2 pixels with starlight falling on them as like an exoplanet transit, and he signs it SE on there. But sorry, he's not here.
But you have to
nice
admit though that even though that's the that's what you have, that's the data that you're looking at, is these numbers. You have to admit that when you get numbers like that, that's telling you that's telling you that's not random. That means something. That is doing exactly what you were predicted to be doing if that was a planet orbiting it.
Yes.
Value, so
yeah. It doesn't matter if the star if the light only falls on 2 pixels or not. The fundamentals of what you're measuring and what you're concluding are unchanged by how many pixels that the star falls on in that case of those memes. Because again, you're just measuring the sum of the star plus the reflected light of the planet at whatever phase it might be at. That's the most simplistic way of explaining what you're actually measuring. Of course, it's just lights in the sky. Of course, these are just luminaries projected by maybe the Illuminati to keep me and other scientists, sheeped and brainwashed. Of course, all that's possible.
I mean, that's not only a straw man to no one in here, but that's also a straw man to the entire world, because I've never heard anyone claim that before.
That's funny, Gio.
You've never heard anyone claim that? Come on.
No, it's true, man. It's definitely a straw man, because Gio's not. I was about to give Gio props, because it sounds like he's. I think, Gio, you can respect at least why Chronic and maybe his peers would have confidence in something, even though it's just data like that. The patterns in that data and the fact that they're cyclical, I mean, that's telling you something, right?
It indeed is telling you something. Whether it's telling you that you're being duped beyond belief, or it's telling you something about reality, that's the point of the debate.
Well, but what I'm saying is I don't think anyone's saying that the Illuminati are putting things up there to dim or whatever, like making the stars that way. I mean, perhaps they're saying the creator is making.
I've been in 24/7 recently, and maybe you haven't, but it's bad over there. It's very bad.
I can't speak for everyone, but if is somebody telling you that there's entities on this earth that are making the sky that way it is?
Yeah, people say that, dude.
There also could be like added things, like they could be adding all kinds of shit. So that's one thing. But.
I have heard from more than one person that there are all of these are astral projections from secret locations that people are not able to go to, Antarctica maybe, of lights that are being projected in the sky by the cabal, the global cabal.
Right the hand said there was LCD, that the dome was LCD screens. The entire dome was all LCD screens.
Only LCD. You can't even get like 8K. 4K.
What were they before they had LCD screens?
They always had them.
Remember those old plasma TVs?
Tube TVs.
Old ones, yeah.
But I guess you could go there with it if someone wants to say that somebody's making it. But I mean, if we just look at the sun and the moon, there is an eclipse process that occurs, and we see sort of a black circle, intercept the light of the sun and so on. So I understand, like, there's, like we said before with the warehouse thing, like either spheres or discs or lights, or, there's lots of different, ways of looking at it in that way. But like an eclipse, how to decipher that that's two spheres doing that versus two round circles?
Again, I did describe it. Did I not? Remember? If it's two flat circles, then in the diagram that I gave, then what our observations would show us, what the data would show us, that no human is intervening in how the data is coming in.
Right, but that's mostly because the thing goes behind it.
In your two circle scenario, the data would not show a phase curve or a secondary eclipse. It would not show that. However, the data does show that. So that rules out the two circle conclusion. That rules out the two circle scenario.
I don't want to take away from Chronic's because that's much cooler one than mine. But mine is simple. I keep saying this, that spheres are it's literally the only shape ever that you can view it and its shadows as circles. Every perspective you have of a sphere from any angle, every shadow it creates is going to be as a circle.
Well said,
whereas
Joshua.
no other shape does that.
Okay, well, that's why I'm kind of trying to get, so Chronic, the thing is, you did say the thing of the fact that the idea that it's going around the back, I got that. But in terms of the actual phasing of it between, let's say, flat circles versus spheres, and again, I'm not even saying they are flat circles, we're just using that as an example. I thought you said that actually those would be indistinguishable in terms of the actual phase itself.
No. This very specific scenario of only the primary transit, when the smaller flat circle is coming in front of the bigger flat circle that is illuminating the light. Only in that specific scenario.
It would be the same in that.
I'd have to think a little bit more about higher order effects like limb darkening or the shape of the ingress or egress, which are higher order things that are way more that don't need to be discussed here. But if I gave more time to think about those I concluded that they would be similar enough in terms of the data that you get to be indistinguishable, then sure, we can go that route. But again, we don't only have data from the main transit. We have data from the entire orbit, which breaks that ambiguity.
Because
which rules out the flat circle thing, right?
I mean, in my viewpoint, I don't doubt that there are these events happening, because I'm aware of cycles within these, what I refer to as luminaries, and how they're moving. And I think it's connected to the electrostatic fields, the electromagnetic fields, the flux lines, the magnetic nodal points that pass between them and within them, which causes an alteration of their light emission, like in eclipses. So I'm saying, from my viewpoint, I'm saying the idea that somebody said, "Oh, the Illuminati are projecting it from the North Pole or something." Yeah, I'm not saying that. I think there are very real cyclical processes occurring with these objects. I may have a different perspective on it than you do in terms of the idea that they're spheres very, very far away and so on, and that they're out, in that particular makeup. But I don't doubt the phenomenon is there. I mean, we see it in eclipses. So I mean, it's very
and there's more specific scientific related questions that have been asked and that have been studied in very in depth are things like figuring out if and how we can determine between a real transit that may happen compared to, let's say, a star spot, which we see on the sun all the time, right? We see sunspots, these dark areas of the surface of the sun that are moving across the surface. So a lot of work has gone into determining if a transit, if this observed dimming of the starlight that we see is due to something like a star spot compared to something like a planet or a body orbiting in front of it. Jeremy almost got to this level of a legitimate, I shouldn't say, of an interesting type of question like this to ask a while ago, where he asked, could it not just be like an asteroid or some other random body that just flew in front of it? Which is still a silly follow-up question, but is like on the line of like, legitimate, questions that have been thought about in this field of astronomy. But again, we know star spots evolve, they change, they go away, they pop up randomly. However, transit of an orbiting body is extremely periodically can be perfectly predicted down to the second, and lasts forever, for as long as human existence has lasted, right?
Forgot.
Yeah, I mean, even in the astrology work, we look at transits. Even that term is called, transit, because essentially all of these bodies, let's just say the Mars-Jupiter cycle. Essentially, there's a conjunction, which is when they're right next to each other in the sky or in the exact same position, and then you have you have all the aspects going out. Like the first one, generally, of the major aspects, you have the 60 degree, which is a sextile. You have the 90 degree, which is a square. So that's when they're 90 degrees from each other. You have a trine, which is 120 degrees, is a trine. These are all just splitting the circle. Sextile is splitting the circle by 6, squares splitting it by 4. The trine is splitting it by 3. And then you have the opposition, 180 degrees, when they're opposite each other. And of course, like the eclipses the moon and sun are on that cycle all the time. New moon, full moon, new moon. And it's like the seeding and the actualization, and then back to seeding, back to actualization, full moon, new moon, etc. So they're always doing those cycles. And then the 2 points that need to be aligned with the sun and the moon would be the lunar nodes. So when the lunar nodes line up in the sky with the sun and the moon, then boom, we get the eclipse. So it's not a far stretch to take that exact same system and to think, okay, let's say a star that we would call a star that, not necessarily like a Mercury or Venus, like a planet thing, but like, let's say a star would also have its own cyclical qualities to it and have its own, perhaps, like the idea of Rahu and Ketu. What if there's tiny Rahu and Ketus that are correlated with particular cycles with those stars?
Okay. Sure. I think you're maybe diverging away from sort of the measurements that are taken and what they imply. I'm not too well read up on the what was the word you called it?
Well, I was just using that basic concept, like even like an hour hand and a minute hand, like obviously once at every hour, those two hands intercept, the hour hand and minute hand. So every hour they intercept somewhere. So if one of those is a star and the other one is a magnetic nodal point that absorbs light, then when they line up, you would get a dimming.
Yeah, you sort of just said words without maybe qualifying them, or quantifying them would be even better. How exactly does a, quote, magnetic nodal point absorb light? In reality, not just maybe in cool psychedelic pictures, but in like reality with measurements. Because I know you're the king of those cool psychedelic, toroidal field type cool stuff. It's all very cool looking. I give you that for sure.
Were you just talking about how magnetic fields can polarize light?
No, not at all. No.
Because that would be what I'm referring to, like a magnetic nodal point that polarizes light.
Okay.
Like those filters, like where you can like polarization filters, where you can turn them sideways and they'll be black, and then you turn it the other way and you can see through it.
Mm-hmm.
I mean, I don't have any way to go up there physically and get a sample, or you know what I mean. So I'm not trying to claim that this. Yeah, I'm not claiming that. Like, I'm not asking you to believe this is what it is or anything. I'm just talking about my understanding of the way the sky works and the way that eclipses work, and then was just linking that to my understanding of how these stars would be having these transits. And I understand the idea that they are spheres and that they're out there and all of that. But to me, that's not the only explanation for the phenomenon.
So is there anything else you think we might be able to do to sort of help us distinguish between these different ideas or scenarios? Maybe taking the data in different like filters, or with a polarizer or something like that? Or there's no hope and we'll never be able to?
When you first,
I would say, I mean, I'm just laughing because at the end there, you're like, there's no hope. We'll never do it. I mean, those are great questions.
I mean, we could speculate until the.
Well, but even so, I mean, when you first have to.
But if we're trying to get to the root of the truth, yeah, it is tricky. I mean, yeah.
Yeah, but if you, to get to that point, wouldn't you have to have an explanation that fit both, that both where both explanations, both models fit the observations? Because that's what I like about what Karnak's bringing up. Is I totally forgot about the different the light at the different portions of the transit or whatever it's doing. Because that to me, that in addition with the cyclical shit, is the damning evidence, which it certainly fits the model that we would predict the orbit. And I agree, Gio, that if there were some other explanation that also had that same description, that would have something. But I think before you try and distinguish this from something else, you have to first. I think right now that this distinguishes it from something else. You'd have to first find something else that also is explained this way.
Yeah, I mean, we're broadly explaining kind of like science, how it's done in reality, beyond just a dumb explanation. Or dumb definition, I should say. Dumb definition. Like the point is to determine if there are X number of equally likely models, or X number of models, or X number of explanations, that can equally describe the data.
Right. Yeah.
So they're indistinguishable from each other. That's why I asked if you can elaborate on this what was the terms you said, a magnetic nodal point that would absorb precisely the correct amount of light that matches perfectly the observations and the data. Then I would consider that a competing model, a competing idea. I haven't seen that yet. I'd like to see something like it so we can test it, put two models against each other and test them with.
I can work on it for you, G, if you want me to.
Yeah, you should do it, Kosha.
To rub in this fucking asshole's face, dude.
Well, I guess, I mean, it's sort of, it's interesting because, I mean, the idea of the Earth being a sphere, in a huge galaxy, I can understand the model you're describing, the idea of the transit and the stars out there and so on. But then, of course, the idea the Earth isn't a sphere and that we're on, sort of like the floor of the universe, like we're on a planar surface, and then the sky is just something above us. And we could, somebody said earlier, an LCD screen. Is it plasma? Is it luminaries? Is it light? Is it gelatin? Like Ben saw was talking about the Jello. So is it light bulbs up in gelatin up there? And I mean, but of course, if the Earth is like stationary and planar in that nature, then we don't have necessarily the light years and light years. Although I guess you still could maybe, but I don't think so. Actually, on a planar Earth, you can't really have them be light years away because they're all moving in relation to each other. So anyways, so then there would have to be another way that it's happening if it's not the spheres that far away. And the same could be said about an eclipse. I mean, is that the moon coming in front of the sun as two big spheres, or is that some kind of a circle in the sky, that absorbs the light? And one thing that's interesting, just to tag out with that about eclipses, is like what I've seen a lot of very deep analyses of the eclipses, and the magnetic field coming from that black thing is like completely null and void. So it doesn't register what physical matter registers. It's just like literally a black circle. And so the idea that it's like absorbing light, it's just, it's interesting.
Connie, I've got a quick question for you, mate. Your work peers and your fellow peers in your field that you respect. You bounce different ideas off all this sort of stuff, looking for competing ideas. Do all these people come from a background of, say, similar to yourself, mathematical, science-based backgrounds, or are you taking opinions and ideas from people that have alternative ideas and looking at those as well?
I think you know
Like
the answer
homeless
to that
people and stuff.
question, Bandy.
Uh-huh.
I don't do alternative facts, Bandy.
Yeah.
No, but I'm sure that
Well,
people.
Hannah, they're 100 million light years away. You've got no idea what they are. So,
Yeah, no, but the people. You have to look at people
Oh
like you're
yeah,
from.
we actually do.
actually, you don't. You got no idea, but you can think you do. You might have an apparent idea, but you don't have an idea.
We have a pseudo idea, and there's
What do you
scientists.
mean apparent
Like,
I've
idea? What does
literally
that even
matched
mean?
the star spectrum to material spectrum in a lab.
Right.
So it's like
So
I know what they are.
ridiculous saying we don't.
Bandy, the obvious answer to the question is, of course, these fields are full of people from all different types of backgrounds. There are alternative theories that are proposed all the time. There are some have been ruled out based on observation data. Some still exist in some form that people are working on. We've talked about MOND before, modified Newtonian dynamics. We've had this kind of conversation before. The answer is obviously it's made up of people from all different types of backgrounds that have have a common one thing in common, which is to have a career in science and figure things out scientifically to advance the knowledge of the human civilization, right? Not trying to give a TED talk or anything, but you know.
But nobody that you're talking to other than on here probably is discussing like the Earth not being a sphere, these celestial objects being more local, etc. Right?
Of course not. Of course not. Because that's all been well established thousands of years ago.
So all of that's being done is kind of within that model, basically.
You know the answers, Gio.
Well, I don't know. There could be some people that.
Well, yeah, you should read into MOND. You will find professors and scientists at accredited universities worldwide who have written and published papers on this alternative theory to relativity, to Einstein's theory.
I gotta say, you guys always kind of paint every globe in this rigid way or whatever, but the truth is, even there's scientists who are so far out there, and they're incredible scientists who are learned people and understand all these theories and everything. What people are not doing, and this is fair, they're not questioning things that have no need for questioning. Things like
that's
I said,
subjective, Kosho.
Well, no, Edgar Mitchell, for example, he may have believed in psychic in this, and he may have believed in astral projection, whatever he believed in. Who knows what he believed in? One thing that would not make sense that he would believe in is the Earth being flat, since he supposedly went to the moon, right? So somebody who actually went to the moon is not. It's not going to be a justifiable question for them to be asking themselves if the Earth is flat. And then there's just a lot of people who are asking out there questions who aren't asking questions like that because they feel like those questions have been answered.
You got to see how that's a subjective statement to make, though, Kosho. Like you saying that to someone who, and I'm not claiming, I'm not saying people are troll. Anyone in here is a troll or a fake flat earther or whatever. Who knows? Because we're all just anonymous internet people. But you see how that's a subjective stance to take when you're trying to tell someone whose thought process and philosophy is to question that exact thing that you just said, that mainstream scientists don't question it because it's not worth questioning.
Well, no, yeah, but my point is that they try to make a dichotomy, like there's these people who are open-minded and skeptical, not just trusting mainstream stuff, but skeptical and looking for alternative theories. And what they don't realize is this is actually most of the best scientists. Like they're gonna have open minds for what could possibly be real based on the things that haven't already been excluded from not being real. That's the only restriction. The things that have been excluded, they don't consider those.
Mm-hmm.
Right, but that can kind
I
of.
went ahead and posted a picture of M101, which is a spiral galaxy that I just took. That's got a little that's been stretched a little bit so you can see a few more details.
Where is it?
Remember, this is just with a camera. This isn't an actual telescope.
Oh, that's
I
fake. I just
don't
saw
see
him
it.
photoshopping it.
Oh, you mean in your stream? Oh, okay.
But Kosho, wouldn't the reverse be? This is actually what I'm going to say to what you said. Wouldn't the reverse be? Let's just take the heliocentric model. Let's just take it at face value and say it's all true. There was a time when people thought the Earth was planar and stationary. It was a plane of existence, etc., and the sky above. I don't think they used the term flat Earth back then, but nonetheless, and the heavens above and so on. So they had whatever concepts they had of the universe, the sky, etc. Would you have said the same thing, that they would have only been thinking within that paradigm? They never would have thought outside of it to think that the Earth was a globe, to even start to think that, oh, maybe these things are actually spheres, light years away.
No, not at all.
In the same,
That's not the reasoning I was describing. The reasoning I was describing was, I forget how the quote goes from Sherlock Holmes when he says, like, once you've eliminated all the impossible, whatever's left, however improbable, must be true. And basically, it's a description of deduction, right? In which you're eliminating the impossible. And that's all I'm saying, is that by doing this is the way scientists are thinking. If they were doing this in the past, then they could have said this, but they didn't eliminate, the globe Earth or things like that. They were just assuming it was flat. I'm saying that there's people today who have eliminated these sort of ideas. That they've exhausted the investigation of it, a long time ago. So they're not even entertaining those questions. It's not interesting to them. It's not like it's a settled thing for them.
Right, but I would go as far as to say that they absolutely don't have actual real proof for it. So they're believing in something on faith, which is not proof.
Well, to entertain this for a second, because maybe no one went to the moon, and maybe you can't go to space. But let's pretend Scott's uncle, Edgar Mitchell, did go to space and did actually go to the moon. Would you consider somebody who's done that and had that experience? Would you consider them capable of eliminating that scenario? If the Earth not being a globe, he wouldn't be able to consider the Earth anything but a globe if he literally experienced that in a very real way. If he did, I'm saying.
Yeah. I don't know if anyone could make an argument that if you went to the moon and you're standing on a rock and you looked directly up, of course, the moon would only be like, if you were on the moon, let's say you're on the face of it, not on the dark side, as it were, but you're on the face of it, anywhere on the face, the Earth would be directly above your head, depending on what side of the moon you're on, but it would be generally right up at like the high noon position, which of course we don't have any footage of that, but I digress. But nonetheless, we never saw them turn the camera up to look at the fucking Earth. But they had a bunch of cameras, but they just never did that. Okay, sure, it makes sense. But anyways, if you turn the camera up, you would see this incredible ball Earth above you, and it would be 4 times the size of the moon. The size that the moon appears to us, like if the moon is directly above you on Earth, flip the other way around. If you're on the face of the moon, you would look straight up and you would see the Earth, and it would be roughly 4 times the size that we view the moon.
It's about 2 degrees angular
Well,
size.
the problem that you run into is that not everywhere on the near side of the moon is high noon for the Earth. You can have the Earth on the horizon. You can have it at the zenith. You can have it on the other horizon. It just depends on where you are there.
Yeah, but you'd have to go around the side or the back of it to do that. Yeah.
And second of all, We have pictures of the Earth from the moon. There's a number of them. Earthrise is a good example of a picture of the Earth from the moon. Apollo 17 and the flag is a good example of the Earth from the moon. So why would you even say that? I mean, why? Have you ever looked?
There's no footage. There's a couple of janky looking snapshots which have like CGI layers put into them, especially the Earthrise is really bad. And it has
it's not.
There's a whole bunch of issues with it. So there are like one or two kind of snapshots as they claim of it. What I was saying is that when they were on the moon for all that time with their cameras, they never once just went whoop and just shot it up to the sky where you could see this huge, amazing ball Earth above you.
They were there to look at the moon, not the Earth, and they did take pictures of the Earth from the moon.
You never see the fourth wall, and you never see the Earth above you.
Fourth wall crap.
You got to remember that the moon, you're right. You probably expect the angular size of the Earth to be 2 degrees in the sky. That's true. But the noon thing, you got to understand that doesn't make a lot of sense. I mean, because
that's if you're on the face of the moon. I mean, obviously you're out on the edges, but that's
no. The face of the moon is very big. It's half of the moon, of course. But like you could be on the face of the light side of the Earth, and that doesn't mean that the sun's going to be directly over your head. You know, it goes around once a day, whereas the moon goes around the Earth, or the moon rotates. Actually, no, the moon's always facing the Earth. So I wonder how the Earth moves across the ground. Either way, it's not
that's what I'm telling you, dude. That's what I'm saying. Let's say you're on the dead center of the moon. Okay, take the moon that we see, and you put yourself smack dab in the middle of it, and you're standing there. You're on the moon. Now, there is the 5-degree tilt, so it would be, you have to incorporate that, but that's only 5 degrees. But the sun would be directly above you at your zenith.
You mean the Earth, you mean?
Sorry, the Earth. Yeah, the Earth.
That's actually interesting that I'm thinking about it. I wonder how the moon, how the Earth moves across the moon.
It would stay there. It would be stationary. You would have.
I don't know about that though.
Yes, it would stay there because it's the face of the moon is always facing the Earth. Yes. However, the Earth would slowly be you would be going around it, but it still is going to stay stationary right at that point. But the Earth would also slowly be rotating. So if you did like a fast motion camera thing, it would be rotating as you're going. It would look like it's rotating because you're going around it.
It's actually kind of interesting. I'm wondering.
And it's rotating.
Chronic. Do you know how that's described exactly? Because I would think it would move across it a little bit, but that's true if it's facing it the whole time. I wonder if the Earth's position over the moon, if it ever changes position over the moon.
The sub-Earth point on the moon, basically, instead of sub-solar, it'd be like the sub-Earth point of the moon would only change. My understanding would only. There is a lunar libration, so there's that.
Yeah. So that's probably a
little bit of a wiggle, and then you also would get it would change 5 degrees as the orbit of the moon is tilted 5 degrees, and that changes. So it would change that 5 degrees.
What is that called? What do you think it's called? The sub. What did you call it a second ago? How about the sub-geo point?
Yeah, that's fixed, right? For the moment.
Is it fixed?
It should be, right?
So you would call it a sub-geo point or something like that, and it is fixed then. So I guess it would depend on what
it would be like right in the center of the face of the moon that we see, right? That should be it.
So then, Geo. I mean, depending on where it landed, it would be.
It'd be nice to stand there because, but you would be able to see Earth spinning, right?
Yeah, it would wiggle. It would wiggle
almost once a day.
That's cool.
Yes, almost once a day. Yeah, you would see the Earth. You'd see like the light side of the Earth, and then the dark side, then the light side. Yeah, of a globe.
I think it would take a little bit more than a day.
Well, it's kind of like the epic discovery.
And the only thing I was pointing out, I know there's a couple of like Earthrise with like this funky looking, fake looking like moon like baseline, and then this like photoshopped like little ball in there. But I'm talking like there's no footage anywhere of them being on the moon. They're playing golf. They're driving rovers. They're doing all this stuff and literally pointing the camera at the most profound thing in the world, which would be the globe Earth directly above your head, shining bright. It's a little strange to think they never did that. The most important thing of the whole mission.
I mean, they did take. I mean, the Earth Rising is pretty.
Jerry, that's tough.
No, Earth Rising is the same kind of poetry you're talking about, dude. Where I mean, that's a pretty cool picture in my opinion.
Right,
Oh,
but
hey,
that,
you know,
that
hold
was,
on.
it was claimed to be taken by like a craft that was orbiting the moon, and as it's coming up around the moon, and you get this like very well. First of all, the Earthrise. You remember the early analysis of that, where it has like digital box around
No.
it, like the Earth does.
Not the early analysis, but the analysis done by seen people in this community do it. You have to remember something that is fairly obvious, but might be overlooked. That's a very famous picture. That picture shows up on shirts, on posters, on all sorts of things. It's very possible that the picture that people are investigating are actually not NASA's photos, but some
No.
secondary picture.
No, take a look at this. These were taken right from NASA's site. There's a whole digital outline around that little layer on the bottom, and then there's literally a square.
That's a compressed image. I would like to remind you, Gio, that they didn't have Photoshop in December of 1968. All right. These have already been addressed. What you're looking at is a JPG. You're looking at a compressed image, and that's just artifact. If you look at the original high definition picture right off of the NASA site, that's not there. But, you know, we've been through this so many times. Why, you know, I don't know why it keeps coming up.
I don't want to change the subject, but I totally forgot that Jerry, you had to ask Chronic a question. I remember you saying, and he's here right now. I just didn't know if you wanted the opportunity.
Here's another one that shows the huge crops in it. I've also got one with the flag that shows that they just Photoshop. It's not technically Photoshop per se, but it's called composite. It's compositry, the way that they do composite images.
Wasn't the one with the flag? Wasn't that not authentic? Like they was it like they have the flag and the earth in the background, but
this is this one. All you have to do is you can see all the. It's the effects of the composite effect work that they do.
Hold on, though. I haven't looked at these in a couple of years, so I don't remember what was concluded. But I thought there was a picture like that, like with the flag and the earth. Where
it's not an effect of a composite; it's an effect of compression, because it's not the original photo.
There's also this issue: the the Earth is way too small. Like I said, it should be 4 times bigger. Whoops, they forgot to make it 4 times bigger.
There's no way to make
the original. Just look at the originals, Kosho.
All right, fair enough.
Well, how is the real apparent size of Earth coming from?
Yeah, there's no possible way you can make that comparison, Gio. There's nothing to reference the Earth to.
Oh, you can if you know exactly how the picture was cropped and what was the horizontal angular size of the.
Oh, yeah, if you have that information, sure.
And if you have a bunch of information, you can.
This last one is just a troll.
No, that's real actually.
It says fake as fuck on it though. Oh no, it says real too. No, but yeah, of course. What Bacon says, if you have that information, of course, you can definitely tell the angular size of the Earth. But I doubt that.
I think it's a little strange that all that time with their filming on the moon, they never once looked up at the Earth.
Well, you have one right there.
All we have is like 2.
You mean like that one right there?
2 like weird hacked up shots. The one with the little flag, one with the astronaut, and then the one other Earthrise. There's only those 2 jacked ones. Of all the video footage, there's not one.
I think somebody said it. Somebody said it best. Like they honestly didn't go to the moon to look back at the Earth. I mean, they did look back at the Earth and they did take a picture, which you'd imagine they would do once or twice, which they did exactly once or twice. But they went to the moon for the purpose of the moon. So yeah.
Well, I would say the number one.
There's a picture of the Earth from the moon right there.
Any and every human being on Earth, if you were on the moon and literally you're on the moon and there's the Earth above you, that's what you would be filming that nonstop. We'd have
unless you work for the government.
That would be it'd be absolutely amazing. But if it's on a Hollywood set and that's not actually happening, you can't do it.
Yeah, but if you're not on vacation and instead you're working for the government to do a mission, and your mission doesn't include just taking pictures of whatever you want the whole time, then you actually just have to do whatever your mission.
Okay, so they ordered them not to film the Earth.
No, they probably
nobody ever said that, Gio.
Well, that's what he was implying.
No, what we said very clearly was they were there to look at the moon. They happened to get some pictures of the Earth, and there's one right there. But their job there was to evaluate the moon.
I get what you're saying, Gio, but I'm just being realistic. They're not on vacation. You know what I mean? Yeah, full disclosure, there was a time where I was 50-50 on the moon before I got into this community. It's like 'cause I dated a Russian girl, and she ridiculed me and told me that in Russia they taught that it was fake, and they laugh at us and stuff. And so I was 50-50 until I investigated it further. And dead air for a second. Jerry, you have time to ask Chronic that question you were trying to ask him, dude?
Well, guys, it's been a little piece of heaven. I've got to get out of here.
It's
Take
very
care.
nice of you to
Good
say
night,
it like
everyone.
that, Bob. And Bob, I appreciate your the data thing that you had up earlier.
Not a problem.
Hey, you
Take care,
should
guys.
bring the thing
Yeah, have a good night,
more
Bob.
times. That's quite nice.
Yeah, it's cool.
Have a good night.
It'd be cool to look at that and do what Chronic was talking about with like the because Chronic does it like with his friends all the time, that they think they're so cool that they're the only ones who can do the transit fucking studies. We can use fucking Dr. Bob's bullshit and study the luminosity of these things, dude. It's just I know people always say like there's no point in doing this stuff, like you're not proving anything to anybody, but there's like a good feeling you get from it, like from like seeing stuff like that for yourself. You know what I mean? Like actually seeing that that dimming exactly the way that you would expect it to be if it was an orbit going around it. And there's probably something like fulfilling about that, observing that directly. I don't know.
Yeah, no, I think observation is great.
Oh yeah. Did you ever do any of those flat Earth meetups or anything like that?
Yeah,
Oh, you used to, right?
I've been to a couple. Yeah,
I'd love to do a flat Earth meetup and go to like an observatory.
that'd be cool.
Actually, would really be cool. Actually, you know what? I'm gonna go ahead and just straight up invite people and see what happens. But there's McDonald's Observatory in West Texas, which sucks. It sucks for me to get there. I live in Texas. It sucks for anybody to get there. But it's a cool place to camp out. There's like a great national park near there, and it's an awesome observatory. But
The meetups I've done, like the energy is just off the hook. It's absolutely amazing.
yeah, well, it's 100% flat Earth, right? It's like even if there's some people who don't believe the Earth is flat, they're not like us, you know what I mean? Not like arguing with you guys or whatever.
Well, yeah, usually the ones I've gone to, yeah. Well, some people like bring friends and stuff, so like, yeah, somebody might believe the globe kind of thing.
Yeah, but they're not arguing with you like nonstop, right?
Yeah, not that I ever saw. In fact, if anything, they're just really like interested and just vibing off the good vibes, and then kind of just maybe asking questions a little bit. But yeah, they're not like confrontational that I've seen. But I'm sure there has been at some of the conferences, like when George went there and stuff. But
yeah, you remember fucking the one in Dallas, man? I wanted to go to that one so bad, but Bob got kicked out. Bob fucking almost got in a fight with or who did what's his name? Stone almost got in a fight with Fokker and a couple other people.
I don't know.
Meetups.
Probably, yeah. Well, I know M Stone like confronted Karen B, and they had a whole thing.
No. M Stone was sitting on a chair by himself, and Karen B harassed him.
Yeah.
Said the other way around, or confronted him. I mean,
what I was gonna say though is that like in terms of like the high frequency, like high energy, it is incredible to be around like a large group of people that know about this. It truly is, because I've had in different communities, working with sacred plant medicines and shamanic communities and a whole wide range of things, and it's hard to kind of put something in a hierarchy like, oh, this one's more than that or anything like that. But just the meetups I've been to, like when I've been in like a in physical person with a large number of people that are aware of this, it's probably the highest frequency human energy I've ever felt before in a group of people.
That's pretty
That's
cool,
not.
man.
That's not to say that I'm not trying to say every single person is enlightened or what. I'm not trying to even go there. I'm just saying that
I get it, man. I totally
there's
get
just
it.
something about this information, the truth, the earth. There's something about it that is just. It's like off the charts compared to any other type of.
You know what I think it is,
Like
dude? When I was a huger conspiracy theorist, because you probably remember what it was like back in the day, because you said you were in this kind of stuff for 20 years almost. And kind of same with me, probably about 2006, yeah. But back then, I can't remember anywhere where there was a place online or anywhere where there's a community to talk about this stuff with people who you could bounce things off of, and not just it's not like you're informing other people. You know what I mean?
Right, and to this day, you know, I mean, where else is there right now? You know, like, yeah, it's meaning that there's not that many places where it's being done. I mean, meaning that, like, I mean, there are like meetups there, like, and then what you were comparing that to like YouTube videos or something where it's just more like content being put out.
Well, yeah, exactly. I mean, I got a lot of my information from YouTube, and there were bookstores. There was a bookstore here in Austin. There's like an underground bookstore, and they would sometimes have, I don't even know what you would call them, like a presentation or something. And so that always felt cool because there was people who were kind of on the same page as you, but other than that, it's like you barely ever came across people like that, you know?
Yeah,
But I bet you it's real cool to have people that we can bounce ideas off, like where you know they're on the same wavelengths as you, basically.
totally, dude. Yeah, I went to this one that was called Flat Camp. I think I probably told you about that when I met ODD.
No. Flat Camp? Maybe you did, but I don't remember. What was that?
Well, maybe it was actually somewhat around the time when Sheeple did the whole server takeover thing. So
Oh shit,
so it was yeah.
dude.
But yeah, it's called Flat Camp, and it was basically like a bunch of people camping out. I didn't spend the night because I lived like close enough that I could just drive and hang out. But I stayed there like all night. I was there until the sun came up.
People were camping.
Yeah, it was like people were camping, and there's like a
Dude,
bunch.
you guys got so many babes. That's
Yeah,
the one thing I'm jealous about Fire Camp. Is like you guys got all the
there's like a big bonfire, and then like ton of food. You know, like tent set up with like, I mean, not like some huge type thing, but just people brought their own, you know, grills and coolers and all kinds of stuff. So yeah, it was amazing. But yeah, ODD was there. That's where I met him.
I'm just kidding. He's a cool dude. He seems. I know people give him shit because of reasons, but what was I gonna tell you?
Yeah, I was awesome to be able to meet him. Yeah, because
what was I was gonna say something about
But what I was going to actually say about it more, I mean, I wasn't really bringing it up to tell the whole story. I was more just saying that one of the interesting things I just was remembering how, like, when I first got there, and it's like you're in a group of people, which somewhat can happen on servers like this, but we're not in person, you know. But it was like I remember getting there, and then like there was like 8 or 10 of us that were all just sort of like standing in a circle, and people were just like bringing up certain things like, oh, do you know about this? Do you know about that? Like, oh, what do you know about that? And it was just, oh man, I just remember it was just like everybody was just like having the best time, like so excited to be able to actually just be ourselves and like actually share information and then have other people actually get it, you know? Like it's
Dude, you know what you don't get really is like you always like I don't there's a lot of people in this community and there's people here for different reasons. But there's dudes like me, and I know like Zanuck, and there's probably a few other of us in here that that's why I'm in this community, is because I can talk to people, which in reality you don't come across that many people who are interested in the same sort of stuff that I might be interested in. Like I'm interested in a lot, like everything science, technology, even conspiracy stuff. You know, just all the subjects we talk about in here. So it's absolutely rewarding for me to be a part of these discussions with you guys and with the people in Gems, the Globers. You know, we're just talking about all the stuff I like to talk about. You know what I mean?
Yeah. Well, that's what I was kind of saying. Like, other than Discord, basically, where are people actually, coming together? I mean, I know there's like Facebook and stuff that's more text based and whatnot.
It's
And
Comic-Con, man. I mean, that's the same sort of thing. It's like they're at school with like all the people, and maybe like their friends make fun of them, and then they go to Comic-Con, and like everybody knows about the shit they know about, and they can talk to people that are like the same kind of shit as them.
I suppose so. Yeah, they're like showing off all of their
they're wearing their fucking. They should do flat Earth conferences are kind of like Comic-Con, dude. People are wearing like globes on their head and like selling all that shit. Yeah.
T-shirts that are like fucking NASA eyes and shit.
Yeah. Is that Nathan Thompson, the one with the globe head?
Oh yeah, he did do that. But I mean, dude, everyone else I've heard, at like, just pretty much as far as I've heard, like pretty much every meetup just sounds like it's like off the hook in terms of like really good energy and people just,
Maybe. I don't want to. I'm reluctant to tell this story. Bam. I'll just say.
Well, I'm sure like stuff has gone down.
No, it's not. It's not an inherent bad thing or something like that. It's just I know Jose. I had a talk with Jose, like intimate conversation with him. We were both shirtless, and I was asking him, like why he changed being a flat earther to a glober, whatever. And he said one of the big, one of the big transitions or big stages of his transition was when he went to a meetup, and I forgot who was there, but he was with his wife or girlfriend or whatever, who's not a flat earther. And I think there was something about him bringing her there and however they were behaving or whatever they were talking about. And he felt like he was an outsider from their perspective because he was probably self-conscious to his wife, right? You know what I mean? That probably affected it in some way. Like if his wife's not a flat earther and these people are saying kind of stuff that he would be reluctant to say unless he was in private, you know what I mean? Yeah, that's what he made it sound like, at least. So I think that kind of pushed him away from the flat earth. That's the way he made it sound.
Okay. Oh, yeah. I don't know. I mean, I guess, the potential that in the human psyche for various levels of like insecurities and, unsureness and different things. Yeah, I'm not saying that is or isn't what it was, but social awkwardness or different things. Is that what you mean? Or
yeah, social awkwardness and kind of like it's kind of like, okay, there's a lot of people in your community and you don't agree with a lot of them, and you agree with a lot of stuff with a lot of them though. But like there'll be people, I'll name some of them, like Right the Hand, Pete Shea, these kind of people. If you happen to go to a flat earth meetup and it just happen to have those two and maybe Nathan Oakley, like people who I know you don't agree with on certain things, you'd be reluctant, and you also brought a friend who's not a flat earther, you'd be reluctant to make it seem as if you had shared ideas as these guys, you know what I mean? Like to put yourself in a group with these guys. So I think he felt like he was an outsider because his girlfriend was there.
Girlfriend.
You said what?
Jose's girlfriend? That was
No, his wife. He was his wife at the time, but they got divorced after they had some time. But yeah, he said he took her to a meetup and they went to a restaurant. I can't remember who was there, but he just said it was like it was like embarrassing. Like he just said that they were saying things that he knew, like his wife was probably getting on him all the time for this stuff, right? And so they're saying silly things, and he's probably sitting there self-conscious about it, you know.
Well, I mean, I guess there could be components of like, social acceptance. And I mean, I think we've all seen people who either question the globe or start to say to their friends and family that they don't think the earth is a globe, or in addition would say that they think it's a stationary plane or flat earth, whatever terminology they use. And I mean, there's a lot that can occur. I mean, there's people that react. I mean, I wouldn't say overall it's like extremely like, I don't know how it compares to other things that are controversial, like abortion or politics or whatever, in terms
there's
of
like an unnecessary kind of anger or aggression or something?
Well, there can be all kinds of stuff. People can have all kinds of judgments and ridicule, and some people kind of just try to ban it out of their lives. Like if someone finds out their friend is questioning the globe, some people just leave that friend. Stuff like that, or like family members do.
That's the one thing that I can give you guys props for is at least the ones that are open about it. Like you guys believe something, and you know just as well as I know, because you used to believe in things like I do, that you're putting it out there to other people, and it's probably not the easiest thing to do all the time. You know what I mean? Because like you probably know right away that you're like, you tell somebody something that you believe something about the flat Earth or something, and you probably immediately get ready to defend it or defend. You know it's coming, basically. Like you know it's going to come most of the time. It's probably like every time you come across somebody and somebody introduces you as a flat Earth or something, then now you have to defend it or whatever.
I've never had any conflicts with that. I've actually never even really been like ridiculed or laughed at in person about it, because
not just laughed at, but I mean like question or whatever.
Yeah. I think there's some people that I've mentioned it to that maybe did kind of have a little bit of like rolling their eyes kind of thing. But a lot of people have actually, depends on who it is and kind of how you're bringing it up. But I've told some people, I've told a lot of people actually, in person, and
sure.
I would say that only like maybe 2% of them have had like a little bit of negative energy, but the rest of them have been pretty positive. And maybe it's the way that I kind of share it and the way that I say, propose it.
Crazy thing is, there's many people I know that believe I'm a flat earther, dude, because they don't fucking listen to me, right? My ex-girlfriend and my current girlfriend, at least she used to. I had to clear it up, but they were both under the impression I was a flat earther.
It would seem that way from
someone who's not paying any attention to what I say to them. Yeah.
Somebody who hasn't heard.
I'm literally.
You can be kind of vague sometimes.
Well, but that's the thing, though. There's people who literally just don't even care about the subject, and so they know, like, they hear you talking about it, and they stop listening to you after that, and they just think you're a flat earther. So I think that's what both my ex-girlfriend and my current girlfriend did.
Well, I also think to a lot of people, you could tell me, but from your experience, but if they know that you're like really into it, like spending a lot of time and all of that, then I think for a lot of people, it would sort of seem by default that you would be.
Yeah. Exactly. But that's why my ex-girlfriend was like that. Even though I literally explicitly explained to her what was happening. Yeah. Yeah. JJ thought, a lot of people in this community actually thought I was a flat earther too, but that's because I used to not argue the globe. I used to just because I didn't want to have a falling out with some of these people for no reason.
Have you ever had people that like you talk to, or if they know that you are as active as you are, kind of talking about all of this? Like, have you ever had people that ask you, like, why would you even talk to those people, kind of thing?
No, but there's people who I've talked to, and they turned out to be flat earthers or flat earth adjacent, and there's people who I talk to, and they just completely don't care. That's most of the people, actually. Most people just don't care. They care about other stuff. That's why Hannah's cool. I don't know if she's a big fan of science or what, but she's interested in this community. I think people who are interested in this community, at least, are not boring. But there's so many boring people who, like, they find out that this community exists and they don't have any questions. They don't think twice about it. They don't think about it again. It's kind of like, I don't know. It's just so boring to me.
Well, like my older brother, for example, and I'm not trying to like say anything really negative about anyone, but like his viewpoint on it, just his viewpoint. He knows, obviously,
You said this to me.
He knows my viewpoints, but like his thing is that like he says to me, he like scoffs and he's like, I can't believe people actually, like globe earthers, as it were, are online talking to you guys. Like I can't, why would you even,
Yeah.
that's kind of what he thinks. Like
You have to remember there's a wide array of people who you call globe earthers. There's people who are here just to listen. They're not even going to ridicule you, not going to argue with you. They're just here to listen. Then there's people who are here literally because you guys appear to be low hanging fruit, just like I don't know, somebody who just somebody else, other people too. But the low hanging fruit, and they want to argue with somebody for some reason. But there's people who are here just because they like I said, like me, like I just like the subject, like I like the subjects we talk about and all that kind of stuff. So, but it'd be wrong to categorize the same motivation.
Right. But I think from my brother's perspective, which is, perhaps could be considered mainstream in that way, he just thinks like that it's so settled in his mind that the Earth's a globe, as it were, that why would you even go online and argue about it or debate about it or even, do any, almost to the level, like we've said, like if somebody made a server called Pigs Can Fly, why would you go to a server and talk to people who think pigs can fly? Meaning that it's like so settled that they can't or whatever, then why would you even do that? That's kind of
that's what I'm saying though. Like he's got a different motivation in his head for whatever. But I've given you two motivations. One is one that's like mine, which is people who like talking about these subjects, and then there's people who particularly like to pick fights with people who they consider to be low hanging fruit, like almost someone where they're almost certain they're going to win an argument against, and they have to argue with that person. And those are the same kind of people that argue with deeply religious people any chance they get. Anytime someone brings up a religion, they'll argue with whatever it is about the religion, and you can tell that they've always done that. So yeah, there's more groups than that even. So it seems like his motivation would be to argue or to teach someone that the Earth's not flat, but that's not everybody's motivation.
Right. No, I hear you on that. Yeah, it sounds like accurate that there's probably different kind of categories of people in that way. That
there's people who I don't understand why they behave the way they behave. Like they get very I don't know, very very upset about something they don't even care about.
But you're kind of like the thing, like your focus though could be said it's even more than just interested in the topics, because like you want a flat Earth girlfriend, you want to go to flat Earth meetups, like you're like
babies.
You would have flat Earth girlfriend?
Yeah, well, my girlfriend actually she's almost there, to be honest with you. And
Are you trying to convince her that the Earth is flat?
I'm not having to do any convincing. But whenever I found out that she fucking was confused and thought I was a fucking flat earther for whatever reason, I was watching this fucking whole video about magnetism, and then it said something about like magnetism in space, and she's like, "Wait a minute, I thought you didn't believe in space." I was like, fucking looked at her. I was like, I didn't even say it. I just thought about it for a little while. I was like, you know what? I showed her some ODD videos after that.
That's funny. So she knew enough to know that we don't think space is the way NASA describes
it. She didn't. Like I don't know, dude. It aggravates me. She doesn't listen. But I don't usually date girls who are into science. It's like all the girls I've ever dated think the stuff that I'm interested in is really boring.
So you would claim from your own perspective that you in no way are questioning the shape of the Earth, but you're only here because of the interesting conversations, and that's it?
I'll be honest with you. Like even what we were talking about last night about astrology, and even with like when you asked me, like, you're not questioning the shape of the Earth. Like I feel like I know what the shape of the Earth is, but I also feel like I know there's mysteries out there. And that's why I like talking to you dudes, is because this is such a boring world without that kind of stuff. And sometimes you find things out that you wouldn't ordinarily think is true. That it turns out there is actually this crazy mystery. You know what I mean? But not that I believe that. I certainly believe the Earth's a globe. I'm not questioning it, but it's nice to discuss and come across these fringe ideas. Yeah. I don't know if that makes any sense or not, but
It doesn't really. I learned a ton of stuff by just coming here and
yeah.
trying to argue. I mean, I'll never ever know celestial navigation for
Yo,
if it wasn't for this.
Yeah, but I mean, there has to be some seedling of curiosity that it could be the case, it would seem, to be this interested in it.
there's curiosity, but it's not that. It's not curious. Like I said about the scientists. Scientists are curious about all sorts of shit, but shit that they already know for a fact, they're not that curious about. And this is one of those situations where there's so much stuff about the Earth. Like we talked about star trails earlier, and I was just doing the math for their behavior and this type of stuff, or with the celestial navigation stuff, like all these different things. You know, these topics, they have so many avenues to go down and learn deeply about these things, and and find out that you were wrong about other things. So it doesn't have to be that the shape of the Earth is even the question. You know what I mean?
Well, dude, I'm 100% with you on that. I mean, these discussions, like if I look back on all of my discussions of the shape of the Earth and all the ancillary topics of, endless topics, yeah, it's when I just think about all the time, it's been absolutely profound and amazing. Yeah, it's like the absolute number one place I would like to be. Like every day I learn new things. There's new avenues. There's so many components to it. So yeah, I mean, I wouldn't be here if that wasn't the case. So if I was a globe earther, as it were, I could see that, you could also be having that. But then the other question I was just going to ask in kind of align with that though, is do you think that for you guys that your attraction, because my attraction is like truth and more truth. I mean, there's a lot of things that I have, but in your attraction, do you think there could be sort of like, if it's true that the Earth isn't a globe, that you're kind of like attracted to it, kind of like moths, come to the light or whatever. Like you are kind of attracted, something about the energy, the vibes, or something there that intrigues you, and that is partly what brings you here.
But Gio, just the vibe that you made that statement in is so. The way you just conveyed you being a truth seeker implies that people on the other side are not, or are trying to hide something in some way, or are not actively or seeking the truth, or don't care to seek the truth. That
well, no, I think that's what I meant. No, what I meant by that is that the Earth, in my view, is a stationary plane. So coming here, talking to people about it being a stationary plane and other topics, to me feels like truth on top of truth on top of truth. Like it's like already here established on the one truth of the Earth not being globe and everything else. And then there's like all these other things. And what I was saying for people who would say it's a globe, it's that same thing can't quite be said. It doesn't mean you're not truth seekers. Absolutely, you could be. I wasn't saying that. It's just the fact that you're coming somewhere where it's actually like you think it's wrong, as it were, to a community of people who, that you think are wrong, and then you're seeking the truth within that.
But you think the same thing, no? You
What
think we're wrong.
truth?
We think you're wrong. That's life.
No, we know we're right. We know you're wrong, but we're only here, like Ricocho said, is because the topics are. I mean, who knew about NLMs? Who knew about how these stars actually were? Who knew that these stars actually rotate in different directions on different planes of the? Nobody. Most of these people here didn't know that before they came here.
But wouldn't that all be done in like mainstream astronomy? I mean, isn't that the globe Earth, the whole deal? Wouldn't there be other communities where it's globe based if that's all happening?
I don't know that question. I don't quite understand the question, but I think the main thing is that
astronomy, science, community.
Yeah, these are all science. These are all established sciences, and they wouldn't be in existence if the Earth. I mean, there would not be any astronomy.
What I'm saying is that why come to flat Earth to learn about science and astronomy if the flat
because there's a bunch of people that haven't studied physics here, studying physics from the internet. And studying all these things in almost pretty great detail, much farther. Like, for example, Coriolis. You never learn as much as we talk about Coriolis in physics first year. You don't learn anything near to what we've talked about refraction and diffraction and all the equations and things that we've all probably learned if you went to school. You've never really applied them, and this is a place to apply all these things actually
So what you got to think, Xanix? Yeah, you got to think to yourself. In
Can
education,
of course, you're not going to let me talk. Of course, there's got to be one in every crowd here.
trying to get you to
So I'm just
qualify.
saying that you're able to now apply these things to an application that we've never really had. We've only been able to take tests. Here's the equation, figure out the answer, done. Now we're saying, here, how do you apply that? How do you apply trigonometry in all these different ways for all these different questions? And it becomes like a challenging
All right. Let me stop.
You know,
I'm going to forget my trailer for.
really, I mean, come on. Seriously.
You've just said something about
that was a long stretch. At least give someone else a chance.
Well, I haven't said anything. I've listened to you guys for almost 2 hours, and I haven't said anything. So I thought maybe I could have a sentence. But no.
That doesn't give you 2 hours.
Boxer boy, I don't need 2 hours. I just needed a couple of sentences.
Right, you got a qualification. You want to defend your qualification.
Panic, chill, bro.
It's a qualification. You want to defend it. You want to make sure that the stuff that you learn in the education system.
Well, if you wait till I stop talking, then try to ask me something, I will answer.
You want to defend it. You want to defend
All
it.
I hear is you talking in the background.
Yeah, come on, don't make me temporarily mute you. Let him speak.
All right.
You have an invested interest.
Can I just start from the beginning? Because I didn't hear anything you said. I heard nothing you said. So start from the beginning. Start from the beginning. I didn't hear anything you said. Go ahead.
At the end of the day, Xanix, right? You got your qualifications, so you've got an invested interest to make sure that it's true. And at the end of the day, like people say, there's an objective truth that we can all agree on, that it's flat and it's observable fact. And like you said, we talked more about Coriolis than you even did at your education system, because in your education system, they just meant to make aware of it, so you can get your qualification and you can apply this illusion to the real world. And at the end of the day, we talk about the actual the real details about it, like you said. So when you actually go into what they're actually teaching you, you actually realise that it's not making sense. And you haven't woke up to it yet because you're still defending it, because you've got an invested interest in it. Yeah, that's what I wanted to say.
Okay, that's interesting. But no, I don't agree with you there. So, you're entitled to your opinion in that respect. But no, we learn things, and some of the things is very topical. Some things we learn in depth, great depth. Something we actually get into the math and have to know the math that supports it. But I have to ask you this. If you think you're right or know more, or any of these people think they're more, why can't they go get a job and use these new sciences, new views of science and physics, and apply them and actually be successful in life, or be successful in industry? You can't, because I'm still talking. My God, I let you stop. I stopped to let you listen.
Brummy, he wasn't done asking the question to you, Brummy.
He just says, what asked these people?
Brummy, come on.
He wasn't done asking the question.
I was in the middle of a sentence, and you go on I was completely silent for what you said. I heard your point. We basically are indoctrinated to all this technology and physics and math, and you're saying, well, they just glaze the surface, as you interpret it from what I said, and then you don't even question it, and you go on in your life believing this nonsense. That's what you basically said. And I told you that's not the way it is. We apply what we've learned, and even the things we've learned in depth apply correctly, and we can make predictive and quantified and repeatable decisions and analysis of all sorts of things in physics without exception. Never proven wrong is the Earth being curved. Never proven wrong is the Earth being round and spinning. None of that is ever proven wrong, ever, with anything. All you can say is observably. All you can say is observably flat.
We heard you.
Yeah, Xanax, you can't do that, bro. You got to keep like bite-sized pieces of.
All right. Sorry about that.
You asked the question. You said, why do they got no new science with these fucking new discoveries? Now listen, you to ask that question would imply you weren't an intelligent person, because you already should have known the answer to why that fucking one of the biggest secrets being held to man hasn't been uncovered, and why we haven't done anything to actually discover it yet. Why are you asking that stupid question? Why we ain't gone to Antarctica and all gone on a boat and just all flew around where we want to? You're asking stupid questions.
What was that? I don't understand what you meant right there. What?
You're asking stupid questions.
I'm asking a stupid question? What's a stupid question?
Why have people got some newfound science and discovered the world yet?
Why hasn't any of this flat Earth technology and views of the world, why hasn't it ever made any incursion into the mainstream? Oh my God!
Scientists. Does he act like we're a group of scientists trying to develop technology for the world? The idiot.
All the things we've learned about space travel, rockets.
We're just normal people.
Brummy is advocating for the fact that he's just a simpleton.
I know, right?
Yeah, well, chronic.
Come on, man.
It's observably flat. You said, Brummy, you said it's observably flat. That doesn't sound very, very technical. It's observably flat. I see something the way, therefore it is. That is the most simple. That's simpleton. Defined right there.
Stop talking for people you don't understand. And you're trying to make them...
Okay, I don't understand. Help me understand, Brummy. Help me
Because
understand.
one minute you don't even know the motives of why that people haven't got no new flat Earth science. So you to put it.
Why?
Then
Yeah.
everyone's
Why hasn't flat Earth
Why-
made any impact into science? Why?
You're capable of thinking for yourself. I dare not to try and educate you. I dare not.
Try. Give me one example. What we could learn from you. Go ahead.
Because to ask them questions implies your intelligence level, and it's too low for me.
Why do horizons drop with altitude?
It's too low, bro. It's too low.
Why do horizons drop with altitude?
Your level's too low, bro. I can't.
He's not going to answer you.
Yeah,
Zach. I've
Really,
always wondered.
The conversation was nice.
Well, hold on. I don't know if we could try to bring it back to something, because actually what Brummy had brought up, which is interesting, is we were talking about, the discussion and being here and everything. And I think part of what I got from what he said is, if you believe, let's say, the mainstream story, as it were, is there some cases in which globe earthers would be here to try to kind of like psychologically reinforce the model that they believe, in contrast to it being questioned?
Because of look at Xanix, yeah. He's got an invested interest. His qualifications, his biggest achievement in his life is what he's achieved through his educational system, and he stands pride by it. And to think that it's wrong is detrimental to him, and that's why he's here defending it every day.
Brummy, I've always wondered, and maybe you have an answer. Is it not really weird to you that there is not one single legitimate flat Earth scientist in the world, someone who is now? Let me get to the end of it. Let me get to the end of it.
You won't be able to.
No. Hopefully, I will. Okay, and by that, what I mean by that is someone who may or may not have been classically trained in physics and gone through whatever educational system. Maybe somewhere in their life they came to a realization that the Earth really is flat. So they're this person who is a credentialed scientist of some sort, who is a flat earther.
You've made your point. Fuck,
I told you you can get through it.
So why?
Do you know any proper certified scientists that stands by the?
Why does not a single one of those individuals exist in the world?
All you had to say. You didn't have to give me a long drawn out explanation, but
I
personally,
don't think it's that long drawn out. It's actually very articulate and
Basically, you're asking.
If I tell you of certain people that have
Yo,
come
Riven,
forward-
it's hard to hear you. Can you come
Hold on
closer
a
to your mic?
second, Hold on a second. Can I reply to the gentleman?
Rumi, slow down. Just slow down so we can understand what you're saying.
So the
You're
answer to
talking
the
a bit
question-
fast.
The answer to the question is: if I told you there were certain people that came forward and exposed certain parts of the lie that were basically told that we're all just faking it and blah blah blah. There's people that have came forward, and there's been reactions from people that don't add up to the to just justify what they did put there. Now look, the radiation belts.
What do they have to show for it?
Hold on. When you're saying that,
He's going to give you substantiation for his nonsense right here.
you guys can just shut up for a second.
Go ahead.
Talk about the radiation belts, right?
Come on.
When you guys say things like the Earth is protecting us from the radiated light rays from the sun, from the magnetic waves, and then you say you sent a little shuttle off into the naked rays of the radiation, and you're saying, oh, you escaped it going through the thin parts of the belt. And they knew all this when they was flying up in the air, when they was bombing each other in little airplanes, like back in them days. There's a lot of suspect things that have happened, and I think it's not.
Do you know how much radiation you're exposed to when you're going through the radiation belts?
I just want to say my question went unanswered as predicted.
Negligible, and it's
of course, that's why I said it wouldn't be. You wouldn't let you finish, and he wouldn't answer it.
I'm sure you tell me it's negligible, yeah. 0.22 on the factor of 4-5 around the radius 2.
Okay, so what's wrong with that?
promises to introduce me to it.
Calculator, and we can just factor that out. Fuck off, man.
So Brumi, why, Brumi, why? Okay, you asked a question. Let me ask you a question. Why does the horizon drop with altitude?
How come I can calculate you smash?
Zanik, on a flat Earth, would you expect the horizon to drop with altitude?
No.
You would actually. So learn your.
No, you wouldn't.
Stop asking stupid
Thanks
questions.
for answering my question for me.
Yeah, you're welcome. You would expect it to drop with
I
altitude.
tell you, I'm not.
Because the horizon
you
requires
would.
both the observer and matter to reflect the light. So even if it was flat, you would still expect it to drop in altitude and curve. So stop asking dumb questions.
It wouldn't. That's not a dumb question. It's a very intelligent question.
At what rate should it drop?
Who knows?
If you were on the surface of Jupiter, you would see it rise to near eye level. Even if it was really far away, that horizon. We see the horizon. You see the horizon of the moon. See the horizon of the Earth. All of it is expected and calculable. I mean, it's not that hard to envision if you use your head and tell me that I'm stupid for saying this. I'm not. It would not rise to it would not. If it would rise to eye level. Hold on. Hold on. Okay, you're going to say that percentage. You're going to say that. But hold on. Hold on a second. Hold on.
Hold up.
If you,
Zanuck, one second. Brummy,
no,
you're
I have to finish this
coming
point.
in low. Brummy, if you could increase your input just a little bit.
Where's your model? Where's your model?
Okay.
Where is your model?
Okay, percentage. We see the horizon, and you're saying it should not rise to level, but yet, why is the moon below level? Why is the sun below level? That's not possible, even in your kind of conjured up idea. And you said I'm wrong. You basically made a declaration. I just showed you why even your idea is below level, perpendicular to plumb.
They never got a model themselves. All you ever hear Globus say is, "Where's your model?" And they never got a model themselves.
No, I'm talking to percent. Just broomy. It's just noise right now in the background with you.
There's observations incoming from Zanuck in the chat with the high altitude observations that show the sun below level. They're incoming very soon in the chat.
Your voice, Alex, but you do drain on and you ramble. Nobody can follow what you're saying, and it's very incoherent. And
I think it's really clear what I'm saying. Why is the horizon drop with altitude? And at level, why is the sun and the moon below level? Because if it was what you're saying, because we have matter for light to reflect, as percentage says, then why do we see the sun below level? It shouldn't be below level. That's where the horizon should be.
I'm having trouble
You're
visualizing what you're talking about.
you're having trouble because you haven't thought it through.
The sun
You haven't thought it through. I need you to think it through.
Hold
Broomy,
up,
you got to shut up.
Zanuck, you got to hand walk him. You got to hand hold him through it, sort of.
The sun when it's Zanuck or what? What are you talking about?
Zanuck, let me ask you this: how come, right? I had 2 sugars instead of 3 sugars this morning. Like,
Come on, Brummy.
Where's the stupid questions? Why is it below the fucking horizon? Where's that come from?
It's not even. It's not, Brummy. It's not a stupid question. Him and percentage are trying to have a legitimate conversation, and you're yapping like a little yappy dog.
I know. It's like a little yapping dog in the background. Seriously, that's what you sound like.
Were you asking me questions like 2 sugars? Or 3 sugars?
No. Percentage and Zanuck are having a conversation. Please.
No, it's open to anyone. But
I'm sure.
Yeah, but Broomy is just making noise. Like
Zanuck,
great example.
You guys, hold on, just one at a time. All we have to do is one at a time. Everybody should have their chance to speak.
Percentage.
I'm sure. Yeah, your man here asked me a question. Did you not that percent? Did he not ask me, Brummy, what was it about this Northern fucking bullshit thing he was on about?
Brummy, it's hard to hear you again. Kind of low. Can you increase your input?
I'm sure that Zanuck asked me the question, and he said asked me something about the fucking moon and something about the moon and the sun and the horizon or something like that.
Yeah, it was kind of like a very vague question. That's why I asked him to rephrase it.
Oh, was he asking it you though? Because I thought he asked me. I'm sure he said Brummy.
I don't think it matters because the question wasn't intelligible.
Zanuck, would you mind elaborating a little bit? There they are, as
Keep it
predicted.
short, please.
They're coming into the text chat. Here we go. Okay, so would you mind elaborating a little bit, Zanuck, to try to clarify for them?
Keep it short and sweet, nice and sweet, mate.
You gotta be slow. No offense.
There's one more. I'll do one more hit.
I think just bite-sized, more like in your mind, you have to think bite-sized pieces of information, because the thing is, when you go and say like 10, 15 things at once, it's impossible to respond to it.
Well, I'm listening to other.
Gio, you sound like Lewis, right? And he's an asshole, but he's direct, yeah, and he's clear. So at least I can understand what he's saying. He's very, very forthright with his words. So, like yourself. You understand now, regardless.
Okay. So, Broomy, thank you for that. Okay. Yeah. So, percentage. We go up in altitude, and what we see, the horizon, we see it drop as we go higher. Mm-hmm. We're seeing further, correct. We see up to 250 miles when we're out at 35, 40,000 feet. But the horizon is dropping. And you may say, well, we can't see any further because it's just the distance now is getting so far that it's at the diffractive limit, and we're not able to see matter, as you said, light reflect off these matter. But if that's true, then that's why I always put at first I was objected to by people saying that, because the airplane's pointed upward or it's pointed downward or this kind of thing. And I showed the actual indicator that showed the airplane not pointed upward or downward, or both, actually, I showed. And then I showed the sun and the moon below level. Level is perpendicular to plumb. It's an orientation perpendicular to plumb, and it's out into infinity. So with respect to the surface, it is above level. If you're on the ground, it's above that level, it's above the horizon. And we know this because the moon and the sun are below level as well. But that doesn't make any sense in your objection.
I'm still not getting it because the picture that you showed has no sun, no moon. So I don't.
Yeah, it says a moon right there below level.
I see the moon. And the second one, you see the moon there?
Let me get the sun in there too. Hold on.
Okay, hold up.
And the second one that's the second image you posted, I see the moon very clearly. Center frame a little bit below center frame.
So these are showing clearly that the celestial body, the sun, wherever you think it lies, wherever close you think it is below level. That can't happen if the surface is flat.
I don't know about that, man.
I know you don't know about that. That's why I'm trying to explain
I wouldn't
it to you.
necessarily use this like the.
What I see
It's the best. You know why it's the best glow proof? Here's another thing.
No, I wouldn't necessarily use this the imaginary horizon on this, heads-up display. I wouldn't automatically say that that's the horizon.
That is level, yes, because you can follow it all the way into the airport when it taxis the gate and see that at level position. Hold on. Your that level line in the cockpit, if you were to measure it above the ground, is exactly where it marks on the building when it docks at the gate. That's how accurate it is. It's very accurate. It's one of the most expensive levels on the planet.
Hold on, when you're at the
Of course, Rudy's going to be talking in the background. Yes.
What about refraction things?
Well, you guys, hold on. Let Brummy trying to speak.
Like, obviously, at the surface level, right, you're going to have like a certain different sort of atmospheric effects and the light that's reaching to the observer. Now, when you're that high in the altitude and you've got looking through different sorts of atmosphere and you've got different sorts of light behavior going through different material, it's going to behave a completely different way. So then, and also, like Percent points out, the obvious thing is you find an airplane in the air going, that's the horizon. Oh, look, it's below, and it's just like you could just literally tilt the plane for a moment and take a picture.
Well, we know this for a fact. If we point at the horizon, we will crash the plane. If we follow the horizon, we will crash the plane. If we fly at the level line, proof that we're flying level, the airplane does not gain an inch of altitude, up or down, or lose altitude. It flies level, meaning across the surface, it stays the same height above the surface. Another indication that we are flying level.
Yo, you don't need that though. You could have no level line and still fly. And
how do you fly level if you don't have a level line?
You don't need a level line to be able to fly and maintain at least a semblance of your altitude.
How do you know if you're level or not?
Pressure.
How do you know if you're level or not?
This is a pilot. You guys don't know.
You're not gonna. You don't need to like. You're only. You have to use this line, or else you're gonna crash into like the ground or something like that. That's not how it works.
Well, if you actually pointed the horizon in the distance, and you saw some kind of like a mountain or maybe a light flashing at that horizon and aimed at it, you would crash the plane into it. You'd be going down.
So you don't need
that.
To do
means
that.
That means the Earth is round. So the other thing you can do. Here's the last thing I'll mention.
You could just use pressure. Why can't you just use pressure or altitude?
Also, you do agree that pressure is.
The pressure gets higher as you go up. Why can't you fix on a certain pressure?
You could look at the gauge and keep the gauge level. Yeah,
so you're accepting the grading of pressure, right?
You could look at the altimeter and you could actually fly level that way too. Sure.
All right.
It'd be hard because you'd be we're looking for a reaction. But if it's very sensitive, you could actually look at it and try to keep it within the range you want.
It doesn't have to be perfectly sensitive either. You don't have to like stay within the same.
It's not easy to fly a plane looking at an altimeter to keep it level.
I mean, it's pretty easy.
It's not that easy.
Come on.
You don't even fly. You have no
telling
idea.
a pilot
if you're at 30,000 feet.
I'm gonna fly with my altimeter and know that I'm level.
Be humble, man.
No, how do you know the wings?
Hold up, Zanuck. Even if it's varying by like 200 feet or something like that, it's not really a big deal.
No. Yeah, because there's no mountains and things that are poking up.
If you got 30,000 feet plus or minus 100, 200 feet, it's not that big of a deal. If you're just looking at the altimeter, making sure it's at 30,000, it's fine.
Who's arguing whether it's a big deal or not? We're not. We're arguing whether the Earth is flat or not.
Well, they were just laughing.
The last thing I'll tell you is that you can actually see, roughly 200 miles out, and you can see in some desolate areas where there's a tower. Maybe your airport will have a green and white flashing light, and you look at that light, you can see with the binoculars or some type of telescope, you could actually see pretty clearly. And if you aim for that, and you look at the angle at which that light is blinking, you'll see that it's close to 3 degrees down. Now, if you do the trigonometry for how far that is away from you, because that airport is 200 miles away, it should only be 100 miles away. So you're seeing something 200 miles at the right angle for only 100 miles. Why is it a greater angle? So you're seeing way too far for a flat Earth. If it's a flat Earth, it should be 100 miles. But yet it's 3 degrees means it's 200 miles on the round Earth. Does that make sense?
I mean,
So it should be 100 miles away, but yet it's 200 miles away. It's twice as far. Your error is 100% off.
You know what?
I would encourage you to make a diagram of this.
I've already have. I've posted it many times. Yeah, I could do it. I could do it again. Let me see if I can find it.
5 years into the debate, and we're still arguing over a fucking picture. I'm bored of this, man. I'm bored. Why can't we get like an actual fucking?
Because it slaps you in the face with reality. You can't. By this 3 degrees, we can actually tell you what the circumference of the Earth is. By the way, we know by this clear picture at 4 degrees at 45,000 that we're roughly 25,000 miles around. And I still talk.
Doesn't make your argument stronger.
I still hear you talking.
Doesn't make your argument stronger. Talking louder doesn't make your argument stronger. Talking louder doesn't make your argument stronger.
Come on, man.
So let him finish the argument then.
Go ahead, Reverend. What are you trying to say?
Little prick. At the end of the day, Alex, we're arguing over a picture again. And you're saying this, they're saying that. And that's what's going to happen. You're going to go round in circles, the black swan and everything else. So, like, at the end of the day, where is the actual just shoot a rocket straight up? Oh, we can't do that. We need to go in to get fucking orbital, whatever it's called. Orbital something. Anyways, and then there's another
velocity.
Why do we need to go in orbit? Why can't we just go straight up?
That's what I'm trying to say. So we could design.
Yeah, go straight up. Yeah, waste a bunch of fuel, go straight up, see the Earth's curve, and then it'll fall back down.
Like all the way out to space, all the way out, shoot a rocket.
Yeah, the Kármán line, they already go there straight up. Yeah. Went beyond the Kármán line, actually.
No, all the way out, and look back at the Earth.
All the way up, look back at the Earth. Yeah, you go as high as you want. I mean, they're not doing this to satisfy flat Earthers. They're doing it for actually, for reasons. Either they want to go into orbit, or they just want to see,
Oh, sure.
They just want to see the view of the Earth at a high position, and then fall back down and have a free fall for a while.
There's a good Blue Origin uncut video.
When you say
recently.
we are shooting stuff up in the air, who's we, by the way?
Yeah, it's called There's a Blue Origin video that's very
that's
recent.
the pinnacle of what they can achieve.
There was a who was that one flat earther guy? Proven that he doctored that video of the raw video of Blue Origin launch.
The Blue Origin.
Yeah,
I think I heard that too. Yes.
Yep.
Actually,
that's red herring.
I find that you're absolutely mindless. What do you mean
Red
that we are
herring.
shooting rockets in the air? What do you mean by that, Zanik? When you said we are shooting rockets in the air, what do you mean by we?
Humans, we as humans have organizations, companies that have built and fired and controlled and piloted rockets up into the upper atmosphere and into space, whether they've gone into orbit or not, and come back down successfully. And the whole time I'm
a normal conversation. This person can't even have another conversation. He's got ADHD, yeah, and you expect to take any advice off this geezer about anything. The geezer has
technically you're a little the same.
He got a
Are you kidding me, Rummy?
This is the person who's got the voice.
Claiming someone else has ADHD.
Let's not ad hom. What are you trying to say, Reverend?
If you want flat earthers, right, get him out there on the street telling them about the Earth's round. He'll turn more flat earthers. He'll turn more people into flat earthers in a day than anyone.
All right, straw man.
So yeah, so why
is that the right term?
You babble so much you can't be thinking coherently. You can't.
Well, when I'm talking to you, I'm saying things over and over again because you keep on interrupting me. And
don't say things over and over again, please, for the benefit of all the other listeners. Just say what you mean to say, and then let someone else speak.
So Xanax.
Same with you, Riven.
No worries. I'm trying to slow him down a little bit.
Rumi, come on.
Xanax. So,
I'll slow down if you slow down, and I'll talk quieter too.
Xanax. Go ahead, Riven.
Fucking hell. So, where was I? Xanax. Yeah, we just want something shooting straight up in the air, something just something a nail in the coffin, just something blatant that we can just show that, oh look, the Earth is round. All you guys talking shit. It's just egg on your face, and then carry on with our lives. You get what I mean? But the problem is, right, every time we get to the corners of where something conclusive can be put, like a camera down Antarctica to view the 24-hour sun. I know there's a few bits of video and stuff like that of people flying over the Antarctica and a few video footage and stuff, but it's really, really, really looks really poor. And there's just not enough discovered down there. There's just not enough going on, and like you've been arguing this for long now, and why do you still argue?
Go ahead, Zanny.
I have no idea what you just said, but I just posted a picture of the airplane at 35,000 feet, showing that at 3 degrees you'd be 114 miles away. And we see the light. It says horizon, but it could be near the horizon. It's something out there 200 miles. You can see a light of a open airport with a green and white flashing light, and that would be at 3 degrees, not the 114 degrees. That would not be a lot further than 3 degrees. So we can see this, and you can measure it yourself. You can do this on mountaintops. You can go to a mountain near a beach, like in LA, there's Mount Baldy, which is 5,000 feet. Go look at the Huntington Beach with binoculars. Get a sextant. Get a freaking protractor, and you can and you can see that it doesn't work with normal trigonometry. You can actually figure it out.
Yo, shout out to JJ in the chat.
What?
So you expect me to watch this dummy and expect that to be? You know, I saw the Chronic.
Mm-hmm.
Do you know what? You know the International Space Station spacewalk that woman does the tour of the actual ISS, and she's floating around. She goes down to the capsule and all
that. Sure.
Yeah. I mean,
Hasn't that been done like a million times?
I've watched loads of stuff like that, and I've seen it. It's quite convincing stuff.
Okay. I mean, you asked for a uncut, unedited launch straight upwards, and I delivered.
It's not quite. It's not quite really though. We don't want something. We don't want something made for us by NASA. We just want something like we want it made by NASA in a way, but we want it more for the public.
Hey, NASA.
No, don't you want to see the whole globe?
Really?
Like, isn't that the point?
We want like a camera that we can just shoot straight.
Hey, Bernie, I got a question for you. So you haven't been on. I haven't heard you in a while. Most of these other discussions, but when we move across the surface of the Earth, why is it we get a 60 mile per 1 degree change of view to the North Star? And you're going to talk before I'm even finished with the one sentence. It literally is one sentence, and you had to interrupt before I was even finished. Amazing.
We know you done well at college, and I'm not interested in your college questions.
Why no? You can do this yourself. Drive 60 miles. Drive 60 miles. Look at the North Star. Take a protractor out with a plumb bob, and then go 60 more miles and see this 1-to-1 relationship between the 60 miles and the degrees change to that celestial body.
I've got a diploma. I'm quite well educated, right?
Okay, so if you're quite well educated, that cannot exist on a flat surface. That relationship, this linear relationship, scribes out a circle. Does not scribe out a flat surface.
I'm trying to explain something to you. I'm sick of doing maths, right? I'm not in school now.
I know I know. That's rich.
Don't
that's
say
rich.
that,
He's sick
Brummy.
of doing math.
Don't say that.
He's sick of doing that.
I gotta give you a pointer. I gotta give you a tip. Don't repeat that again, please. Scrub the live stream.
Maths is not reality. Maths is not you guys what's that guy's called? Red Rhetoric, when he said maths is reality. You guys think reality is maths, do you?
So what do you require from now on? Just pretty cartoons and videos?
No. At least a fucking sentence to reply to what the fuck I'm talking about before people jump down my neck when I say one little word.
I mean, it was kind of embarrassing, but
not really. I mean, it's a bit immature for you to find that embarrassing. Like when I say I'm tired of doing maths, like I've done these questions like, well, trains traveling 100 miles an hour, it's going 4 miles. How much are you traveling with 40 minutes? It's like I don't really give a fuck right now. I'm not in college doing my fucking maths and like
saying that you don't want to do math is, in my opinion, the same as covering your ears and going blah 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 blah. I'm not listening. Blah 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 blah. It's the same thing to me.
I've done my listening. What I'm trying to say to you, I've done my listening before. I've done my listening, and I passed my maths. I'm not bad at it. I'm good at it. And I've done maths for these things when I was interested in this topic. I've proven it with these little numbers and these little videos. Yeah, I was in it. I used to do that, but now I don't really give a fuck about it because I've gone to the conclusion that really.
So then stop asking for things then.
No, because the things that we're asking for, you haven't got. And that's the point we're trying to make.
Scroll up in the chat.
You're too busy posting shit that I ain't asking for, thinking this is satisfactory. You don't understand the fucking thing that I'm saying to you. That's the problem. The communication barrier is horrendous. So you're sitting there
on whose side? On whose side though?
You're sitting there laughing at me, and you ain't even got a clue how the conversation's really going because you're immature and you're young, and you got your head up your ass.
I disagree.
Well, okay,
He's immature and young.
I disagree, man.
Chronic. You are young and you have your head up your ass.
I only ever see in this entire community, I only ever see Globers delivering demands that flat earthers make Never once ever the reverse of that ever.
What I'm just saying
Because
now.
Globers have the burden of proof.
We
So?
explain it to
Not
me,
only
right?
you guys make a bunch of claims as well.
Even if that statement was true, so
Anyone who makes
you can still
claims
provide
that require
you
a
can
burden
still
of proof
provide
should be
it.
providing the
No,
evidence.
you can still provide it on both sides. Even how ludicrous that statement was, even if it was true, you should still be able to provide something, anything.
Again, anyone who makes any claims that, like, you know, that go against the default of what we all agree has a burden of proof that they have to substantiate.
Yeah, you guys do that.
We know they do that, Bacon. We know
some
they do
flat earthers may, and that's why I said anyone.
Mm-hmm. So
but the default is that we have an observably flat and motionless Earth.
Again, any of the statements that you make right now, even if any of them are 100% true, that doesn't completely negate the fact that, in my experience, I've never, ever seen a flat earther deliver anything that a glober asks for in this community ever. And again, you'll say your response is, again, the burden of proof of blah. If you're making the claim,
that's not what my
blah.
response was going to be. My response was what I said that you didn't listen to, which is that's not true, because there have been many instances where flat earthers made claims. Maybe it wasn't like, you know, directly that the Earth is flat or something like that, but made claims relative to the discussion and they substantiated it. I can think of, like, you know, at least
name one.
Jeremy, whenever he makes like a claim about like light or something like that, he'll, you know, it'll be something that he was recently looking into. He'll post the link or something like that. You know?
I have never
Posting a
seen
link?
Jeremy.
I know, right?
Is that the thing you're saying? You meet the requirement just posting a link?
With
Is that
like
the
with
thing
the
you guys did?
what's her name, Andrea Getz or something like that, talking about how, you know, Einstein has, you know, the Nobel Prize winner was talking about how Einstein got it wrong basically, and they're modifying it and stuff like that. That claim has been, you know, contended multiple times, and he's like, you know, that's just one. You know, there's a lot. Like Jeremy comes correct with it, so he's always substantiating his stuff.
Everything we do, we back up with these the math, the pictures, the drawings to try to explain things, to have it very easily understandable. I mean, things like the sextant. I mean, how many times have you heard the curved adjacent? That is like so asinine. The whole curved adjacent, even in a sentence in our discussion,
And by
is
the
so
way,
stupid.
it was claimed multiple times that you can do celestial navigation on a flat surface, and I have yet to see a single person doing that.
Yeah,
and I asked it a bunch of times. Globus just left. I was asking him yesterday. He said he can do it, but
we provide all the evidence, all the reinforcements, all the pretty pictures, things so you can understand what we're talking about. Yet it just goes right over your head. Percentage.
Let me
you
ask
tell me, why do you think? Why does the GP have to be on the same surface, same flat horizontal surface as the observer? Why do you think that is?
Since you like questions,
the go-to statement.
Oh
my God, it's always brewing in the background. I can always tell.
Explain to me, right then, why Nathan Oakley's arguing about this measuring to the horizon on a sextant when you get your straight lines to determine the GP location from stars. How do you do that on a ball?
That doesn't determine the GP. The GP is determined from the almanac in your clock. Has nothing to do with that.
Ironically, that's affirming the consequence. That is a definition of affirming the consequence. He's saying that, but we're actually saying it's not on the flat surface. We're determining what the surface looks like by the horizon. Now, we don't want to get in the horizon because it gets into refraction, and that's a whole other argument. So you know what? We remove that part of the argument. That's what's good about arguing these kind of all this types of math or this type of physics. You can remove certain variables and do another test. And the other test would be just a bubble sextant. So now there's no more horizon involved. Just a vertical, just a celestial body, an elevation angle. Complementary angle would be the co-altitude angle, and the co-altitude angle is what you use to measure the distance because of a degree to hold on. Almost done. Ryvan, come on. So there's a 60 mile to 1 degree relationship. So whatever that co-altitude angle is, you multiply it times 60. That's so far the GP. It has no bearing on whether the surface is flat or round. What it does tell you, it's round. Oh my God.
Seriously, slight correction. It's not affirming the consequence. It's affirming the consequent.
What have we all learned today? We've all learned.
I meant consequent. Yes. Yeah. I just hear Broomy talking in the background. I can't keep my concentration. Affirmative consequent. Yes, you're right. So listen, the reason we know that it's round is because
Zanuck, it's pretty rude to just say somebody else is talking in the background while you just dominate and bowl over the whole conversation.
He literally, he's mindless. Now, look, he's obviously good at his maths. Brilliant. I asked him a simple question. What is the determining difference between the Earth's surface on a sextant determined to be flat, like Nathan Oakley said? And he just fucking started talking about angles, this, that, and the other. Let's just break it down. Only asked him a simple question.
What was the question?
Nathan Oakley saying that to the horizon on a sextant, when you're making your the positioning of the stars, when you're doing your angle to them, you have to presume the Earth's flat in order to do that. And
no, you don't.
No, you don't.
Okay, cool.
Not at all.
Okay, so you
I mean, technically, you have to treat it as flat.
No, you don't.
No, you don't.
You do,
Not even
because
close.
How?
In reality,
Why?
you can't get an angle from a curved surface.
You're not getting an angle from the surface.
You're getting an angle from the curved surface.
You're getting the angle from the side to the horizon, not from the
Exactly.
surface.
Yeah, with the horizon, you treat it as flat.
No, you don't.
No.
Why do you keep on saying that? Why does everybody keep on saying that? It's so silly.
You do, because you're not getting
The proof is using
you're
a bubble
not getting it from
sextant.
an infinitely small tangent point. You're treating it
An
as flat
infinitely
from wherever you're
small
looking at
tangent
it.
point?
Yes, the tangent points are infinitely small, right?
Okay.
So the tangent point is infinitely small. You're not getting it
Okay,
from that.
so
You're
what?
getting it from at least a segment of the horizon, which you're treating it as flat.
No, you're not treating it
Yes,
as
you're
flat.
treating one end of the segment to the other end of the segment as the same.
Yes, it's a segment.
You're
It's a
treating-
flat
you're
horizontal
treating
line.
a thing of distance as a point. So
It's
therefore
a
you're treating it
flat
as flat.
horizontal line.
Exactly.
Excuse me. It's not. It's not even. It's not. Actually, it's not. Actually, it's not. I don't know why I even said that. It's just a straight line.
said that
It's
'cause
not
you had multiple
horizontal. It's not.
clarity.
It is flat, but it's not horizontal.
Guys, I posted a link, right? Yeah, at 8:39, Nathan Oakley posted a video where there's somebody, a glober, that I used to make the argument that all these globetards are making now, saying that no, you presume it's round, but evidently it proves that it has to be on a flat surface. So yeah.
No, it doesn't. The fact that we let me say it one more time, Jeremy, because you must talk to me when I was trying to explain. If you sight the horizon and then apply a dip angle, which is going to be affirmative consequent as well, and then you also blend in refraction, you'll have a straight line to that point, and it'll be adjusted for the dip and for the refraction. Now, if you don't like dealing with refraction, don't do it. Don't do. Hold on, I'm almost done. Come on, can I just finish? All you get is a vertical. Everyone can get a vertical. Just drop a plumb bob and get a deviation vertical. Now the answer will be in degrees, and that degree times 60 gives you the distance to the GP. It doesn't tell you what the surface shape looks like. What tells you what the surface shape looks like is taking multiple values. And if every time you go 60 miles, you see 1 degree, the surface is flat. Does that make sense?
So why did you mention refraction?
Real quick,
It's real, 'cause it
you can
happens.
address that, but real quick, Zanuck,
Because
here's some
when you
constructive
look at the
criticism for you.
horizon, the
Hold up,
horizon can be loomed up due to
Zanuck.
refraction, and refraction plus the dip angle will change that position of what would be the horizontal, the level line from you into the distance. You need the level line. You need the horizontal.
please
Level
make it
horizontal
concise.
line. You can get that from
Monologuing, please.
opposing it to vertical, or you can get it from the horizon plus dip plus refraction. Get it?
Okay. So when it comes to celestial navigation, does refraction have anything to do with the horizon? The refraction correction?
Yes, the horizon will be
Incorrect.
loomed up or down depending
The
on the conditions.
correction for dip includes refraction.
No, the refraction correction is only a correction for the sighting of the celestial body. It's got
That's
nothing
not what
to
I
do with
said.
the
No,
horizon.
that's not
No,
true.
no, wait. You
I-
ask
I-
it. No.
I can back that up if you like.
No,
You know,
that's not
wait,
true.
wait. You're if you're asking the part in which you correct for refraction of the angle, yeah, that's the position from the start after you already subtracted the dip. But the dip includes refraction. It's not a
No, it doesn't.
geometrical dip.
No,
Yes,
no.
it does.
All the dip does is include your height of eye correction. That's the height of eye above sea level.
Yes,
That's
dip
all
plus the
dip
refraction.
Yeah, but
has
that
to do.
includes the
No, it
refraction
doesn't.
that
No, the
I wasn't
refraction
finished.
correction
I wasn't finished.
It's very
I
specific.
wasn't finished.
Carry on.
It does. Yeah, it corrects for how much the horizon drops, including refraction of the horizon, not of the celestial bodies, of course.
Incorrect. The refraction correction is purely just for the sighting of the celestial body.
No.
And the dip correction.
There's no refraction.
That's
There's
not
no
what I'm saying.
refraction for. There's no refraction. There's no
Let me
refraction for a
finish.
celestial body above your head.
Let me finish. The dip correction is purely a height of eye above the sea level correction, which is the angle subtracted from the observed angle. You subtract that dip correction because you are above the sea level.
Yeah,
So
that
would
includes the
create
refraction of the
let me
horizon.
finish. No, it
And they
doesn't.
have you that dip
No, it
correction
doesn't.
is based on height above the surface and
The
the
dip
round Earth
correction
8
is
inches per
purely
mile squared.
the
You're
dip
wrong.
correction.
You're wrong.
Let me
No, you're correct.
finish. Let
You're
me
wrong.
finish, please. The
You won't
dip
let me
correction.
finish.
Let me
Let him
finish.
finish. Let him finish, Zanuck.
The dip correction is purely an angular correction that's subtracted from your observed angle. It's got nothing to do with the refraction. The refraction correction is all about you sighting the body and it appearing to be somewhere else.
Yeah,
It's
that's
all
one of
about.
them. That's
Not
one of
about
them.
the body. It's about the horizon.
No, it's not. It's the only.
It's
the
not.
only
Go look
it's
it
the
up.
only.
Bring it
Okay,
back
so
to me.
if
You're
you guys just
wrong.
want to
You're
talk
wrong.
over me, this
You're
is
wrong.
pointless.
You're wrong.
Yeah, the
You're being a
correction.
child.
No, because there's no
correction for dip.
refraction looking straight up.
No, he's not. That's not what he's saying, Zenek. There is a when you get the angle, you subtract dip first, and then you go to
then
the
refraction.
elevation of and you go to the elevation of the star. You input your pressure and temperature, and you get a new elevation angle from the star. That's the correction for refraction that he's
Right, but the
referring to,
refraction is based
which does
on
not.
you. It's based on you to the horizon, not based on you to the star.
No. That one is based on the elevation, the corrected elevation angle
The
from dip.
elevation angle is the dip plus the refraction.
No, the elevation
I mean,
angle is already.
the dip is the elevation plus the refraction, as you said. Both
Yeah,
are included.
but that's the refraction of the horizon. What he's referring to
Right.
is the refraction of the celestial body you're sighting. So you
There's
have
no-
both. You have
there's no
both of
refraction
them are
correction.
reflected.
There's no refraction of the North Star at 45 degrees up in the sky. That's
There
not
is
what
no
it's all about.
horizon refraction correction when it comes to celestial
Okay,
navigation.
you know what?
It's already
Tell you
included
what.
in the deep.
Tell you what.
It's not
Let's
included
forget about
anywhere.
that. Let's hold on.
Yes,
Hold on,
The dip
Globus.
angle is purely your
Let's
height
forget about it.
above.
Let's forget about
The
it.
dip angle
Just
is
go
purely
vertical.
your.
Just
This
take
is
a bubble.
impossible with
Same
this
type
guy.
of
This
device.
guy's a child. It's
Guys,
impossible to
we're
have
out
a
of
debate with
time.
him.
Seriously.
Same type of device. Let's use the bubble sectors. We don't have to worry about horizons anymore. That's the
I'm going to
point.
engage if Zanuck gets muted. This is pointless with him. All he does is talk
It's
over
not
me.
pointed. You're just not listening.
Yes, it is. It's
Forget about
pointless with you.
why are we arguing about something we can remove? Let's remove that factor. Just use vertical.
Zanuck.
Can I just talk to Globus?
Listen,
Let me have a conversation with Globus. Just shut up
let
for a
him
second.
finish his points. Let
He
him
already
finish
did.
his
He's waiting for.
points. Right?
I had to do it, man.
There you go. Yeah, go, Globus. Finish your point and let.
Thanks. So, as I mentioned, there is no refraction correction when it comes to the horizon. If there is, I would love a citation because all I've seen is a refraction correction for the sighted body. Now, the dip angle is the angle that you subtract for your height above sea level, for your height of eye correction. That there is no refraction included, and if there is, I would love to see a citation for that.
Just posted. Just posted.
Can I? Yeah, we get right there. There's your angle correction, altitude angle correction.
Can I clarify myself here? Because when you're correcting for dip, the horizon is always the horizon. It doesn't have a it's not like celestial bodies. Celestial bodies are changing their elevation angle all the time, and the higher they are, the less refracted they are. So you need you have a table for the correction of celestial bodies. So each angle is going to have a different correction.
Correct.
Horizon isn't like that. So it's fixed to your elevation. If you go higher, you get a bigger dip. That dip is not just geometrical; it's always refracted. So the dip it doesn't have to separate the geometrical from the refracted horizon. They're both compiled at the same table.
Bacon, tell him that but also tell him that dip angle is based on a curved surface too. The horizon dip angle is based on a curved surface.
I know that, but let me just conclude here because you having a single table for dip correction does not mean there's no refraction being corrected there. They're already compiled in the same table. So at that same table, you have the geometrical dip minus the looming of the horizon. It's in a single table, so there's no second step for the refraction of the horizon. It's all in the same step. And the citation is just posted in Livestream one text.
Right, but the main thing here is let's remove all this argument of the horizon and any kind of dip. Let's just use vertical and derive the elevation angle from that. Then you just take the complementary angle of that. Then you get the co-altitude angle, multiply times 60. That's how far you go for every degree you see that star change in your field of view. There's no dip to worry about, no refraction to worry about. You just go on your merry way and see that every time you go 60 miles is a 1 degree change. That means the Earth is spherical. Lobus, you understand that?
Right, but so this line of sight that you're drawing to this tangent line that you're drawing.
No tangent line.
There's clearly a tangent line there. There is a visible horizon there. That line there.
You're not talking to me. You're talking to
It's impossible to talk to.
Because I just got done telling you that there was no tangent. We're just going to talk about vertical versus the observed altitude angle.
In the reference that Bacon posted, there's quite clearly a tangent line drawn.
Yes.
What are you drawing that tangent line to?
That's to the horizon.
To the horizon.
Correct.
To what? To the geometric horizon?
Yes.
No, to the refracted one.
Yes or no? You guys have got to make up your mind. You guys are in contradiction with each other.
No, the first picture
is no.
Yeah, the first picture is no. The second picture is yes. First picture is a geometrical horizon. The second one is more detailed and where the line is curved. So that would be then the apparent horizon.
Okay, so why is that line curved?
Because the atmosphere is denser at the bottom and less dense at the top. That makes it curve down, which makes things moves up.
So that line of sight there is curved.
If you're calling the path of light the line of sight, yes.
So so the line of sight is straight or is it curved? Which one?
If you're calling the path of light line of sight, it's curved. If it's just a direction you're looking at, it's straight. You pick the definition you want.
Your line of sight is directly dependent on the path of light.
No, it can be just a direction you're looking at. That's the one way to define it, which is not the path of light.
That's the only way to define it. Your line of sight is directly dependent on the path of light. So it's either curving or it's straight. You can't have both.
No, I was saying it's both if you're picking different definitions. Oh, I'm gonna pick yours, so it's curved.
There's only one definition for it.
Okay, I'm gonna pick yours then. So it's curved.
It's curved.
Oh, no.
Yes, that curved line is curved. That's your line of sight. Okay.
So your line of sight is curved now. It's not straight. So what's the tangent line you're drawing?
If you look at that curved line, that's showing the T, and that is an object that you would see from E over a curved path, which is refracted. If you have a density gradient that is denser on the bottom than on the top along its path.
So what are you measuring your angle of elevation off? The line of sight or which one?
The direction of the apparent horizon.
So that curved line.
No, I said the direction. I didn't say the line of sight.
So okay, you can't measure an angle off a direction.
Yes, you can.
Off a direction.
Yes, you can.
So not
directions are vectors, right? You always have an angle between two vectors. That's what the sextant gives you. It measures the angle between the two directions you're looking at.
But you're measuring an angle of elevation off the surface.
No,
because the star is elevated from the surface.
And it also, but I'm not. My eye is not at the surface. Sextant is not at the surface. I mean, the sextant is not at the surface. The celestial body is not at the surface. The only thing that's on the surface is the horizon, which is not even necessary.
The whole point of acquiring an elevation angle is because you're trying to measure an elevation angle off the surface, and then you don't
need it. You just need vertical.
You then subtract your dip angle to get the GP of that body on said surface.
Why can't we just get the angle
get the
between
GP?
C and Y?
Wait. What do you mean you subtract the dip to get the GP? The GP doesn't come from the measurement of the angle. It comes from the almanac and the clock.
You subtract the dip angle off the observed angle because every single table and chart assumes that your eye is at sea level.
So it assumes you have an elevation angle.
No.
It assumes you have an elevation angle.
Like I said, every table and chart, every single
plus
almanac
the dip angle. Plus the dip angle.
You subtract that from your observed angle because, like I said,
why is this so hard for you to understand? Why are you struggling here?
I'm not finished, and you're talking through me.
You're struggling.
Every single table and chart assumes that your eye is at sea level. That's why you subtract the dip angle because
It assumes you have an elevation angle, which is an angle from horizontal.
No, it assumes that your eye is at sea level, and that's where you're acquiring your angle of elevation
from horizontal. It assumes it's an angle from horizontal. That's what it assumes.
Which is the surface.
If you were at the
Not
surface,
necessarily.
there would be no dip
necessarily,
angle.
because- Of
If you're
course
at the
necessarily,
surface,
because that's what you're
if you're
trying to
at the
find out.
Let me
surface, there would
give
be
you an
no dip
example.
That's
angle.
where you want you
If
to
you're at
find
the
your
surface,
position
there is no
on the
dip
surface.
angle.
Globus,
If
Globus,
you're
let
at
me
the
give you an
surface, there's
example.
no dip angle.
Let me give an example. So
Well, hold on.
I
Wait, this is obvious. If you're at the
Rumpus,
surface,
Rumpus,
there is
can you
no
not
dip
just let
angle.
Aiken
There's no refraction either. All right? If you're at the surface, you understand? There's no dip angle, there's no refraction, there's nothing if you're at the surface.
Why have you got to try and
So
take over this
why aren't you
conversation?
just using the vertical and get the angle to the star? That'll give you the elevation angle, and then you can give you the co-altitude angle, which can give you the distance they travel for every 1 degree that you move.
And that co-altitude that you speak of has to match the zenith angle.
No, it's not the zenith
That's
angle.
the angle he's
It's
measuring.
complementary. It's complementary to the zenith angle.
It must
It's
match
complementary to the zenith angle.
co-altitude distance must match the zenith distance.
No.
Yes.
What zenith's distance?
The zenith distance is the distance between your zenith and the zenith of the GP of the
Right.
celestial body.
Oh, the GP? No.
Yes.
No.
You can say no, but it
No. Your zenith
Yes,
is a
of course
vertical.
it
Okay,
does.
let's
That's
get
why-
here's
that's why
okay, I
it's
see your problem.
co-altitude.
I see the problem. Let me give a sentence out. You can respond after I tell you. So you have a
I'm
zenith.
letting you
Hold
get your
on.
sentence out.
You
You're
have
the
a
one
zenith.
that
You
doesn't
have
let
a
anyone speak.
hold on. You have a zenith straight up. You have an angle to a celestial body. Say it's at 60 degrees. What is the co-altitude angle?
It'd be the complement of that.
What is that?
The complement of that angle.
What is the complement of a 60-degree angle to a celestial body?
It would be 30 degrees.
Okay. And so how would you dictate the distance to the GP with 30 degrees?
So
Using
you
a
want to.
sextant?
The thing
It's an
is,
easy answer.
yeah.
How do you do it?
Your little math problem, which you think necessitates a globe. But
I don't need annotation. I just need to answer. How do you figure out how far you are to the GP?
Your 60 degrees.
No, you said 30.
Sorry, you're
You're
60
getting
nautical
mixed up.
miles per degree. Blah blah blah.
No.
That's
You already used the wrong number. It's not 60 degrees. It's 30 degrees.
That is not the point. That is not the issue
It's
here.
30. It is the point. How far is it to the GP?
The issue here
How
is
far is it to the
that-
GP,
the
Globus?
issue here is that your zenith distance must match.
No.
Yes, it does.
I'm asking you. You
Zenith
can't even
to
answer the
zenith-
question. How
Zenith
far?
to zenith
How
has
far are
to
you to
be-
the GP?
Let me finish.
You have a 30-degree co-altitude
Zenith
angle. How far?
to zenith, the distance must be the same.
No.
Because
How
these
far
are
is-
these are two
Can you answer
straight.
the question?
These are two
Why is it so
vertical
hard for you to
lines.
answer the question? I
These-
just told
these
you you
are
had a co-altitude
two
angle of
vertical
30 degrees.
lines.
Hold on. You have a co-altitude angle of 30 degrees. How far is it to the GP?
That's
Do
inconsequential.
you have any clue?
That is inconsequential to my point.
No, it's absolutely consequential.
It's inconsequential to my
It
point.
is
What I'm saying
consequential.
is that zenith to zenith,
No.
the distances must be the same. Yes.
No. What
otherwise,
is the
otherwise
distance?
they wouldn't be at right angles
Why-
to the surface.
No,
Look,
that's how you determine. That's how you determine the surface.
Okay, so
you're not answering the question because you know you're wrong. You are completely
the
wrong.
zenith, the
What
zenith,
is the distance based on the 30-degree
not, oh my god!
You guys, I know
Zenith-
if you could.
He won't answer the question, Gio.
All right, but Zanuck, we can't hear anyone when two people are talking at the same time.
Okay, I'm trying better. I'll try to be better here. So tell me what the distance is to the zenith of the GP, the GP position. What is the distance to the GP knowing a co-altitude angle of 30 degrees? Go
As I
ahead.
said, that's not my point. My point is
My point is, I'm asking the question. You can ask your question after I'm done. But just answer the question.
That's not what I'm talking. That's a complete red herring. That's not what I'm
It's
talking
not
about.
a red herring.
Yes, it
Okay, I'll
is.
give you the answer. I'll give you the answer.
Zanuck, hold on. The only way it works is to say your piece, and then you have to mute yourself for like 20 or 30 seconds. No matter what
All right,
the person
all right.
says, that just let them respond, and then you can, of course, respond.
Okay. So what is the distance to the GP with the 30-degree co-altitude angle?
Why don't you just tell me, because that's not my point.
I didn't say. Why was it making your point? I'm making my point.
Yeah, that's all you want to make, quite clearly.
No, that's all you want to make. We all want to make our points, right? That's why we speak.
But
30 times 60 is 1,800 miles. That's how far the GP is.
Okay, cool. Originally, who mentioned the terms co-altitude?
I did.
You're being dishonest. I did.
No, you didn't. I was the first one to
Oh
bring up
my God.
altitude.
Did anyone
Anybody
hear
in the
me
audience
mention
want to
that
back that
first?
up? Bacon, you heard me say it.
I don't remember who said it
I
first.
quite clearly mentioned the fact that your co-altitude has to match your zenith distance, because if these zenith lines are perpendicular to the surface, then they must have an equal distance.
No, they don't.
don't
But they
Distance
must.
as in miles or distance in degrees? Because we got into this with Jeremy the other day. Distance in angle or distance in miles?
Linear distance.
Okay, no, then you're wrong.
I'm absolutely correct, because these zenith
No, you're
lines
not correct. Every single person ever
oh
used
my
a
God,
sextant.
see what I mean?
would disagree with you.
I can't get a sentence out.
Sure you
You
can.
can't.
Go ahead.
You can't restrain yourself, can you? So these zenith lines are perpendicular to the surface. Therefore, they must be at the same distance to each other at every point on that zenith line.
Okay, my turn. That is affirmative consequent.
No, it's not. How
Yes,
is
it
it?
is. You're assuming that line has to be straight. Because they're perpendicular to a surface, all surfaces must be flat in order for that to occur. What if it's not flat? What if it's round?
Well, at right angles too would necessitate two straight lines.
They're two straight. Yeah, when you have a tangent at that surface, that is the horizontal
Actually,
versus the
no.
vertical.
What tangent?
90 degrees, 90 degrees opposing a horizontal. Whether it be flat or round, I'll give you that. Whether it be flat or round, that's not. It doesn't mean this. The surface. It means that the tangent there or the surface is straight and horizontal. But you're assuming by saying that they're parallel that along the path from one GP to the observer that it will be flat. That is an incorrect assumption.
Well, we're talking about the surface, and these zenith
Yes,
lines.
I just said that. I
these
just said the
zenith
surface.
lines are perpendicular to said surface.
Yes.
We're not talking
It's
about
what if the surface is round?
A tangent line does not represent your surface, sir.
Yes, it doesn't have to be the surface. You're missing the point. We're
talking
going around
about
in
the
circles
surface.
here.
We are
Globus, you're being
talking
really
about
dense.
the surface.
Seriously. You're being really dense.
Let Globus make the damage on himself. Go on, Globus.
That's very dishonest. I'm not damaging myself at all.
You are damaging yourself.
I'm purely mentioning objective geometric facts.
No, you're
here.
making assumptions that the zenith
give a pause then.
It's
So
pointless, guys.
okay, so the zenith line is perpendicular to the surface, right?
Yes.
Okay, what do you get from that?
So if you have another zenith at the GP, these lines would be parallel, and the distances, the co-altitude, would be at the very same distance as the zenith distance.
Why does this line have why these lines have to be parallel?
Because they're perpendicular to the ground.
Yeah, but the ground has to be flat for them to be parallel, right?
Well, if they're at right angles too, then that would necessitate a horizontal flat ground, yes.
No, it doesn't.
Not even close.
Yeah, for a line to be perpendicular to a surface, the surface doesn't have to be flat. You can have perpendicular lines to curved surfaces.
You can't though. That wouldn't be a right angle then.
Yes,
Yeah, it
you
is.
still will. That's
No, it
that's
wouldn't.
exact. Okay, so do mirrors reflect light in the same angle that the light is reaching the surface of the mirror?
Mirrors have to do with anything. We're talking about the surface.
You get there. You get there. Yeah, the surface. The mirror has a surface, right? And
No.
the angle of incidence. Don't mirrors have surfaces?
Yeah, but we're talking about the surface of the Earth.
Yeah, I'll get there. So mirrors reflect light, right? And the
Hang
angle
on
of
a second.
incidence is the same as the angle of reflection, right?
Yeah. Yes.
Yeah, and those angles are measured from a normal line by definition. A normal line is perpendicular to the surface. What happens if you have a curved mirror? Does that change anything? It doesn't. Same law still holds. You have a line that's perpendicular to the surface, to the curved surface, which is a normal line, and the angle to the line, which would be similar to the zenith on the spherical Earth, is the angle of reflection and the angle of incidence. So
It's
the
not
fact that the surface is
perpendicular.
curved does not prevent you from having a perpendicular line to it.
It's a very simple depiction there in the live stream text of what necessitates perpendicularity, right? So the one on the left is not perpendicular. The one on the right is.
They're both perpendicular.
All right. So the one on the you're saying the one on the left is a right angle?
Look at look at the drawing above
Yes
that.
or no?
Look at the drawing
Yes.
above that. All we have is a horizontal, perpendicular
Hang
to
on, Zanuck. Hang on. Hang on.
perpendicular to the vertical is the horizontal. That's what you would actually get. It's implied what Bacon is saying is that when you shine a light that way to a curved surface, you have a perpendicular to that curved surface. Yes, your question mark is a 90 degrees. It's not to the entire curve. It's to where it makes contact. Because if that wasn't perpendicular to it, it would have a different reflective angle, which it doesn't.
Even
It'll
where it
reflect
makes
directly back.
contact, even where it
Oh
makes
my
contact
God!
to it,
Go Globus.
even where it makes contact to the surface, it's not at 90 degrees because that surface is curving at every point. There's no one point where it's horizontal. There is just none. That's the whole purpose of a
That's not a
curved surface.
requirement. That's not a
It is a
requirement.
requirement. It
No.
is.
Okay, so
It absolutely is.
curved mirrors don't work then, right?
Who's talking about a curved mirror?
Yes, because they also the angle of incidence is defined to be an angle to the normal line, which is a line that is perpendicular to the surface of the mirror, right?
Globus isn't going to get
What's
this.
what's a normal line, Globus? What's a normal line?
That's again, that's inconsequential. Again, red
What's a
herring.
normal line?
It's not
No,
inconsequential.
that's not a red
Exactly
herring.
what
That's
you need to think.
completely in the context.
It's
What's a
not
normal
though.
line?
It's not.
What's a normal line?
We're talking about zeniths.
Yeah, which is on
zenith
the
line.
globe is normal to the surface.
No, it's not.
In the globe, it is. Okay, on the globe, the plums points to the center, right? Center of the Earth. On the globe model, right?
Sorry, yeah, apparently. But
Okay,
yeah, I mean a presupposed center.
So zeniths are opposite to plums, right? Because they point up on the globe model, right?
Zeniths are not are supposed to be perpendicular to the surface, and in your globe representation, they are not.
They are.
They are.
There is no right angle there.
This
Sorry.
is like Dumb and Dumber. Come on, you got to stop doing this.
What's a
Globus.
normal line, Globus? What's a normal line, Globus?
He doesn't know
What's the point of your question though?
because you think
because it debunks our claim.
It doesn't at all.
It does. That's a perpendicular line that can be perpendicular to a curve. The same thing you're saying is impossible.
There's no such thing as you. It's an oxymoron. You can't have perpendicular to a curve.
You can. That's what a normal line is.
You can't because a perpendicular line means at right angles too. You
So
quite
you're
clearly don't have
defining
a right angle here. If you don't
define the concept of normal lines,
can you define a right angle then?
Yeah, it's a 90-degree angle.
Okay, so my picture on the left, is that a 90-degree angle?
Yeah.
You can't say yes to that. That's
Why?
ridiculous.
Why?
Because it's not 90 degrees. There's no perpendicularity there.
Yeah, the dead straight line hits the surface at a 90-degree angle.
A 90-degree angle necessitates two straight lines. Straight.
No, it doesn't.
You can just say that, but I mean that's.
Oh, you can just use the tangent then, the tangent of the surface. It works as well.
But we're talking about this. We're not talking about the tangent. We're talking about the actual surface.
That's the same thing.
No, it's not. The surface is not the tangent. A tangent line does not represent the surface. I'm sorry. The surface
That's all I'm
represents the
saying.
surface.
I'm talking about the angle, not the surface itself. It does represent the angle of the surface.
Well, we're talking about the surface. We're talking about zenith
Can you read
line.
Can you read the thing I just sent on Livestream in one text?
Yeah, you're drawing a tangent plane. That's not the surface.
Can you read what it says? Can you read what it says? A normal to a surface at a point is the same as a normal to the tangent plane or to the surface at that same point. So the angle of a line to a surface is the same angle to the tangent line of the surface. That's one way you can get the angle of a curved surface.
I'm curious why.
Right, but that's not the surface.
It's the angle of the surface.
Which is not the surface.
Yeah, it's not the surface, but it's the angle of the surface.
That's my point.
The thing you're claiming doesn't
what's
exist.
in question here. The surface needs to be perpendicular to the zenith.
And it is.
It's quite clearly not. If you're having to draw tangent planes, it's not. Otherwise, you wouldn't have to draw a tangent plane. If it's perpendicular to the surface, then why are you drawing a tangent plane?
Because you can't see why that's perpendicular to the surface. That helps you visualize.
It helps you visualize it, but it's not reality, is it?
None of them are. Lines aren't reality. Planes aren't reality.
The surface is supposed to be reality. Quite clearly
Yeah,
here.
the surface is, a plane
In order
isn't,
for you to
right?
get your
Plane is a
perpendicular
geometrical
zenith,
object.
you're having to draw
Doesn't
a
exist in
tangent
real
plane,
life.
which is not the surface. Just admit it. It's not the surface. In order for you to get your
Yeah, I
90
said it's not the
degrees,
surface.
in order for you
Neither is
to
a
get,
plane.
let me finish. In order for you to get your 90 degrees, you're having to draw this tangent plane. That's what you need to do in order to get your 90 degrees.
All you got to do is do it vertical.
That's the same
Well,
thing.
you know what? You're Bacon. You're going over and over again. Let me just interject one thing. Forget about the surface. Just have a vertical and establish a horizontal, which you force to be 90 degrees opposed to vertical. Are you with me so far?
You don't have 90 degrees. You can keep saying
I'm
that. but
making 90. I'm making 90. I have a protractor. I have a vertical line. I'm making a 90-degree angle to that vertical line. There's my horizontal. Okay.
On a protractor, you have a
Hold on.
horizontal base.
I don't need to do this, but I'm doing it for you because I'm being polite here for you.
Look,
Because you're
it's
just
so
you've
pointless to speak to
you've
you.
hit a mental block and you're not able to listen to what's been explained to you very articulately
No.
and slowly by Bacon. You're not
Bacon
listening.
made it quite clear that in order for him to get 90 degrees, he has to invoke this tangent plane.
Okay, so let's
There's
forget
no
about
other
the
That's
way.
the way to explain it.
I can invoke it. I
It's the
can give
only
you the
way you can explain
I can give you the can I finish? I can give you the tangent plane. I can give you just a horizontal. You can call it what you want. It doesn't have to necessarily be a tangent unless the surface is curved. And let's say we don't know. All we do know is I've given you a horizontal, which is perpendicular to plumb. Then you look at your celestial body and you get an elevation angle from that horizontal up. You take the complementary angle as we talked about before, and that gives you your co-altitude angle. That times 60 will tell you your distance from the GP. We don't know what the surface yet looks like. All we need to do is make one movement, 60 miles, and if we see a 1 degree change, we know the surface is curved. Get it?
So you're measuring things off a tangent plane again. So not the surface.
No, I didn't.
No,
I
he
don't know.
didn't
I don't
mention
know
tangent
it's a
plane.
tangent. I just told you. I measured
Are
a
you listening?
horizontal, 90 degrees opposed to vertical. I measure that. I get elevation angle. Then I take the complementary angle of that. Remember before it was 60 degrees elevation, so we know the co-altitude angle is 30. That means you take 30 times 60 gives you 1,800 miles. Now that we know, we don't know whether the surface is flat or round yet. We make a movement of 60 miles. We see there's a 1 degree change in that co-altitude
You've already
angle.
gone through that.
Hold on. Now we know that the surface is curved. Now we know it's a tangent, not before. Afterward. I can't make it any more clear than that, Globus.
So you're still measuring things off tangents then?
Oh my God! Are you serious?
Okay. Let me try something
Bacon,
different.
I tried.
Yeah. Okay, let me try something different. I'm going to describe how I sighted my position, how I make my sights and get my position right. And then you tell me how that's a problem for globe. So what I did was I had a pen with water on it, right? And I measured, I sighted the moon through the reflection of the water, and I sighted the moon directly. Then I measured the angle between those two directions, right? And then I got the half of that to be my elevation angle. Is there a problem for the globe Earth so far?
So what are you measuring your angle from? Off?
Yeah, I have a sextant, right? The sextant has two sides. One of the sides I'm pointing to the moon. The other side I'm pointing to the reflection of the moon on the water.
Why are you doing that?
Because I don't have a horizon. I don't live near the coast. So I'm getting twice the elevation angle because the horizontal line going up is the elevation angle, and the horizontal line going down, the same amount of angle is going to give you the reflection of the moon. So if I sight the reflection against the own moon, I get twice the elevation angle. Correct? That's actually a common tactic if you don't have a horizon. All right. So is that a problem for the globe for me to do that? Is there something on being on the globe that prevents that?
I don't see one so far.
All right. So I did that for a star as well, right? And I then got the co-altitude angle. I just subtracted that from 90, right? And then I got the GPs of them from the almanac, and I plotted a circle around the sphere around that GP using that distance, and they intersected 5 kilometers from my house, right, on the globe. Can you do that on a flat surface?
Why wouldn't you be able to?
No, I'm asking if can you do that on a flat surface?
Well, why wouldn't I be able to?
Because no one has done it.
Because no one has done it.
I've told
Yes,
you why you
if
can't
you do it, you're gonna be the first ever to do it, right? I'm gonna give you the sites and see how you can find where I live with them. What about that?
Yeah, fair enough. Go for gold.
What is the barrier here for you to understand this, Globes? It's fascinating right now to me.
The issue here is that you guys quite clearly don't understand elevation angles.
We do actually. The elevation angle is an
I
angle
just told you how to
above
measure
the
one,
horizontal.
right?
The horizontal can be found. Hold on. The horizontal can be found as a deviation from vertical by 90 degrees. Would you agree?
Come again? Go again?
The horizontal can be found by just getting a deviation from vertical of 90 degrees. I can create this horizontal. As long as I have vertical, I can create a horizontal. Correct? That's 90 degrees opposed to vertical. Do you understand that?
Well, is that horizontal your surface?
No, just a horizontal.
How can
it be on a mountaintop?
But why wouldn't it be your surface? That's where you are located.
Why can't you answer the question? This is what
hang
has been
on.
the problem
The
since we
thing is-
started
the thing is-
interacting.
The thing is, you want to find
possible to
the thing
find
is
the
you wanna find-
horizontal that is 90 degrees opposed to vertical? Yes or
The
no?
thing is, you want to find out your location on the surface. So
Yes,
why
I'll
isn't
get
that
to that.
horizontal your
Well,
surface?
you got to walk before you can run, Globus. Can I find that? Can I get that horizontal?
The horizontal needs to be the surface because that's
No, it does
where
not. That's
you
where
are
you're wrong.
situated.
That's the Nathanism. Nathan says that.
In the way I sighted the stars, my horizontal isn't the surface, right?
Well, it should be because that's where you're trying to find set position on.
You don't even need
No,
the
no, no.
horizontal, actually. I'm just doing it for fun. You can just
if-
you can get the zenith angle to the star, and that is equal to your co-altitude angle, is it not?
Yeah, you disagreed on that earlier. You said the zenith distance
No,
wasn't equal.
you're talking over me, dude. Come on.
What? I'm not talking. I'm responding to you.
I gave
What are
you
talking
the
about?
exact. I gave you a 60-degree elevation. I said,
Hang on. Earlier,
altitude.
hang on. Earlier, you said the co-altitude is not equal to your zenith distance. Now you're saying they are.
Well, you said distance was in miles.
Well, the distance should be the same. The distance should be the same, especially if you're converting, especially if you're converting that angular site into linear miles. They should be the same because you're using the same math.
But it's not.
But it should be.
I'll let you contradict your assumption right here. So we have your elevation angle. Forget about the horizontal. Let's just go right to the co-altitude angle, which would be the zenith angle to the star, correct?
I can't forget about the horizontal. That's where you're
No,
getting.
we don't need the horizontal. We do not need it.
Yes, you do. In order to,
I'm telling you, why don't you just let me finish this?
In order to get your zenith angle,
is your zenith angle to the star the same as your co-altitude angle?
In order to get your zenith angle,
or no?
you first must get an elevation angle.
No, you don't. All you need is a zenith angle to the star.
Yes, you do.
All you need is the angle to the star.
No, you can measure with a bubble.
Well, what do you
with
measure
bubble
with a
level.
sextant then? What do you measure with a sextant? Do you
Why
not
are
measure
you
the
asking
elevation angle?
questions with questions? Just follow me. You might learn something, Globus. Seriously, you are wrong, and I'm trying to help you understand. I really am.
You're not trying to help anyone by speaking.
I'm really trying to help you. As a human to
Really
another
not.
human, I feel you're so lost. You need help, and I'm trying to help you. Now, if I'm wrong, I will eat my shorts right here on Livestream.
I doubt you will. So,
Oh, yeah, I
in
would.
order
because I'm not wrong.
what angle do you acquire with the sextant?
A bubble sextant just gets you a co-altitude angle.
A marine sextant.
What?
A marine sextant.
Gives you an elevation angle of the star.
All right. Okay. So that's what you acquire.
Not
And then,
directly.
Can I get that same value? You have to understand Keltman angles. Can I get the same angle by just getting a deviation from vertical?
No.
Yeah, of course you can.
No,
Aren't
you
they complementary? Aren't
they complementary?
Yeah.
They might
Aren't
be,
they
but you're acquiring the
Why
angle.
do you think
of a
they don't use? Why do you
horizontal.
think they don't use a bubble sextant on a ship?
You're
Why do you think?
acquiring that.
Why do you
angle
think?
off
Stop talking for a second. Why do you think they don't
I
use a
wasn't
bubble
finished
sextant?
my statement.
Stop talking for a second. Why do you think they don't use a bubble sextant on a ship?
Because why do they use it? Because you've got the horizon there.
Do you have the answer or not?
Because you have the horizon there. Listen.
No, that's not why. Why do you think they don't use a bubble sextant?
That's not
Because
why.
it's pointless. Because you have the horizon in sight. That's why.
No, that's not why.
That's exactly why.
No, that's because of your ship is tilting back and forth. It's like wobbling. That
It's
doesn't help.
moving. You
with
can't
that bubble
get a
section.
vertical.
Of course,
You
that's
can't
why
get an
it's hard,
accurate vertical.
it's hard for you to acquire
Stop
horizontal.
talking.
That's why you use the horizon on a ship.
Yeah, because you cannot
Bubble
use a bubble
sextant on a
sextant.
ship.
Using a bubble
Because
sextant would be better.
Because you've got the horizon.
no,
No, because you can't use a bubble sextant.
Why do you rock the horizon from side to side then?
stop talking this about the horizon. When you're on an airplane, same deal. Why do you not use
rock
a
the
C
sextant from
sextant?
side to side
Why
then?
do you not use a C sextant on an airplane?
Because the horizon is not normally in sight.
Correct. So if you don't have a horizon, you're agreeing that we can use a bubble sextant for the same exact information.
That's what I said. You use a marine sextant.
Okay. So forget about
on
this.
a
Forget
ship,
about
you
why
use a
not
marine sextant
simpler?
on a ship.
Forget about
You use
forget
a
about the
marine
horizon.
sextant on a
Oh
ship
my
because
God.
you have the horizon in sight. There's
Forget
no
about
need
the
for a bubble
horizon.
sextant.
Forget
We
about things that are
already have
confusing you.
horizontal.
We're just going to use the bubble sextant, and we're going to get what? We're going to get the co-altitude angle automatically, right?
Why are we talking about a bubble sextant now?
Because it gets rid of all the things you seem to be confused about. And it's the same exact program and the same exact 60 miles per 1 degree movement. So why make it more complicated with a C sextant since you obviously don't understand how it works?
Well, what you don't understand is elevation angles, quite
I
clearly.
do. So how do I
you
get an
do.
elevation angle, which I wouldn't use on a bubble sextant? How would I get that with just a zenith angle?
You don't.
You don't? What do you mean?
It's just a complementary angle of the
It's
zenith
just
angle.
90
Well,
miles.
the thing is, first you acquire the elevation angle before your zenith angle. I've already
How do you
told
get a zenith angle for the bubble sextant?
You're measuring your elevation angle off a horizontal, off a
How do I
level.
get the horizontal with the bubble sextant?
With a level, because it's
Right.
level.
Okay,
No,
good.
the level
Yeah.
lines it vertically.
Level is just 190 degrees opposed from vertical. No horizon needed. See?
Yeah,
You're starting to get it. You're starting to get it now, aren't you?
The bubble sextant establishes a theoretical horizontal, a theoretical surface for you to measure your angles of elevation from.
No, when you set it level, it's actually pointing up. It's not pointing to the horizon.
What's not pointing to the horizon?
The side of the bubble sextant. When you
Yeah,
when you
yeah,
put at 0 degrees and you make it level, it's pointing up. It's not pointing to the horizon. You measure from up.
I
from
know
zenith.
because you already have of course it's not pointing at the horizon. That's the whole point of the spirit level.
And
My
the
God.
dip
Seriously,
angle.
Globus, come on, man. There's no dip angle. There's no horizon. All we have is vertical. We have a deviation from vertical, and that deviation from vertical times 60 tells you how far you are away from the GP. It's that simple. It really is. That sentence encompasses everything you need to know, and you're fighting it like it's the plague.
Well, what you're fighting is the fact that you have no elevation angles. They need to be measured
saying
from
that.
the surface.
Do you know how silly you sound when you say that?
You need a horizontal surface in
No,
order
you
to
don't.
acquire. Yes,
No,
you
you
do.
don't. You
Yes,
have the,
you do. Otherwise, you do
all
not
you
have
need
an
is
angular
vertical.
value.
All you need is vertical and a
No, you
variation
don't.
from vertical, and it's an angle.
How can you acquire an angle off just one line?
Because you have a line to the object in the sky. That's their angle.
Why do you require the horizontal to be physical, but the vertical line doesn't have to be physical, or the line to the celestial object?
I'm
Why
not
is there one
mentioning
line that suddenly has to be physical?
You have the
because
one
that's
line.
the
You have one
surface. That's
line
the surface
vertical.
that you're on.
You have one line vertical. Listen, you have one line
That is-
vertical.
hang on, let me answer, Mole Man. That's the surface that you are on. You are acquiring an angle of
No,
elevation
yeah,
to said
that's a
surface.
Nathanism.
That's why you cite the celestial
That's a
object.
Nathanism. Nope.
That's why you cite the celestial object and you bring it down to the horizon, because the horizon
No.
represents
Wrong
the
answer.
surface. The
No, it
horizon
does.
No, but
represents
the horizon.
yes, it
No, the
does.
horizon is irrelevant because you can be in an airplane at an altitude of fucking 10 kilometers, and you get the same angle using the bubble sextant.
Because
So
Or you can do the way I did.
because the bubble establishes a theoretical horizontal.
Wait, where's my horizontal then?
Why are you okay with a theoretical horizontal in this case, but not when you're at sea level?
You're not, because you're not on the surface when you're flying.
Yeah, so you
But
don't
that gives
use
the same
surface.
angle. No
Yeah.
surface required.
But it establishes a theoretical horizontal, a theoretical surface.
Which is not the surface. No, that's not the surface
Yeah,
of the
but
Earth, is it?
Well, it represents the surface, yes, 1 to 1.
Yeah, but so you don't need to do that in the surface, right? The surface is relevant.
Well, there's only if you are on the surface, you use a marine sextant. If you're not, you don't. But the level on the
Yeah, but not
bubble
even the marine sextants
the
give
level
you.
on the bubble sextant represents the ground 1 to 1.
If it does it, well, how can you get the same angle? How can you have you have two lines? You have an elevation angle, a line from, let's say there's a ship and an airplane, and they're both one at sea level and one at 10 kilometers in altitude. They are exactly at the same position. They have exactly the same angle to a star. So you have two parallel lines going to a star. How can that happen on a flat surface? That would mean that the star is in two positions at the same time.
I have no idea what you're saying.
That's the smartest thing you said all day.
But you have two lines.
For a second, I
agree
thought
that
you
get
were
the same-
referring to mailman.
You got the same angle to the celestial object using the bubble sextant and a marine sextant, correct?
Yeah, because you're getting that angle off horizontal.
Sure, okay. And those lines would be parallel, correct?
Yeah.
Okay. So you have two parallel lines pointing to a single object on a flat surface.
Two paralyzed point. Yes, I'm losing you.
Well,
Does
Well,
anybody else
let's say
know
you
what
have-
I'm saying?
the airplane is a lot higher than the person on the surface, and they're both measuring, pointing to the same object, and that is forming parallel lines. So either the star is like almost infinitely far, or I don't know else how else you can get it.
Yeah, if you have two straight lines that are 10 kilometers away from each other but are parallel and pointing to a single object, how does that work?
So you understand that you're using these horizontal lines to acquire the elevation angle, yeah?
Mm-hmm. Which is the same for both the person on the surface and on
And
the
these
airplane, right?
horizontal lines represent the surface, yeah?
No, they do not.
Even if
represent
we grant you
they
that,
do not represent the
that's
surface
a red
of the-
herring. But that's just a red herring.
How
Let's
can-
just
How is it a
accept that
red
for.
herring?
Yeah, but
Yes, because
the
that's
other
not the
ones
point.
My premise all along.
Because that's not the point of
also goes
mailman.
to my
Mailman's
problem.
making a point now. Mailman's making a point now.
Yeah.
And your answer has
Yeah,
nothing
you
to
have
do with
two
that point.
straight lines. Yeah, you have two straight lines, one from the surface and one from the airplane to a celestial object. Those lines have 10 kilometers of distance between those two. They are parallel. How do they point at a single point?
On one from
when they're parallel.
One from the airplane to the celestial body? No.
Yeah, you do. You have that to the bubble set. That's
Who
your
said that?
elevation angle.
Yeah, a person.
No, that's the
a person,
bubble sextant elevation angle.
Yeah, a person at the ground and a person at the airplane. They're both sighting the same star, and they're getting the same zenith angle, which means they're pointing towards the same direction.
Yeah.
Yeah, but
Which,
actually,
if those
no,
lines are
because
parallel.
the lines are parallel.
So the
Yeah.
angles would be different. Is
They
that what you're
can't be.
saying?
They should be.
Yeah,
The
if
Earth
the
is
star
flat.
is closed, if the star is closed, the angle should be different. If the angles are parallel, the star cannot be close.
Yeah.
So what if the stars are not close?
Then you'd see them from
And
every
everyone see
point
the
on
same
the Earth.
sky.
You know.
On the flat surface,
Yeah,
everyone
and
sees
we
the same
have
sky now.
1 degree per 69 miles. So it's
You can walk
it
as
can't
much
be
as you want on the
far away
surface. You
on
wouldn't see.
flat surface.
Sorry, Mailman.
Globus
The
is
angle-
he's almost getting
the
it. He's
angle
almost
to
there. I
Polaris-
feel it.
The angle to Polaris would not change 1 degree per 69 miles if the Earth is flat and it's infinitely far away. The angle would be the same because you get the same angle regardless of the elevation.
If you go 1 kilometer up, it doesn't change. You can go 1 kilometer backwards
so-
or forwards. It wouldn't change it also.
So are these angles not relative to the ground?
You stop talking about the ground.
Yeah, you'd like
No,
me to.
Yeah,
wouldn't you?
no, that
No, but
angle,
if we take
that horizontal is not relative to the ground. It does not represent 1-to-1, as you said, to the ground. Absolutely not. And we're
Should,
showing why it
should.
doesn't. Because if it did, we wouldn't
Like-
see the 1 degree for 60-mile relationship.
Like
Don't
I
you
said,
get it?
it should, because you're measuring these elevation angles with reference to the ground. That's
No,
the
you're
whole-
not. You're doing it
that's
with
the whole
reference to
point.
horizontal only.
That is the
And
whole
that
point.
horizontal is shown to be not parallel to the other horizontal.
That is
Because let me finish. We've shown, and Mailman did a real good job articulating that by saying if we are saying things the way they are, then those two horizontals will not be parallel and they'll be off of a round surface because we're seeing a 60 mile per degree relationship to distance. That can't happen on a flat surface. Otherwise, it
keep
would be
going to the
parallel.
60 mile per
Otherwise,
degree.
they would.
That's
Hold
not
on.
the point.
Otherwise,
That's
they
not
would be on the
that's
same
not the
plane,
point.
and they're not.
That's not the point. The point is that what is the whole reason of subtracting a dip angle if it's if the
We don't
angle
have a
of
dip angle. We're
elevation?
using a bubble sextant. There's no dip
Oh
angle.
my god! All right, let's stick with the marine sextant then. What is the whole
No,
point?
because you don't understand how refraction and dip angle work.
As mentioned previously, the refraction has nothing to do with the dip angle.
It does.
You may think it does,
Yeah,
but it
yeah,
doesn't.
yeah, it does actually. It does.
You may think it does, but it doesn't.
You want me to give you the
Provided
manual
the
to the
citation.
sextant? I'll give you the manual to the sextant. Okay, how about that?
So why do you subtract that from the observed angle? If it's got if that observed angle has nothing to do with the surface.
What do you mean?
I mean what I said.
I didn't get what you said.
So why do you subtract the dip angle if that it's got nothing to do with the why do you subtract the dip angle from the observed angle if that has nothing to do with measuring an angle of elevation from the surface?
Because the horizon drops from eye level, which doesn't make a horizontal line.
In your paradigm.
No. If it drops from eye level, it's not a horizontal line, right?
In your paradigm, it drops from
No.
from eye level. Yeah,
Oh, so you
yeah.
think it's at eye level?
It's quite clearly at eye level when you're
Oh, so if it's at eye level, that's a horizontal line, isn't it?
Well, due to perspective, it wouldn't be, no.
It's at eye level and it's not horizontal line.
Oh my God! You
Look,
just
I'll
get
show you.
rich
How
with
can
every
that be?
statement.
How can
Every
that be the
statement.
I'll
case?
show you. I'll show you
You
what
just
I mean.
shoot yourself in the foot right now.
No, I didn't. All right.
Okay, so if it's at eye level, right? Then
that
they're
that
both
there,
at the same.
what I've posted there is that's the dip correction.
Why does the black line just stop?
Wait. Is it just me or the dip correction points to the GP of the star? It makes the line that you observe goes to the GP of the star. Is that what you're trying to represent there?
Well, it would go to the horizon. That's probably not to scale.
Yeah, but is the horizon?
Why is the horizon at the GP?
Well, like I said, it's not to scale.
So it's not at the GP.
So it's just happenstance that it's at the GP. You don't mean that the dip correction is because of GP. There's
Oh,
nothing
is
to do
that
with
not
the GP.
is that not the dip correction? What I'm
No.
So that's not the height of eye correction above sea level.
That wouldn't make sense because you would be able to see the ground that is right after that line intersects the
One
ground.
at a time.
Yeah, if you extend
Why is the horizon?
the baseline further than where the red line intersects it, there's no reason why you shouldn't be able to see that extended line. So that makes no sense.
So you don't think that that is the dip correction angle?
Nope.
It's
No,
when it's quite clearly. Go
Sorry,
on.
why don't you see further? Why don't you see further than the red lines? If you look a bit higher, why is the horizon there?
Why is the horizon there?
Yeah.
Let me show you
That's
what a
as
dip
far as you
correction
can
is.
see.
So that's the simplified version of dip correction. Can you see that?
Right. So what is that straight line coming off the guy's head onto the ball there?
It's his line of sight.
And that's a straight line.
Yep, because that's a simplified version.
So
a
it's not a
simplified
refraction.
explanation.
So it's
Yeah,
not a
this
refraction.
one isn't. Yeah, this is a
So
geometrical
that one
explanation
isn't.
of depth.
Okay. So
Yeah,
that's
that's
not
a
a refraction.
geometrical explanation
Yeah,
of depth.
but if it actually represented your reality, wouldn't that be a curved line due to refraction?
Yeah, it would be slightly curved.
Okay,
For
so
the
you wouldn't.
purpose of this explanation,
Okay,
it's
okay,
straight.
hang on. Stop there. So you wouldn't actually be able to get an angle off that slightly curved line, would you?
Yeah, you would. It's just a little bit more complicated.
A little
But,
bit more complicated, although quite simply, an angle
yeah,
denotes two
it
straight
is
lines.
simple because the
It's
almanac
not-
already
yeah,
compiles
it's
that.
simple because angles require two straight lines, not a slightly
Are you
curved line
denying-
and a straight line.
No,
And
actually,
also,
the angle.
and also,
One second.
Also, is that line of sight? Is that a tangent to what? To the geometric horizon?
In that picture, yes. Which is just
The geometric horizon.
Yeah, that picture is representing the geometric horizon. So that's not including
So
reflection.
now there is a geometric horizon that you can see with your line of sight.
In that picture, yes, which is not exactly what we do.
Well, you
It's
can
a
say
little
in
bit
that
different.
picture, but that's what you've presented.
Yeah, which is completely
is it-
different. One
Is that
second.
accurate or not? Is it accurate or not?
It's 100 times more accurate than the one you sent.
Is it accurate or not?
It's a lot more accurate than the one you sent.
Is it accurate or not?
What's the minimum level of accuracy for me to call it accurate?
Does it represent reality or not? Your reality.
How accurately does it have to represent reality for me to claim it's accurate?
Well, if you're trying to make a point here that this is reality, and this is what we do with selective navigation, it would have to represent it quite clearly.
You made a drawing saying that you draws
Don't
the
worry
foot.
about my drawing. Does your drawing represent reality or not?
Well, I'm giving you why I'm saying this. You sent a drawing showing a flat surface that you just draw yourself. I'm saying what's on the manual of the almanac that shows a spherical Earth and the dip being the line that goes to the horizon that is tangent to the surface.
Right, but
Right?
it doesn't comport with what
because it's not slightly curved.
then, does it?
Because it's not slightly curved due to refraction. I don't have a point anymore here. This is inaccurate just because it's not slightly curved due to refraction.
Well, you're drawing straight lines and you're getting dip angles when you quite
Okay,
clearly
so
mentioned, you quite clearly admitted that that's a curved line.
Yes. So let's say that is a curved line, right? And
So
that,
you
that
don't have
guy
an
is
angle
using. Okay, that guy is using an angle, a sextant, right? And he points to where he sees the horizon. What happens to the angle that he's measuring? What difference does it make?
But that's not the point of your drawing. You were trying to correct my dip correction. And
Yes,
quite
that is a
clearly-
correction for yours. You can correct mine,
All right,
adding
okay,
reflection.
cool. Okay, cool. But you've got two straight lines there when you said that the one would be curved.
Yeah, and you
Plus-
got a straight line.
Not to mention the fact that you're drawing a straight line to the geometric horizon that, according to you guys, we never see.
Yeah, I
None of
already
your lines
I
are
granted
straight
you that.
focus
I
either.
granted you that. But the thing is, you send us a flat surface, right?
What is that?
That
Hang
you
on.
draw yourself.
Mailman
That is
says, now I
completely off.
deny refraction. When have I denied refraction? And how
Did
did
I say you
deny
denied
when you
refraction?
said when you said that the red line is a straight line, then it can't refract. It's impossible. If it's a straight line, it doesn't refract. So you denied refraction.
Hang on. Your mate, he has also drawn a straight line. So does he deny refraction?
Sure. So
I didn't draw it. That's the picture
he
from
didn't
the
draw a straight line.
manual.
And he said,
Whether
he
you
said
drew it or not, it's your evidence.
but
Yep,
what
that's
my
come
friend
from
does is irrelevant to you denying refraction. Is the line of sight to the horizon straight? Is there refraction?
According to Bacon's picture, there's no refraction. He's drawing a straight line.
No,
Where's the refraction?
according to your picture. I didn't ask about Bacon's picture. I asked about your picture.
Of course,
Can
you
talk
don't want
about
to
your
ask about Bacon's picture because you
because
don't
I
want to.
asked you.
You don't want to scrutinize anyone else's evidence besides mine.
No,
but you're
I
okay.
can scrutinize Bacon's evidence.
Okay.
Bacon's
You're okay
graph
with Bacon
doesn't
I was
drawing
answering
straight
about-
lines. You're
we
okay
were
with
answering-
Bacon drawing straight lines that aren't refracted to an
How about-
unrefracted horizon.
We
How
were
about you stop
answering.
pivoting? How about you stop
Yeah.
pivoting, Globus?
We were answering about mine so far. Now he's making a question about yours. So Do you acknowledge refraction?
Right. Yeah.
Do what now?
Do you acknowledge refraction?
Yes.
So why is your
Would that-
red
would
line
that-
straight?
would that, yeah, would it bend the line from
Because
the
lines of
observer to the
sight are
horizon?
straight. They don't bend.
So no refraction then.
Oh, so no
Then there
refraction.
can't be no refraction.
Not at all.
Yeah.
You
denied
defined
refraction.
earlier that line of sight is the path of light. You said yourself. That's the only way to define it.
Straight lines. When you're sighting the horizon, you're looking straight at the horizon. You're the guy.
So
you're
no
the ones that
refraction.
say. You are the ones that say that it's bending.
So no, what you said you acknowledge refraction.
Can I
Now you
interrupt
don't
for a
anymore.
second? Can I interrupt, please?
Feel
I'll
free.
be super quick and concise. Yeah. So they used to say boats go over the horizon, and now they say when we measure the distance to the horizon, well, it's just a product of refraction. So you guys don't have a globe edge. Thanks for playing. Better luck next
No one's
time. Good game,
measuring
guys.
distance to the horizon.
Either way,
No one's measuring
Globus,
distance
the
to the horizon.
problem, Globus, is that in one sentence you will say that when you're sighting the horizon, in your example, you are looking at a completely straight line. But then we ask you, does refraction exist? Does the light bend? Yes. You say yes to that. Well, doesn't that
No, I
instantly
don't.
imply?
No, you got that wrong. That's what
okay.
you guys say.
So you
So
don't
do you-
acknowledge refraction.
Hang on. This is what you guys say, and then you show me a picture where you have no curved lines. So I'm holding your feet to the fire with your. This is what you guys say. This isn't.
I haven't presented anything. I'm asking you. You say in one sentence that would your line of sight is straight, and then the next sentence that refraction is real. How do you hold both of these without them being contradictory?
Because your line of sight has nothing to do with refraction.
How come? Is it not light just as any other refraction?
To make everything clear, earlier he said that the only way to define the line of sight is the path of light, which, when you have refraction, is being bent.
You're the ones that say it's being bent.
But no, hold on, Globus.
No. If you acknowledge refraction,
hang on.
you're saying
Why did you post that picture then? If it's not representing a refracted line of sight,
You're pivoting again. I'm trying to ask you how you hold these two sentences or these two statements as correct. That one, the line of sight is completely straight, and two, refraction exists.
This is your claim is the fact that you can see over horizons. You can see over. You have curved lines of sight.
This is pivoting again. I'm not asking about what I'm asking.
I'm not pivoting.
asking what I would say. I'm
I am
asking
not pivoting. I am not pivoting. Bacon showed me a picture with a straight line of sight when in his paradigm there's no such thing.
Yeah, but we're not asking about his paradigm. I'm asking about yours. Stop pivoting to his paradigm. I'm talking about yours.
He applied a correction to my drawing, and you don't want to hold him to any scrutiny?
If you want me to hold him to scrutiny, I can. If
You won't, though. You won't.
if you
Otherwise you would have.
address
You were on
address the
mute
point
until
I'm
then.
bringing up, but you're constantly pivoting to his example. I'm asking you about yours. How do you hold these two statements as correct? Both refraction being true and that the line of sight is completely straight.
Your line of sight is completely straight. It's got nothing to do with refraction.
So what? So if it's what is refraction then? Is it not the bending of light?
Everything's subjective. There you go. Done.
Please look up Snell's law if you don't know what refraction is. Right? It's when the light hits the boundary between two media at a certain angle. It causes it to change angles.
So
when people say slow down.
Two mediums. Exactly right. Yeah, two
media.
mediums.
Okay, so no refraction going on. So for you, there's no refraction going on because the medium isn't changing, right?
Well, according to you guys, there's refraction. When we look at the black swan, it's refraction.
I'm asking according to you. If you accept there's refraction, or because if you say, well, there's no changing medium, so are you saying that therefore there's no refraction?
Well, there's quite clearly we're not looking through two media, are we? We're looking through one media.
It's just pure dishonesty.
Okay.
Yeah,
So
you're just,
here's the thing,
just
right?
pretending you didn't say you
That
said.
doesn't just to pass someone's argument as dishonesty doesn't mean anything, Mole Man. You're better than that.
Well,
But first,
you
Well,
said
addressing
you
Andrew
said that
face is not
hold
being.
on. I want to answer. I want to answer. You said that
Yes, sure.
refraction requires 2 medium, right?
Yeah, in order to get a great deal of change, yeah, 2 media.
Okay. Do we have those in the atmosphere?
No, we just got
No.
gas. Sorry.
It's just
Okay,
gas.
so no refraction then. So you do deny refraction then.
No one's denying
So-
refraction.
No, okay.
You absolute fool.
Let me ask
I'm not
this.
saying
Globus.
refraction doesn't exist.
Globus,
I'm not
do
saying
you
refraction doesn't exist, right? I'm saying the amount of refraction is going to be negligible in one media.
okay? So do
Medium,
you not
excuse me.
agree? Do you not agree that let's talk about simply air? Okay, so the same whatever we have in the air. Do you not agree that the refractive properties of hot air is different than cold air? So they're both air, it's the same medium, but if you change the temperature, you get a different refractive
Yeah,
property.
I agree. I agree. You get the little heat waves, right? When a helicopter takes off. Good night, bud. Right, but those heat waves don't cause the sun to set and rise again, do they?
Okay, so you're saying
They
that there
cause
is
things to.
so
Sorry,
there
I
is
asked you a
still
question.
no, yeah, yeah,
Does the heat waves from a helicopter taking off cause the sun to set and rise?
no,
Okay, would heat waves cause a what do you call it? An oil rig, an oil platform to sink or rise above the platform?
no.
Probably not. It might cause it to wave a little bit, right? Like atmospheric turbulence
Okay,
would cause it to wave,
fine.
Can we
heat
go?
waves. Okay,
Okay, so
but I
We're not
wouldn't.
talking
I
heat
wouldn't
waves
really
is
cause
only
it.
one part.
I wouldn't
so
call it refraction. Though.
Okay, well, for example, heat waves is only one part. If you drive on a road on a hot day, you can see the sky seemingly refracted on the road as if there's a puddle of water up ahead. But when you arrive there is no puddle of water. That is also refraction due to heat differences. And that's seeing the sky on the ground. That's a huge difference. That's not just
Right,
heat
but does
waves.
it cause you to see the car on the other side of the hill? No, it doesn't.
Hank, Snell's law isn't supposed to be the definition of refraction. It's one way you can treat it when you have boundaries. When you don't have boundaries, there's other ways to do it. It doesn't mean there's no refraction
I just
if you
asked
don't
a
have a boundary.
question. Does this refraction cause you to see cars on the other side of the hill?
Yes. There's also
It can, yeah.
It does.
There's also
And
different.
It does.
It does. Yeah.
Before we
Really?
go off into the
Also,
weeds, if I may,
See, guys, here's the thing. I live in Texas
hold
where
on.
there's lots of heat, right? And I've driven 1,000,000 miles. I've delivered pizza for 20 years.
I
I've
know, but
never seen
I
a
was
car on the
in the
other
middle of
side of the
responding
hill.
to you, man.
Go ahead.
Yeah, I was saying, yeah. So there's differential Snell's law, first of all, and I was saying yes, you can see cars over the hill, and the way that you can know this, you can substantiate this, is by the fact that you can refraction certainly causes you to see objects obstructed by objects that they're not actually obstructed by, and you can see them around objects that they are obstructed by. You can do this in
Show me.
everyday experiences, but
Show me a car on the other side of the hill.
I'd like to bring the subject of our conversation back where it was, which was celestial navigation, if you guys don't mind.
And by the way, Hank, I'm sorry I didn't mean to take away from what you were saying. I just wanted to finish what I was saying.
what I would like is for Gummy Bear to scrutinize Bacon's picture just like he scrutinized mine.
I think you got a great picture.
Yeah, go on, Gummy Bear. Go on, Gummy Bear. Scrutinize mine.
I think Globus has a great picture, man.
Okay.
Can you tell
I
what's
just want
wrong with
somebody to show
mine?
me a car that's on the other side of the hill because I've seen lots of mirages due to heat on the road. I've never seen a car that wasn't in
Why
front
would
of
you
me.
expect that to be there?
Well, because you guys are saying that the old platforms are actually behind the hill at 1.2 miles, and that we're actually seeing the light bend down around the hill. I've never seen that in my life.
You have to understand that the extreme cases of refraction where buildings can be, brought up beyond the horizon, it's not just because refraction is some strong thing. It's because the amount of refraction that exists and the amount of atmosphere you're looking through is not going to be there when you're looking at a road in front of you in a car. There's much more atmosphere and there's much more gradients and all that stuff. But I don't want to take Bacon. I just walked in, so Bacon wants to take.
So, Gummy Bear, Can you have a look at Bacon's
Yep.
picture, please?
So Bacon's picture. Of course, I'm gonna assume it's not to scale because that's. But
That's not in contention. We know that.
okay, yeah. So the only thing that I see wrong with his picture is that okay, fine, we have straight lines. Bacon, why do you not have curved lines?
Oh, because when I sent this picture, I said that that was a simplified version of the dip. The actual version will have curved lines because of the refraction. That's what I said right when I sent the picture, and that's
So-
also backed up by the citation sent previously. So that's the reason.
the picture, the figure is a simplification to show the idea, but when you do the actual calculation, you take into effect refraction.
Mm-hmm.
Hey, you guys.
So there,
Right.
it doesn't sound like he has anything wrong
Hang on,
with what
hang
he
on.
said.
No. Of course, I knew you were going to be very light with it. The fact is that he has straight lines here, and he has quite clearly demarked a dip angle. So in the non-simplified version, he would have curved lines, and he would still have an angle somewhere, a dip
Yeah.
angle.
Do you not get that you can have angles to curved lines?
Oh, see, there's where the ridicularity starts to rear its
Okay.
ugly head.
So are you no, hold on, baby steps, yeah.
Guys,
Do you not agree? So when we talk about geometry, wouldn't you say that we would usually go back to the big guy, Euclid?
Right.
Okay. Do you get that Euclid defines angles against curved lines?
No.
Okay. So that's where you're wrong, because Euclid does define angles towards between curved lines.
Guys.
This dip angle is defined in Euclid's work.
Guys, I can give you 5,000
I
reasons
give many
why.
examples of angles curved lines. You can have that
So
reflection. You can have it normals.
You can have an angle with a curved line and a straight line. That's what you guys are saying.
Correct. That is
Okay, cool.
that is word by word from Euclid's
All
work.
right, if
Would
we're
you
gonna,
like?
no worries. Okay,
Would
so
you like for me? I could read out a specific definition word by
Before-
word from a
before you
specific
go
book,
there,
if that helps you.
I will allow you to do that, but before you go there, let's look at let's further analyze this picture. What does that P horizontal line represent?
It's a line that's tangent to the surface.
What does it represent?
It might be perpendicular to plumb.
Yeah, it represents the horizontal line tangent to the surface. What I just
Does
said.
it
That's what I
represent?
have.
Does it represent what would you guys would call the true horizon?
It represents tangent
No.
from the point where he's standing.
No.
No.
I don't know what a true horizon
Horizon's where the H is.
Well, that's the horizon that should be the actual horizon.
Oh, that's a horizontal line. That's on the horizon.
No, hold
Horizon's
on.
where the H is.
That would be so. P would only be the astronomical horizon of a zero height observer. It is not the true horizon. The true horizon would be the H.
Yeah, the horizon.
If the P line was instead raised to the height of the eye, that would be the astronomical horizon.
So the H wouldn't be the visible horizon.
It'd be the geometric horizon.
No, that's the true horizon.
All
right. I would call it the geometric horizon, but
yeah, I would also call it
this is a picture. This is a very simplified picture, so it doesn't matter what you call it, in my opinion. I think you guys are arguing about all the wrong things, though. I don't know why.
Okay, let's do baby steps, right? So let's say there's no atmosphere, so no refraction. So that would be accurate, right? On a globe, that would be accurate, correct, Globus?
What would be accurate?
The picture I sent on the globe that has no refraction. Would that be accurate?
I agree with Kosho.
You guys, there's an easy map around this, and you guys aren't taking it for some reason.
Enlightenment.
Go ahead. What's the easy path?
Well, first of all, because the thing, especially when it got to curved angles and stuff like that. First of all, it shouldn't have even gotten there because you're taking an angle from your horizontal or from your tangent. You're not taking it from the curvature of the earth. So but that doesn't matter. Let's say I'm wrong there. Okay. We don't need dip angles. We don't need to take that angle at all. You don't need to make this type of measurement. If this does not need to be where the argument gets stuck at, because you can just use a fucking bubble sextant.
He doesn't want to go there.
But it doesn't matter though, because the purpose of making a measurement with a sextant is to take the type of measurement you would be making with a bubble sextant. So this problem with the horizon is not a problem if you just use the because it's not the end all be all. That's the means to end. So why don't you get to that end some other way by using a bubble sextant so you don't have to worry about this
because
problem?
the bubble sextant would of course you don't need dip angles because it would be like you having your eye at sea level.
Which you don't.
Oh.
Which
No,
you
it
don't, of
wouldn't
course.
be.
That's why you need, when you're using a marine sextant, that's why you need to subtract that angle from the observed angle. Because every single table and every chart, every single almanac assumes that your eye is at sea level.
You don't have to worry about that.
No. When you're no, it uses the zenith angle. It doesn't.
Exactly, the angle
it
you
uses
use.
the elevation angle.
The elevation angle is not the zenith angle.
I know.
I agree, and that's not the one that it's used in celestial navigation. We don't use the elevation one. We use the zenith.
Only get the elevation angle so you can
Hang on,
obtain
how
the
can you
zenith
not
angle.
use the elevation angle in celestial navigation when that's the angle that you acquire with a sextant?
Yeah, so that you can get the zenith angle.
Yeah, you only use that just a mean of getting the zenith. If you get the zenith, that's completely disposable.
Bacon just said that you don't use an elevation angle in celestial navigation. That's ridiculous.
You don't use during the calculations. You only use that as a matter of getting the zenith angle, which is the one that we actually use.
You're right. In order to get your zenith angle, you need the angle of. So you can't say that you don't.
No, you can use a bubble sextant.
Right, but you're still getting an elevation angle from your bubble sextant.
No,
No,
you're getting
you
a
get
zenith angle.
angle. The bubble sextant gets the zenith angle directly.
Yeah, but technically, you could just agree with him that by extension, you're also getting elevation angle. But that's
not what you're measuring.
Yeah, that's not what you're
Every
measuring.
time you measure either, you get the other
Exactly,
because
right,
they're connected.
All right. Okay. Cool. But that's what's in the almanac. The almanac has the elevation angles.
No, that's where you're wrong. It uses
You never use an almanac, have you?
the almanac uses the zenith angle every time. It never uses the elevation angle.
Right, but they're both intrinsically linked.
Well,
they're linked, but they're not the same thing.
One is the complement of the other.
One is
the one
but
we
you can't
use.
get one without the other, right?
No, but the one we always use in the calculation is the zenith angle. Always.
If you obtain your plumb,
I think you might use the elevation for the refraction of the celestial body.
Yeah.
Yeah, but you don't have to take. Oh yeah, sure, but you don't have to worry about refraction if you're taking the observation in the right range, right?
Yeah, if you're taking above 30 degrees, that's
exactly. You shouldn't be taking below 30 degrees.
So you don't even need a bubble, like a bubble sextant. You can use the way I did. You can use a marine sextant against the reflection of the water. There's no horizon there. There's no horizon there. You're measuring twice the elevation angle. You just have that, and there you have it. Elevation angle without horizon.
It's actually not bad. I don't want to take away from regular sextants. Regular sextants are fine for the sake of what we're discussing. We're arguing about the shape of the Earth. We can move past the issues of elevation angles and what do you call that? The fucking dip angle, all that kind of stuff. Those are just means to get to the zenith angle, which you can get directly with a bubble sextant. So.
Yeah, that's exactly it. Anytime you use a sextant, no matter what sextant you use, your goal is to ultimately know the zenith angle.
And you guys know why we spent hours just talking about the angle, right? You know why the argument doesn't evolve from here.
Yeah. Because as soon as you have
next completely demolishes this idea of a flat surface.
Well, that's why I was trying to, and that's why I apologize to you guys. I didn't mean to disrupt whatever, but it's just you never get to a conclusion if you focus on these things that are never going to be.
I think that's the purpose.
The thing is, it's step one. The elevation angle is step one. That's what you get with the sextant. That is what you measure.
Step 2 requires a sphere.
You're right about that, Globus.
You can say it demolishes a flat surface, Bacon, but that's just an empty claim, really. At the end of it.
Oh yeah. Let's go further then. It's not going to be an empty claim if we all allow the argument to go from elevation angles to the next step, right?
But you can't get past that. That's the thing.
No, but
you won't allow it.
I agree with you, Globus.
I won't allow it because it's the crux of the whole argument.
No,
that
guys, you have no idea how to go from there.
Yeah, Globus, I made a sextant.
Prove me wrong, please.
Yeah, it's just a what's the old-fashioned sextant? It's not a sextant. The other thing.
Quadrant. Hadley's quadrant. Octant.
No, maybe no. So it's called something else, but whatever it's called, I just made it was like it's like an angle.
Astrolabe?
Yeah, sure, yeah. What I did was I got a hanging plumb bob, and I got this thing with precision angle, and all I do is I tilt my thing until it's pointed at the star, and then the angle is red where the plumb bob is. So but that angle tells me is the elevation. It's not the elevation. It's the zenith angle. And it's that zenith angle that you multiply by 60 nautical miles. You don't multiply elevation angle. You multiply the zenith angle by 60 nautical miles. So if you obtain the zenith angle through a simpler method, then you can. But there's no point arguing about the rest of it, right?
Yeah, but if you had to have a zenith angle, then by default you would need to have an elevation angle.
I think instead of saying you
may not need it, but that's the complement of said angle.
Yeah, you're right.
So it would be there whether you need it or not. It would be there. In reality, it would be there.
I agree with you. Yeah, but you're right. By extension, you also have that.
Which is. I know you guys are going to deny it again. But
I would like to hear Kosho finish speaking.
No, it's fine. He's making his point, so it's fine.
Okay, so let's do a side reduction, right? Let's do position fixing. So I'm gonna send on the live stream text.
So you want to move past elevation angles, yeah?
No, but the
Globus, please.
Globus, I think you understand what's being said about the zenith angle. If you have the zenith angle, you're right that you also have the elevation angle. If you have the elevation angle, you also have the zenith angle. However, the only angle you need to do this task is the zenith angle. The elevation angle is only a means to get the zenith angle, but you can't do it with the zenith angle.
Yeah, right. But why is it that every table and chart assumes your eye is at sea level?
Because they use sextants.
Is sea level not the surface of the Earth? Is it the surface or is it not?
It assumes you have the angle corrected, which just means you already subtracted dip. Doesn't mean you have your eye at the sea level. Just means you have the angle.
I know it
corrected.
doesn't mean that. Of course, it assumes that you've subtracted the dip because your eye isn't at sea level. But why is it that it assumes that your eye is at sea level? Is it not
assume your eye is at sea level? It assumes the angle is correct.
Yeah, every table and chart assumes that your eye is at sea level.
You're getting this wrong.
Yes, it does. You can say it doesn't, but they do.
Can you back it up?
How does it assume that your eye is at sea level when you can use the almanac using a bubble system?
I'll provide a video from an actual navigator, not just some armchair navigators on Discord.
Do you know that you can get the elevator?
Myself included. I include myself as an armchair navigator.
But you know you can
really?
You can get the right ascension and the declination from 100 miles up in the air. You know that, right?
Let's see.
Can you since you're a navigator, right? Can you tell me what's the location of those sites that I sent on live stream on text?
You don't listen. He said armchair navigator.
Yeah,
what is wrong?
he's excited.
Can someone kind of summarize what does this overcomplication do for us? What does it do?
It keeps them spinning in the
I think it does like what Globus said about the we can't get past of the angle.
Exactly.
That would be like me asking why do things fall on a flat Earth and you have to accept gravity in order for us to continue to talk about why things fall.
I wouldn't even say that. I would say, and I'm not calling Globus dishonest because he's actually an intelligent dude. But I think
it feels like
this thwarts the conversation, and I think that's the only thing. That's the only purpose this has. It's just thwarting it.
That's why it's like when you go to Nathan's and you ask how do you use a sextant on a flat Earth, they say, well, can you get an elevation angle? Do you need a flat baseline? You say, well, for the sake of the argument, let's agree. And they say, welcome to flat Earth. Go on mute. It's kind of like that. Like we can't get past the angle.
Don't worry about Nathan's moment. Don't worry about it.
Yeah, it's
No,
just like when the globals
so
used
can
to say,
we?
jump
So we
off a
can.
bridge and prove
So
gravity.
we can get a angle on a from a vertical. Would you agree? Vertical is a straight line, right?
Yeah, vertical is a straight line, but you guys say that.
Okay. So we can get a zenith angle then.
You guys say that horizontal is perpendicular to plane, and I've shown that with quite simple graphics how it's not perpendicular.
Yeah, but that's not
Oh,
an
it's not?
issue in this conversation.
But
That's
it
that's
is.
the problem.
Yeah.
You can say, but it is.
Yeah,
But
you need but there's two straight lines, vertical and the view to the celestial object. We get the angle, the zenith angle. Now we can continue with the angle to actually figuring out where we are.
the two straight lines that I was just talking about were how you guys say that horizontal is perpendicular to plumb.
Yeah, but
You
that's
ha-
not. But that's
Yeah,
not.
but
That,
that's
we can
just
argue about that. We
definitional.
can disagree
Not a
about it.
physical horizontal.
But it's not involved.
It's not a
in
physical horizontal. Oh, right, because you don't have a physical horizontal. I know you have a curve. I get that.
Yeah, but now you also debunk, like if I use a bubble sextant on the surface of, let's say, Finland, then I debunk topography because it has to be flat, so there can't be topography. Like, I don't see your point with the horizontal
The
thing.
only reason you ever use a bubble sextant is when you can't sight the horizon. If you want to use it,
So
if you want to
I'm
use
flying
a
for
sextant
flat.
over topography, then that just makes you an idiot.
No, dude, I did.
No, but I'm using a bubble sextant. I'm using a bubble sextant on the surface of Earth where there's land. Now, is the land flat because I can use a sextant over the land?
No.
Okay,
Who
so
said that?
I don't need a flat horizontal baseline. Then I don't need a flat horizontal baseline. All I need is vertical because of
With
the
a
bubble
marine
sextant.
sextant, you do because you're sighting the
Yeah,
horizon.
but with a bubble
Guys,
sextant,
this
I
is
don't.
Right, with a bubble sextant, you don't because you're
Yeah,
not
it's
sighting the horizon.
Okay, so I can get an angle using the bubble
You're
sextant.
over topography.
Guys,
Yeah, then I can just use vertical to get the zenith angle. I don't need the surface.
Just stick with that, dude, because there should be no confusion there. Like if you take the angle from vertical to where the star is, that's the only angle you need. There's nothing you could be on any shape, anything to do that, and that's all you need. There's no other angular measurement you need to take, and you can move on to the rest of the celestial navigation.
Right, but with the bubble sextant, it already establishes your horizontal baseline for you.
That's irrelevant to you. That's not even. You don't even need to acknowledge that. Like, you don't even need to know where that. You don't have to look in that direction ever. There's no point in knowing that. It's just a thing that's true. Yeah, it's
But
true.
you wouldn't have an elevation angle or a zenith angle if you don't have that.
No, that's not
you
true.
have the zenith angle.
No.
You may have it, but yeah, in order to have the zenith angle, as Kosho conceded to earlier, you would have by default an elevation angle. It would be there.
No, but if I'm let's say I'm in the Alps and I use a bubble sextant to get the zenith angle, do I then say how can I get the elevation angle when there's mountains around? Is it there? I mean, what do you mean with that?
All right, you may not need it, but it would be there whether you like it or not.
Yes, that's fine.
And it would be an actual angle.
Let's acknowledge that. That's true.
Measured off a horizontal surface.
Yeah,
it would
but it
be
doesn't
that whether
care.
you
It
like
doesn't
it or
care.
not.
Okay,
No,
that's
it's
true.
not a horizontal surface. I'm between mountains.
I know that, but the bubble would establish a theoretical flat surface,
Fine.
whether you like that or not.
It doesn't exist, so it's a theoretical surface, not the physical surface. So it's irrelevant.
Right, okay, but that's why we talk about marine sextants. That's why we
just give them the irrelevant things, man.
Like you're scared about the bubble sextant.
It's a practical surface.
Of course, that would allow the conversation to continue.
Look, I'm going to post. I don't know the exact timestamp, but somewhere within that video, this guy that I trust to be an actual navigator.
He's legit.
Yeah, you know the guy, right?
Yeah,
he actually mentions that verbatim. He says that every table and chart assumes that your eye is at sea level. So you can contest that with me if you like, but this guy that's not an armchair navigator like I'm sure most of you guys are, myself included, actually coincides with my premise.
But that's because he's talking about using a sextant, man.
Yeah, except when he draws the Earth. I don't think that coincides with your premise very well. Every time he's drawing the Earth,
of course you're going to go to that, but that's got nothing to do with the point I just made. Another red herring.
But this is what this is what I don't understand is why you guys keep going back to.
Well, I knew he was gonna. I knew he was gonna harp on that. Oh, he draws the Earth to be a globe, therefore, that debunks your whole premise,
No,
which is not my premise.
That's not what I'm saying. But you're relying on this what is guy as an authority because he's saying that you're measuring from.
Well,
He also likes to have sex with men. That doesn't mean
One second.
Right.
Wait.
This is the same reasoning I had when I put a post of the Coriolis effect and within said post, even though I was trying to zeroing on the definition, somebody said, "Oh, but within said post, they say the Earth is a globe, therefore, you're wrong." It's like, no, stick with my premise,
Sure.
which is
I
All
can
right,
accept
sure
that
now.
makes sense because the lower you are, the smaller the deep angle you are. So if you get your eye at the surface, the deep angle would be 0. So
I know.
that would be pretty much the same as correcting for the dip.
Why don't we? He's teaching you how to use a sextant, in which case you would correct for the dip angle. But why don't we just really why don't we realize what we're talking about and why we're talking about it? We're talking about celestial navigation for the purpose of determining if it works on either model. Okay, and so why don't we move past the stuff that is irrelevant? It's irrelevant to be talking about whether you can measure a sextant, an elevation angle with a sextant on a globe because of reasons. Because even if that were true, that you can't do that, let's just say, fine, we'll use a bubble sextant and we'll measure the same angles to do the same exact thing, and we'll move forward with it. Because it doesn't make sense that we're arguing about something that is we don't need to argue about. It's the same thing like GPS. It's like when I talk about using GPS to get precise positions, and then people want to start arguing about how GPS works, or is it really satellites? When they're admitting that it's giving you exact positions. It's like, yeah, we're not trying to argue about satellites. We're trying to move forward with the conversation.
You can't skip angles. I'm sorry, Kosha. I know you want to, and you'd like to go onto the map. Excuse me?
I know you don't want to.
We're not skipping angles. We're simply saying, no, hold on. We're not skipping angles. We're saying that since we can just get an angle with a bubble sextant right away from the zenith, we don't need to bother with the dip correction and the angle against the surface and horizontal and all of these things that you're complaining about. We simply just get the angle from the zenith right away using the bubble sextant.
You don't need to bother with them because they're already there.
Okay, so we don't have to bother with them. Let's go to the next
they're
step
already
now.
there. They're a default, but you can't negate the fact that they're there, and they don't comport with a curved Earth.
They do.
We can just ignore everything that's going on outside of the zenith angle. We have the zenith angle. We can do celestial navigation. We don't have to care about all the other things that you're trying to bring up as red herrings.
They're
We
by
have the
default,
zenith
whether you
angle.
like them or not.
Yeah,
They're
but
there by default,
whether they're
and
there or
represent
not,
the surface.
whether they're there or not doesn't mean that we have to go to them. That's the definition of a red herring. It's
I'm not
something
saying you
that's
have to go
there.
to them, but the fact
Yeah,
that
but
they're
talk
there,
about them.
the fact that they're there, completely contradict the fact that the Earth is a globe. They're there.
No.
The angles are there. There's no, in order to get these angles, you can't have a curved surface.
Oh,
I'm
but
sorry.
We have the
Globus,
azimuth at the zenith
can I
angle.
ask you a question, Globus? Can I ask you a
You
question?
sure can, Bandy.
Cool, right? So just say that this tool can only be used over using angles as you're describing them. Okay, then how are they then transcribing these things that are using straight lines and angles and stuff onto a curved map to work out locations?
They're doing it however they're doing it. That's not my forte.
Okay.
But the fact that they're doing it, that's where I have an issue, because they can't be using that data, those angular measurements, in order to do anything with it. Because in order
So what in that data do you think has been manipulated, right, to represent a globe and not a planar surface? Have you got any thoughts on that?
No, because I haven't really looked into that per se, because I don't think that's consequential to the argument. The fact is that they've used these angular measurements in order to then then put that put that together with their math and then get their supposed fix. But the fact is that they can't skip the first step, which is the angular measurements, the angles.
And I get that, or I'm on board with that, Globus, but they are drawing these tangents, they are acquiring these angles, and then with this information, with this data, it's then being transcribed onto a globe projection.
The thing is, sorry, carry on.
No, and they're working out locations, and so I'm because using sextants and celestial navigation, I've got absolutely no idea about it. I'm not going to claim to have any sort of idea about it, but I'm just interested if you've gone past that first step to see how things may be manipulated is all.
No, I haven't, and I'll happily admit that. But like you, just with one thing that you said, that they're drawing tangents and then getting these they don't do that when they acquire angles with a sextant. Nobody draws a tangent anywhere. All you do is you sight the celestial body, through the telescopic sight. You then bring it down to the horizon with the index arm, and then you measure the angle in arc minutes. And then you can derive your zenith angle and then go to your almanac, blah blah blah, and then have the time and all that good stuff. But that's my point. My point is that they're getting this angle when they, when in their paradigm they wouldn't have an angle off. I know they contest that it's not off the surface, but as you've heard for the past couple of hours, I contest that it is, purely based on the fact that I've heard navigators say that that the almanacs actually assume that your eye is at sea level, which would mean to me that the angle of elevation is measured off the off the surface of the Earth, which is where you're situated. So that's why you want to find your relative position too.
It just means you want the elevation angle, because if you have your eye above the surface, the horizon drops from eye level, and then you have to correct for that.
Yeah, right.
That's all it means. That's all it means.
I know, but that horizon, that when you sight the celestial body and you bring it down using the index arm, you bring it down to the horizon. That's because you're measuring the angle of elevation of said body to the surface, because the horizon represents the surface.
Yeah, but it's a specific point on the surface that is below a horizontal line.
What does that mean?
Yeah, the direction of the horizon is lower than the direction of a horizontal line. A horizontal line would be above the horizon.
No, that's in your globe paradigm.
Oh,
but I mean,
you don't think that's okay? Let me draw on paint here. Let's see if we.
Yeah, I've seen it. I've seen it drawn though. I've seen it drawn. You think the horizon is? You think the horizon is level? Sorry, you think the horizon is dropped below a horizontal when it's not?
Yeah, I'll share my screen and then you tell me what I'm wrong, right? Let's use a flat surface. Let's do the way you think, if the way I think is wrong. So that's a surface. That's you.
I've got more muscle than that, by the way.
That's an angle. That's a side of the star, right? So this line here is sighting the star, right? And then I'm also sighting the horizon that you think is at the eye level, or it's horizontal. Do you think this line is horizontal? The one sighting pointing to the horizon?
Yeah, I know what you're doing. That doesn't take into account perspective. We don't see things in orthographic view.
I'm asking if this line is horizontal.
Yeah, like I said, we don't see things in orthographic view. So the line is obviously horizontal.
Okay, and you're measuring this angle right here, right?
Right, but when if that line of sight, right, is actually is in reality, that line of sight would meet the horizon, right, at a certain point.
Yeah, which is if the same level as your eye, it wouldn't change, right?
But the horizon represents the surface. It's water.
Not asking that. I'm saying that if the horizon is at eye level, and your eye is at eye level, right? And this is a horizontal line, it would still be.
That doesn't take into account perspective.
How isn't it? Because what gives you perspective is exactly this triangulation we're doing here.
Right,
So
but-
as I raise something up, this angle here is the one perspective gives you. As I raise it down lower than eye level, perspective gives you this angle here. So
Hang on.
according to perspective, this angle here is 0.
It's actually more like hang on, my pick here, because quite clearly you're not taking into account. If you were to take into account perspective, it would be more like my picture.
Yeah.
It would be more like
Perspective
my
doesn't do
picture.
that. Perspective doesn't
Yes,
change
it
the path
does.
of light.
It
Perspective
does.
doesn't change the path of light.
I'm not saying
I
it
don't think
changes
you
the
know what
path. I'm not
perspective is
saying
then.
it changes the path of light, but it brings the horizon up to what your eye level would be.
Well, what is wrong about this picture here? So the red
How
line.
do you know those lines
Okay, so
are
your red line is
reality?
horizontal.
Yeah, it is. That's a line of sight. It
So
may
a
not look it. It
horizontal
may not.
line.
Okay.
So
It
a
may not
horizontal
look
line
like.
hits the ground.
Okay, it may not look like it in that but that's not how we see things. We don't view things in orthographic view.
It
My picture.
doesn't matter. The
Yes, of
orthographic
course
view.
it matters.
No. The orthographic view is what gives you the angles of perspective.
In
You cannot just
orthographic,
bend the
look,
line and say the perspective makes the line bend down.
orthographically, it does not. If you look at things in orthographic view, it doesn't represent perspective.
It does. That's how you know perspective.
No, it doesn't.
That's where the formulas.
How can it represent? Hang on, Bacon. How can it represent perspective when we don't view things orthographically?
Because that's
We
how you
don't.
get
We
the
don't see
angles
the
that
sides
perspective
of our
give
own
you.
heads when we look at things.
Yeah, but if you study perspective, you're gonna see things from a perspective orthographically for you to understand how the angles are affected by the distance.
Right, but when
So
you view things orthographically,
seeing
it
it
doesn't represent.
orthographically.
Look,
Yeah,
actually,
this is-
exactly. Look at what Geo just posted. Right, that's more like it actually.
No, that's not more like it.
It's absolutely more like it, and it's actually absolutely how it is. This
No.
is what I'm trying to represent with my picture. I know my picture doesn't do it justice, but yeah, the one
Okay,
below
say
it,
you
the
have
one
a-
on the bottom.
If
The one on the-
something, according to perspective, if something is at eye level, it's gonna stay at eye level. It's not gonna go left or right, up and down. It's gonna be at eye level. Doesn't matter how
Yeah,
far it goes.
right,
If
but
it
not all-
goes away horizontally, it doesn't drops. It doesn't go up. It keeps on the same position. I don't know where you're getting this from. That's not how perspective works.
So you disagree with the picture that Geo just posted?
Sure.
So that's not accurate.
No.
Yeah, no. That what Geo
Uh,
just posted is
have
way
you-
more accurate because the horizon
Um,
appears to rise to eye level, and it's just like the force seems to ramp up, and the
Yeah, but
ceiling
that's not
seems
how
to go
you
down
represent it
to
orthographically.
about eye level.
But that's not how you represent it bento. That's not how you represent it orthographically. The way you represent the horizon going up to eye level orthographically is that the further you go horizontally in that direction, right? That angle from the ground to the observer gets higher and higher until it approaches your horizontal line, right? So that's the representation. That's how perspective gives you the angle of the horizon. It doesn't just go down. You would have to go infinitely far for it to reach eye level, unlike Geo's picture, right? Because Geo's picture, the lines converge at a finite point. That has nothing to do with perspective.
It absolutely does. That's the whole point of a vanishing point.
Yeah.
That has, dude, you're so far off here.
And the horizon
Yeah,
does seem to
dude,
appear
okay.
at a finite point. That's what the horizon appears to do. It appears to be at a finite point.
Yeah, but this is described in a very specific way that is not being depicted correctly, neither for Geo's picture nor for Global's picture.
Well, how do you know that the lines of sight on your little picture there are straight?
That's not my claim. It has nothing to do
Yes,
with
it is.
whether or not they're straight. No,
Whole
it's not.
reason.
No. He's referring to perspective. Perspective assumes straight lines. I'm taking his claim.
Navigation.
I'm scrutinizing his claim that he thinks he has a line of sight that is perpendicular to the surface, is horizontal, it's eye level, and somehow it drops. There's nothing about perspective that can back this up.
Nothing's dropping.
Okay, so
nothing is dropping.
Are you measuring this angle or not?
It may look like that. Hang on. Let me just edit GA's picture.
What is perspective? What do you think perspective is?
What's armchair? Did you learn what armchair means yet?
Yeah, what is that?
Let's just see if you paid attention to one word. Just a simple spot check, if you will. What does armchair mean?
Is anyone saying so?
Amateur.
You, Bandit. Not for you, dude.
Sorry. I thought it was a pop quiz.
No, it could be an open book test. Let's see if he passes an open book test. Armchair means amateur. What does armchair mean? Just say the word amateur to prove that you've been paying attention at all.
It was just a quick little.
Can't do it.
I think he has you turned down.
Well, that's even more funny.
Have you got crit turned down by any chance, Bacon?
Yep.
There's your answer, crit.
Yeah, he doesn't listen to anything.
Boom. FE proven again.
Look, so in the picture that I edited quickly, what I added was that is the dip angle, your height of eye above the ground. That's the angle that you subtract
makes
from
zero
your.
sense. Tell me the formula for that. Tell me the formula for that.
Why would there need to be a formula for that?
Because perspective is pretty well defined.
Perspective has nothing to do with your height of eye correction. Sorry.
So where does this number come from?
Which number?
The dip correction.
It's an angular measure. Look, it's an angular measurement.
Yeah, where does it come from?
What do you mean? Where does it come from?
Yeah, it's just a random number. Where does it come from?
No, your height of eye has a direct value, which
becomes an angle,
which is an angular measurement that's subtracted
No.
from the observed
height
angle.
of your eye. The height of your eye is not an angular measurement. It's a distance. Your distance above.
Yeah, right. Which is converted to an angle, a dip angle.
Exactly. How do you get the angle from the height of eye? What's the calculation that you do?
I don't know the exact calculation, but why does that matter?
I'm pretty sure because that's what dip means. The value of dip, the value of the dip comes from what it means, right? And you're saying it means something else, and you can't point to how the numbers are, where the numbers are coming from.
I'm sure.
And no idea to validate what you're saying.
I'm not contesting the value. I'm contesting what it actually is, like how it's represented.
Yeah, which changes the value. So if it means something
else, why would
else,
it change the value?
Because it means something else.
How?
All right. If I have a sphere, right, and I'm in the dip is how much it drops from eye level. It's the
that's what you think it is, but it's not.
I'm trying to give a reasoning here. I'm not saying that that's the case. I'm not saying that's reality. I'm explaining myself. So if you're in a sphere and have a horizontal line, and you're aiming at the surface, right? There's a mathematical formula that will give you the angle, right? And that's pretty close to what you get from the almanac. The almanac is a little bit smaller, which you would expect from refraction because it looms things up. So it's actually a little bit of a smaller angle. But you can actually do the geometrical and still get pretty close.
The almanac has is a height correction, and then it converts that into an angle.
Yeah, that's what I'm telling you.
Yeah.
How
All right. So
then
then once you get, that's all you need. There's got nothing to do with the globe.
Do you hear what I just said?
It's a height above the surface.
Okay, so you're not allowing me to finish the point.
All right, go on.
That angle, you can calculate that angle based on the size of the Earth, and it's pretty close to what the almanac gives you. So for every distance on the table of height correction of the almanac, it has an angle for that distance. And if you run this formula I'm telling you, we're gonna get almost the same value. So this calculation comes directly from the thing I just described plus refraction. You can actually just add refraction to the formula and see that the values are going to match exactly what you find in the almanac, right? What you're saying that is the case gives me no way to find what the angle should be for my height. The only way to know that is to look at the almanac. But the almanac isn't a black box. It means something, right? So what does it mean? How do you get from the picture you're sending to the values on the almanac?
As I mentioned before, I don't know where in the formula, in your formula, is there an earth included? Where is there a radius value there somewhere?
Yeah.
All right, can you show that somehow?
Sure, let me pick it up. I think it's this one.
Oh, I thought you were going to actually post a reference, not just...
Oh, you asked the formula? It's pretty... Just from my description, you can get the same formula. Just from the description, you can get the same formula.
Well, is there a reference that you can post where this is actually stated somewhere?
Oh, I checked those values to the almanac, but I can try to find a reference for you if you want to.
Yeah, I'd like that, from someone that's actually...
Can you provide the same thing from your case?
That doesn't matter. You're making the positive claim that this formula somehow is used when it comes to dip correction. And
I said that that's the geometrical one. The dip correction actually includes refraction.
Yeah. Okay. Whatever it is, you're saying that this is somewhere within when they derived all the values on the almanac, they used this particular formula. So I would like to see that in a reference.
This particular formula because they account for refraction as well, which this formula doesn't.
Right. Well, can you include refraction in your formula then?
No, I'm not sure how to do that.
Oh, okay. So we just have to take your word on it, I suppose.
No, you can run the formula and see that the values are pretty close.
But you say that it includes refraction, so isn't that going to come?
That's backed up by my previous citation.
Right, which didn't include a formula or a refraction value.
Yeah, it was explaining.
And again,
the dip correction, and it was telling you that it does account for refraction.
Okay, where within that formula do I see a radius value?
It's right there, 6,371 times 10 to the power of 3 meters. That's the radius of the Earth right there.
Right. So, okay. Again, can you provide a reference for this, where this formula is actually included in a dip angle correction, including or excluding refraction?
Dip correction includes it's a different formula because it takes into account refraction.
I heard you.
Actually backed up by the reference I sent you before. Right. So
I know,
why are you asking this?
You're repeating yourself, but I want an actual citation for that. We're just gonna have to take your word on that, then, I suppose.
Or
he's
what?
off by
What do you want the
lot there.
citation for?
He's got the wrong radius too.
What do you want the citation
Don't let him
for?
squirm on that.
I want a citation saying that this formula is used with dip when it comes.
I already said this is not the formula you use. That's the formula.
All right. Well, okay. Then where can I find this where it says that they use any sort of formula?
In the citation sent you previously.
They say that they use a formula there.
Well, they say what they do to get the dip correction.
So they don't use a formula.
Geometrical considering refraction.
So there is no formula used within your citation. Just say yes. It's okay to be wrong. You seem to just want to one up me on everything, but
I'm trying to understand what you're asking when I'm answering you.
You know exactly what I'm asking. That's why you keep eluding my questions.
Stop for a second. You ask it if they don't use any formula. They don't say if they use or don't use any formula. They say what the dip is, right? If they're using a formula to get to the table, this is not being mentioned.
Well, this is your point. You say that there is a formula to arrive, to come to this dip correction.
You can use
that's your whole point.
From water business, if you include standard refraction, you get the same values of the almanac.
He's working with a different globe than what other people are. He's got his own model here, so it's just a belief system.
Yeah, I'm trying to understand how you think the dip can mean anything that will make any sense on a flat surface. Because
Maybe he's talking about a pair.
You stop trying to throw it back on us. Hang on. I want. Can you provide anywhere where it says that they use a formula to arrive to this dip calculation? If you can't, that's okay. Just say you don't. You just came up with it.
No, I didn't come up with it. What I said is that dip correction includes refraction, and it's based on Earth being a sphere, which is backed up. I already backed that up with citation as you asked it for.
All right, but then you
Now
came.
I'm
Then you came up with the formula all on your own.
Now I'm telling you how you can get close to their values just by assuming the Earth being the radius that we tell you it has. That's all I said, that you can get close to this value by assuming Earth to be a sphere. And now I want you, how can you ever get to anything close to what's on the dip correction table by assuming a flat Earth? Where would those values come from?
That's even if I'm kind enough to give you a radius value that you haven't measured. But again, and I'm going to continue harping on this, you haven't provided a citation that uses this formula. You just admit that you came up with it. Well, you provided a formula.
You asked it for. You asked it for the one I mentioned. The one I mentioned was the geometric one. This is the geometric one.
But so they don't use the formula. So your formula is just it's null and void.
No, it's what I said before. If you assume the Earth to be flat, and if you assume the Earth to be a sphere, and you just calculate without taking into account refraction, you already get very close to what's on the almanac. That's what I said. And then you ask for that formula. I gave you that formula.
But it's a formula you came up with.
Yes, because it's the geometrical one.
But I want to see someone, employing this formula somewhere. But you said they don't. So we have to just take your word that this is how they derived the dip correction from your formula that only you use.
They did by my formula. Stop misquoting me.
So
Stop
what's the point of
strawmanning what I'm
providing
saying.
your formula then? What is the point?
Again, I already answered that 3 times. The point of my formula is that you can get very close to the values of the dip correction in the almanac just by assuming the Earth to be a sphere. That's the point.
Does that mean the Earth is a sphere because your formula gets very close?
No, I'm not saying that.
All right, cool. So what the hell is the point of it then?
I'm showing you I have something. Do you have something? Because you're treating dip correction as a black box.
Can I
and
ask
you're just stating what this black box is doing.
I just go off the dip correction on the almanac, but according to you, they've used the globe Earth and a formula that includes the radius to come to that conclusion.
Yeah, Globus just said it. You answered my question. Thank you.
You can get the same values of the almanac just by using the radius of the Earth and standard refraction.
This is just going around in circles.
What's wrong with what I said?
Yeah, I mean, I watched the video and you just look up the dip correction, right?
Yes, we argue with that. The discussion right now is what the dip correction mean. Where does those values come from, right?
Yeah, well, and you think it comes from a globe, but you're the only proponent of that. And then when I ask you, all right, is there anyone else that says that formula, that dip okay, not the formula, because the dip correction is derived from a globe, and there isn't.
The citation I sent you.
That says that it comes from the globe.
Yes, you can just read it. It's right there.
How is the dip correction derived in the almanac thing?
I don't know. I know a way you can do it yourself, which is just apply standard refraction to radius of the Earth. That's going to give you the exact same values. I don't know if that's what they did, but I know if you do that, you're going to get the same thing.
Yeah, we should figure out how they derived it.
Yeah, that's a very fair thing to ask for. We can look it up.
Everything I've heard from actual navigators say that it's just, you know, it's the angle from your height of eye, which is like I showed in my picture. You just subtract that from the observed angle.
Yeah, but it clearly shows a spherical Earth as a representation of how the height of your eye gives you a dip angle. Doesn't it?
No, it doesn't.
Isn't that on the picture I sent you?
That doesn't mean they derived it like that. It could be derived from just sample data.
Sure,
That's probably
yeah,
how
you
I
could
would do it.
You could do that.
I would do it from sample data.
Right. You can definitely do it. I'm not disputing that.
And we already went through your little picture of that had all those straight lines and a globe on it, and we established that, you know, you have all these straight lines when you quite clearly invoke refraction, and you said that line would be slightly curved, which and if that's a fact, you wouldn't have a dip angle. You would not have a dip angle. But then you guys say,
Why
you can get a.
Why not?
You know,
Why
Euclid said that
why
you can
wouldn't
get an
you have
angle from a curve.
Why wouldn't you have a dip angle?
Because you don't have an angle with a straight line and a curved line. That's why.
Why not? Why not?
Because that contradicts the whole definition of what an angle is.
Not conventional. It's not a convention.
Let me explain you why. So just contemplate for a second that there's no refraction on the spherical Earth. So you can cite a straight line right to the horizon, and you have a straight line to the celestial body, right? What happens if you add refraction to that Earth? That's going to loom up the horizon. So what you're going to do with your sextant is that you're going to measure a slightly smaller angle, right? You can still measure an angle with your sextant, even though the light is curving before it reaches your sextant. That doesn't prevent you from pointing to two things using a sextant. The universe is not going to explode because you measured an angle.
We know this,
curved
but
light.
when you represent it, right? But when you represented it with no refraction, right?
Yeah, I said that. That's a simplification.
Okay, cool. Well, then represent it with refraction, and we'll see if those angles are actually angles.
It's in the other citation, the one I sent previously. That's representing it with refraction. So what's your problem? Why are you complaining about it still?
Because what citation? Can you repost it? I think that was a while back.
Can I get like a summary, Bacon? How does this prove round Earth?
So this doesn't prove round Earth. What comes after is a very strong evidence for the round Earth, but we cannot get past it because Globus knows what comes after.
He just doesn't want to get past step one, and he can't. You know, that's why we've been here for a couple of hours going at it, because
if you feel
he thinks, look, this is the crux. This is what it boils down to. They think that they can have angles with a straight line and a curved line. That's simple.
You most definitely can. If you
see what I mean,
what happens if you measure an angle to something that is being refracted? What happens if you measure an angle to something that is being refracted? What happens? Can you measure an angle? What happens to your sextant? Does it locks? It doesn't allow you? Does it becomes invisible? Does it explode?
No one's saying
are you
that.
measuring? What prevents you from measuring a fucking angle to something that is refracted?
Yeah, he's getting upset. Look, there's no need to swear.
Okay, so what prevents you from measuring an angle using a sextant pointing to something that is being refracted? What happens if you try?
The fact that you're not measuring an angle?
Yeah,
nothing prevents you from thinking nothing prevents you from thinking you're measuring an angle, but the sad fact is that you're not. You think you are, but you're not.
Like, if you read
in your paradigm, you're not. What you're actually doing when you're measuring this angle is that you're not realizing it, that you're actually measuring an angle between two straight lines.
That's
you then want to superimpose You then would
not a straight line.
you then would love to superimpose your glow belief and fantasize that you're actually measuring an angle between a curved line and a straight line, but that's not reality. You're not actually doing that, but you think you are.
How are you
I'm
going to
not- I'm
use
gonna
the
go with
Pythagorean theorem if you don't have 3 straight lines? How are you
We
going to
don't.
do that?
We don't use the Pythagorean theorem to get the distance to the GP. It's a simple multiplication. There is no Pythagorean theorem used. There would be if you were on a flat surface, but there isn't.
It's still not a straight line, though.
Why don't you use the Pythagorean theorem if you're on a flat surface and that's a straight line?
We have the tables, right?
So, so
So
you
do you
think
think the
it's-
tables match Pythagorean theorem?
No, I didn't say that.
Okay, so if they don't match Pythagorean theorem, then why don't you use Pythagorean theorem?
Because the tables are more accurate? What do you mean?
They're more accurate than Pythagorean theorem?
In this
What's the
case,
inaccuracy of
well,
Pythagorean theorem?
yes, in this case. What do you mean?
What's like Pythagorean theorem is pure geometry. There's no inaccuracy on geometry.
Okay, that's not relevant anymore.
Why not?
So how are you making this angle with a curved line?
Because I'm measuring the angle in which the line hits my eye or the sextant. Like if a car makes a curve and hits you, it hits you in a certain direction, regardless of the curve they made before hitting you, right?
Well, you're not really saying that what you do is you create an artificial horizon line. You create an artificial horizontal and then create the angle off of that.
I'm not sure what you're saying.
It's often referred to as the astronomical horizon, the horizontal reference point.
You don't measure to the astronomical one. You measure to the apparent one. You correct for deep to get the astronomical one, or just to the horizontal line.
But that's where you're getting your angle from. That's the right angle that you're using, is the horizontal coming off from the vertical that you basically have to kind of
Actually, no, use the angle that comes
assume
from
is
the
there.
vertical. Yeah, we use the angle that comes from the vertical. not
You
from the
basically
horizontal.
you put an invisible horizontal plane in order to make it all work.
No, you don't have to. You can measure directly from a vertical. Or you can do what I did. I measured against the reflection on the water. No horizon needed.
So just a quick question, Bacon. I'm going to post that. I know you're probably going to say yes, but I'm going to try anyway. I just posted there in the live stream. Do you think the one on disregard what it says below it? Do you think the one on the right is actually an angle?
Yeah, there's an angle between those lines.
Well, that's. All right, I'm done. I'm done here. I think, guys.
We're back to the very start of the conversation here, Clovis.
Yeah, there's no problem on a curved line having an angle to a straight line.
Okay.
That is exactly what a normal line is, and it's used in calculating a reflection to curved
Yeah, but
surfaces.
we're not able to do calculations when there's an
Yes,
angle involved with a curved line. You can't do a
You
calculation.
are. You're most definitely. You are completely. For example, if I give you a convex mirror, for example, convex mirror is a curved surface. If I tell you the angle of incidence, you can know exactly the angle of reflection, and that comes from the normal line, which is perpendicular
You
to that
don't.
surface.
I don't think you have any kind of guarantee for that kind of accuracy. Dealing
Hang on.
with this.
Did you
It's
just
not
say?
about accuracy.
Did you just invoke a surface normal? Where in my picture do you see a line that would represent a surface normal?
There's no representation of surface normal there.
Yeah, but you just said that's you can get angles off surface normals.
You can, sure.
All right, but in my picture there's no surface normal.
Okay.
So why did you mention that when you were going? You just said, "Oh, well, you can
Because
get
I
angles off
contradict-
surface normals," but in that picture there's no surface normal. So what are you getting an angle off?
So you ask what I mentioned that? I mentioned that because it contradicts your claim that you cannot have an angle to a curved line. If you can't, normal lines wouldn't exist.
Wow,
Would it?
you
But
guys! Wow, man. What?
If you have a straight line and a curved line, right, and what other things do you have to add, right, to that information to be able to get the angle.
What do you mean?
Well, you've only got a straight line and a curved line. That's all you've got. That's all you've got. So what things do you have to add to actually to be able to work out what that angle is?
That depends. Are you referring to a curved line that is coming from, let's say, a function, or is this like a physical object?
If you only had the information in that diagram that Globus just posted, right? The one on the left and the one on the right, right? The one on the right, what other information do you have to add to that diagram to be able to work out what the angle is?
I need to know the function of the curve. I can tell it by just looking at it.
So just with the curve and that straight line, you cannot work out the angle.
No, I don't
He
have the
wants an
curve.
equation.
I only have the curve visually, right? If I have the formula for that curve, so I can know exactly what that curve is, I can give you exactly that angle.
So you have to add more information to that second diagram, whereas
No,
the
that information
first
is the curve
diagram,
itself.
with the two straight lines,
Yeah,
that's
no,
all
no,
you
no, no,
need.
no.
That's all
No,
you need.
Benzo.
Yes.
Listen. The first diagram, I can see the line is straight, and there's only one way to describe the formula line like that. So I know exactly the formula that describes that line. The curved line, there are many curved lines that look similar, so I don't know exactly how the curve is. So I need the formula for the curve. I'm not asking for any extra thing. I'm asking for the curve itself.
You
Because
need
that
more
picture,
information. That's
no,
my
no, no, no.
point.
I'm asking the curve
Agent.
itself. Ben, so you're not listening. I'm asking for the curve. I'm not
Very
asking for anything
clearly.
extra.
Very
The
clearly,
thing,
I'm listening, right?
the,
Because
yeah,
with
the
two
thing,
straight lines, Bacon, right, you can work out the angle. And that's
because
it.
I
That's all.
have the
That's
angle.
all you need. That's all you need is those two straight lines. But if you only have one straight line and one curved line, you need more information
Actually, I
to be
don't.
able
Actually, I
to
don't.
drive.
I don't. I don't. If I have the curve, I know how to get the angle.
How
How do you
again does
know?
this show globe Earth?
It
Well,
doesn't. I'm trying to get past it to show how celestial navigation completely demolishes the idea of a flat surface.
okay, now let's take the two lines on the right side of Globus's picture there. How do you know that that curved one is the surface of the Earth and not the
I don't think that
direction,
is.
or how do you know that that is not the path of light that's reaching your eye and the other line is the surface of the Earth?
But that's not what's in contention. The contention is just the possibility of you having a curved line, an angle to a curved line. What you're
No,
asking is
the
completely
assumption here
separate.
is that the light is reaching your eye in a straight line.
No, that's a complete separate discussion.
No, that's what the whole thing is rooted in.
No,
That's
the
where
whole
this
thing
of
is whether
that's
you can
where
have
this
a.
discussion will go.
Okay, when you get there, you can have the question. But
No,
what's being in contention now is if you can have an angle to a curved surface, and geometrically you can. And just like Gummy Bear said previously, it's even defined in Euclid's book.
I have a
good.
question.
How do you know which line is curving? The angle at which the light is reaching your eye or the surface of the Earth? How
In
did you
Globus
decide which
diagram,
one? Yeah.
it's the surface of the Earth.
How did you decide that? And it's not
In his
the
diagram,
path. Right. How do you know which one is which?
he draw both. I'm saying that the right one, you have a curved surface and you have a straight line from the star to you.
Right. How do you know it's not a curved line from the star to you and the surface of Earth is the flat line? How do you know that?
I'm not making that claim.
How do you know that?
How do you know something that I'm not claiming? What do you mean?
No, that you
Am
need
I
these
claiming?
straight lines. You need these straight lines to the stars. How do you know that you
I'm not
have that?
claiming that. I'm not claiming that. Actually, I'm actually assuming the opposite. That they curve. Otherwise,
Okay.
we wouldn't correct for refraction, would we?
No, I'm not talking about that. I'm talking about from you all the way to the star.
Yeah, it passes through the atmosphere.
Yeah. How do you know? Well, from you to the star, there exists quote unquote space, right? Right. And how do you know that that path isn't curved?
I'm not claiming that.
Yes, you are.
I'm not claiming that. Why am I claiming that? When did I claim that?
Because you assume that the light is going in a straight line, you know,
Yeah,
after
that's
it.
true. Yeah, I assume that.
Yeah, that's what I'm talking about.
Okay, so that's my assumption. That's not my claim.
Right. Yeah. Yeah.
It's
How do you,
it's
like,
global
why do
theory
you
assumes
assume that? Why do you assume that?
Well, that's just the model we use. It's the assumption of the model we
Uh-huh.
use
Uh-huh.
to navigate.
I would assume that based on the fact that it doesn't change,
How do you know it doesn't change?
because it doesn't.
How do you know? Did you take a piece of string and stretch it all the way to the North Star?
No, but if I go below the North Star, it's just going around in a circle. It doesn't change.
So what? We're talking about the path that the light takes to your eye, all the way from the star.
Yeah, and it's consistent with the time of day, and it doesn't change.
Yeah, if you assume that that the surface that you're standing on is curved, and those
No, I
light
can.
rays are straight, yes, you will end up with a globe.
No,
But if you
this is
curve those
based on
lines,
measurements.
you could model it on a flat surface. It look
Okay,
exactly
let's say
fine.
that's the case. Let's say that's the
No, but
case. All right. So let's say
Polaris
that's
takes
the
a
case.
circle.
How do you find our position now? So I'm gonna send a set of star sites, as I send multiple times, with the time marks on them, so we can actually find our position using them. Right? What's the
You
next
would
step?
create a more complicated math, but you could do it theoretically, correct?
Okay, yeah. How would you do it on a flat surface?
I rest my case.
Do you know how to do it?
No, I'm not a
Okay.
mathematician.
Globus here claim he can, so let's give him the floor to do it, right? So Globus, I sent there. You seem to be very experienced with this, right? Should have no problem
What did
finding
I
the
claim?
position.
Armchair. He's
What did I
still
claim?
brain farting this.
Oh,
Sorry?
this. All right. Yeah.
Yeah, he's still he
Yeah.
doesn't know what
So what's the
armchair
next
yet
step?
means.
What's the next step, Globus?
Listen to words. This is the next step.
Globus. What's step 2?
Open book test. Can you pass an open book
Show
test?
me how to do celestial navigation, assuming a flat surface. Let's see how that
Amateur.
goes.
It means amateur.
Yeah, you don't understand my claim. If you're asking this again, you clearly don't understand my claim.
He's not even listening.
Well, you
to
said
your
you could do it.
I said I'd give it a
I wanna
go.
know how.
So what's the
But I
second
mean,
part?
I asked you, can you
What's
get
the second part of the argument?
I assume
Okay.
that these measurements in arc minutes and arc seconds are elevation. Have been derived from elevation angles, which I'm not sure how you got.
Okay, yeah.
So you're conceding that?
Right there. Yeah, elevation angles right there.
So you're conceding
Let's say,
that you don't know how you got them?
I'm conceding you a flat Earth. Right.
Welcome to flat Earth, then.
Okay, so now let's see how you. So teach me celestial navigation on flat Earth. That's what I'm begging you to. Anyone
back to armchair
to do it. So what's
Yeah,
the
I
next
guess,
step, Globus?
like I said, that is not my forte. I can definitely give it a go.
Yeah, let's see.
I'm not going to be able to do it on the spot.
All right. So tell me, what should I do then? What's the next step?
Well, you just go and you need a nautical almanac for
I
starters.
have one right.
Well, I mean, I just watched the video. It was pretty clear. There's 3 steps to it. What do you mean?
Yeah, let's see where the flat Earth come into play here.
Before we go there, I just a simple question. You don't have to answer it if you don't like. Just going back to my picture, the one with the 2 angles there. Well, one's an angle, one's not. The one on the right. What instrumentation would you use to measure that angle? I know for a fact the one on the left I could use a protractor and get that angle. But the one on the left, what would you use?
A protector.
A projector?
Yeah. I can align the projector with the part of the curve that touches the straight line, and then measure the angle from the straight line to the zero of the projector.
And that would give you an accurate angle, even though the bottom of the projector actually has a horizontal line for you to align that up with.
Yeah, as long as I could have the extension of the curve line, because it conveniently stops right at the intersection, which makes it a bit more difficult. But if I could see where the curve is from, because that line could just curve up instantly, could curve down. I don't have the continuation of it. If I had, it would be easier.
So you'd use a protractor for that, would you?
That would be my goal.
Okay. Okay. Cool.
Okay, so now can we continue from?
And that protractor would make a tangent at that point, wouldn't it?
Yeah, you would, because I cannot warp the projector.
So you have to actually add more information to
It's
it. You
actually
actually
not.
have to
It's
create.
not extra information.
Well,
There's
it
no
is,
other
because you
tangent.
have to create
points up.
something.
There's no other possible. There's no other possible tangent line there. There's
You're
only
not going
one
to be able
possible
to
tangent
measure
line.
that.
Sorry.
You're not going to be able to measure that. That must be derived through a calculation on the right.
Oh, you should say so. Doesn't prevent an angle from being there.
I'm just trying to show how you're just making this a lot harder than it needs to be.
Okay, so I accept there's no way you can. Yeah, I'll accept for now that there's no way you can then calculate and get an angle to a curved surface.
Bacon, give
And,
me a preview. What's the second part of your argument?
It's the trilateration part.
Did you say you'll accept that now, Bacon?
Yeah.
For the
After we spent freaking 3 hours on it, bro?
I don't agree with it. I accept it for the sake of the argument. So
Okay, so you're being dishonest. I knew it.
That's not being dishonest. Considering
You're not.
something for
Well,
the
you're
sake
not
of
accepting it at all, are you?
I'm accepting it. I'm not agreeing with it. But I
Well,
will
you
accept
just
it.
said you accept that you can't measure an angle off a curved line, but now you're not agreeing with it. What does it even mean?
It means that I'm accepting for the sake of the argument, so we can move on. Which apparently you still want.
The argument is the whole point.
No,
you
my
can't
argument
accept
is
something for the sake of argument.
When you
And the
say
argument
argument is
like it means nothing.
I don't understand all
this
this.
is the Nathan Oakley part where they say that welcome to flat Earth and no discussion further.
Yeah.
Mole man, welcome to Flat Earth.
I think I'll never
There
see
we
any
go.
flat Earth.
Why get your identity involved? Why get your identity so involved in this, Bacon?
Identity? What do you mean?
Because a bunch of people sent him some stuff.
What are you
and
talking
he's
about?
gotta bear
What do you mean my
faith
identity?
and allegiance.
So what exactly do you want Globus to do with these?
Find a
coordinates
position.
you have
Yeah, get a position, as he said he can.
He just doesn't want me to use 60 nautical miles per degree because that's apparently a globe.
No, feel free. Feel free. Use that.
Okay.
That doesn't work on a flat surface.
He's doing a MC tune on me.
Oh,
No.
okay.
Well, what's the problem with
No,
me
but
asking
if
you to do this thing you said you can do?
What if you
There's no
take
problem.
if you
He wants to
assume
be the
straight
first
lines?
globalist to turn it in and then collect the prize money.
So if you assume straight lines and you have the angle, then obviously it's not 1 degree per 69 miles because that's a linear function. So you can't have that on a flat surface.
Well, in order to have angles, we not only have to assume straight lines, we necessitate straight lines.
Yeah, sure. Vertical is straight line, so that's your zenith angle. And then no
you don't
linear
just
function.
get an angle off a vertical line, do you? You need two straight lines.
You do though.
It doesn't bother you.
You don't though.
It doesn't bother you.
Use a bubble
that-
sextant. So.
It doesn't
we
bother
went
what
through that,
what
Molman. Where
Leoman
were you?
just said. That a linear
Yeah, we went
function
through
does-
it, and you just said that you need to reify the horizontal line when we said that that was in the middle of the mountains.
I didn't
You said, yeah,
reify
there's a
anything.
straight line, horizontal,
I
straight
didn't
line.
reify.
Oh, okay.
I did not reify anything. You're using the incorrect terminology there.
Okay,
Especially
so the
when
horizontal.
I used
so the,
a very
so the
specific
horizontal line.
term. I used
Okay, so the
theoretical
horizontal
horizon.
line. Sure. So the horizontal line
I'm not going to
doesn't
put everyone
have to
through
be
this again. I'm
No,
really not.
okay, but you now agree. So now you agree that the horizontal line
No,
doesn't
I
have to
don't.
be vertical.
Don't tout a faux victory, Mole Man. You're better than this. I just
There
not
is no
gonna put
full
people-
victory. I'm just asking. Do
Well,
you
you just
agree
said,
that
well,
the
no, you
horizontal
agree.
line?
You agree this and that now, don't you? I
Yeah,
don't
yeah.
agree.
If you're saying,
No, I don't.
if you don't reify it, then the horizontal line doesn't have to be physical. Because it can be
But
theoretical.
we went through this, yeah, with the bubble. That's why I'm not going to do it. I'm seriously not going to do it again.
Sure, okay. Then we agree that you can use a bubble sextant and you don't need a physical horizontal. So, yeah, we can
Yeah,
move
we
on with
already agreed on that. But then I said that the horizontal represents the ground, the physical ground.
Oh, so it is then it is a physical horizontal, and you'll
It
be
represents it. The theoretical obviously isn't. It's not the ground, but it represents the ground because you're not sighting the horizon. I'm not seriously, guys. I'm sorry. I'm not going to do it again.
No, thank you, Globus. Thank you
Yeah,
for.
you're welcome. Just going around in
sure.
circles.
I mean, this is like me saying that if objects move up and down, there's gravity. So
All right, yeah,
we can
false
move forward, yeah.
equivocation. Carry on.
No, it isn't. No,
Yes, it is. It is.
I have a question I've been wanting to ask Globus the whole time. Could I ask it?
Sure.
Okay, I guess I was just curious. Okay, Globus, like what your thoughts are on this. If the Earth was a globe for a moment, just in terms of thinking of it that way, just imagining it to be that. And let's say the stars were, light years away and all the rest of it. So, the way that they describe. If that was the case, do you think that a sextant could be used to navigate upon the globe?
It does.
I didn't know who Globus is now.
Look, I think it could be a possibility, yes. But the fact is that when you're actually, you'd have to convert those elevation angles to something that would match a globular surface somehow. And I think that is what they do. So yeah, that's my answer, essentially.
That's a good
Also,
one.
can you do
They have to use it locally
the position
flat.
fixing now?
You got to take a globe and then make it flat.
Yeah,
It's 69 miles of flat area.
Yeah, well, you have to convert those measured angles somehow in order to fit the globe, which I'm sure it can be done. But the fact of the matter is that we can't really disagree on this objective
Is how it's
geometry.
done.
And what? Sorry,
The trilateration is being done on a globe.
the
It's
trilateration
clearly
being done on
done.
a globe,
Yeah, the trilateration is clearly done on a globe.
even though the line of position is a radius, which radiuses by definition cannot be curved.
In celestial navigation, it is used as a line over the surface.
But it's a straight line distance. It's not a
No,
an
in celestial navigation, it isn't.
but it's a radius. When you
radius
yeah, right.
on the surface of
Yeah.
a sphere.
When you plot it on a plotting sheet, it's a straight line. It's a radius. It's
a radius on the surface of a sphere.
Right, but then if you were to turn that on its side, then that would be an arc, not a radius.
That would still be the distance from the center to the line of the circle.
But it would be different to a
straight line through the Earth.
The chord distance would be different to an arc distance, right?
We don't use the chord. We use the surface over the distance over the surface.
Right, but when
actually, I use the chord line because I do use an Euclidean geometry and it does the same result. But yeah, you can usually it's just used in spherical geometry as the distance from the center.
I think so.
Okay, so if you know something some different way to do it, I beg you to show me.
But is your point that like we can't have a Earth with gravity because there are some mathematical concepts?
Gravity, really? You really want to go there, mole man?
No, I'm not saying that gravity exists. I'm saying, are you saying that it can't exist and a sphere can't exist because of mathematics?
Yikes! Again.
Well, I suppose gravity could exist, but I haven't seen anything that would tell me indicate that it does exist.
Sure. So if gravity existed and we lived on a sphere, could you use a sextant?
Yeah, a lot of ifs there though.
Yeah, but those ifs, would it be okay to use a sextant on that Earth? Could it be used?
I think that's the same sort of question that Geo asked me, and I already said yeah.
Yeah. So the issue isn't that you can't get the angle, because you clearly can. You said that if those things
Well,
were real,
you,
then you can get the angle.
you can't, but you can mathematically derive it somehow, which is what you guys do.
Well, it's not mathematics. It's just simple. I mean,
It's simple.
I
What?
don't know where the magic part is.
Well, it's quite evident when, like I said, angles by definition require two straight lines. Blah blah blah. So
Well, then,
yeah, but
because
again,
it's like, what if I put a camera on a large sphere and I just put an object somewhere? Can I get the angle from the surface to that object?
you put a camera on a large sphere, you get the angle to what?
Yeah, if I let's say I put a camera or a
On
string
top of his head.
on a
Put
large
the camera
sphere,
on top of his head.
and I put an object somewhere, and I pull the string
his
from
head.
the surface of the sphere to the object, can I get an angle between those two?
What is
top
you
of his
getting an
head.
angle between the string and
Yeah, between the let's say that it's a magnetic sphere, so I got vertical from magnetism. I can get an angle from that vertical to the object using the string. So it's
right,
vertical, it's a
right?
zenith
Would that
angle.
be right? Yeah, okay. Would that be an elevation angle? No.
Yeah, it would be a zenith angle.
Right, but not an elevation
Yeah.
angle, which is what
Sure.
you get with a sextant.
Sure, and I can get the elevation angle from the zenith angle on my
yeah.
big sphere, right? Sure.
But then
You can use
wouldn't
that.
be an elevation angle, because if it were to be an actual elevation angle, then the surface would actually have to be flat.
Okay, so you are saying that there is no angle. I mean, this is just weird to me. Like if I hang a ball from a ceiling with a string, you're saying that it can't be a sphere because of an angle.
No, I'm saying that you can't measure an angle off the surface.
But there is an angle.
There may be a zenith angle, but there's no angle of elevation.
Yeah, I wrote down like a simple reflection problem on the classic ones. So there's a convex mirror, a spherical mirror there, and there's a point source of light, or like a beam of laser, at the coordinate given, and it's hitting the sphere at another coordinate that is also given. Do you know how to get the angle that the laser is gonna reflect off the surface?
Was that aimed at me?
Yeah. Yes. Does that laser beam reaches the surface of that sphere at an angle?
Does it reach it at an angle with reference to what?
To the surface of the sphere.
So, all right. So where would that angle be?
That's
where
what
would
I'm
that?
asking you.
Oh well.
Okay, so let's do something else.
Where
Can you predict to me?
What lines are we using to create an angle?
I don't know. That's on you.
What do you mean it's on me?
Okay,
you know my
so
stance on what angles are.
Can you predict what's going to be the direction of the laser after it reaches the surface of a mirror sphere? Have any idea how to predict the direction of the laser beam? Or if that's too complicated, can you at least tell me if that's predictable?
I don't know.
We don't know.
No.
Okay,
You're asking like an esoteric example. Who gives a shit? Why don't you tell us if you're going to enlighten us?
Yes,
What are you
you
trying to
can
do?
just-
Fucking ask us? You're going to ask us something to show that we can't do something?
No,
Is that
that's
what
not
you're
the
doing?
purpose. That's actually an argument.
Seems like it is. Seems like you're
Okay,
playing
so you
around.
allow me to clarify. Don't assume
Seems
my
like you're
intention.
playing
right?
around, Bacon.
Can you
So
show us
you-
where the angle is, Bacon? Can you show us where the theta would be? If there is a theta there somewhere?
Yeah,
With a
first
blue
you need the
dot.
normal of the surface, right?
The blue dot is where the theta would be.
Which for that circle is clearly just 45 degrees because you have the same coordinates for the x and y.
So that's
So you-
so between the surface and the red line, that's 45 degrees.
No,
For
The
what's
normal
what,
vector
okay.
on the point of incidence is the 45 degrees.
Oh, so just where the blue dot, that's where the 45 degree is.
The normal starts there and it goes away from the surface at 45 degrees.
Oh, so you've got like a little straight line and then suddenly it goes to 45.
Yeah, it leaves the surface perpendicular to it, right? Which in this space is 45 degrees, right?
So you're measuring an
I'm
angle
not measuring.
from.
That's
So
the
you're
normal
not
vector.
measuring.
That's a normal
Is
line,
there
right?
What's all the obscurity? Is this obscure to anyone else besides me?
No,
Uh,
no, it is. He's trying to.
No. The claim, it was claimed a bunch of times that you don't have a curved, you don't have an angle to a curved surface, right?
And this
And there's
doesn't.
something called the law of reflection that states how reflection works, and it tells you that the angle of incidence is the same of the angle of reflection, and that
Yeah, and
angle
I agree with that.
is taken. Sorry.
The angle of incidence and the reflection angle.
Yep. Let me.
Can you zoom in and show that in that?
Sure.
What he does is he brain farts. Which
That's
what's the angle?
Those are the angles.
Just as I thought.
Yep,
Okay.
exactly.
Yeah, those are angles to
This is why
the
he put
normal
me on
line,
vocal
which is
mute.
perpendicular to the surface, right?
Yeah, I agree. Those are angles, Bacon. I completely agree. Those are actual angles because you have straight lines in between said vertexes.
Yeah, what's the definition on the blue line?
Look.
What's the definition on the blue
Right,
line?
those are quite clearly angles, yes,
Yeah,
but
yeah, what's the blue line?
Does anyone else see what he's doing, guys?
Yeah.
So you have to know the radius.
Asking a question
right?
that has
And
not
you
been
You
answered.
have to know the center. You have to draw a line from the center outwards, right?
These gymnastics.
Yeah, what is this
Which
blue line?
which you have to add all this information to a
I'm not
curved
adding.
surface to
On
be able
all
to
that is not
gather
new information.
to
That's
be
not new
able to
information.
gather the info. You do. You can't just get it from a curved surface.
That's not new information.
Right?
All the
You
information,
can't
all the information
derive it.
required, all the information required was already present in the first picture.
No, you can't derive it just from the curved line and the straight line, right?
Yes, you
You have
can,
to you have to draw other lines,
which
right?
is being derived from the curved line and the straight
There you
line.
go. Right, so
So
you've
there's
had to
no
add
extra information.
things. You've had to add things,
That's not.
right,
Yeah,
to
that's not new
calculate it.
information.
You've had to
It's not new
add
information,
things
Benzo.
to calculate it. You
That's
have
not new information, Benzo.
100% in anyone's book. It's adding.
That's adding stuff to the picture. That doesn't mean adding new information.
Yep.
That information
No,
is already there.
the information might be there, right? That you can derive from adding things,
So what's the
right,
problem?
to something else other than just the curved line and the
So
straight line. Because
if
you
I
can't
can
get
drive,
an angle, you can't put a protractor right there on that
yes, you
curved
can, as
line.
long as it's tangent.
Yes, which creates a tangent point, which
And
creates
what's the
another.
problem with that?
It creates another straight line.
Yeah, if I can create a
exactly what it
tangent,
does.
if I can create a tangent to a curved surface to measure an angle, why can't I create a tangent surface to the Earth and measure an angle?
You can do whatever you want.
So stop complaining about it.
But you can't get it just from right the curved line, normal line, an abnormal line, a wiggly line. You can call it whatever you want, right?
Well, thank you.
Yeah,
So,
surface
which
normals are
proves my
said to
point.
be perpendicular, but as I outlined earlier, by definition, they're not.
They are by
because
definition
they
perpendicular.
are not at right angles to the surface.
They are by definition at angle at the surface. That's
Yeah,
what a
but
normal line is
all right, but
defined to be.
when you investigate that claim further, you realize that there is no right angles being formed.
No, that's your conclusion. That's
anyone with a simple understanding of geometry and angles. That should be anyone's conclusion. Of course, this is your conclusion because
Can
you
you
believe
back
in
that
a
up?
theory.
Can you provide a
I
citation
can
for it?
definitely back up what a right angle is and what perpendicular means. Yeah.
Yeah, so can you provide anything to back up that you cannot have a right angle to a curved surface? Because I can provide citations that tell you can.
Well, if the surface is curved, then you're not going
I'm
to
not
be at
asking
right
for
angles
reasoning.
to it.
I'm asking for you to back it up.
All right,
Your reasoning is flawed. You're just not accepting that. So now
So
I'm
you
going to
want
ask
me
you for
to
a citation.
provide the definition for what a right angle is? and what
No.
perpendicular is. Of course you don't.
any
Of course
to
you don't, because
anywhere.
you know that destroys your globe.
No,
It destroys your curved surface. If I provide that definition, it destroys your curved surface.
It doesn't.
No, it
I mean,
doesn't.
tennis balls are flat.
Us.
Basketballs are flat.
That's a
Just
squat.
because perpendicular.
That's squat.
That's
Yeah,
just
so
a
spheres,
non-argument.
mirror spheres can exist then, cannot exist then, right?
Yeah,
Cannot
there are
reflect
no
light
spheres.
because
If you put a sphere on a
all right,
surface,
mirror
it
a
doesn't exist.
sphere that's mirrored will not give you a specular reflection.
No, it wouldn't give you any reflection because you can't have angles to that surface, so you can't have light bouncing off of it.
Nobody said that. That's just another non-argument from Mole Man. You're just not
well,
getting anywhere
you
with
said you cannot have angles to a
those
curved
attempts at
surface.
condescension. You're just not getting anywhere, mate.
No, but
The fact of the matter is, if you just address what I said, if you address what I just said, which was, if you have a mirrored surface that's a ball, you're not going to get a specular reflection.
What kind of a reflection would you get from it when you can't have angles to it? So
You
there's no
wouldn't-
angle of incidence.
Well, my
for the
point
light.
is, you wouldn't get a specular reflection like you would on a flat surface,
But how do you know that?
because the angle of incidence would not match the angle of reflection.
It does.
You're saying that there would be no
Actually,
angle
it
of
does.
incidence.
Yeah, the law of reflection, the thing you just quoted, is holds for curved surfaces.
If that's true, then have you ever used the funhouse mirror?
Yes, I have, and there is light going
so
in.
Does it
and
reflect? Does it reflect what you look like?
No,
No. Thank you.
because it's
So
a
why
curved
is that?
surface.
Because it's
Because
curved,
the angles,
so it's not giving you a specular reflection.
are different. The angles
Yes,
are different.
that's my whole point.
Yeah,
You're not
the
getting,
angle.
the angle of incidence is not equal. In that case, the angle of incidence is not equal to the angle of reflection.
But there is still angles, right?
No, it is. It is the same angle.
It's not.
There's still angles.
In order to have
what is changing is each point of the surface has a different incident ray, and it has the same reflection ray. So the angle of incidence is different for each point, but it still matches the reflection angle. What you're saying is just a non sequitur. The fact that it doesn't create, the fact that the picture is distorted, does not imply that the angle of incidence is not matching the angle of reflection. It is. They're just changing. They're still matching each other.
They're
But
quite
at a different
clearly
point,
not.
they're different. It's just
If
it's
there's
just a
still an
fallacy.
angle, and if
What
there's still an angle,
fallacy would that be?
A non sequitur.
How?
Because you said that if that's distorting your image, then the angle of reflection is not matching the angle of incidence.
Is that a
It's a non sequitur.
It's right on
Yes.
point. We were
No,
we were
that's a
literally
non
talking
sequitur.
about the angle of incidence, and that was my whole premise. So how is that a non sequitur?
Because just because the picture is the margin is being distorted, right? Doesn't mean that the angle of reflection is not matching the angle of incidence.
It's not a non sequitur. Sorry.
That is, if that
It's
your
not.
justification.
It's right
if
on
that's your-
point. It's what we were talking about.
no, you said A,
It
therefore
absolutely
B.
follows. It absolutely
It
follows.
doesn't follow. It doesn't follow because the angle of incidence is changing. That's what's distorting the image, not a mismatch between the angle of
said
incidence.
you
You're
wouldn't
just
get-
denying physics because it's the law
denying
of reflection holds for curved surfaces.
All this stuff, does this help show us if a sextant proves the shape?
No, let's get past that and now go to the trilateration, please.
Not yet, Jay. Not yet. We're getting
Thank you,
there,
Dobby.
right? We're getting
However
there.
it's pronounced.
It never will because we
Don't
can
make
never
claims
get.
about me in chat, Mole Man. Come on, be honest. You're better than this.
Well, are there angles to that curved lens?
Don't make claims about me that I didn't make in chat. Come on, mate.
Are there angles to
You're
that
better
curved
than
lens?
this. You're trying to get your
Okay,
little
the
wins in
concave-
chat. It's
hold
just
on.
not cool.
No,
man.
I'm not getting any
I
wins.
agree
I'm
with all
asking.
of this.
You're
There's a concave
not, but you're
mirror.
attempting to.
So there's a concave
That has
mirror.
to be
Can you have
fake,
an angle?
according to Globus. He says, "Come on, man."
Yeah. Can you
Am
have
I
an
making those?
angle?
Am I making those little claims about every little statement you make? You
trying
can
to squat.
you can be an adult about
Let's
this.
go.
Come
Sure,
on.
okay, I can be an adult about this.
Sure.
There's the
You
concave
say
mirror.
sure a lot, but you don't
Just
seem
show
to
the
follow
shape.
through with your
Concave,
sure
I've been
statement.
asking you questions and you haven't answered a single one. So there's
I'm
a
answering
concave
every
mirror.
question you've
Can you
asked.
have an angle to the concave mirror?
Can you have an angle to the concave mirror?
Yeah.
Well, show me what angle you'd be measuring.
The red ones in the image. There.
Okay,
So
so
it's
what?
the curved
So what?
mirror. I'm just asking, are they angles? Can they be angles?
Whereabouts though? Like, let me see.
Where the mirror is?
Yeah, of course. Good luck measuring them.
Yeah, when
Yeah,
the
but
light reflects, yeah, but is there an angle to the surface? That's my whole point.
yeah, I'm asking you.
Is there
Is
an
there an
angle
angle?
to the surface? No.
Yeah. No. Okay. So according to you, that when the light hits the surface and reflects, there's no angle to the surface.
The light can be created an angle, but the surface isn't.
So no angle to the surface. No
That's what I just
no
said.
angle of incidence.
Yikes.
Okay.
This point doesn't do
no
anything.
angle of incidence.
It doesn't do anything explaining this and dragging this out and getting him to say I made a mistake.
Look,
Okay, just no angle of incidence.
It doesn't do anything.
I just think it's just, if we can't come to a consensus on what an angle is, I mean, we should just stop speaking to each other now. I mean,
Well, it seems